Big data is a term used to describe the large volume of data, both structured and unstructured, that inundates a business on a day-to-day basis. But it is not the amount of data that is important, it's what the organization do with the data that matters. Big data can be analyzed for insight that leads to better decisions and strategic business moves. Hi everyone, welcome to this Big Data full course. Today we have an exciting agenda lined up for you. But before we get started, if you like our videos, then please do not forget to subscribe to our Edureka YouTube channel and hit the bell icon to stay updated with all the latest trending technologies. Also, if you are interested in our Big Data certification training, then please click on the link given in the description box. Now, without any delay, let us go through the agenda. First, we will start with an introduction to Big Data by discussing what is Big Data and the challenges it poses and the opportunities it presents. Next, we will dive deep into the Hadoop fundamentals, followed by HDFS, MapReduce, and other key components of Hadoop ecosystem. We will also discuss the advanced topics such as Sqoop, a tool for transferring data between Hadoop and relational database. Next we have Flume, a tool for collecting, aggregating and moving the large amount of log data. Then we have Pig, a high-level platform for creating MapReduce programs used with Hadoop. Then we have Hive, a data warehousing and SQL-like query language for Hadoop. After that, we have Hbase, a NoSQL database that runs on top of Hadoop and it is used for real-time data accessing and analysis. And after that, we will learn about Oozie, which is used to manage and coordinate Hadoop jobs. After that, we will dive into some of the popular Hadoop projects, which will give you an understanding of how these technologies are being used in these industries. We will also cover the career opportunities in the big data domain and tips to prepare for Big Data Hadoop interview questions. By the end of this full course, you will have a plenty of opportunities for hands-on practice and you will have a solid understanding of Hadoop ecosystem and be well prepared to work with the big data in professional setting. So, let us get started with our first topic, that is, what is big data?
What is big data? With the spike in internet usage and other technologies such as IoT devices, mobile phones, autonomous devices like robotics, drones, vehicles, appliances, the volume of generated data is growing exponentially at an unprecedented rate. This constant increase in the amount of data generated has led to the emergence of big data. So, what is big data? Let's keep it simple. Big data refers to a collection of data that is so huge and complex that none of the traditional data management tools are able to store it or process it efficiently. Now, you know that big data involves lots of data, but have you ever stopped to think about just how big is big data? According to Forbes, there are 2.5 quintillion bytes of data created every day. Now, you might be wondering how big data tools manage to handle such a huge amount of data. When Netflix offers you personalized recommendations from its library of thousands of movies and TV shows, that's big data at work. Big data helps Netflix determine which programs may be of interest to you, and the recommendation systems actually influences 80% of the content we watch on Netflix. In the near future, with the growing increase in the volume of data, big data will grow bigger and the demand for data management experts will shoot up. The gap between the demand for data professionals and their availability will widen. This will help data scientists and analysts draw higher salaries. So, what are you waiting for? Drive into the world of big data and towards a brighter future.
Now I feel, Saurabh, it's the best time to tell the story about how data evolved and how big data came.
Fine, Reshma. So we'll move forward.
So Saurabh, what can you notice here?
Reshma, I see how technology has evolved. Earlier we had landline phones, but now we have smartphones. We have Android, we have iOS that are making our lives smarter as well as our phones smarter. Apart from that, we were also using bulky desktops for processing MBs of data. Now if you can remember, we were using floppies and you know how much data it can store, right? Then came hard disks for storing TBs of data, and now we can store data on cloud as well.
And similarly, nowadays, even self-driving cars have come up. I know you must be thinking, why are we telling that? Now, if you notice, due to this enhancement of technology, we're generating a lot of data. So let's take the example of your phones. Have you ever noticed how much data is generated due to your fancy smartphones? Your every action, even one video that is sent through WhatsApp or any other messenger app, that generates data. Now this is just an example. You have no idea how much data you're generating because of every action you do. Now the deal is, this data is not in a format that our relational database can handle. And apart from that, even the volume of data has also increased exponentially. Now, I was talking about self-driving cars. So basically, these cars have sensors that records every minute details like the size of the obstacle, the distance from the obstacle, and many more. And then it decides how to react. Now, you can imagine how much data is generated for each kilometer that you drive on that car.
I completely agree with you, Reshma. So let's move forward and focus on various other factors behind the evolution of data. I think you guys must have heard about IoT. If you can recall in the previous slide, we were discussing about self-driving cars. It is nothing but an example of IoT. Let me tell you what exactly it is. IoT connects your physical device with internet and makes the device smarter. So nowadays, if you have noticed, we have smart ACs, TVs, etc. So we'll take the example of smart air conditioners. So this device actually monitors your body temperature and the outside temperature and accordingly decides what should be the temperature of the room. Now, in order to do this, it has to first accumulate data. From where? It can accumulate data from internet, through sensors that are monitoring your body temperature and the surroundings. So basically from various sources that you might not even know about, it is actually fetching that data and accordingly it decides what should be the temperature of your room. Now we can actually see that because of IoT we are generating a huge amount of data. Now there is one stat also that is there in front of your screen. So if you notice, by 2020 we'll have 50 billion IoT devices. So I don't think so I need to explain much that how IoT is generating huge amount of data. So we'll move forward and focus on one more factor, that is social media. Now when we talk about social media, I think Reshma can explain this better, right Reshma?
Yeah, Saurabh, but I'm pretty sure that even you use it. So let me tell you that social media is actually one of the most important factor in the evolution of big data. So nowadays everyone is using Facebook, Instagram, YouTube, and a lot of other social media websites. So these social media sites have so much data. For example, it will have your personal details like your name, age, and apart from that, even each picture that you like or react to also generates data. And even the Facebook pages that you go around liking, that is also generating data. And nowadays you can see that most people are sharing videos on Facebook. So that is also generating a huge amount of data. And the most challenging part here is that the data is not present in a structured manner. And at the same time, it is huge in size. Isn't that right, Saurabh?
Can't agree more. The point you made about the form of data is actually one of the biggest factor for the evolution of big data. So due to all these reasons that we have discussed, have not only increased the amount of data, but it has also shown us that data is actually getting generated in various formats. For example, data is generated with videos, that is actually unstructured. Same goes for images as well. So there are numerous, or you could say millions of ways in which data is getting generated nowadays.
Absolutely. And these are just few examples that we have given you. There are many other driving factors for the evolution of data.
So these are few more examples because of which data is evolving and converting to big data. We'll discuss about the retail part. I'm pretty sure that all of you must have visited websites like Amazon, Flipkart, etc. And Reshma, I know you visited a lot of times.
Yeah, I do.
And suppose Reshma wants to buy shoes. So she won't just directly go buy shoes. She'll search for a lot of shoes. So somewhere her search history will be stored. And I know for sure that this won't be the first time that she's buying something. So there will be her purchase history as well, along with her personal details. And there are numerous ways in which she might not even know that she's generating data. And obviously Amazon was not present earlier. So at that time, there is no way that such huge amount of data was generated. Similarly, the data has evolved due to other reasons as well, like banking and finance, media and entertainment, etc., etc. So now the deal is, what exactly is big data? How do we consider a data as big data? So let's move forward and understand what exactly it is.
Okay, now let us look at the proper definition of big data, even though we've put forward our own definitions already. So Saurav, why don't you take us through it?
Yes, Reshma, sure. So big data is a term for collection of data sets so large and complex that it becomes difficult to process using on-hand database system tools or traditional data processing applications.
Okay, so what I understand from this is that our traditional systems are a problem because they're too old-fashioned to process this data or something?
No, Reshma. The real problem is there is too much data to process. When the traditional systems were invented in the beginning, we never anticipated that we would have to deal with such enormous amount of the data. It's like a disease infected on you. You don't change your body orientation when you get infected with a disease, right, Reshma? You cure it with medicines.
Couldn't agree more, Saurav.
Now the question is, how do we consider some data as big data? How do we classify some data as big data? How do we know which kind of data is going to be hard for us to process?
Well, Saurav, we have the 5 V's to tell us that. So let's take a closer look at what are those. So starting with the first V, it's the volume of data. It's tremendously large. So if you look at the stats here, you can see the volume of data is rising exponentially. So now we're dealing with just 4.4 zettabytes of data, and by 2020, just in 3 years, it is expected that the data will rise up to 44 zettabytes, which is like equal to 44 trillion gigabytes. So that's really, really huge.
It is because all this humongous data is coming from multiple sources, and that is the second V, which is nothing but variety. We deal with so many different kinds of files at all once. There are MP3 files, videos, JSON, CSV, TSV, and many more. Now these are all structured, unstructured, and semi-structured all together. Now let me explain you this with the diagram that is there on your screen. So over here we have audio, we have video files, we have PNG files, we have JSON, log files, emails, various formats of data. Now this data is classified into 3 forms. One is structured format. Now in structured format you have a proper schema for your data. So you know what all columns will be there, and basically you know the schema about your data. So it is structured, it is in a structured format, or you can say in a tabular format. Now when we talk about semi-structured files, these are nothing but JSON, XML and CSV files where schema is not defined properly. Now when I go to unstructured format, we have log files here, audio files, videos and images. So these are all considered as unstructured files.
And Saurabh, it is also because of the speed of accumulation of all this variety of data altogether, which brings us to our third V, which is velocity. So if you look here, earlier we were using mainframe systems. Huge computers, but less data, because there were less people working with computers at that time. But as computers evolved and we came to the client-server model, the time came for the web applications and the internet boomed. And as it grew among the masses, the web applications got increased over the internet. And everyone started using all these applications, and not only from their computers and also from mobile devices. So more users, more appliances, more apps, and hence a lot of data.
And when you talk about people generating data over internet, Reshma, the one kind of application that strikes first in my mind is social media. So you tell me how much data you generate alone with your Instagram posts and stories.
It will be quite a boast if I only talk about myself here. So let's talk including every social media user. So if you see the stats in front of your screen, you can see that for every 60 seconds, there are 100,000 tweets, actually more than 100,000 tweets generated in Twitter every minute. Similarly, there are 695,000 status updates on Facebook. When you talk about messaging, there are 11 million messages generated every minute. And similarly, there are 698,445 Google searches, 168 million emails, and that equals to almost 1,820 terabytes of data. And obviously the number of mobile users are also increasing every minute. And there are 217 plus new mobile users every 60 seconds.
Geez, that's a lot of data. I don't even want to go ahead and calculate the total. It would actually scare me.
Yeah, that's a lot. Now the bigger problem is how to extract the useful data from here.
And that's when we come to our next V, that is value. So over here what happens, first you need to mine the useful content from your data. Basically you need to make sure that you have only useful fields in your data set. After that, you perform certain analytics, or you say you perform certain analysis on that data that you have cleaned. And you need to make sure that whatever analysis you have done, it is of some value. That is, it will help you in your business to grow. It can basically find out certain insights which were not possible earlier. So you need to make sure that whatever big data that has been generated or whatever data that has been generated, it makes sense. It will actually help your business to grow and it has some value to it. Now, getting the value out of this data is one big challenge. Let me tell you why. And that brings us to our next V, which is veracity. Now, this big data has a lot of inconsistencies. Obviously, when you're dumping such huge amount of data, some data packets are bound to lose in the process. Now what we need to do, we need to fill up these missing data and then start mining again and then process it and then come up with a good insight if possible. So if you can notice, there's a diagram in front of your screen. So over here we have this field which is not defined, similarly this field, and if you can notice here, when we talk about this minimum value, you see the other minimum values, and when you talk about this, it is way more than the other fields present in this particular column. Similarly goes for this particular element as well.
Okay, so obviously processing data like this is one problematic thing, and now I get it why big data is a problem statement.
Well, we have only 5 V's now, but maybe later on we'll have more. So there are good chances that big data might be even more big.
Okay, so there are a lot of problems in dealing with big data, but there are always different ways to look at something. So let us get some positivity in the environment now, and let us understand how can we use big data as an opportunity.
Yes, Reshma, and I would say the situation is similar to the proverb, when life throws you lemons, make lemonade.
Yeah, so let us go through the fields where we can use big data as a boon. And there are certain unknown problems solved only because we started dealing with big data.
And the boon that you're talking about, Reshma, is big data analytics. First thing with big data, we figured out how to store our data cost effectively. We were spending too much money on storage before. Until big data came into the picture, we never thought of using commodity hardware to store and manage our data, which is both reliable and feasible as compared to the costly servers. Now let me give you a few examples in order to show you how important big data analytics is nowadays. So when you go to a website like Amazon or YouTube or Pandora, Netflix, any other website, so they'll actually provide you certain fields in which they'll recommend some products or some videos or some movies or some songs for you, right? So how do you think they do that? So basically whatever data that you are generating on these kind of websites, they make sure that they analyze it properly. And let me tell you guys, that data is not small. It is actually big data. Now they analyze that big data and they make sure that whatever you like or whatever your preferences are, accordingly they'll generate recommendations for you. And when I go to YouTube, I don't know if you guys must have noticed it, but I'm pretty sure you must have done that. So when I go to YouTube, YouTube knows what song or what video that I want to watch next. Similarly, Netflix knows what kind of movies I like. And when I go to Amazon, it actually shows me what all products that I would prefer to buy, right? So how do you think it happens? It happens only because of big data analytics.
Okay, so there is one more example that just popped into my mind I'll share with you guys. So there was this time when the Hurricane Sandy was about to hit on New Jersey in the United States. So what happened then? The Walmart used big data analytics to profit from it. Now I'll tell you how they did it. So what Walmart did is that they studied the purchase patterns of different customers when a hurricane is about to strike or any kind of natural calamity is about to strike on a particular area. And when they made an analysis of it, so they found out that people tend to buy emergency stuff like flashlight, life jackets, and a little bit of other stuff. And interestingly, people also buy a lot of strawberry Pop-Tart.
Strawberry Pop-Tarts? Are you serious?
Yeah. Now, I didn't do that analysis, so Walmart did that, and apparently it is true. So what they did is they stuffed all their stores with a lot of strawberry Pop-Tarts and emergency stuff, and obviously it was sold out and they earned a lot of money during that time.
But my question here, Reshma, is people want to die eating strawberry Pop-Tarts? Like, what was the idea behind strawberry Pop-Tarts? I'm pretty unsure about it. But yeah, since you have given us a very interesting example and Walmart did that analysis, we didn't do it. So yeah, so it is a very good example in order to understand how big data analytics can help your business to grow and find better insights from the data that you have.
Yeah, and also if you want to know why strawberry Pop-Tarts, maybe later on we can start making an analysis by gathering some more data also.
Yeah, that can be possible.
Okay, so now let's move ahead and take a look at a case study by IBM, how they have used big data analytics to profit their company.
So if you have noticed that earlier the data that was collected from the meters that you have in your home that measures the electricity consumed, it is actually sending data after 1 month. But nowadays what IBM did, they came up with this thing called smart meter. And that smart meter used to collect data after every 15 minutes. So whatever energy that you have consumed after every 15 minutes, it will send that data. And because of it, big data was generated. So we have some stats here which says that we have 96 million reads per day for every million meters, which is pretty huge. This data, the amount of data that is generated is pretty huge. Now IBM actually realized the data that they're generating, it is very important for them to gain something from that data. So for that what they need to do, they need to make sure that they analyze this data. So they realize that big data analytics can solve a lot of problems and they can get better business insight through that. So let us move forward and see what type of analysis they did on that data. So before analyzing that data, they came to know that energy utilization and billing was only increasing. Now after analyzing big data, they came to know that during peak load, the users require more energy, and during off-peak times, the users require less energy. So what advantage they must have got from this analysis? One thing that I can think of right now is they can tell the industries to use their machinery only during the off-peak times so that the load will be pretty much balanced. And you can even say that time of use pricing encourages cost-savvy retail like industrial heavy machines to be used off-peak time. So yeah, they can save money as well because off-peak times pricing will be less than the peak time prices, right? So this is just one analysis. Now let us move forward and see the IBM suite that they developed. So over here, what happens? You first dump all your data that you get in this data warehouse. After that, it is very important to make sure that your user data is secure. Then what happens? You need to clean that data. As I've told you earlier as well, there might be many fields that you don't require. So you need to make sure that you have only useful material or useful data in your data set. And then you perform certain analysis.
And in order to use this suite that IBM offered you efficiently, you have to take care of a few things. The first thing is that you have to be able to manage the smart meter data. Now there is a lot of data coming from all this million smart meters. So you have to be able to manage that large volume of data and also be able to retain it because maybe later on you might need it for some kind of regulatory requirements or something. And the next thing you should keep in mind is to monitor the distribution grid so that you can improve and optimize the overall grid reliability so that you can identify the abnormal conditions which are causing any kind of problem. And then you also have to take care of optimizing the unit commitment. So by optimizing the unit commitment, the companies can satisfy their customers even more. They can reduce the power outages so that their customers don't get angry more, identify problems, and then reduce it, obviously. And then you have also to optimize the energy trading. So it means that you can advise your customers when they should use their appliances in order to maintain that balance in the power load. And then you also have to forecast and schedule loads. So companies must be able to predict when they can profitably sell the excess power and when they need to hedge the supply. And continuing from this, now let's talk about how Encore have made use of the IBM solution. So Encore is an electric delivery company and it is the largest electrical distribution and transmission company in Texas. And it is one of the 6 largest in the United States. They have more than 3 million customers and their service area covers almost 117,000 square miles. And they began the advanced meter program in 2008 and they have deployed almost 3.25 million meters serving customers of North and Central Texas. So when they were implementing it, they kept 3 things in mind. The first thing was that it should be instrumented. So this solution utilizes the smart electricity meters so that they can accurately measure the electricity usage of a household in every 15 minutes because like we discussed that the smart meters were sending out data every 15 minutes and it provided data inputs that is essential for consumption insights. Next thing is that it should be interconnected. So now the customers have access to the detailed information about the electricity they are consuming, and it creates a very enterprise-wide view of all the meter assets, and it helps them to improve the service delivery. The next thing is to make your customers intelligent. Now, since it is getting monitored already about how each of the household or each customer is consuming the power, so now they're able to advise the customers about maybe to tell them to wash their clothes at night because they're using a lot of appliances during the daytime, so maybe they could divide it up so that they can use some appliances at off-peak hours so that they can even save more money. And this is beneficial for both of them, for both the customers and the company as well. And they have gained a lot of benefits by using the IBM solution. So what are the benefits they got is that it enabled Encore to identify and fix outages before the customers get inconvenienced. It means they were able to identify the problem before it even occurred. And it also improved the emergency response on events of severe weather events and views of outages. And it also provides the customers the data needed to become an active participant in the power consumption management. And it enabled every individual household to reduce their electrical consumption by almost 5 to 10%. And this is how Encore used the IBM solution and made huge benefits out of it just by using big data analytics that IBM performed.
But let me just interrupt right now. So since Reshma told us in the beginning as well that there are no free lunches in life, right? So this is an opportunity. But there are many problems to encase this opportunity, right? So let us focus on those problems one by one. So the first problem is storing colossal amount of data. So let's discuss few stats that are there in front of your screen. So data generated in the past 2 years is more than the previous history in total. So guys, what are we doing? Stop generating so much amount of data. And it is said that by 2020, total digital data will grow to 44 zettabytes approximately. And there's one more stat that amazes me is about 1.7 MB of new information will be created every second for every person by 2020. So storing this huge data in traditional system is not possible. The reason is obvious. The storage will be limited for one system. For example, you have a server with a storage limit of 10 terabytes, but your company is growing really fast and data is exponentially increasing. Now what you'll do? Now at one point you'll exhaust all the storage. So investing in huge servers is definitely not a cost-effective solution. So Reshma, what do you think? What can be the solution to this problem?
According to me, a distributed file system will be a better way to store this huge data. Because with this we'll be saving a lot of money. Let me tell you how. Because due to this distributed system, you can actually store your data in commodity hardware instead of spending money on high-end servers. Don't you agree, Saurabh?
Completely. Now we know storing is a problem, but let me tell you guys, it is just one part of the problem. Let's see a few more.
Okay, so since we saw that the data is not only huge, but it is present in various formats as well, like unstructured, semi-structured, and structured. So you not only need to store this huge data, but you also need to make sure that a system is present to store this varieties of data generated from various sources. And now let's focus on the next problem.
Now let's focus on the diagram. So over here you can notice that the hard disk capacity is increasing, but the disk transfer performance or speed is not increasing at that rate. Let me explain you this with an example. If you have only 100 Mbps input output channel and you are processing say 1 terabytes of data. Now how much time will it take? Maybe calculate, it'll be somewhere around 2.91 hours, right? So it'll be somewhere around 2.91 hours. And I've taken an example of 1 terabytes. What if you're processing some zettabytes of data? So you can imagine how much time will it take. Now what if you have 4 input output channels for the same amount of data? Then it'll take approximately 0.72 hours, or converted to minutes, so it'll be around 43 minutes approximately, right? And now imagine instead of 1 TB you have zettabytes of data. For me, more than storage, accessing and processing speed for huge data is a bigger problem. Okay, so Reshma has a very good example to discuss.
Yeah, so since you were talking about accessing the data and you told us already about how Amazon, different websites and YouTube, they make those recommendations. So if there was no solution for it, if it would take so much time to access the data, the recommendation system wouldn't work at all. And they make a lot of money just by recommendation system because a lot of people go there and click over there and buy that product, right? So let's consider that it is taking like hours or maybe years of time in order to process that big amount of data. So let's say that at one time I purchased an iPhone 5S from Amazon, and after 2 years, I'm again browsing onto Amazon, and since it took so much time to access the data, and I've already switched over to a new iPhone, and they are recommending me the old iPhone case for 5S. So obviously that won't work. I won't go there and click it because I've already changed my phone, right? So that will be a huge problem for Amazon. The recommendation system won't work anymore.
And I know that Reshma changes her phone every year. So if she has bought a phone and people are recommending, if she has bought a phone now and someone's recommending the case for that phone after 2 years, doesn't make sense to me at all.
Yeah, only it'll work if I have both the two phones at the same time. But yeah, I don't want to waste money on purchasing new iPhone case for my older phone.
So basically, it won't be fair if we don't discuss the solution to these problems. Reshma, we can't leave our viewers with just the problems, right? It won't be fair. What is the solution? Hadoop. Hadoop is a solution. So let's introduce Hadoop now.
Okay, so now what is Hadoop? So Hadoop is a framework that allows you to first store big data in a distributed environment so that you can process it parallelly.
There are basically two parts. One is HDFS, that is Hadoop Distributed File System for storage. It allows you to store data of various formats across a cluster. And the second part is MapReduce. Now it is nothing but a processing unit of Hadoop. It allows parallel processing of data that is stored across the HDFS. Now let us dig deep in HDFS and understand it better.
Yeah, so HDFS creates an abstraction of resources. Let me simplify it for you. So similar to virtualization, you can see HDFS logically as a single unit for storing big data. But actually you're storing your data across multiple systems, or you can say in a distributed fashion. So here you have a master-slave architecture in which the name node is a master node and the data nodes are slaves. And the name node contains the metadata about the data that is stored in the data nodes, like which data block is stored in which data node, where are the replications of the data block kept, and etc., etc. So the actual data is stored in the data nodes. And I also want to add that we actually replicate the data blocks that is present in the data nodes. And by default, the replication factor is 3. So it means that there are 3 copies of each file. So Saurav, can you tell us why do we need that replication?
Sure, Reshma. Since we are using commodity hardwares, right? And we know failure rate of these hardwares are pretty high. So if one of the data nodes fail, I won't have that data block. And that's the reason we need to replicate the data block. Now this replication factor depends on your requirements, right? Now let us understand how actually Hadoop provided the solution to the big data problems that we have discussed. So Reshma, can you remember what was the first problem?
Yeah, it was storing the big data. So how HDFS solved it, let's discuss it. So HDFS provides a distributed way to store big data. We've already told you that. So your data is stored in blocks, in data nodes, and you then specify the size of each block. So basically, if you have a 512 MB of data and you have configured HDFS such that it will create 128 megabytes of data block. So HDFS will divide the data in 4 blocks because 512 divided by 128 is 4. And it will store it across different data nodes, and it will also replicate the data blocks on the different data nodes. So now we are using commodity hardware and storing is not a challenge. So what are your thoughts on it, Saurabh?
I will also add one thing, Reshma. It also solves the scaling problem. It focuses on horizontal scaling instead of vertical. Now you can always add some extra data nodes to your HDFS cluster as and when required instead of scaling the resources of your data nodes. So you're not actually increasing the resources of your data nodes, you're just adding few more data nodes when you require. Let me summarize it for you. So basically for storing 1 TB of data, I don't need a 1 TB system. I can instead do it on multiple 128 GB systems or even less. Now Reshma, what was the second challenge with big data?
So the next problem was storing variety of data. And that problem was also addressed by HDFS. So with HDFS, you can store all kinds of data, whether it's structured, semi-structured, or unstructured. It is because in HDFS, there is no pre-dumping schema validation. So you can just dump all the kinds of data that you have in one place. And it also follows a write once and read many model. And due to this, you can just write the data once and you can read it multiple times for finding out insights. And if you can recall, the third challenge was accessing the data faster. And this is one of the major challenges with big data. And in order to solve it, we're moving processing to data and not data to processing. So what it means, sort of, just go ahead and explain it.
Yes, Reshma, I will. So over here, let me explain you what you mean by actually moving process to data. So consider this as our master and these are our slaves. So the data is stored in these slaves. So what happens, one way of processing this data is, what I can do is I can send this data to my master node and I can process it over here. But what will happen if all of my slaves will send the data to my master node? It will cause network congestion plus input-output channel congestion, and at the same time, my master node will take a lot of time in order to process this huge amount of data. So what I can do, I can send this process to data. That means I can send the logic to all these slaves which actually contain the data and perform processing in the slaves itself. So after that, what will happen, the small chunks of the result that will come out will be sent to our name node. So in that way, there won't be any network congestion or input-output congestion, and it will take comparatively very less time. So this is what actually means sending process to data.
Problems faced by traffic. Now, there are a hell lot of problems that are being faced by us in our day-to-day lives. A few major problems are delays. The first thing many people think of when it comes to congested roadways are the delays. During the morning commute, there is an additional stress because of delays caused by traffic that can make people late for work. And at the end of the day, the afternoon rush is again frustrating time because of the workday is done and the people want to go home and relax, and the traffic is preventing it. These delays are common to most of the people because it is universal and everyone who has to maneuver through congested roads. Just in case time, a secondary effect of traffic congestion related to delays is the inability to estimate travel times. Those who regularly travel congested areas know approximately how long it usually takes to get to a particular area depending upon the time of the day and the day of the week. These experienced city drivers have to build in time just in case the traffic is too bad. This takes away the time from their leisure and the time to do other tasks throughout the day. Also, on a few days, when the traffic is usually light, the built in extra time may be of no use and the person arrives too early. Followed by the first problem, we move into the second problem, which is the fuel consumption and pollution. The stopping and starting in traffic jams burns fuel at a higher rate than the smooth rate of travel on the open highway. This increases the fuel consumption, costs commuters additionally for fuel, and it also contributes to the amount of emissions released by the vehicles. These emissions create air pollution and are related to global warming. Followed by the second problem, the third major problem is the road rage. Road rage is a senseless reaction to traffic that is common in congested traffic areas. If someone is not driving as fast as the person behind him thinks he should, or someone cuts in front of someone else, it can lead into an incident that is dangerous to the offender and those around him on the road. Road rage often manifests itself as shouting matches on the road, intentional tailgating, retaliatory traffic maneuvers, and mostly a lack of attention being paid to the traffic around the people involved. It is basically a temper tantrum by frustrated drivers in traffic. Followed by this, we have the emergency vehicles. When you dial 911 or 108 in case of India and request a police officer or an ambulance or a fire truck, and the emergency vehicle is unable to respond in appropriate amount of time because of the traffic congestion, it can be a danger to you or your property. Systems are available that help elevate this problem by allowing the emergency crews to automatically change the traffic lights to keep the line moving. So with this, we move ahead into the next topic, where we will learn exactly how big data is solving it. The higher risk of passenger safety, loss of productivity, increase in fuel consumption, and fuel is all the effects of urban traffic congestion. Efficient traffic management will reduce congestion, improve performance measurements for seamless traffic flow, and proficiently manage current roadway assets. Government organizations and administrative authorities are implementing coordinated traffic signals and variable messages to manage traffic congestion. By implementing big data solutions, administrators can leverage historical trends, a combination of real time information, and new age algorithms to improve and traffic networks in urban areas. The growing focus on the development of intelligent network systems and the use of big data analytics will assist traffic management and result in reduced congestion and roadblocks. The adoption of advanced sensors and GPS signal systems is revolutionizing the urban traffic network. These systems are designed to help reduce network congestion and act as alerts that notify traffic authorities of potential roadblocks and how to avoid them. The sensors are installed in trucks, ships, and airplanes that give real time insights into drivers' capabilities and the traffic. GPS signals are utilized for bottlenecks and predict the condition of the transportation network. Followed by that, we have the emergence of smart vehicles. The advent of smart vehicles will help reduce the network congestion across several cities in the world. These are connected vehicles that provide real time estimation of traffic patterns that help authorities with the deployment of management strategies. These systems are designed to improve the communication, vehicle to infrastructure communications, and monitor the traffic control to reduce collisions and accidents. Additionally, the implementation of speed trackers, traffic sensors, and display boards will result in smarter roads and help control speed and traffic issues effectively. Followed by that, we have telematics solutions. Telematics is extensively used in traffic management to provide statistics and information data such as weather condition, traffic conditions, and navigation systems. These systems provide real time information, and authorities leverage predictive analysis to determine the state of transportation network. Moreover, telematics provide speech-based internet access to the consumers through wireless links that monitor the driver's state and stress levels and send alerts to the systems if there is any issue to avoid or reduce chances of collision. Now, we shall discuss the outcomes and solutions offered. Big data analytics assessments on traffic network congestion identifies a set of transportation indicators that are measured using the mobile phone data available to travel agencies to optimize route planning. Some of the solutions offered are develop an integrated platform to perform data analysis in a scheduled, easy, and controlled way using a user friendly interface, offered an exhaustive understanding of how traffic demand is distributed in the transportation network and how it varies over time, and listed the different types of bottlenecks of the transportation network and enabled enhanced route planning, evaluated the travel delay due to congestion based on travel time distribution between peaks and non peak periods, provided a comprehensive analysis of total number of trips made to and from each zone based on day, time, month, and holiday. Next, we shall learn the architecture of intelligent traffic management systems. ITS generally has cameras set up on most populated areas of metropolitan cities. These cameras collect the visuals data in the form of photos and videos. This data is collected and stored in a storage unit. Generally, HBase is used for the job as it is capable of storing all sorts of data regardless of the type of data. Now, there are n number of calculations and processing that is applied onto the collected data. So, for an offline data processing procedure, we use MapReduce, whereas on the other hand, we use some high end processing frameworks for online and interactive applications. The procedure involves active data mining for fetching most accurate data. The data is ingested into RDBMS and other servers using Sqoop, where the data is aggregated and the legacy applications are run over the data to analyze the data and provide the traffic department with latest updates in the live traffic. Now, our next concern would be learning the approach to intelligent traffic systems. There are 5 different stages in which the intelligent traffic control system works. They are traffic data collection, traffic data transmission, traffic safety measures, traffic data analysis, and lastly, providing the traveler with latest traffic updates as per his needs. Let's discuss each one of them. The first one, Traffic Management Center. Traffic Management Center is the vital unit of ITS. It is mainly a technical system administered by the Transportation Authority. Here, all data is collected and analyzed for further operations and control management of the traffic in real time or information about local transport vehicles. Well organized and proficient operations of Traffic Management Center depend on automated data collection with precise location information, that analysis of data to generate accurate information, and then transmitting it back to travelers. Let's understand the entire process in a more detailed way. The first stage is data collection. Strategic planning needs precise, extensive, and prompt data collection with real time observation. So, the data here is collected via varied hardware devices that lay the base of further ITS processes. This data is collected and stored into a storage unit. Generally, HBase is used for the job as it is capable of storing all sorts of data regardless of the type of data. Now, there are n number of calculations and processes that need to be applied onto the collected data. The next stage is data transmission. Rapid and real time information communication is the key to proficiency in ITS implementation. So, the aspect of ITS consists of the transmission of collected data from the field to TMC and then sending back the analyzed information from TMC to the travelers. Traffic related announcements are communicated to the travelers through the internet, SMS, or onboard units of vehicles. Other methods of communications are dedicated short range communications or DSRC using radio and continuous air interface, long and medium range, that is CAILM, using cellular connectivity and infrared links. Followed by this, we have the safety. Intelligent transport systems' top priority is to make sure the travelers are safe. It mainly targets on the making way for emergency vehicles like fire and safety, ambulance, and curbs. It looks after real time traffic information, analyzes it, and redirects the emergency vehicles to the most favorable routes to reach their destination faster and safer. The next stage is data analysis. The data that has been collected and received at TMC is processed for further in various steps. These steps are error rectification, data cleansing, data synthesis, and adaptive logical analysis. The inconsistencies in data are identified with specialized software and rectified. After that, the data is further altered and pooled for analysis. This mended collective data is analyzed further to predict traffic scenarios which are available to deliver appropriate information to users. Lastly, the traveler information. Travel Advisory Systems or TAS is used to inform transportation updates to the traveler. The system delivers real time information like travel time, travel speed, delays, accidents on roads, change in route, diversions, work zone conditions, etc. This information is delivered by a wide range of electronic devices like variable message signs, highway advisory radios, internet, SMS, and automated cell call. With urbanization expanding with speedy stride, the number of vehicles on road is also increasing. Combination of both in return puts enormous pressure on cities to maintain a better traffic system so that the city keeps on moving without any hassle. For the purpose, application of intelligent transport system is the only solution. ITS is a win-win situation for both citizens and city administrators where it provides safety and comfort to citizens and easy maintenance and surveillance to city administrators. Now, moving ahead, we shall understand the hardware requirements of ITS. The hardware requirements for ITS are categorized into 3 major components. Those are the field equipment, communication systems, and traffic management center. Now, these 3 components have further requirements which are mentioned below. They are field equipment, that is the inductive loop detectors, magnetic detectors, infrared and microwave detectors, acoustic detectors, and video imaging. Moving ahead, The next one is the communication system, which requires wired and wireless communications. Followed by that, the last one is the traffic management center, which requires basic facility of staff, signal control unit, traffic surveillance, freeway control, integration for regional control, incident detection, incident response team, information dissemination, electronic tolls, rail crossing monitors. Now that we have a brief idea about the hardware requirements of ITS, let's move ahead and understand the major challenges faced by ITS. So, the major challenges faced by ITS are lack of resources for operation and maintenance of ITS technology, lack of in house technical capacity to process, understand, and analyze the data, lack of advanced analytic solutions in the public transport industry, lack of knowledge on ITS systems and capabilities to specify suitable terms when contracting ITS services to vendors. Followed by that, the lack of knowledge among vendors on specific needs of public transport operations, which significantly affects the utility of the end product. Now, with this, we shall now move ahead and wind up our session discussing the benefits of ITS. Data is stored in data centers in different regions with global access. Each data center is universal live backup. It offers real-time statistical data analysis. It has common data source, which is shared among offline analysis and interactive applications. It offers full text search capabilities inside the storage systems. It has an inbuilt indexing system to offer synchronization of traffic data. Standard HBase interface increases image storing and processing performance. It integrates our language support for HBase, HDFS, and MapReduce. Finally, exponential reduction in designing logic for complex data mining.
So who's a big data engineer? Now, every data-driven business needs to have a framework in place for the data science and data analytics pipeline. And a data engineer is the one who's responsible for building and maintaining this framework. Now, these engineers must ensure that there is an uninterrupted flow of data between servers and applications. So in simple words, a data engineer builds, tests, maintains data structures and architectures for data ingestion, processing and deployment of large-scale data-intensive applications. Now, data engineers work in tandem with data architects, data analysts, and data scientists. So they must all share these insights to other stakeholders in the company through data visualization and storytelling. But what does a big data engineer do exactly? Now, the most crucial part of a big data engineer is to design, develop, construct, install, test, and maintain the complete data management and processing systems. They are basically the ones who handle the complete end-to-end infrastructure for data management and processing. They build a pipeline for data collection and storage and funnel the data to data analysts and scientists. So basically what they do is they create the framework to make data consumable for data scientists and analysts so they can use the data to derive insights from it. Note that the data engineers are the builders of data systems and not those who mine for insights. So the data engineer works more behind the scenes and must be comfortable with other members of the team producing business solutions from this data. Now all their responsibilities revolve around this. They need to take care of a lot of things while performing these activities. Hence, one of the most sought-after skills in data engineering is the ability to design and build data warehouses. This is where all the raw data is collected, stored, and retrieved from. Without data warehouses, all the tasks that a data scientist does will become obsolete. It is either going to get too expensive or very, very large to scale. Now, data engineers should always keep in mind that the system which he or she builds needs to be scalable, robust, and fault-tolerant, so that the system can be scaled up without increasing the number of data sources and can handle a huge amount of heterogeneous data without any failure. Now imagine a situation wherein the source of data is doubled or tripled, but the system cannot scale up. Will it not cost a lot more time and resources to build the same system again, which is suitable for this kind of intake? Exactly. This is why the big data engineers have a role here. Next, he or she is the one that handles the extract, transform, and load process, which is basically the blueprint for how the collected raw data is processed and transformed into data ready for analysis. Now you're going to acquire a lot of data from different sources. How do you bring them together to one platform? ETL is your answer. Apart from all this, a data engineer should always aim at deriving insights by acquiring data from new sources. Some of the responsibilities of a data engineer also include improving data foundational procedures, integrating new data management technologies, and the software into existing systems and building data collection pipelines. And finally, one of the major roles of a data engineer is to include performance tuning and make the whole system way more efficient, which is pretty self-explanatory if you ask me. Now, most of us have some idea about who a big data engineer is, but there's still some confusion about their responsibilities. Now, this ambiguity further increases when we gain more information about the role. Now, let me help you debunk all your queries about it. So let's talk about some big data engineer responsibilities. First up, we have data ingestion. Now, this is associated with the task of getting data out of the source systems and ingesting it into a data lake. Now, a data engineer would need to know how to efficiently extract the data from a source, including multiple approaches for both batch and real-time extraction, as well as needing to know about the incremental data loading, fitting within small source windows, and parallelization of data loading as well. Now, another small subtask of data ingestion is data synchronization. But because it's such a big issue in the big data world, we are going to talk about it. Now, since Hadoop and other big data platforms don't support incremental loading of data, a data engineer would need to know how to deal with detecting changes in the data source, merge and sync changed data from sources into the big data environment. Next, we have data transformation. This is basically the T in the extract, transform, and load that we had discussed earlier. It is basically focused on integration and transformation of data for a specific use case. Now, a major skill set here is the knowledge of SQL. As it turns out, not much has changed in terms of the type of data transformations that people are doing now compared to purely relational environments. Now, imagine all this data that you've acquired from various sources. What would you have to do to make them all palatable in the same platform? You need to transform that data, and this is what a data engineer does here. And finally, we have performance optimization, which is one of the tougher areas because anyone can build a slow-performing system. The challenge is to build data pipelines that are both scalable and efficient. So the ability and understanding of how to optimize the performance of an individual data pipeline and the overall systems are a higher level of data engineering skill. Now, for example, big data platforms continue to be challenging with regard to query performance and have added complexity to a data engineer's job. In order to optimize performance of queries and creation of reports, the data engineer needs to know how to denormalize, partition, and index data models. He also needs to understand tools and concepts regarding in-memory models and OLAP cubes. Now let's quickly move ahead and look at the required skills to fulfill these responsibilities. Now we'll be going through these skills in a clockwise order, so starting with big data frameworks. Now with the rise of big data in the early 21st century, a new framework was born, and that is Hadoop. All thanks to Doug Cutting for introducing this framework. It not only stores big data in a distributed manner, but also processes the data parallelly. There are several tools in the Hadoop ecosystem which cater differently for different purposes and professionals. For a big data engineer, mastering big data tools is a must. Some of the tools which you will need to master, first of all, you have HDFS, which is the storage part of Hadoop. Being the foundation of Hadoop, knowledge of HDFS is a must to start working with Hadoop framework. Next, we have Yarn, which performs resource management by allocating resources to different applications and scheduling jobs. Now, MapReduce is a parallel processing paradigm which allows data to be processed parallelly on top of the HDFS. Next, we have Pig and Hive. Now, Hive is a data warehousing tool on top of HDFS which caters to professionals from an SQL background to perform analytics on top of HDFS. Whereas Apache Pig is a high-level platform which is used for data transformation on top of Hadoop. Now, Hive is generally used by data analysts for creating reports, whereas Pig is used by researchers for programming. Both are pretty easy to learn if you're already familiar with SQL. Next, we have Flume and Sqoop. Flume is a tool which is used to import unstructured data to HDFS, and Sqoop is used to import and export structured data from RDBMS. Now next we have Zookeeper, which acts as a coordinator among the distributed services running in a Hadoop environment. It basically helps to configure management and synchronize services. And finally, we have Oozie, which is basically a scheduler which binds multiple logical jobs together and helps in accomplishing a complete task. Next up, we have real-time processing frameworks. Now, real-time processing with quick actions is the need of hour. Either it is a credit card fraud detection system or a recommendation system. Now, imagine if you wanted a red dress today and Amazon decides to suggest it to you a month later. Now, wouldn't that be completely useless for you? In this case, you need real-time processing. It is very important for a data engineer to have knowledge of real-time processing frameworks. Now, Apache Spark is one of the distributed real-time processing frameworks which is used in the industry rigorously. It can be easily integrated with Hadoop leveraging HDFS as well. Next, we have DBMS. Now, a database management system stores, organizes, and manages a large amount of information within a single software application. Now, data engineers need to understand the database management system to manage data efficiently and allow users to perform multiple tasks with ease. This will help data engineers in improved data sharing, data security, data access, and better data integration with minimized data inconsistencies. These are the fundamentals that data engineers should know prior to building a scalable, robust, and fault-tolerant system. Next, we have SQL-based technologies. Now, there are various relational databases that are used in the industry, such as Oracle DB, Microsoft SQL Server, etc. Now, data engineers must have at least the knowledge of one such database. Now, knowing SQL is also a must. This structured query language, as SQL is also known as, is used to structure, manipulate, and manage data stored in relational databases. As data engineers work closely with RDBMSs, they need to have a strong command on SQL. Now next, we have NoSQL technologies. As the requirements of organizations have grown beyond structured data, NoSQL databases have been introduced into this environment. It can store large volumes of structured, semi-structured, or unstructured data with quick iteration and agile structure as per application requirements. Some of the most prominently used databases are Hbase, Cassandra, and MongoDB. Now, Hbase is a column-oriented NoSQL database on top of HDFS, which is great for scalable and distributed big data stores. It is also great for applications with optimized read and range-based scan, and it provides consistency and partitioning out of CAP. Now, Cassandra is a highly scalable database with incremental scalability, and the best part about Cassandra is the minimal administration and no single point of failure. It's good for applications with fast and random read and writes. It provides available and partitioning out of CAP. And finally, we have MongoDB, which is basically a document-oriented NoSQL database, which is a schema-free database. It gives full index support for high performance and replication for fault tolerance. It has a master-slave sort of architecture and provides CP out of CAP. It is rigorously used by web applications and semi-structured data handling. Next, we are going to discuss programming and scripting languages. So various programming languages can serve for the same purpose. So knowledge of one programming language is enough. I'm saying this because the flavor of language may change, but the logic remains the same. If you're a beginner, you can go ahead with Python as it is an easy language to learn due to its syntax and good community support. Whereas R has a steep learning curve which is developed by statisticians, and it is mostly used by analysts and data scientists. The next skill we're going to discuss is an important one. It is ETL or data warehousing. Now, data warehousing is very important when it comes to managing a huge amount of data coming in from heterogeneous sources where you need to apply extract, transform, and load. Now, data warehousing is used for analytics and reporting and is a very, very crucial part of every business intelligence solution, because this is the part which is going to take you most time. Now, it is very important for a big data engineer to master one data warehousing or ETL tool. After mastering one, it becomes pretty easy to learn new tools and as the fundamentals remain the same. Now, Informatica, ClickView, and Talend are very well-known tools used in the industry. Informatica and Talend Open Studio are data integration tools with ETL architecture. The major benefit of Talend is its support from the big data frameworks. If you're new to data warehousing and ETL tools, I would definitely recommend you start with Talend because after learning this, any data warehousing tools will become a piece of cake. And finally, we have our operating systems. Now, intimate knowledge of Unix, Linux, and Solaris is very helpful, as many mathematical tools are going to be based off of these systems due to their unique demands for root access to hardware and operating system functionality above and beyond that of Microsoft's Windows or Mac OS. Now, some level of understanding of how to act upon this data is also very valuable for data engineers. For this reason, some knowledge of statistical analysis and the basics of data modeling are also hugely valuable. Knowledge of machine learning in cloud also will serve as a big plus. While machine learning is technically something relegated to a data scientist, knowledge in this area is helpful to construct solutions usable by your cohorts. Now, this knowledge has the added benefit of making you extremely marketable in this space as being able to put on both hats, in which case makes you a really formidable tool.
Now, let us quickly start with our first chapter. The first chapter is about learning why exactly we need to test the big data. Most of the users might end up with one question that asks why exactly we need to test the big data. You might have written the queries correct and your architecture might be just fine, yet there might be many possibilities for a failure. Let us assume a classic case of a drastic failure that occurred in a bank. The designers of the bank database wanted to create a phone application which could enable phone banking to the customers. So, the designers of the bank database named the customer name as CN, the customer bank location PIN code as CL, customer ID as CID, and customer phone number as CP. Now, the bank wants to make key value pairs of customer ID, which is CI, and customer phone number, that is CP. In this scenario, the MapReduce algorithm gets messed up between the letters P and L, which is a keypad error or the typing error. Now, the customers won't be getting the OTP and the phone banking facilities. Just imagine this scenario in a real-time situation. Horrible, right? So to avoid such mistakes in real time, we prefer the big data testing. Now we shall understand what exactly is big data testing. So big data testing can be defined as a procedure that involves examining and validating the functionality of big data applications. The big data is a collection of a huge amount of data that traditional storage systems cannot handle. Testing such a huge amount of data would take some special tools, techniques, and terminologies which will be discussed in the later section of this tutorial. Followed by this, we shall understand the strategies behind testing the big data. Testing an application that handles terabytes of data would take the skill from a whole new level and out-of-the-box thinking. The core and the important test that a quality assurance team concentrates is based on three scenarios, namely batch data processing test, real-time data processing test, and lastly, the interactive data processing test. So what exactly is batch data processing test? The batch data processing test involves test procedures that run the data when the applications are in batch processing mode, where the application is processed using batch processing storage units such as HDFS. The batch data processing test involves test procedures that run the data when the application is in batch processing mode. In this, the application is processed using batch processing storage units such as HDFS. The batch processing test mainly involves running the application against faulty inputs, varying the volume of the data. Now, next comes is the real-time processing test. The real-time data processing test deals with the data when the application is in real-time data processing mode. The application is run using the real-time processing tools such as Spark. Real-time test involves application to be tested in the real-time environment and it is checked for stability. And the last one is interactive data processing test. The interactive data processing test integrates the real-time test protocols that interact with application as in a view of the real-life user. The interactive data processing mode uses interactive processing tools such as Hive SQL. Now moving ahead, we shall understand the different forms of big data. So there are three main forms of big data, which are structured format, semi-structured format, and unstructured format. Firstly, we shall understand what is the meaning of structured data. Any tabular data which is meaningfully organized under rows and columns with easy accessibility is known as structured data. It can be organized under named columns using different storage units such as an RDBMS. For example, any tabular data stored in an RDBMS. Now, we shall understand what is semi-structured data. Semi-structured data lies perfectly between structured and unstructured data. It cannot be directly ingested into an RDBMS as it includes metadata, tags, and sometimes duplicate values. Data needs some operations to be applied on it before the data is ready to be ingested. For example, .csv format and .json format. Now lastly, we shall understand what exactly is unstructured data. Data that does not obey any kind of structure is known as unstructured data. Unlike the structured data, the unstructured data is difficult to store and retrieve. Most of the data generated by organizations is unstructured type of data. For example, image files, video files, and audio files. Now we shall understand the big data formats in a little detailed way, where we have the examples for structured, semi-structured, and unstructured. Firstly, we shall deal with the structured data. So the structured data is available from the sources like data warehouses, databases, ERP, and CRM. Now when we enter into semi-structured data, we find the sources from .csv files, .xml files, .json files. And finally, we come into the unstructured data, and the sources for the unstructured data are audio files, video files, and image files. Now we shall move ahead and understand the big data testing environment. Owning a perfect environment for testing big data applications is very crucial. The basic requirements for big data testing are as follows. Firstly, space for storing, processing, and validating terabytes of data should be available. Then, the cluster and its respective nodes should be responsive. And lastly, the data processing resources such as a powerful CPU should be available. Now with this, let us enter the big data testing. So the general approach in big data testing involves three stages. Firstly, the data ingestion stage. In the data ingestion stage, the data is first loaded from the source to the big data system using extracting tools. The storage might be HDFS, MongoDB, or any other similar storage. Then the loaded data is cross-checked for errors and missing values. The basic example for data ingesting tools is Talend. Followed by the data ingestion phase, we have data processing phase. In this stage, the key value pairs for the data get generated. Later, the MapReduce logic is applied onto the nodes and checked if the algorithm works fine or not. A data validation process takes place where we make sure that the output generated is as expected. And finally, the last stage is about the validation of the output. At this stage, the output generated is ready to be migrated from the data warehouse. Here, the transformation logic is checked, the data integrity is verified, and the key value pairs at the location where the data needs to be dumped is validated for accuracy. So these are the three phases in which the big data is tested. So with this, let us enter the next chapter where we will deal with the different categories in which a big data application can be tested. Firstly, unit testing. Unit testing in big data is completely similar to any other unit testing in similar applications. The complete big data application is divided into segments, and each segment is rigorously tested with multiple possibilities for an expected outcome. If any segment fails, then that particular segment is sent back to the development stage for improvements. Now, after unit testing, we enter functional testing. Functional testing can be otherwise called as different phases in testing the big data application. The big data application is designated to deal with huge blocks of data. Such a huge volume and variety of data is often prone to bring data issues such as bad data, duplicate values, metadata, missing values, and whatnot. This is exactly why the pioneers in testing the big data designed the procedure for functional testing of big data. The different phases in which the big data is tested are as follows. Firstly, the validation phase. Data validation phase deals with the business logic and the layers of big data application. The data is collected from the source and it is run against the business use case. Data collected is checked for accuracy and movement through the different layers of the application. At this stage, the big data is tested with aggregation and filtering mechanisms. The data undergoes end-to-end validation and transformation logic based on business rules. The next stage is data integrity phase. Data is checked for completeness with referential integrity validation. Data constraints and duplication is verified against error conditions. Boundary testing recognizes schema limits for each layer in integrity phase. The next phase is data ingestion phase. This is a very important phase where the data gets ingested into the Hadoop ecosystem. The ability of the application to connect with different data modules is checked here. The data is replayed with messaging systems and loss of data is monitored. The main motto of this phase is to achieve the following qualities. Firstly, fault tolerance, then continuous data availability, and lastly, stable connection with a variety of data streams. Followed by data ingestion phase, we have data processing phase. The data processing phase carefully examines and executes the business logic. The business rules are cross-validated. The MapReduce logic is validated at every stage. Data is processed from end to end. The application is checked for exceptions and they get perfectly handled. Followed by the data processing phase, we have the data storage phase. The data storage phase concentrates on the following parameters, which are the read and write timeouts, continuous data availability, load balancing, and finally the query performance analysis. After all these stages, we have one final stage which is called the report generation phase. It is the final stage in functional testing and it deals with the following: data validation for measures and dimensions, real-time reporting, data drill up and data drill down mechanisms, and lastly, the business reports and chats. So this was the functional testing. Now let's move ahead and understand non-functional testing. The non-functional testing phase takes care about three major dimensions and characteristics of big data, which are the volume, velocity, and variety of big data. There are 5 stages involved in non-functional testing, which are data quality monitoring, infrastructure, data security, data performance, and failover testing mechanism. Firstly, we shall understand data quality monitoring. Data quality monitoring checks for erroneous data, records, and messages. Data quality monitoring makes sure that the following parameters about the data are available, which are the data accuracy, data precision, data timeliness, data consistency, data profiling. Now, the next stage is the infrastructure. The infrastructure makes sure that there is a continuous service availability in both external big data processing applications and internal big data processing applications. Infrastructure also takes care about the data replication factor, data backup, and data restore point. Followed by the infrastructure, we have the data security. Data security is called to be the most important aspect of the big data application. Data security stage protects the sensitive data. It manages user authentication and checks user role-based authorization. Data security also takes care about the data encryption and masking of personal information. Followed by data security, we have data performance. Data performance evaluates every single component. It evaluates maximum data processing speed, evaluates maximum data capacity size, checks the message transfer speed and response time, calculates the number of operations performed per unit time, engages parallel job monitoring, and finally performs read, write, and update operations on real-time databases. And lastly, we have failover test mechanism. Failover test mechanism ensures seamless data processing while switching to neighboring data nodes. It creates data recovery points and parallelly, it will be ready for any unexpected calamities. Failover test mechanism will be ready to replay the data using multiple offsets. It enables dynamic clustering. With this, let us move ahead into the next type of testing, which is based on the performance testing. Performance testing highly concentrates on the performance delivered by all the components in the big data system. Performance testing includes the following categories. Firstly, the data collection phase, data ingestion phase, data processing phase, and finally, component testing phase. Firstly, we shall understand what is data collecting phase. In this stage, the big data system is validated based on its speed and capacity to grasp the data within the given frame of time. Data can be collected from different sources such as RDBMS, databases, data warehouses, and many more. The next stage deals with the data ingestion. Here, the application is tested and validated based on its space and capacity to load the collected data from the source to the destination, which might be HDFS, MongoDB, Cassandra, or many other similar storage units. Followed by the second stage, the third stage is data processing stage. Here, the application is tested based on the MapReduce logic written. The logic is run against every single node in the cluster, and the processing speeds are validated. The queries to be executed are expected to perform with high speeds and low data latency. And finally, we have the component testing. This stage is related to the component performance. Each component in the system should be highly available and connected. The component backup should be online when any node fails. High capacity data exchange should be smoothly supported. Now with this, let us move ahead and understand the performance testing approach. The performance testing approach can be understood through the following flow diagram. Firstly, the procedure begins by establishing a big data cluster and running the application. Later, the big data developer designs the workload required to run the test. Then in the next stage, we involve the clients into the test and take their feedback. After that, execute the application with data and analyze the results. And now, if we find the application to be performing with optimum stability, then the process is finished. Else, we apply the required modification and retest the application. So this is the performance testing approach. Now, followed by this, we shall understand the parameters involved in performance testing. So the parameters involved in performance testing are data storage. Data storage takes note of the orientation in which the data gets stored in the system. Followed by that, we have commit logs, which marks the limits for committing logs. Followed by that, we have the concurrency, which checks the number of threads allocated for the read and write process. And next to the concurrency, we have caching. Caching includes dedicated row cache and key cache. And finally, we have timeouts. The timeouts set the timeouts for the application, which are related to the connection and queries, etc. Followed by the performance testing, we have architecture testing. Architecture testing concentrates on establishing a stable Hadoop architecture. The Hadoop architecture of big data processing application plays a key role in achieving smooth operations. Poorly designed architecture leads to chaos, which might be performance degradation, node failure, high data latency, and may require high maintenance. So these were the chaos which may show up if you have a poor architecture in your big data application. Followed by this, we shall understand the big data testing tools. So the big data testing tools are majorly classified into 4 categories. Firstly, big data ingestion tools, then big data processing tools. Followed by that, we have the big data storage tools, and lastly, we have big data migration tools. Now we shall look at the examples based on each one of them. Firstly, the big data ingestion tools. Zookeeper, Kafka, and Sqoop are the best examples for data ingestion. Next, we have data processing, and the popular tools used in big data processing are MapR, Hive, and Apache Pig. The next kind of tools are the data storage tools. The most famous examples for data storage are Amazon S3 and HDFS. Finally, we have the data migration tools, and the popular examples for data migration are Talend and 𝐶𝐿OVE-DX. Now with this, we shall move ahead and understand the challenges faced in big data testing. So the key challenges faced in big data testing are: big data testing is highly complicated and the process requires highly skilled officials. Automated big data testing procedures are predefined and they are not suited for unexpected errors. Virtual machine latency creates latency in tests and managing multimedia is a big hassle. Followed by that, the volume of the data is one major challenge for big data testing. The testing environment and automation should be developed for different platforms. Each component is from a different technology as it requires isolated testing. No single tool can perform end-to-end testing. Followed by that, high degree of scripting is required for designing test cases. And finally, customized solutions are required to increase performance and test in critical areas. So with this, we shall move ahead into the last topic, which deals with the difference between traditional testing and big data testing. So the first difference is the big data testing supports all type of data testing, whereas the traditional testing supports only structured testing. The next difference between the both is big data testing requires research and development, whereas in traditional data testing, we don't require research and development. The third difference is the data size is unlimited in big data testing, whereas the data size is limited in traditional testing. Followed by the third difference, we shall enter the fourth difference, which says big data testing requires special environment. But whereas the traditional testing doesn't require any kind of special environment. So now we shall enter into the last difference, which says only highly skilled and qualified candidates can perform big data testing. But when it comes to traditional testing, the basic operations knowledge is enough to run the tests.
Let's take a look at the various application domains that big data offers to the industries. As big data is growing at an exponential rate, various fields in day-to-day life are using big data to ease the process of storing and processing the data. So here I have listed few of the sectors that have been implementing big data like healthcare, education, e-commerce, government, IoT, and even in media and entertainment. Now, let's look at each of these domains in depth. First, let's see how big data is used in healthcare industries. Guys, you all know that there is a huge amount of data generated in healthcare industries, and that data includes patient records, transactions, research data, and many more. So, traditionally what happened? They failed to use the big data. Why? Because they had the limited ability to store and consolidate the data. Okay, I got a query from Piyush. He asks how big data analytics has improved healthcare industries. Thank you, Piyush, for this question. I'll explain you how. Big data analytics have improved the healthcare by providing personalized medicine and prescriptive analytics. Not only that, but also the researchers are mining the data to see what kind of treatments are more effective for particular conditions, and based on that, they identify the patterns that are related to drug side effects and then provide the solution that can help the patients and reduce the cost. And also on adoption of mHealth, eHealth, and wearable technologies, the volume of data is increasing, and that includes electronic health records data, CRM data, that is customer relationship management data, fitness trackers, historic patient, research data, purchase data, and many more. So now let me tell you why demographic data plays a vital role in healthcare industries. Here what we do is we map the healthcare data sets with the geographical data sets. And by doing that, it's possible to predict the disease that will escalate in specific areas. And based on these kind of predictions, it is very easy to strategize the diagnostics and then plan for stocking serums and vaccines. So this is how big data analytics has enhanced the healthcare industries. Now let's see how big data is used in real-world clinical analytics. Healthcare industries wanted to replace their legacy data warehousing solution with a data lake that could manage high volumes of data. In order for this, healthcare industries selected a company called CTS Tech, which is a specialist provider for healthcare, to build the solution. So CTS Tech designed the solution based on Cloudera Hadoop distribution, MapReduce, Spark streaming, and other Hadoop technologies. So here is how it works. Here we have diagnostic results and billing messages. This is nothing but the data source from where we get the data. And this data is injected into the data ingestion stream, wherein it undergoes Spark streaming and produce real-time data streams. And these real-time data streams are capable of processing 20,000 records per second. And they are then landed onto the Cloudera landing zone, wherein it undergoes deduplicating, cleansing, and standardization of the data. And once deduplicating, cleansing, and standardization of the data is done, it is then processed using MapReduce job and data processing stream. And this processed data is queried using Cloudera Impala. Now we populate and store the messages from Cloudera Impala into IBM Unified Data Model for healthcare organization. And from there we visualize the results and dashboard, and then we arrive at the solution. So this is how CTS Tech has used big data analytics and provided the solution in real-world clinical analytics. Now let's see how big data is used in education sector. Big data is revolutionizing the way we manage education sector. So how is it doing that? Here I have jotted down few of them. First, let me tell you how it is used in improving evaluation of student results. Guys, can you guess what is the only way to assess the performance of a student? The only measurement of the performance of a student is the answers that they write to assignments and exams, correct? So however, during his or her life, each student generates a unique data trail. And analyzing this data trail in real time, one can understand the individual behavior of students, and that helps to create an optimal learning environment for the students. And also, it is possible to monitor student actions such as how long they take to answer a question, which sources they use for exam preparation, which questions do they skip, and many more. So by considering all these factors, one can improve the evaluation of student results. Next, analyzing and creating the custom programs. You all know that we have lakhs of students from each and every universities, but customized programs for each and every individual student can be created. Everyone wondering how? That is possible with the help of a technique that is called as blended learning. Confused? What is this blended learning? It is very simple. It is just a combination of online and offline learning. And that gives the students the opportunity to follow the classes that they are interested in. And also they have the possibility for offline guidance by professors. Next, how big data helps us to reduce the dropout rates. As we have already discussed that it would help to improve the evaluation of student results, it's an obvious fact that the dropout rates at schools and colleges would also reduce. So what does educational institutions do? They use predictive analytics on all the data that is collected to give them insights on future student outcomes. And such kind of predictions will also help to run a scenario analysis on a course or a program before it is introduced into the curriculum. And this minimizes the need for trial and error. Next, now let's see how to compute the marks of students. Let me take an example here. Say, let me take attendees' names itself. Consider Priyat scores 90 marks in mathematics and 60 in geography, but Chaitra scores more in geography and less in mathematics. So what does Big Data Analytics do? It helps to combine and analyze all the data of students, and based on that, importance can be given to each of the students who lack the scores and also to give an insight about how to improve the performance. So these are the various ways where we use big data analytics in education sector. Now let's see a case study of IBM in education. It is used to monitor individual student performance, to prevent attrition from a course or a program. Next, to identify outlines for early intervention, to identify and develop effective instructional techniques, for testing and evaluation of curriculum. Now let's see how IBM has used big data analytics in learning analytics flow model. Here we capture instructional transactions as they occur. And these instructional transactions occur in a time-sensitive learning application. And this would be actually possible within a learning management or a course management system. And we use full capabilities of a learning management system and then generate a 15-week online course. And this 15-week online course would generate thousands of transactions per second. And then we perform real-time analysis on these transactions, and that would be used to feed a learning analytics app. And to process all these data, we need a big database system. Without the help of analytics software, it is not possible to process the data in big database system. So we use Apache Spark for data processing, and then we analyze the transactions and establish a pattern, and then we arrive at decisions and course of action. And these decisions and course of action is then introduced into a curriculum or a course management system. So this is how IBM has made use of big data analytics in learning analytics flow model. Now let's see how big data is used in e-commerce industries. Big data is a game changer when it comes to retail and e-commerce. Retailers and e-commerce brands are using more of analytics to drive strategic action and offer better customer experience. So these are few of the usages. First, it is used to predict the trends. In order to predict the trends, we used a trend forecasting algorithm. And this trend forecasting algorithm combines the data from social media posts and web browsing habits to identify what is causing a buzz. And also to know which product is discussed more of online, we perform sentiment analysis task. And based on sentiment analysis and trend forecasting algorithm, it is very easy to predict the trends in the market. Next, optimize pricing. Big data enables retailers to identify best price for goods by tracking transactions, competitor, and cost of goods. And not only that, but retailers can also map the rise and fall of demand and match the pricing accordingly. Now, let's see how analytics has enhanced Amazon to forecast its demand. Analytics enables Amazon to predict the traffic on the website along with the possible conversion rate. And through the Amazon Web Services Cloud, the business has the flexibility to scale up in a real time. So as it can scale up in a real time, analytics enables Amazon to forecast its demand. Next, how one can create a personalized store. We have something called as fast web server technologies. And this fast web server technologies in combination with big data, businesses can generate dynamic websites that are filled with relevant products based on the historic behavior of a consumer and their personal preferences. So by grouping the personal preferences and the historic behavior of a consumer, one can create a personalized stores. Next, customer service. Customer service is available 24/7 in all the e-commerce industries. So big data analytics allows business to optimize this customer service. And how does it do? It compiles the data from previous online and offline transactions, social media information, purchase history, and many more. And by this, businesses can create a 360-degree view of the customer, and based on that, they provide enhanced customer experience. Next, sales generation. The main motto of all the e-commerce industries is to sell their goods and products. And retailers use big data to offer a personalized experience and prevent potential abandonment. So by this, we can have more number of sales generated. So these are few of the usages in e-commerce industries. Let's see a real-time use case in e-commerce. Here we have a user. User communicates with the e-commerce server portal in data stream. Here, the data is collected from various sources, and that includes customer information, purchase history, reviews, and many more. And we have something called as input selection module to remove the noise from the data. So this input selection module is based on two factors. One, singular value decomposition. Second, dimensionality reduction. So what is the singular value decomposition? It is nothing but the technology that is used to speed up the recommendations with very fast online performance, and that requires just few simple arithmetic operations. So the data which is used to speed up the online performance is selected. Next, what is dimensionality reduction? Here we reduce a number of random variables under consideration that are not required in the data. So based on these two factors, the input selection module removes the noise from the data. So this noise-free data is fed as an input to HDFS input in Hadoop stream. And that input undergoes MapReduce job and produces HDFS output. The data that we get after applying MapReduce job is ready for analyzing. So in the data analytics stream, we use our tool to analyze the data, and from there we arrive at textual and graphical reports, and they are nothing but the reports that are used in prediction of trends, forecasting demand, and in sales generation. Now let's see how government sector has made use of big data analytics. In government use cases, the same data sets are often applied across multiple applications, and that requires multiple departments to work in collaboration. Okay, I got a query from 𝐂𝐿𝐺. She asks why big data analytics is needed in cybersecurity and intelligence. 𝐂𝐿𝐺, I'll surely tell you, but for now, let's see how it is used in traffic optimization. Big data helps to aggregate the real-time traffic data generated from road sensors, GPS device, and video cameras. The potential traffic problems in dense areas can be prevented by adjusting public transportation routes in real time. 𝐂𝐿𝐺, now I will tell you why it is used in cybersecurity and intelligence. You all know that the cyber attacks are increasing in volume and complexity, and that's becoming a tedious task for traditional analytics tools. But companies have to protect themselves against all kinds of attacks, and they also need to be able to detect and respond fast. So it's nothing but a PDR paradigm, that is prevent, detect, and respond. And in order to prevent, detect, and respond at a faster rate and quickly, there comes the big data analytics approach. And these challenges can be prevented and overcome with the help of big data analytics. For example, you can say it is used in enterprises to fight against cyber threats. I hope you got an idea about it, 𝐂𝐿𝐺. Now let's see how it is used in crime prediction and prevention. Police departments use advanced and real-time analytics to understand the criminal behavior, identify crime, and uncover location-based threats. Next, weather forecasting. The National Oceanic and Atmospheric Administration gathers every minute of every data from land, sea, and space-based sensors. And on a daily basis, National Oceanic and Atmospheric Administration uses big data to analyze and extract value from over 20 terabytes of data. Next, drug evaluation. The National Institution of Health uses big data technologies to access large amounts of data to evaluate drugs and treatment. Next, tax compliance. Big data applications can be used by tax organizations to analyze both unstructured and structured data from a variety of sources in order to identify suspicious behavior and multiple identities. This actually helps in tax fraud identification. So these are the various sectors where big data is used in government. Now, let's see how it is useful in e-government portal. So what is this e-government portal? It is an application that uses electronic communication devices, computer, and the internet to provide public services to citizens and the other people. So citizen or enterprise user use certain services via e-government portal. So these user requests are sent to big data infrastructure in order to be processed. And this big data infrastructure has a database that is not centralized, and hence it integrates with database of different ministries, government agencies, and local authorities. So both the databases are then deployed to cloud infrastructure, and in this solution we use cloud infrastructure to reduce the cost for storage. And here we have Hadoop framework to process the data. We run Pig and Hive queries on a Hadoop data platform and then store this data into HDFS, and then the response is sent back. So now let me tell you the workflow. Use a sensor request to the network using an appropriate interface. In this case, the appropriate interface is nothing but the web application that he interacts with. And the request is then forwarded to big data, and the processing happens using these technologies, and hence the response is sent back. So this is the internal working that happens, but for the user, when he communicates or interacts with the web application, he gets a response immediately. So this is how big data analytics is used in e-government portal. Now let's see how big data is used in IoT. Data extracted from Internet of Things devices provides a mapping of device interconnectivity. Such mappings have been used by various companies and governments to increase the efficiency. And IoT is also increasingly adopted as a means for gathering sensory data. And this sensory data is used in Medicare, industry, retail, vehicles, communication, and many more. So IoT represents the connected devices. But as there is an enormous amount of data, these devices are connected through IoT, and big data technologies is used to store and process this huge amount of data. Let's take a look at the smart city concept. The combination of IoT and big data is an unexplored research area that has brought new and interesting challenges for achieving the goals of future smart cities. You might have heard of Amsterdam, right? It is the pioneer in the concept of smart city. Now, you might be wondering how it has introduced the concept of smart city. Amsterdam has introduced the concept of smart city in smart government, smart health, smart retail, smart agriculture, and many more. I got one more query here, and this query is from Gino. He asks how Amsterdam has implemented the concept of smart city in smart home. Gino, I will explain you now. In case of smart city, they use a wearable technology. That is, any person in the home can wear the fitness band, that is a wearable technology. And the techies have programmed and integrated this smart thing in such a way that when the person wakes up, the lights will automatically turn on and the coffee machine starts to brew the coffee. And it is vice versa. When the person who is wearing the fitness band goes back to sleep, the light turns off. I hope you got an idea about it, Gino. Now let's move further. In this case, various smart applications exchange information using embedded sensor devices and other devices that are integrated with cloud computing infrastructure to generate large amounts of unstructured data. And these large amounts of unstructured data are collected and stored in a cloud or a data center using a distributed fault-tolerant database, that is NoSQL. and that is used to improve the single service or application and is shared among various devices. And we also have a programming model for processing large data sets with the parallel distributed algorithm, and that can be used for data analytics to obtain the value from the data. Here we have query engine like Hive and Mahout to query and structure the data. So this is how cloud and big data both are used in the smart city concept. Last but not the least, let's see how big data is helpful in media and entertainment. Various companies in the media and entertainment industries like publishers, broadcasters, cable companies, YouTubers are facing new business models for the way they create, market, and distribute their content. And that is happening because of the current consumer search and the requirement of accessing this content anywhere, anytime, and on any device. And big data provides actionable points of information about millions of individuals. And all these insights are gathered through various data mining activities. And big data applications benefits media and entertainment industry by media scheduling, ad targeting, content monetization, audience interest, customer churn prevention. So now let me tell you how to prevent a customer churn. Customer churn is a serious menace that media companies find almost impossible to tackle, and it has been found that at least 30% of the customers share their views through social media. And until big data arrived, combining and making sense of this user data was next to impossible. And with the advent of big data analytics, it is possible to know why customers subscribe and unsubscribe and what kind of programs they like, dislike with crystal clear clarity. So by analyzing all these factors, it is very easy to prevent the customer churn. Let's take a look at the Netflix example in big data. Netflix has tons of user data present in its database system. And this data is processed and analyzed, and we recognize the patterns for that. And here we have a new user request. And this user comes and search for a video in the Netflix search engine. And based on the video preferences and the user choice, we rank the video and also we give user experience. And then we continue to watch the trending video and we arrive at video similarity algorithm. So now let's see how the decision is made and the video ranking is being given. This is decision making Netflix data framework. Netflix uses Cassandra because it is highly scalable and strong on performance. Here we have Cassandra, that is a NoSQL database, and it is used by Netflix because it is very strong on performance. And we have Priam, that is a Cassandra helper tool, and also it is a Netflix cluster management tool that simplifies the Netflix administration, and it also uses API to query the Cassandra metrics. And next we have HDFS tables. The query data is stored in HDFS table in a table format. And we have 𝐂𝐳𝐺𝐿, that is a platform built by Netflix engineer to work on Hadoop MapReduce. And this 𝐂𝐳𝐿 converts the Cassandra S3SS tables into queryable format. And we have S3JSON, that is a JavaScript object notation, and that is used to structure the query data. And hence, based on all these factors, the decision is made and the video ranking is being given. So if you go back, you continue to watch the trending video and you get the video similarity algorithm. So this is how Netflix has used big data analytics. Now let's move further and see the scope of big data that will create a havoc in the near future. First, 6x growth. It's obvious fact, the amount of data that will be generated in the next 5 years will be 6x times more than that what was generated in the past 5 years. So imagine we'll be having huge amount of data. And not only that, but also the Hadoop adoption is growing at 29 times more than that of US GDP. Next, an open source supernova. Let me bring out the comparison here. In 1998, only 10% of the companies used to use open source networks, and that gradually increased to 50% in 2011. And now, 78% of the companies use open source softwares, and in the next years, entire 100% of the companies use open source softwares. And these advancements is because of the growth of big data in the market. Next, why it is termed as meteoric innovation. You all know that in 2008, there were more things connected to the internet than people. And now, IoT devices represent over 6.48 billion devices connected. And in 2020, the IoT market will connect to over 21 billion devices. And by 2030, self-driving cars will rule the roads of the world. And that is why it is termed as a meteoric innovation. The next, 3x increase in profit. Based on the above three terms, that is 6x growth, open source softwares, meteoric innovation, it is an obvious fact that as the technologies evolve, the growth will be evolved, and that leads to 3x increase in profit rate as well. So in the next few years, the profit rate will tend to increase to 3x times more than that what it is there in today's world. So this is why we say that big data is going to create a havoc in the near future.
Why do you think big data analytics is so important, and why do you feel that we need to study this topic, or we should know what exactly it is? So now let me tell you why. So just like the entire universe in our galaxy said to have formed due to the Big Bang explosion, similarly, data has also been growing exponentially, which is leading to the explosion of data. So this can simply be termed as big data. And do you know that we are creating about 2.5 quintillion bytes of data every day? And 1 quintillion amounts to around 10 raised to the power of 18 bytes. So you can do the math and imagine the amount of data that we are creating every day. And this data, as you can see from the image that I've depicted here, is coming in from various sources, whether it is from social media, from banking sectors, from governments, from various other institutions, all right? And this data is not in the same format. So it is coming from various sources, so it is in different formats. So now, guys, what do you think? That is big data only limited to the volume or the enormous amount that is being generated? Or does it define with various other characteristics that, exactly define what big data is? So I have put down 4 such reasons here to tell you that why it is so important and how it is helping many organizations all around the globe. So the first reason here that I've stated is for making smarter and more efficient organizations. So big data analytics is basically highly contributing to these factors, and organizations are adopting this to basically lead them to faster decision making. So one such example that I came across that I wanted to share with you guys is about the New York Police Department, in short, which is the NYPD. So big data and analytics are helping the NYPD and the other large police departments to anticipate and identify the criminal activity before it occurs. So what they do is that they analyze the entire big data technology to geolocate and then analyze the historical patterns. And they map these historical patterns with sporting events, paydays, rainfalls, traffic flows, and federal holidays. So essentially what the NYPD is doing, that they're utilizing these data patterns, scientific analytics, technological tools to do their job. And they're ensuring that by using these different tools, they're doing their job to the best of their ability. So by using a big data and analytics strategy, the NYPD was able to identify something called crime hotspots. So basically where crime occurrence was more. So they were able to identify these hotspots, and then from there they deployed their local officers so that they could reach there on time before it was actually committed. So this is how NYPD basically utilizes entire, this field of big data analytics so that they can prevent crime and make New York a more safer place. So now, after exploring the first reason, let's move on to the second reason and see what is it. So the second reason here is to optimize business operations by analyzing customer behavior. So the best example for this is Amazon. We all know how much Amazon is popular and how much we use it on our daily basis. So Amazon basically uses our clickstream data, that is the customers. So they use our clickstream data and the historical purchase data of more than 300 million customers which have signed up for Amazon, and then they analyze each user's data, how they are clicking on different products and how they're navigating through their site. So basically they show each user customized results on customized web pages. So after analyzing all these clicks of every visitor on their website, they're able to better understand their site navigation behavior, the paths that people are taking to buying their products and services, and what else a customer looked on while buying that product, and also the paths that led a customer to leave their page. So this information basically helps Amazon to improve their customer experience and hence expand their customer base. So guys, let's see what the third reason is now. So big data technologies like Hadoop and cloud-based analytics, they basically reduce your cost significantly for storage of big data. Because for storing big data, if you buy like huge servers and huge machinery, so that is going to cost you a lot. So by using Hadoop technology, so what Hadoop does basically, it stores big data in a distributed fashion so that you can process it parallelly. So it reduces your cost a lot. So by using commodity hardware, they are reducing their costs significantly. So which brings us to our third reason. You must have gauged what the third reason is. It is cost reduction. So now let us see how healthcare is using big data analytics to curb their costs. So using new data tools that send automatic alerts when patients are due for immunizations or lab work, more and more physicians could reduce the hospitalizations by practicing better preventive care. So you know what? The patients started using these new sensor devices at home and on the go. So these new sensor devices, they basically, deliver constant streams of data that can be monitored and analyzed in real time. So they help the patients avoid hospitalization by self-managing their conditions. Now, for hospitalized patients, physicians can use predictive analytics to optimize outcomes and then reduce the readmissions. So Parkland Hospital in Dallas, Texas is one such example, which has been using analytics and predictive modeling to identify these high-risk patients. And then they predict likely outcomes once the patients are sent home. So as a result, Parkland has been able to reduce its 30-day readmissions back to Parkland and all area hospitals for Medicare patients with heart failure by around 31%. So for Parkland, that estimates about a savings of $500,000 annually, and of course, not to mention that the savings which patients are also realizing by avoiding these readmissions. So this is how healthcare is widely using big data analytics to reduce their costs significantly. Now let's move forward to see the last reason for why big data analytics is so essential. So our last reason is next generation products, that how big data analytics is really contributing to generate more such high tech products. So to see how customers needs can be satisfied and how they can use these new generation products for their own benefit. So I have cited three such examples here for you guys. So the first example here is Google self-driving car. I'm very sure that most of you guys must have heard about it. What Google self-driving car basically does is it makes millions of calculations on every trip that help the car decide when and where to turn, whether to slow down or speed up, and when to change their lanes. So the same decision a human driver is making behind the wheel, Google self-driving car is also doing that with the help of big data analytics. Another example of a self-driving car is the Toyota Prius, which is fitted with cameras, GPS, as well as powerful computers and sensors to safely drive on the road without the intervention of human beings. So this is how it is, really contributing to making such high-tech products, which in the long run we'd be using probably, and it will make our life more easier. Now, moving on to the second product that I'm going to cite here. So it's a really fascinating product. Let me ask you a question. How many of you all love watching TV shows? And how many of you all prefer spending your weekends doing nothing but Netflix and chill? Let me guess. Almost all of us do. I mean, I love binge watching shows over the weekend. So I know by now you would have guessed what example I'm arriving to. So it is Netflix. So Netflix committed for 2 seasons of its extremely popular show House of Cards without even seeing a single episode of the show, guys. And this project of, House of Cards of 2 seasons, it costed Netflix about $100 million. So guys, how do you think that Netflix was able to, take such a big risk monetarily? So the answer to this, my friends, is big data analytics. So by analyzing the viewer data, the company was able to determine that the fans of the original House of Cards, which aired in the UK, they were also watching movies that starred Kevin Spacey, who is playing the lead in the show House of Cards, and they were directed by David Fincher, who's also one of the show's executive producers. So basically, Netflix is analyzing everything. So from what show you are watching to when you pause it or to when even you turn it off. So last year, Netflix grew its US subscriber base by around 10%. And then they added nearly 20 million subscribers from all around the globe. So how fascinating is that? I mean, this is brilliant. I am sure that the next time you guys are watching a show on Netflix, you'll be really happy because you already know how the backend is working and how Netflix is recommending you new shows and new movies. So now moving on to the third example that I've cited here. So it's one of the really cool things that I've come across. So this is a smart yoga mat. Now this has sensors embedded in the mat which will be able to provide feedback on your postures, score your practice, and even guide you through an at-home practice. So the first time you use your smart mat, it will take you through a series of movements to calibrate your body shape, size, and personal limitations. So this personal profile information of yours is then stored into your smart mat app, and this will help the smart mat detect when you're out of alignment or balance. So over time, it will automatically evolve with updated data as you improve your yoga practice. So now I'm sure that with these, very interesting and exciting examples, you would have got an idea about what exactly big data analytics is doing and how it is improving various organizations in their sales and marketing sector. So now let's move forward and finally, formally define what big data analytics is. So guys, what is big data analytics? Big data analytics examines large and different types of data to uncover hidden patterns, correlations, and other insights. So basically what big data analytics is doing, it is helping large companies to facilitate their growth and development. So this majorly involves applying various data mining algorithms on a given set of data, which will then aid these organizations in making better decisions. So now that you know why we need big data analytics, what is exactly big data analytics? Now let us see and explore what are the different kind of stages which are involved in this procedure of big data analytics. So these are the different stages involved in this entire procedure. So the first stage is identifying the problem. So what is our problem that we need to solve? This is the most important step, of course, and this is the first step of the process. The second step is to design our data requirement. So of course, after identifying the problem, we need to decide what kind of data is required for analyzing this particular problem. The third step is pre-processing. So in the pre-processing step, basically cleaning of data takes place and you perform some sort of processing. Now, after the processing stage, we come to the fourth stage, which is the analytics stage. So in this stage, you would be basically analyzing the processed data using various methods. After the analytics stage, we'll move to the final stage, which is data visualization. So in visualization of data stage, you will basically visualize the data using tools like Tableau, AngularJS, but the visualization of data will only take place in the end. So these are the basic 5 stages in this entire procedure. Now that you've understood this, let's move forward and understand what are the different types of big data analytics. So there are 4 basic types. One is descriptive analytics, second is predictive analytics, third is prescriptive analytics, and fourth is diagnostic analytics. So let us understand the first type, which is descriptive analytics. So descriptive analytics basically answers your question, what has happened? And how does descriptive analytics answer this question? It uses data aggregation and data mining techniques to provide insight into the past, and then it answers what is happening now based on the incoming data. So basically, descriptive analytics does exactly what the name implies. It describes or it summarizes the raw data and it makes it something which is interpretable by humans. And the past, which I just referred in this context, it basically can be 1 minute ago or even a few years back. So the best example that I could cite here for descriptive analytics is basically the Google Analytics tool. So Google Analytics basically is aiding organizations or different businesses by analyzing their results through Google Analytics tool. So the outcomes that help the businesses understand what actually has happened in the past, and then they validate if a promotional campaign was successful or not based on the basic parameters like page views. So basically, descriptive analytics is therefore an important source to determine what to do next. Another example is what we saw earlier in the new generation product, which is Netflix. So Netflix basically uses descriptive analytics, as I told you guys, to find the correlations among the different movies that a subscriber is watching. And to improve their recommendation engine, they use historic sales and customer data. So this is what descriptive analytics is. Now let's move forward to the second type, which is predictive analytics. So the second type, which is predictive analytics, basically uses statistical models and forecast techniques to understand the future and answer what could happen. So basically, as the word suggests, it predicts. We are able to understand through predictive analytics that what are the different future outcomes. So basically, predictive analytics provides the companies with actionable insights based on the data. So through sensors and other machine-generated data, companies can identify when a malfunction is likely to occur. So then the company can preemptively order parts and make repairs to avoid downtime and losses. So an example of this type of analytics is the Southwest Airlines. So Southwest analyzes their sensor data on the planes to identify the potential malfunctions or safety issues. So basically, this allows the airline to address the possible problems and then make repairs without interrupting the flights or putting the passengers in danger. So this is a very great use of, predictive analytics to how basically reduce their downtime and losses, and as well as, prevent delays and various other factors like accidents. So now let's move forward to the third reason, which is prescriptive analytics. Prescriptive analytics uses optimization and simulation algorithms to advise on the possible outcomes and answer the question, what should we do? So basically, it allows the users to prescribe a number of different possible actions and then guide them towards a solution. So in a nutshell, these analytics are all about providing advice. So prescriptive analytics, they use a combination of techniques and tools such as business rules, algorithms, machine learning, and computational modeling procedures. So then these techniques are applied against input from many different data sets, including historical and transactional data, real-time data feeds, and then big data. So these analytics go beyond descriptive and predictive analytics by recommending one or more possible courses of action. And the best example for this is the Google self-driving car. This example also we have already seen in the new generation product section. So basically, Google self-driving car analyzes the environment and then decides the direction to take based on the data. So it decides whether to slow down or speed up, to change the lanes or not, to take a long cut to avoid traffic or prefer short routes, etc. So in this way, it functions just like a human driver by using data analytics at scale. Now, prescriptive analytics is a little complex type of analytics and it is not yet adopted by all the companies. But when implemented correctly, they can have a large impact on how the businesses make their decisions. So now let's move on to our last type, which is diagnostic analytics. So diagnostic analytics is used to determine why something happened in the past. So it is characterized by techniques like drill down, data discovery, data mining, and correlations. So diagnostic analytics, it takes a deeper look at the data to understand the root cause of the events. It is helpful in determining what kind of factors and events contributed to a particular outcome. So mostly it uses probabilities, likelihoods, and the distribution of data for the analysis. So for example, in a time series data of sales, diagnostic analytics would help you to understand why the sales of a company has decreased or increased for a particular year and so on. So examples for diagnostic analytics could be a social media marketing campaign. So you can use diagnostic analytics to assess the number of posts, mentions, followers, fans, page views, reviews, pins, etc. So, and then you can analyze the failure and the success rate of a campaign at a fundamental level. So therefore, there can be thousands of online mentions that can be distilled into a single view to see what worked in your past campaigns and what did not. So now that we have seen all the four types, I hope that you've understood the different examples of all the four types and the difference between them. Now let's move forward and have a look at the tools which are required for big data analytics. So these are some of the tools that I have listed down here. So there are more such tools which are used for big data analytics, but let us explore the ones which I have mentioned over here. So let me name them: Hadoop, Pig, Apache Hbase, Apache Spark, Talend, Splunk, Apache Hive, Kafka. So now let me start with the first one, which is Hadoop. So Hadoop is basically a framework that allows you to store big data in a distributed fashion so that you can process it parallelly. Apache Pig is a platform that is majorly used for analyzing large data sets and then represent these data sets as data flows. So basically Pig is used for scripting and the language is Pig Latin. Now coming to Kafka. So Kafka is a messaging system. Now guys, what is a messaging system? A messaging system is basically something which is responsible for transferring data from one application to another. So the applications can focus on the data and they do not need to worry about how to share it. So this is what Kafka does. Now coming to Apache Hive. Now Apache Hive is a data warehousing tool. So it allows us to perform big data analytics using Hive query language, which is similar to SQL. Coming to Splunk. So Splunk is a log analysis tool. Now what are logs? So logs are generated on computing as well as non-computing devices, and they are stored in a particular location or directory. So they contain details about every single transaction or operation that you guys have made. So next is Talend. Talend is an open source software integration platform which helps you to analyze effortlessly and then turn the data into business insights. So it helps the company in taking real-time decisions and become more data-driven. Next is Apache Spark. So Apache Spark is an in-memory data processing engine that allows us to efficiently execute streaming, machine learning, and SQL workloads. And it requires fast iterative access to data sets. So basically it is used for real-time processing. Now moving to the last one, which is Apache Hbase. So Apache Hbase is a NoSQL database that allows you to store unstructured and semi-structured data with ease and provides real-time read or write access. So these were the tools that I could list down, and I have also told you about the different functions in brief that they perform. So now let us move forward and explore the different kind of domains which are using big data analytics. So these are some of the domains that I've listed out for you guys to understand how they're using big data analytics and how widely it is being used in different kinds of domains. So healthcare, we've already discussed previously, has been using big data analytics to, reduce costs, predict epidemics, avoid preventable diseases, and then improve the quality of life in general. So one of the most widespread application of big data in healthcare is electronic health records, which is EHRs. I'm sure that most of you must have heard about it. It basically stores the patient's entire data. Now coming to telecom industry. So telecom industry is one of the most significant contributors to big data. So telecom industry basically analyzes all our call data records in real time, and then they identify fraudulent behavior and acts on them immediately. Now the marketing division of telecom industry, it basically modifies their campaign to better target its customers and then use these insights which are gained by them to develop new products and services. Coming to insurance companies, so insurance companies use big data analytics for risk assessment, fraud detection, marketing, customer insights, customer experience, and much more. Now, governments across the world are also adopting big data analytics. The Indian government, for example, had used big data analytics to get an estimate of the trade in the country. So the economists used central sales tax invoices for trade between two states to estimate the extent to which the states were trading between each other. Coming to banks and financial firms. Now, banks and financial services firms, they use analytics to differentiate fraudulent interactions from legitimate business transactions. So by applying analytics and machine learning, they're able to define the normal activity of a user or a customer based on their history and then distinguish it from the unusual behavior indicating fraud. So then the analysis systems, they suggest immediate actions such as blocking the irregular transactions, which stop the fraud before it occurs and improves the profitability. Now moving on to the next domain, which is automobile. So many automobile companies are utilizing big data analytics, and one example is Rolls-Royce. So Rolls-Royce embraced big data by fitting hundreds of sensors into its engines and propulsion systems. And these sensors basically record every tiny detail about the operation of these engines and propulsion systems. So then the changes in the data in real time are reported to the engineers, who will then decide the best course of action, such as scheduling a maintenance or dispatching the engineering teams if the problem arises. Now, the next domain is education. So education is one field where big data analytics is very slowly and gradually being adopted, but it is very important that we utilize big data analytics in this field, because so by opting for big data powered technology, as a learning tool instead of the traditional lecture methods, we can enhance the learning of a student, as well as it can aid a teacher to basically track the performance in a better manner. Now coming to the last domain, which is retail. So retail includes both e-commerce and in-stores, and they are widely using big data analytics to optimize their business strategies. So we already saw that with the example of Amazon. So now that we've explored the various domains, let me show you the use cases that I have taken here to explain you about how big data analytics is widely being used. So I've taken two such use cases here. So the first use case is of Starbucks. So the leading coffee house chain makes use of behavioral analytics by collecting the data on its customers' purchasing habits in order to send personalized ads and coupon offers to the customers' mobile phones. So the company also identifies trends indicating whether the customers are losing interest in their product, and then they direct offers specifically to those customers in order to regenerate their interest. So I came across this article by Forbes which reported how Starbucks made use of big data to analyze the preferences of their customers to enhance and personalize their experience. So they analyzed, every member's coffee buying habits along with their preferred drinks, to what time of the day they are usually ordering. So even when people visit a new Starbucks location, that store's point of sale system is able to identify the customer through their smartphone, and then the barista gives them their preferred order. So in addition, based on ordering preferences, their app, which is the Starbucks app, will suggest new products that the customers might be interested in trying. So this is how Starbucks is basically optimizing their business strategies and improving and basically increasing their customer base. Now let's move on and see what is the second use case that I want to share with you guys. The second use case is of P&G, Procter and Gamble. So Procter and Gamble uses market basket analysis and price optimization to optimize their products. So market basket analysis analyzes customer buying habits by finding associations between the different items that the customers place in their shopping baskets. So this is what exactly market basket analysis does. So apart from this, market basket analysis may be performed on the retail data of customer transactions at your store. So stores like Target, Walmart, etc., that they use market basket analysis to basically increase their sales and marketing. So you can then use the results to plan marketing and advertise your strategies, or even design a new catalog. So for instance, market basket analysis may help you design different store layouts. In one strategy, items that are frequently purchased together can be placed in close proximity to further encourage the combined sales of such items. So example, I'm going to a store, I want to buy bread. Then I also, cite butter. So I will want to buy butter as well. So that's how, stores optimize their sales. So they place all these products like butter, bread, milk, eggs in close proximity, because they know when a customer comes to buy bread, they might also want to buy butter or milk or eggs. All right. So this is one such example. So how P&G basically utilizes it is the company uses simulation models and predictive analytics in order to create the best design for its products. So it creates and sorts through thousands of iterations in order to develop the best design, for example, for a disposable diaper. And then they use predictive analytics to determine how moisture affects fragrant molecules in a dish soap, so that the right amount of fragrance comes out at the right time during the dishwashing process. I mean, so we can't even imagine that a simple product like a dish soap also has so much thought process behind it, and also has so much strategies or, analytics applied behind it. So I hope that you guys found both these, use cases really interesting, and how more such companies are utilizing big data analytics in a more proficient manner in order to basically increase their sales and marketing. So now let's move forward and see the next one, which is facts and statistics by Forbes. So I've collected some of these, so 4, which I found really interesting and I wanted to share with you guys. So the first one here basically states that nearly 50% of respondents to a recent McKinsey Analytics survey say that analytics and big data have fundamentally changed business practices in their sales and marketing functions. So we also have seen examples of this by, like by Starbucks, of P&G, of Amazon. So these are such companies which are responding to such surveys. Now the next one is showing that how big data applications and analytics is projected to grow from about $5.3 billion in 2018 to $19.4 billion in 2026, which attains about a compound aggregate of 15.49%. So the next one here is an extremely important fact or a stat which I found out, and it is basically an eye-opener. So according to an Accenture study, 79% of enterprise executives agree that companies that do not embrace big data will lose their competitive position and could face extinction. Even more, 83% have pursued big data projects to seize a competitive edge. So this very fact, guys, tells you that how important this field is, and if your particular organization or company is not adopting big data analytics in the future, it is going to lead to obsolescence. So now let's see which is the last fact that I have stated here. So according to New Vantage Venture Partners, big data is delivering the most value to enterprises by decreasing their expenses by about 49.2% and creating new avenues for innovation by about 44.3%. An example of both of these facts we saw in New Generation Why We Need Big Data Analytics section, where we spoke about cost reduction as well as new generation products. So this is an example of that. So now let's move forward and look at the career prospects in big data analytics. So the first one here that I've stated here is there is a soaring demand for analytics professionals. So technology professionals who are experienced in big data analytics are in high demand as organizations are looking for ways to exploit the power of big data. So therefore, there is a soaring demand for analytics professional, and as and when the data is going to grow, more such people will be required to analyze that data. So that leads us to our second point, which is huge job opportunities. So there are more job opportunities in big data management and analytics than there were last year. And many IT professionals are prepared to invest time and money for the training. So now that companies under various domains are adopting big data analytics, so there are definitely more huge job opportunities. So now let's see what are the salary aspects. So I think this is one of the most important ones again, because we need to know that what kind of salary are we going to draw if we become a big data analytics professional. So 6 analytics and data science jobs are included in Glassdoor's 50 best jobs in America for the year 2018. These include data scientist, analytics manager, database administrator, data engineer, data analyst, and business intelligence developer. And the average salary of the 6 analytics jobs that I just stated, along with data science jobs, is about $95,000, which is absolutely amazing. And data scientist has been named the best job in America for about 3 years running, with a median base salary of $110,000 and 4,524 job openings. I mean, how wonderful is that? So you guys can see that how great the prospects are in this field. And if you guys are interested, then you should definitely learn more about this field. And who knows that you might be drawing such kind of a salary. So, but in India, the percentage of analytics professionals commanding the salaries lesser than 10 lakhs, it has gone lower, which is great. So the percentage of analytics professionals earning more than 15 lakhs has increased from about 17% in 2016 to 21% in the last year, 2017, and to the current 22.3% in this year, 2018. Now, let me tell you what kind of job titles are there in this field. So the first one here is Big Data Analytics Business Consultant. Second is Big Data Analytics Architect. Third is Big Data Engineer. Fourth is Big Data Solution Architect. Fifth is Big Data Analyst. Sixth is Analytics Associate. Seventh is Business Intelligence and Analytics Consultant. And the last one is Metrics and Analytics Specialist. So I've just stated 8 over here. So these might be addressed in different names and different job titles. And there are more such job titles, I'm sure, so you can explore that. So now let's move on to see what are the skill sets that you require if you want to become an analytics professional. So these are the few skill sets that I've mentioned over here, and there can be more depending on the role that you're going to play, or maybe even restricted to one particular skill set. So it depends upon what role are you going to play in this field of big data analytics. So the first one is that I've put down here is basic programming. So you would obviously be expected to know some kind of a general purpose programming language. The second one here is statistical and quantitative analysis. So it is preferable if you know about the statistics and quantitative analysis. Now moving on to data warehousing. So knowledge of SQL and NoSQL database languages such as MySQL, and NoSQL has MongoDB, Apache HBase, and Cassandra. So knowing these databases is also very important. So next one is data visualization, which is I think one of the most important skill sets which are required. So as an analytics professional, you should know how to visualize the data in order to basically improve your business. So you need to know what kind of trends are going to be there in the data and how it is increasing and what kind of insights this data is going to provide you. So you should be able to visualize the data. You should be able to understand what the data is indicating. The next one is specific business knowledge. So this is extremely necessary according to me, because if you're an analytics professional and you don't know what business your company is basically working on and you're not aware about it, you won't be able to apply your knowledge of analytics to basically increase the sales and marketing of the company. All right, so the business knowledge of a particular company or the area which you're working on is extremely important. The last skill set that I've mentioned over here is computational frameworks. So out of the tools that we discussed in the previous section, one is expected to know at least more than one. So if you know Apache Spark, Hadoop, Pig, also again that is depending upon the job role that you're going to play. So it is important that you're aware about at least one or more tools which are required for big data analytics, and one or two such computational frameworks, because it is going to of course help you, and you'll have a basic knowledge about how these tools are used for analyzing the data.
Let us start with the U.S. primary election use case first. In this use case, we will be discussing about the 2016 primary elections. In the primary elections, the contenders from each party compete against each other to represent his or her own political party in the final elections. There are two major political parties in the U.S., the Democrats and Republicans. From the Democrats, the contenders were Hillary Clinton and Bernie Sanders, and out of them, Hillary Clinton won the primary elections. And from the Republicans, the contenders were Donald Trump, Ted Cruz, and a few others. As you already know, Donald Trump was the winner from the Republicans. So now, let us assume that you are an analyst already, and you have been hired by Donald Trump, and he tells you that I want to know what were the different reasons because of which Hillary Clinton won. And I want to carry out my upcoming campaigns based on that so I can win the favor of the people that voted for her. So that was the entire agenda. So this is the task that has been given to you as a data analyst. So what is the first thing that you will need to do? The first thing you'll do is that you'll ask for data, and you have got two data sets with you. So let us take a look at what this data set contains. So this is our first data set, which is the U.S. primary election data set. So these are the different fields present in our data set. So the first field is state. So we've got the list of the state of Alabama. The state abbreviation for Alabama is AL. We've got the different counties in Alabama like Artuga, Baldwin, Barber, Bibb, Blount, Bullock, Butler, etc. And then we've got FIPS. Now, FIPS are Federal Information Processing Standards Code. So this basically means zip code. Then we've got the party, so which we will be analyzing the Democrats only because we want to know what was the reason for Hillary Clinton's win. So we will be analyzing the Democrats only. And then we've got the candidate. And since I told you there were two candidates, Bernie Sanders and Hillary Clinton, so we've got the name of the candidate here and the number of the votes each candidate got. So Bernie Sanders got 544 in 𝐓𝐺𝐾 County, and Hillary Clinton got 2387. And this field over here represents the fraction of the votes. So if you add these two together, you will get a 1. So this basically represents the percentage of vote each of the candidates got. So let's take a look at our second data set now. So this data set is the U.S. County Demographic Features data set. So the first we will have, again, the FIPS in the area name, 𝐓𝐺𝐾 County, Baldwin, and different other counties in Alabama and other states also. The state abbreviation, so here it is only showing Alabama, and the fields that you see here are actually the different features. You won't know what this exactly contains because it is written in a coded form, but let me give you an example what this data set contains. Let me tell you that I'm just showing you a few rows of the data set. This is not the entire data set. So this contains different fields like population in 2014 and 2010, the sex ratio, how many females, males, and then based on some ethnicity, how many Asians, how many Hispanic, how many Black American people, how many Black African people, and then there's also based on the age groups, how many infants, how many senior citizens, how many adults. So there are a lot of fields in our data set, and this will help us to analyze and actually find out what led to the winning of Hillary Clinton. So now you have seen our data set. You have to understand your data set. You have to figure out what are the different features or what are the different columns that you are going to use, and you have to think of a strategy or think of how you are going to carry out this analysis. So this is the entire solution strategy. So the first thing you will do is that you need a data set, and you've got two data sets with you. The second thing that you'll need to do is to store that data into HDFS. Now, HDFS is Hadoop Distributed File System, so you need to store the data. The next step is to process that data using Spark components, and we will be using Spark SQL, Spark mlib, etc. So the next task is to transform that data using Spark SQL. Transforming here means filtering out the data and the rows and columns that you might need in order to implement or in order to process this. The next step is clustering this data using Spark mlib, and for clustering our data we will be using k-means, and the final step is to visualize the result using Zeppelin. Now, visualizing this data is also very important because without the visualization you won't be able to identify what were the major reasons, and you won't be able to gain proper insights from your data. Now, don't be scared if you're not familiar with terms like Spark, SQL, Spark mlib, k-means, clustering. You will be learning all of these in today's session. So this is our entire strategy. This is what we're going to do today. This is how we're going to implement this use case and find out why Hillary Clinton won. So now let me give you a visualization of the results. So I'll just show the analysis that I have performed, and I'll show you how it looks. So this is Zeppelin, which is in my master node in my Hadoop cluster, and this is where we're going to visualize our data. So there's a lot of code. Don't be scared. This is just Scala code with Spark SQL, and at the end you will be learning how to write this code. So I'm just jumping onto the visualization part. So this is the first visualization that we have got, and we've analyzed it according to different ethnicities of people. For example, in our x-axis we have foreign-born persons, and in the y-axis we're seeing that among the foreign-born people, what is the popularity of Hillary Clinton among the Asians. And the circles represent the highest values. The bigger circle is the bigger counts. So we have made a few more visualizations. So now we've got a line graph that compares the votes of Hillary Clinton and Bernie Sanders together. Again, we have got an area graph also that compares Bernie Sanders and Hillary Clinton votes, and hence we have a lot more visualization. We have got our bar charts and everything finally. We also have state and county-wise distribution of the votes. So these are the visualizations that will help you derive a conclusion to derive an answer, whatever answer that Donald Trump wants from you. And don't worry, you'll be learning how to do that. I'll explain each and every detail of how I've made these visualizations. So let's get started with Hadoop and Spark. We will start with an introduction to Hadoop and Spark. So now let's take a look at what is Hadoop and what is Spark. So Hadoop is a framework where you can store large clusters of data in a distributed manner and then process them parallelly. Then Hadoop has got two components for storage. It has HDFS, which stands for Hadoop Distributed File System, and it allows to dump any kind of data across the Hadoop cluster, and it'll be stored in a distributed manner in commodity hardware for processing. You've got Yarn, which stands for Yet Another Resource Negotiator, and this is the processing unit of Hadoop, which allows parallel processing of the distributed data across your Hadoop cluster in HDFS. Then we've got Spark. So Apache Spark is one of the most popular projects by Apache, and this is an open source cluster computing framework for real-time processing, where on the other hand, Hadoop is used for batch processing. Spark is used for real-time processing, because with Spark, the processing happens in memory, and it provides you with an interface for programming entire clusters with implicit data parallelism and fault tolerance. So what is data parallelism? Data parallelism is a form of parallelization across multiple processes in parallel computing environments. A lot of parallel words in that sentence. So let me tell you simply that it basically means distributing your data across nodes which operate on the data parallel, and it works on fault-tolerant systems like HDFS and S3, and it is built on top of Yarn, because with Yarn you can combine different tools like Apache Spark for better processing of your data. And if you see the topology of Hadoop and Spark, both of them have the same topology, which is a master-slave topology. So in Hadoop, if you consider in terms of HDFS, the master node is known as the name node, and the working node or the slave nodes are known as data node. And in Spark, the master is known as master and slave are known as workers. So these are basically daemons. So this is a brief introduction to Hadoop and Spark, and now let's take a look at Spark complementing Hadoop. There's always been a debate about what to choose, Hadoop or Spark, but let me tell you that there is a stubborn misconception that Apache Spark is an alternative to Hadoop, and that is likely to bring an end to the era for Hadoop. It is very difficult to say Hadoop versus Spark because the two framers are not mutually exclusive, but they are better when they are paired with each other. So let's see the different challenges that we address when we are using Spark and Hadoop together. You can see the first point that Spark processes data 100 times faster than MapReduce. So it gives us the results faster and it performs faster analytics. The next point is Spark applications can run on Yarn leveraging Hadoop cluster, and you know that Hadoop cluster is usually set up on commodity hardware, so we are getting better processing, but we are using very low cost hardware. And this will help us cut our cost a lot, so hence also the cheap cost optimization. The third point is that Apache Spark can use HDFS as storage, so you don't need a different storage space for Apache Spark. It can operate on HDFS itself, so you don't have to copy the same file again. And if you want to process it with Spark, so hence you can avoid duplication of files. So Hadoop forms a very strong foundation for any of the future big data initiatives, and Spark is one of those big data initiatives. It has got enhanced features like in memory processing, machine learning capabilities, and you can use it with Hadoop. And Hadoop uses commodity hardware, which can give you better processing with minimum cost. These are the benefits that you get when you combine Spark and Hadoop together in order to analyze big data. Let's see some of the big data use cases. So the first big data use case is web e-tailing. The recommendation engines, whenever you go out on Amazon or any other online shopping site in order to buy something, you will see some recommended items popping below your screen or to the side of your screen. And that is all generated using big data analytics and ad targeting. If you go to Facebook, you see a lot of different items asking you to buy them. And then you got search quality, abuse, and click fraud detection. You can use big data analytics and telecommunications also in order to find out the customer churn prevention, the network performance optimization, analyzing network to predict failure, and you can prevent loss before the error or before the fault actually occurs. It's also widely used by governments for fraud detection and cybersecurity in order to introduce different welfare schemes. Justice, it has been widely used by healthcare and life sciences for health information exchange, gene sequencing, serialization, healthcare service quality improvements, and drug safety. Now let me tell you that with big data analytics, it has been very easy in order to diagnose a particular disease and find out the cure also. So these are some more big data use cases. It is also used in banks and financial services for modeling true risk, fraud detection, credit card scoring, analysis, and many more. It can be used in retail, transportation services, hotels, and food delivery services. And actually, every field you name, no matter whatever business you have, if you're able to use big data efficiently, your company will grow and you will be gaining different insights by using big data analytics and hence improve your business even more. Nowadays, everyone is using big data, and you've seen different fields, and everything is different from each other, but everyone is using big data analytics, and big data analysis can be done with tools like Hadoop and Spark, etc. So this is why big data analytics is very much in demand today and why it is very important for you to learn how to perform big data analytics with tools like this. So now let's take a look at a big data use solution architecture as a whole. You're dealing with big data now. The first thing that you need to do is you need to dump all that data into HDFS and store it in a distributed way. And the next thing is to process that data so that you can gain insights. And we'll be using Yarn because Yarn can allow us to integrate different tools together, which will help us to process the big data. So these are the tools that you can integrate with Yarn. You can choose either Apache Hive, Apache Spark, MapReduce, Apache Kafka in order to analyze big data. And Apache Spark is one of the most popular and most widely used tools with Yarn in order to process big data. So this is an entire solution as a whole. Now, so let's take a look at Apache Spark. Apache Spark is an open source cluster computing framework for real-time processing, and it has been the thriving open source community and is the most active Apache project at this moment. And Spark components are what make Apache Spark fast and reliable. And a lot of Spark components were built to resolve the issues that cropped up while using Hadoop MapReduce. So Apache Spark has got the following components. It's got the Spark core engine. Now the core engine is for the entire Spark frameworks. Every component is based on and it is placed in the core engine. So at first we've got Spark SQL. So Spark SQL is a Spark module for structured data processing, and you can run a modified Hive queries on existing Hadoop deployments. And then we've got Spark Streaming. Now, Spark Streaming is the component of Spark which is used to process real-time streaming data and is a useful addition to the core Spark API because it enables Hive throughput and fault tolerance, stream processing of live data streams. And then we've got Spark MLib. This is the machine learning library for Spark, and we'll be using Spark MLib to implement machine learning in our use cases too. And then we've got GraphX, which is the graph computation engine, and this is the Spot API for graphs and graph parallel computation. It has got a set of fundamental operators like subgraph, join purchases, etc. Then you've got Spark R, so this is the package for R language to enable our users to leverage Spark power from R shell. So the people who have already been working on R are comfortable with it, and they can use R shell directly at the same time, and they can use Spark using this particular component, which is Spark R. You can write all your code in the R shell, and Spark will process it for you. Now let's take a deeper look at a realistic people and all these important components. So we've got Spark Core, and Spark Core is the basic engine for large-scale parallel and distributed data processing. The core is the distributed execution engine, and Java, Scala, and Python APIs offer a platform for distributed EDL development, and further additional libraries which are built on top of the core allow for diverse streaming, SQL, and machine learning. It's also responsible for scheduling, distributing, and monitoring jobs in a cluster, and also interacting with storage systems. Let's take a look at the Spark architecture. So Apache Spark has a well-defined and layered architecture where all the Spark components and layers are loosely coupled and integrated with various extensions and libraries. First, let's talk about the driver program. This is the Spark driver, which contains the driver program and Spark context. This is the central point and entry point of the Spark shell, and the driver program runs the main function of the application, and this is the place where Spark context is created. Well, what is Spark context? Spark context represents the connection to the entire Spark cluster, and it can be used to create resilient distributed data sets, accumulators, and broadcast variables on that cluster. And you should know that only one Spark context may be active per Java virtual machine, and you must stop any active Spark context before creating a new one. Let's talk about the driver program that runs on the master knob of the Spark cluster. It schedules the job execution and negotiates with the cluster manager. This is the cluster manager over here, and the cluster manager is an external service that is responsible for acquiring resources on that Spark cluster and allocating them to a Spark job. Then in the worker node, we have got the executors. The executor is a distributed agent that is responsible for the execution of tasks, and every Spark application has its own executor process. Executors usually run for their entire lifetime of the Spark application, and this phenomenon is also known as static allocation of executors, but you can also opt for dynamic locations of executors where you can add or remove Spark executors dynamically to match with the overall workflow. Okay? So now let me tell you what actually happens when the Spark job is submitted. When a client submits a Spark user application code, the driver implicitly converts the code containing transformations and actions into a logical directed acyclic graph, or DAG, and at this stage the driver program also performs certain kinds of optimizations like pipelining transformations, and then converts the logical DAG into a physical execution of a plan with a set of stages, and after creating a physical execution plan, it creates more physical execution units that are referred to as tasks under each stage, and these tasks are bundled to be sent to the Spark cluster. So the driver program then talks to the cluster manager and negotiates for resources, and the cluster manager then launches the executors on the worker nodes on behalf of the driver. And at this point, the driver sends tasks to the cluster manager based on the data replacement, and before the executors begin execution, they first register themselves with the driver program so that the driver has got a holistic view of all the executors. Now, the executors will execute the various tasks that are assigned to them by the driver program, and at any point in time when the Spark application is running, the driver program will keep on monitoring the set of executors that are running the Spark application code. And this driver program here also schedules future tasks based on data replacement by tracking the location of the cache data. So I hope you have understood the architecture of Spark. Any doubts? All right, no doubts. Now let's take a look at Spark SQL and its architecture. So Spark SQL is the new module in Spark, and it integrates relational processing with Spark's functional programming API, and it supports querying of data either via SQL or via Hive query language. So for those of you who have been familiar with RDBMS, so Spark SQL will be a very easy transition from your earlier tools because you can extend the boundaries of traditional relational data processing with Spark SQL, and it also provides support for various data sources and makes it possible to read SQL queries with code transformation, and that is why Spark SQL has become a very powerful tool. This is the architecture of Spark SQL. So let's talk about each of these components one by one. First, we have got the data source API. So this is the universal API for loading and storing structured data, and it is built on support for Hive, Avro, JSON, JDBC, CVS, Parquet, etc. So it also supports the third-party integration through Spark packages. Then you've got the data frame API. Data frame API is the distributive collection of data that is organized into named columns and is similar to relational table in SQL that is used for storing data in tables. So it is the domain-specific language applicable to, or DSL applicable on structured and semi-structured data. So it processes data from kilobytes to petabytes on a single node cluster to a multi-node cluster, and it provides different APIs for Python, Java, Scala, and R programming. So I hope you have understood all the architecture of Spark SQL. We will be using Spark SQL in order to solve our use cases. So these are the different commands to start the Spark daemons. These are very similar to Hadoop commands to start the HDFS daemons. So you can see to start all the Spark daemons, so the Spark daemons are master and worker, and you can use this command to check if all the daemons are running on your machine. You can use JPS like Hadoop, and then in order to start the Spark shell, you can use this. And you can go ahead and try this out. So this is very similar to the Hadoop part that I just showed you earlier, so I'm not going to do it again. And then we've seen Apache Spark also. So now let's take a look at K-means and Zeppelin. K-means is the clustering method, and Zeppelin is what we're going to use in order to visualize our data. So let's talk about the K-mean clustering now. K-means is one of the most simplest unsupervised learning algorithms that solves the well-known clustering problem. So the procedure of K-means follows a simple and easy way to classify a data set to a certain number of clusters, which is fixed prior to performing the clustering method. So the main idea is define K-centroids, one for each cluster, and the centroids should be placed in a very cunning way because of different location causes different results. So here, let's take an example. So let's say that we want to cluster total population of a certain location, and so we want to cluster them into 4 different clusters, namely group 1, 2, and 3, and 4. So the main thing that we should keep in mind is that the objects in group 1 should be as similar as possible, but there should be as much difference between an object in group 1 and group 2. It means that the points that are lying in the same group should have similar characteristics. And it should be different from the points that are lying in a different cluster, and the attributes of the objects are allowed to determine which object should be grouped together. For example, let us take in the same sample that we're using in the U.S. county. So let's consider the second data set we have used. There are a lot of features that I already told you, like there are age groups, and they are categorized by professions, and they also categorized by the ethnicity. And so this is the thing that we are talking about. So these are the attributes that will allow us to cluster our data. So this is K-means clustering. Here is one more example. Let us consider a comparison on income and balance. So in my x-axis, I've got the gross monthly income, and in the y-axis, I have the current balance. I want to cluster my data according to these 2 attributes. Here, if you see, this is my first cluster, and this is my second cluster. So this is the cluster that indicates the people who have high income and low balance in the account, and they spent a lot. And this cluster comprises of the people who have got a low income but a high balance, and they are safe. You can see that all the points that are lying here have got similar characteristics, that they have got low income and high balance. And here are the people who share the same characteristics, where they have got low balance and high income. And there are a few outliers here and there, but they don't form a cluster. So this is an example of K-means clustering, and we'll be using that in order to solve our problems. So does anybody have any questions? So here is one more example and one more problem for you. So you guys will tell me now. So the problem is that I want to set up schools in my city, and these are the points which indicate where each student lives. So my question to you is, where should I be building my school if I have students living around the city in these particular locations? And in order to find that out, we will do K-means clustering, and we'll find out the center point, right? So if you can cluster and make groups of all these locations and set up schools at the center point of each cluster, that would be optimum, isn't it? Because that is how the students have to travel less. It will be close to everyone's house. And there it is. So we have formed 3 clusters. So you can see the brown dots are one cluster, and the blue dots are one cluster, and the red dots are one cluster. And we have set up schools in the center points of each cluster. So here is one, and here is yet another one. So this is where I need to set my schools up so that my students do not have to travel that much. So that was all about k-means, and now let's talk about Apache Zeppelin. This is a web page notebook which brings in data ingestion, data exploration, visualization, sharing, and collaboration features to Hadoop and Spark. So remember, when I showed you my Zeppelin notebook, you can see that we have written the code there. We have even run SQL codes there, and we have more visualizations by executing code there. So this is how interactive Zeppelin is, and it supports many, many interpreters, and it is a very powerful visualization tool that can use, that goes very well with Linux systems, and it supports a lot of language interpreters. It supports R, Python, and a lot of other interpreters. So now let's move on to the solution of the use case. So this is what you've been waiting for. First, we will solve our U.S. county solution. So the first thing we will do is we will store the data into HDFS, and then we will analyze the data by using Scala, Spark SQL, and Spark ML Lib. And then finally, we'll find out the results and visualize them using Zeppelin. So this was the entire U.S. election solution strategy that I told you. And I don't think I should repeat it again, but if you want me, I can. Should I repeat? All right, so most of the people are saying no, so I will go right through this one again. So let me just go to my VM and execute this for you. So this is my Zeppelin, and I open my notebook here, and let us go to my U.S. election notebook, and this is the code. So first of all, what I'm going to do is that I am importing certain packages because I'll be using certain functions that are in those packages. So I've imported Spark SQL packages, and I have also imported Spark ML Lib packages because I'll be using k-means clustering. So vector assembler enables me certain machine learning functions. So over here, I have the vector assembler package that gives me certain machine learning functions that I'm going to use. I've also imported the k-means package because I'll be using k-means clustering. Then the first thing that you need to do is that you need to start the SQL context. So I've started my Spark SQL context here, and the next thing that you need to do is that you need to define a schema, because when you want to dump our data set or we want to dump our data, it should be in a particular format, and we have to tell Spark in which format it should be. So we're defining a schema here. So let me take you through the code. So I'm storing schema in a variable called schema, and we have to define the schema in a proper structure. So we're going to start with struct type, and since you know that our data set has got different fields as columns, we're going to define this as an array of fields. And then this is an array and struct, so we are defining the different fields now. So we'll start with the first field by defining it as struct field inside the braces, which should mention what should be the name of that particular field. So I've named it as state. It should be a string type, and true, that means it is a string type. The next we've got FIPS, which is of string type. Now I know that FIPS is a number, but since we are not going to do any kind of numeric operation on FIPS, we're going to let it stay as a string. Then we've got party as a string type, candidate as a string type, and then votes as integer type, because we're going to count the number of votes, and there is going to be certain numeric operations that we are going to perform that will help us to analyze our data. Then we've got a fraction votes, which you know is a decimal type, so we have to keep it as double type. The next thing you need to do is that Spark needs to read the data set from the HDFS. So for that, you have to use the command spark read, option header true. Header true means that you have mentioned and you have told Spark that my data set already contains column headers, because state as AVBR, they are nothing, but they are column headers. So you don't have to explicitly define the column headers for it. Neither will Spark choose any random row as a column header. So it will choose only the column headers your data set has. Then you have to mention the schema that you have defined. So I have defined it in my variable schema. So that's why I have mentioned it in my file. It should be in CSV format. And then I have mentioned the path of the file in my HDFS. This is the path, and I stored this entire data set in my variable df. Now what I am going to do is that I'm going to divide up certain rows from my data set, because you know that my data set contains both the Republican and Democrat data, and I just want the Democrat data, right? Because we're going to analyze the Hillary Clinton and Bernie Sanders part. Okay, so this is how you divide your data set. So the first thing that we have done is that we have created one more variable called DFR, and we have applied a filter where party is equal to Republican, and then we are storing the Democrat Party data into DFD. So we're going to use the DF_D from onwards, and DFR, the Republican data, is going to be your assignment for the next class. Now, I am going to analyze the Democrat data, and then after this class is over, I want you guys to take the Republican data. This data set is already available in your elements, and you've got the VMs, also with everything installed. So please, when you are at home, when you have free time, just analyze the Republican data and tell me what were the reasons that Donald Trump won. I want you to do all that analysis and come up with that in the next class, and we'll discuss about it and whatever results and conclusions that you have made after analyzing the Republican data. And that way you'll also learn even more, and it will also be practice for you after today's class. So all right, so we are going to take DF_D now, and the first thing that we will do is that we will create a table view, and I'm going to name the table view as election. And let me just show you what it looks like and what it has. So this is the command that I have run in Zeppelin. So this is SQL code that I have run in Zeppelin. And you can see that I have got states, state_ABBR, and I have only got the Democrat data. All right. Now let's go back. All right. So after creating the table view, now all of the Democrat data is in my election table. So now what I'm going to do is that I'm creating a temporary variable, and I'm running Spark SQL code. So what I'm actually doing by writing this code, the motive of writing this SQL code or the SQL query is that I want to refine my data even more. So what I'm trying to analyze here is how a particular candidate actually won. I don't have to do anything with the losing data, because you know that each of FIPS contain one of the losing candidate members and one of the winning candidate members. It contains the data of the winning candidate and the losing candidate also, because my data set contains both of the data of Bernie Sanders and Hillary Clinton. In some parts, Bernie Sanders won, and in some counties, Hillary Clinton won. So I just want to find out that who are the winners in a particular county, okay? So I'm going to refine that data, and for that I'm using this query. So I'm going to select all from election, and then I'm going to perform an inner join with their query. So this is one more query inside this query, and let me tell you what I'm actually doing. So first of all, what we have done is that we have selected FIPS as B. You know that now you have got two entries for each FIPS, so each FIPS actually appears twice in the data set. So I've named it as B, and now we are counting the maximum fraction votes. So you know that in each FIP we have the maximum fraction vote, and then we can find the winner by actually seeing who has got the maximum fraction votes, and then we have named it as A. The maximum fraction votes column is named as A, and we are grouping by FIPS. So now each of my FIPS will be selected, which has a maximum fraction vote, and I have two columns for that, FIPS, which is 1001 and 1001. So the only row will be selected which has the maximum fraction votes. Now I'll have the winner data, and I've named this entire table inside this query as group TT, and then I'm validating it as where election.fips, the main table view.fips, should be equal to the B column that we have created in group TT table, and election.fraction votes should be equal to group TT.A. So any doubts on this query and about how I have written this? All right, so now what we're going to do is that whatever data that we've got here, I'm storing that in election 1. Let me just show you what is in election 1 now. So this is my election table only, and you can see that I've got two FIPS, so 1067, 1067. Now let me show you election 1. So there now I don't have repetition of FIPS. I have only one entry for FIPS, and that is the row which tells me who won in that county, or in that particular FIP, or in the FIP associated with a particular county. And you can see for Bullock, it was Hillary Clinton. For Calhoun, it was Hillary Clinton. Cherokee, also Hillary Clinton. And then State House District 19 is Bernie Sanders. So Alaska is mainly Bernie Sanders. So this is what we've done now, and then you can see that we have also got additional columns as B and A. So A tells you the maximum fraction votes and B tells you the FIPS. So the data in FIPS and the data in B are the same, and data in fraction votes and data in A is the same, right? What I'm going to do now is, since my columns are repeating and they have the same value, I don't want A and B now, right? So what I'm going to do is I'm going to filter out the columns I don't need, and in this case I don't want B and A. And what I'm going to do is I'm going to make a temporary variable again, so I'm using the temporary variable to store some data temporarily. So I'm writing to the Spark SQL code to select only the columns that I want. I want the state abbreviation, county, FIPS, party, candidate, votes, fashion votes from election 1. I'm storing everything in dwinner. I've created this new variable, and whatever there was in temp, I'm assigning it to dwinner. And now I've got only the winner data, so I have got all the counties, and I've got who won in that particular county and by how much in the fraction of the votes. What I'm just doing till now is that I'm just refining our data set so that it will be easy for us to make some conclusions or gain some insights from that data, right? And also let me tell you that it's not always necessary that you are filing your data set in the exact way that I'm doing it. If you have something in mind after you've seen your data and understand your data and you found out what actually you need to do, you can carry out different steps to do that also. This is just one way of doing it, and this is my way of doing it. So I'm just telling you, and then we are creating a table for dwinner, and we are going to name it as Democrat. So let me go again and let me show you what the Democrat table view looks like. You can press Shift-Enter, so there you we have column A and B that we had in election 1. And so I've just got the winner data. So now let us go back and find out what we're going to find is that I want to find out that which of the candidates won my state, and then whatever date and whatever result I'll get will be stored in the temporary variable when I'm assigning everything. That will be stored in the temporary variable to a new variable called dstate, and then similarly I'm going to create a table view for dstate, which is state. Let me show you what my state table view actually contains. So there it is. So I've got state, Connecticut, Hillary Clinton won 55 counties, Florida, Hillary Clinton won 58 counties. So this is what we've come up to for our first data set. So now let's see what we can do with our second data set that contains all the different demographic features. First thing, again, you have to define a schema, and this time I'm naming that schema schema 1, since you know that we have got almost 54 columns, so I have to define all those 54 columns also. So you remember what each of those columns contains. So this is exactly what I have done, and I don't need to go through every line, but like I already told you how to define a schema, you can have the code in your LMS so you can take a look at it. So the next thing we're doing, again, we have to read our data set, and I'm storing my data set into a new variable called df1, and this is the path in my HDFS where my data set was. And then I have created a table view for my data set, which is called facts. Now, let me show you what facts contain. And as you can see, that it contains abbreviation, state abbreviation, population 2014. So instead of using the code now, or the encoded form that was actually there in my data set, I have given a varied meta name that would describe what it contains, right? So instead of PST 214, I've got population 2014. So does that make sense? Right. It contains all the 54 demographic features or different features that was in my data set. White alone, not Hispanic or Latino, living in the same house, 1 year and over, foreign-born persons, language or other than English spoken at home, high school graduate or higher. So it contains basically all the different features or all the different columns that actually was in my data set and that I have defined in my schema. So this is what facts I have. So now what I'm going to do is that I'm not going to analyze my whole data based on all these different features. I'm going to choose some specific features in order to analyze it. I'm going to take just a few, add one. So these are the different features that I'm going to use. I'm going to use FIPS. I'm going to use state. I'm going to use state abbreviation, then area name, candidate and people who are over 65 years, senior citizens, Female people, white alone, black African alone. I'm choosing Asian alone, Hispanic or Latino. So basically what I'm trying to do is I'm trying to check what is the popularity of Hillary Clinton among the foreign people or people from different ethnicities. So I'm choosing white people, black people, and Hispanic people. So I'm just trying to analyze it, okay? And you know that I have stored this in a temporary variable again, and then whatever result I'll get by running this Spark SQL code, I'll store it in a different variable called dfx, and then I'll store it, and then I'll make a table view for df facts such as winner facts. So let me show you what winner facts look like. So it's winner facts. You've got FIPS. The state is Alabama. The state abbreviation is AL for Alabama. The area name is 𝐬𝐞 County. The winner was Hillary Clinton, and the people over 65 years in that particular county is 13.8%. Female percentage is 51.4%. White alone, 77.9%. And so these show you the data. So black, white, or African is 18%, and then I've got the different fields that I have selected. Asian alone, Hispanic or Latino, foreign-born, so I have chosen 14 features to analyze it from. All right? So now what I'm doing again is that I'm going to divide the Hillary Clinton data and the Bernie Sanders data so that we can analyze only why Hillary Clinton won or why Bernie Sanders won in some particular counties. So we are planning to filter the same way we divided Democrats and Republican data from our initial primary result data set. So this is what you have done. So you know that is stored in df facts. So we are putting a filter in df facts where candidate is equal to Hillary Clinton. So that will be stored in HC, and the data of Bernie Sanders will be stored in BS. So after that, what we are doing is that we are doing a one-hot encoding. So we'll add two more columns in our data set, a WBS and WHC. In this case, we are going to do one-hot encoding, and what we're going to do is that we are going to include, or we are going to attach two more columns in winner facts as WHC and WBS. So it'll just contain either 1 or 0. And so you can edit it in that way, whichever county. So if you're considering a county, let's say 𝐬𝐞 County, say if Hillary Clinton is the winner, it will have a 1 in WHC, and in WBS, it will have 0. Similarly, in which counties Bernie Sanders won, so Bernie Sanders will have 1, so WBS will have 1, and WHC will have a 0. And then we are creating different views for both of these two together. So this will only tell me wherever WHC is 1. That means this will only show me the counties where Hillary Clinton won. This will only show me the counties where Bernie Sanders won. And we are creating a view for both of these. So for Bernie Sanders, the view is WBS, and for Hillary Clinton, it's WHC. Then finally, we are merging both of them together using union. So select all from WHC, union all select from WBS, and finally, you have stored it in result, and we have created a table view known as result. So let me show you what this result contains. So there it is for 𝐬𝐞. It was Hillary Clinton. So we've got the Bernie Sanders data over here at the bottom, and I've got all the different fields also from my second data set, the different features that I chose from my second data set to analyze it. So now comes the actual analyzing part. This is where we are going to perform k-means, but first we have to define the feature columns. Actually, you have to define what is the input that you're going to feed so that you get an output. So this is actually the input that you are going to feed to the machine so that the machine learning goes on, and finally it gives you some kind of result, right? So this is where I'm defining. Again, I'm using an array to define all the different fields from my data sets. I'm using person 65 years and older, female person percentage, white alone or black or African, American alone, Asian alone, Hispanic or Latino, foreign-born persons, language other than English, spoken at home, bachelor degree or higher, veterans, home ownership rate, median household, income, persons below poverty level, and population per square mile, WHC and WBS. And then I'm going to use the vector assembler. So this is what enables different machine learning algorithms where we are using k-means. So my input column is features calls. So this is going to be the input, and my output column and will be called features. So whatever result that I'm going to get is features, and we have to transform the results. So this is the final table view that we have created, and you know what transforming means, or transforming again means. So in our strategy, we already saw that we have to transform the data first. So my updated data set was results. So I'm going to transform result and put columns as going to be these, which is feature columns. And output table view will be called features. And then we're going to perform the k-means clustering, and we're going to store it in a variable called k-means. So we're using different functions from Spark library, and we have chosen Spark with clustering k-means. And you know that in k-means we already defined that how many clusters do we need, and we need 4. So we have selected 4 clusters, and then we're going to set feature columns as features. And then set prediction column as predictions. So after that, we're going to make a model, and we have defined our input and output columns in rows. So we're going to use 𝐾EANS.FitRow, and whatever predictions we will get, we're going to store it in a model. And then we are going to do this, and that we are going to print the cluster centers for each cluster. So let me show you what my cluster centers are. So after we run this code, you can see that these are the different cluster centers. So just what I can make you understand about what we're going to do after k-means clustering and how to analyze it. So the numbers are present. They are placed very haphazardly. So what I have done is that I've picked out each of the cluster center points, and then I have made a new table. Yes, so this is it. So you know that we have 4 clusters. We have got the 0th cluster, 1st cluster, 2nd cluster, and third. So 0, 1, 2, 3. Okay, so 4 clusters, and we have found out this cluster centers according to different features that we fed into my k-means algorithm. So what we observed here in WHC and WBS is that the winning percentage, or the winning chances of Hillary Clinton, was 0.9, whereas winning chances for Bernie Sanders was 0.1. And then if you observe the differences in the cluster centers for each feature, here you can see that there is not much difference, not even here. So it's 50, 49, 49, 51, and then again, it is not much of a difference, but if you see here that it's 9 and it's going to 16. So you can do a more detailed analysis on Black or African American. So if you want to know the real support of Black or African American, and you want to see what was their voting pattern, or how popular was Hillary Clinton among them, so maybe this could be a good field to analyze because you see the variations in the number. Similarly, you can check out other features, and you can check out here at 16, 8, 9, and 36. So maybe, again, Hispanic or Latino field, and you should do some more analysis on it. And even here you can see in veterans there's 47,806, whereas we've got 182,000 all. So there is also a lot of difference. And here is only 2,759, and we've got in the 10,000s, we've got numbers, and even 100,000s here. So this is how we can identify that, which are the fields, or which we can find the main reasons of the main points where you should make your analysis. So let's go back to our Zeppelin notebook, and here it is. So now what we're going to do is that we're going to visualize the result first. So we are counting from predictions. So you can see that in cluster 1s, the prediction means prediction contains my cluster. Since you know that I've stored my clusters, my cluster information and prediction, this is my output after k-means. So I've got this many clusters. So this is the count of my counties, or a count of different various that lie in my particular cluster. You can see that in cluster 1, I have got 1,917. In cluster 2, I've got 751. So maybe I should pay more attention on analyzing cluster 1, right? So that's why I've selected cluster 1 here, and we're making different predictions. So you can see that in the x-axis, I have got foreign-born people, and in y-axis, I have chosen language other than English spoken at home. And then we are grouping it by candidate. So you can see the lighter blue is for Bernie Sanders and the more dark blue is for Hillary Clinton. So all this light blue is for Bernie Sanders, and you can see that as the number of foreign people increases, you can only see Hillary Clinton in the scatter plot here. So there might be a few outliers like back here in the sizes defined according to Black or African American alone. So you remember that this was the feature where we find a lot of variations in the numbers. So that's why we grouped it according to that. And you can see the bigger the circle represents, the more Black or African American alone. And that's what the conclusion we can find out from this scatter plot. And we can see that as the number of foreign people increases, the popularity of Hillary Clinton is more in larger groups of foreign people. You can also choose different parameters out of all the different features that you have chosen. So remember that we have also seen the variation in veterans. So let's choose veterans in a y-axis. So let's also change x-axis, and let me just use white alone here. So you can see here that there is the x-axis that has white alone, and this is the veterans. So you can see that Hillary Clinton is popular among veterans, also in a smaller group of veterans. Since we have decided the size in Black or African American alone, so the size also represents some values. She is popular among the African American veterans. And then as you go ahead and as the count increases, you can see actually, since it's a scatter plot and it almost represents that this is a point as the number of people increases, or as the number of white people increases, the votes are equally kind of distributed between Bernie Sanders and Hillary Clinton, because there are a lot of points in this scatter plot over here. And you can go ahead and drag and drop different features, and you can make different visualizations on that. Now what we've done is that we know that there are 1,917 counties in my cluster, one. So I am going to do is that I'm going to see that among these 1917, how many were in favor for Hillary Clinton, whereas she got 1,153. Similarly, in cluster 3, again, Hillary Clinton is the winner with 9, and Bernie Sanders with 1. Then it 2, she's also got 388, and Bernie Sanders was 363. So this was very close call. And again, in 0, you've got 119 and 30. And then we went ahead and created a line chart also of the word distribution for Hillary Clinton and Bernie Sanders. So in keys, we have selected prediction. The values here are WHC and WBS, the sum that we have got over here. So definitely Bernie Sanders is lagging behind. So even though you don't have that table for you, you can also find it out according to this line chart. So you can see that in cluster 0, even again, Hillary Clinton was ahead of Bernie Sanders. In cluster 2, there was a very neck-to-neck competition, and you can see it in the graph year. So this represents cluster 2, and so you can see you have a neck-to-neck competition. And again, in cluster 3, they have got neck-to-neck competition. So this describes the distribution of votes for Hillary Clinton and Bernie Sanders, and definitely Hillary Clinton knows ahead, and that's why, of course, she won the primary elections. So again, you can go ahead, and we have created the same graph. It's only just area graph instead of a line graph. The key here are state and candidates. So I've got states and candidates over here, and the values is counties. Once, if you just hover onto this bar chart, you can see that in Connecticut, Bernie Sanders won 115 counties. In Connecticut, Hillary Clinton won 55 only. So in Florida, Hillary Clinton is 58, and in Florida, Bernie Sanders is 9. And here you can see in the Maine, Bernie Sanders won 462. So Bernie Sanders got a majority of votes for Maine. So you can also classify it state-wise. You can find out which are the states. And as Donald Trump, now you will know that which are the states that you can target, right? So you know that in Maine, a lot of people voted for Bernie Sanders, and maybe Hillary Clinton is not popular. So you can go ahead and lead out. So as Donald Trump's party member, you can just advise him to go in Maine and carry out different campaigns because Hillary Clinton is not so popular there. So maybe it would be a little easier to get votes from the people in Maine. So this is what you can make a conclusion from, and it might not be very accurate, but this will be very close. The thing is that you can make different charts. You can make bar charts, you can make pie charts, so whatever counties won have made in the bar chart. So here it is in a pie chart. It looks better, but it's not maybe as insightful. I just placed it so that I can show you you can make pie charts also. So these are the insights that you can make after analyzing your U.S. county data. And this is what you can tell Donald Trump. These are the different suggestions that you can actually go and tell Donald Trump that she is popular among the foreign people and the people who speak different languages. She is popular among the Hispanic people. Then in Maine, she lost a lot of counties. She almost lost all of the counties in Maine. So these are different insights that you have got, and then you can tell your superior or your employer who has hired you to do that. So this is what you can present, right? So this is for a very beginner's level, and there are some more analytics that you need to do. I just showed you a few options. You can go ahead and try more in the Democrats section also. And you remember that you have to do it for the Republican Party also. Now let me see what you've learned today. So if you have any questions right now, you can just go ahead and ask me. So does anyone have any questions? So now we will move on and find out the solution for the instant cab use case. You remember that we have got the Uber data set, which contains the pickup time and the location by 2 columns, latitude and longitude, and we have also got the license number for a particular Uber driver. And what we have to do is that we have to find the beehive locations. That is the point where we will find the maximum pickups, and then we will also have to find out what is the peak hour of the day. So this was the entire strategy. So we've got the Uber pickup data set, and then we store the data into HDFS. We will transform the data set and make predictions by using k-means clustering on the latitude and longitude and find out the bee point or beehive point. So now let me open my other notebook, the Uber notebook. So again, the first thing that you have to do is copy the Uber dataset into your HDFS. Now we've done that before explaining to you the U.S. county analysis. So again, the code is kind of the same. The first thing is that, again, we are importing some Spark SQL packages and some Spark ML-lib packages because we are going to use k-means clustering. And you can see vector assembler here again, Spark ML, clustering k-means, and other Spark SQL packages. So then we have to start our SQL context, and we're doing it the same way. Then the first thing, again, we have to define a schema. So now I don't have many fields. I've got only 4 fields if I remember. So the first field was the date and timestamp that defines the time. So we're defining it as DT. And the next field is the latitude, the longitude, and base. Then I'm going to read my data set. This is the path in my HDFS where my Uber data set is there. So I define schema as schema here. The header is true because, again, my data set contains column headers, and I'm going to store in DF. So feature calls here is going to be latitude and longitude because I'm going to find out the beehive point, the point where I will get my maximum kick up from. So again, I have set the input calls as feature calls and output calls as features. So I'm using the assembler to transform my data set, and then again I'm using k-means, and we use the same elbow method. We found out that we should make 8 clusters for this data set, okay? And then we are selecting the prediction column and the output column as predictions, and then we have printed the cluster centers for each cluster. So definitely whatever result we are going to find, the cluster centers will tell me the exact location. So this cluster centers that we will find after k-means is actually the beehive points. This will be the point where I will find maximum pickups, right? So here I have printed my cluster centers, and this defines the latitude and longitude. And this is going to be my location where I'm going to find the maximum pickups. And I got 8 results like that because I got 8 clusters and defined the 8 centers for different clusters. So this is exactly like the K-school problem that I explained to you in k-means. This is exactly what happens just as we found out the center of each cluster, and that is where we are replacing the school or building, the new school, So similarly, this is going to be my beehive point, and this is where I will place my maximum number of cabs, okay? So we found out the beehive points. The next thing we will need to do is we need to find the peak hours, because I also need to know at what time should I place my cabs in the location. So what we're doing now, we are taking a new variable called Q, and we are selecting hour from the timestamp column, and then the alias name should be hour, and we're getting it from our prediction or from the result that we got after my k-means clustering. So now we are grouping it, and it will have the different hours of the day, and then it will just show me the pickups at the different hours of the day in the location that we found out are the beehive points. And then we're going to count how many pickups we are going to get from that place, right? So we're ordering it by descending. So the smaller pickup count will be the first, and then the larger will be at the bottom. Similarly, again, we are creating a new variable called t, and we're going to do the same thing. So here what we're doing is we are selecting the time, the hour of the date, the latitude, longitude, prediction, and we filter by hour, which is not null. So we're filtering out the null values from here. So now we have created a table view for categories. So let me show you what the categories contain. Okay, let me just go down. So I've done some few operations here. So let's scroll back up and I'll show you. And again, we have created table views for T and Q also, which is again T and Q, all right? And then I have made some visualizations for each. So then we have created a value P where hour is not null. So again, we have filtered out the null hours and we have created a new view called P. So here is my hours. This is my count and in the x-axis that show how many pickups were there, and this contains different hours of the day, and then I have grouped it by prediction. So the size is according to the count. So you can see that the bigger the circle means the more pickups. So you can find out the biggest circle, and you know that you can find the biggest circle as you go along the x-axis because this is where the count increases. So you can find out the biggest circle would be here, and it lies in my fourth cluster. And you can see that there are 8,915 pickups at the 17th hour of the day, which is around 5 p.m. And so you know that the maximum pickups are around 4 o'clock or 5 o'clock, and this lies all in my fourth cluster. And so it means my peak hours are around 4 or 5 o'clock in the evening, right? So this is what insight we have gained, and you can tell Instant Cab CEO that I have found out that your cabs should be ready around 4 or 5 because that's the time when people go home from offices or they're going out for dinner or something. And this is what another table view looks like, which is T. So here we have latitude and longitude, and this is where we are finding the beehive locations. So I have got the distribution in a scatter plot again, and you can see that we have got very dense points over here. It means that these represent the beehive points. So what you can do is that you can just put the US map and scale it according to this scale over here, and then you can exactly find out what is the exact location where you need to put your cabs around the 17th hour or the 16th hour of the day, all right? And you know that we had a lot of rows, but the results are only limited by 10,000 if it's around 10,000 rows. But we obviously had a lot more, and you can check in different clusters. So now we are analyzing cluster 0. So here, if you see this point over here, this lies in cluster 4. And this lies in cluster 5, and this lies in cluster 0, so you can analyze each cluster also. So here I have just laid out the latitude and longitude for my 0th cluster, so you can see here where prediction is equal to 0, and I've selected this from the table view of T. So here you can find out the exact latitude and longitude. And here the latitude is 40.722 and the longitude is negative 73.995. So this is how you can pinpoint location where your cab should be during the peak hours. Again, if you see this distribution, this is just a pie chart that I've created with that tells you what is the count of pickups at each hour of the days, starting from 0 to 23. There are 24 slices in this circle. So you can see that these few slices are the bigger chunks, and this is the 19th hour of the day, which is around 7 o'clock, 6 o'clock, 5 o'clock, 4 o'clock, 3 o'clock, and so on. So you can see the midnight, maybe nobody travels. So maybe your cabs could rest, or you don't have to place any more cabs during this part of the day. These are the insights that you gained. So any questions on that? I think after doing the U.S. county election, this was pretty easy to do, and this is also pretty easy to understand, and the results which were also much more clear, correct?
What is a Hadoop cluster? Before getting started into the Hadoop cluster, let us understand what actually a basic computer cluster is. A cluster basically means that it is a collection. A computer cluster is also a collection of interconnected computers which are capable enough to communicate with each other and work on a given task as a single unit. Similarly, Hadoop cluster is also a collection of commodity hardware which can be computers and servers interconnected with each other and work together as a single unit. Hadoop cluster has a master and numerous number of slaves. Master assigns the task and guides the slaves. Now that we know what a Hadoop cluster is, let us now understand its advantages over the other similar data processing units. Some of the major advantages of Hadoop cluster are: Hadoop cluster is scalable, cost-effective, flexible, fast, and resilient to failure. Let us now discuss each one of them in detail. First, Hadoop cluster is scalable. Hadoop is a beautiful storage platform with unlimited scalability. Compared to RDBMS, Hadoop storage network can be expanded by just adding additional commodity hardware. While RDBMS can't scale and process huge amounts of data, Hadoop on the other hand can run business applications over thousands of computers altogether, processing petabytes of data. Second one, the Hadoop cluster is cost effective. Traditional data storage units had many limitations, and the major limitation was related to the storage. Hadoop clusters overcome it drastically by its distributed storage topology. Hadoop clusters use commodity hardware, and the lack of storage can be handled by just adding additional storage units to the system, and the clusters functions as good as new. The third one is Hadoop clusters are flexible. Flexibility is the major advantage of Hadoop cluster. The Hadoop clusters can process any type of data, irrelevant whether it is structured, semi-structured, or completely unstructured. This enables Hadoop to process multiple types of data directly from social media. The fourth advantage is Hadoop clusters are fast. Hadoop clusters can process petabytes of data within a fraction of a second. This is possible because of the efficient data mapping capabilities of Hadoop. The fourth feature is Hadoop clusters are fast. Hadoop clusters can process petabytes of data within a fraction of a second. This is possible because of the efficient data mapping capabilities of Hadoop. The secret behind high-speed performance is that the data processing tools are always kept available on the service. That is, the data processing tool is available on the same unit where the data needed is stored. The fifth advantage is the data clusters are resilient to failure. The data loss in a Hadoop cluster is a myth. It is practically impossible to lose any data in a Hadoop cluster as it follows the data replication, which acts as a backup storage unit in the case of a node failure. So with this, let us move on to our next topic, which is related to Facebook's Hadoop cluster. Since 2004, from its launch, Facebook is one of the biggest users of Hadoop cluster. It is called as the beefiest Hadoop cluster. It approximately uses 4,000 machines and is capable to process millions of gigabytes together. Facebook has 2.38 billion number of active users. To manage such a huge network, Facebook uses multiple storage frameworks and millions of developers writing MapReduce programs in multiple programming languages. It also uses SQL, which drastically improves the process of search, log processing, recommendation system, starting from data warehousing to the video and image analysis. Facebook is growing day to day by encouraging all possible updates to its cluster. Sqoop. With a huge amount of unstructured data coming across each and every day, Facebook slowly realized that it needs a platform to speed up the entire analysis part. This is when the Sqoop was developed. Hadoop developers can dive into massive datasets and carry on ad hoc analysis in real time. The second update was Cassandra. The traditional data storage units started lagging behind when Facebook search team discovered an inbox search problem. The developers were facing issues in storing the reverse indices of messages sent and received by the users. The challenge was to develop a new storage solution that could solve the inbox search problem and similar problems in the future. The objective was to develop a distributed storage system dedicated to manage a large amount of structured data across multiple commodity servers without even failing for once. This is when the Cassandra was developed. The next update is Hive. After Yahoo implemented Hadoop for its search engine, Facebook thought about empowering the data scientists so that they could store larger amount of data in the Oracle data warehouse. Hence, Hive came into existence. This tool improved the query capability of Hadoop by using a subset of SQL and soon gained popularity in the world of unstructured data. Today, almost thousands of jobs are run using this system to process a range of applications quickly. Today, Facebook is one of the biggest corporations on earth, thanks to its active 2.5 billion users. Let us have an overview on the Facebook's Hadoop cluster, then let us move on to the architecture of Hadoop cluster. So this is the overview of Facebook's Hadoop cluster, which consists of web servers, ad hoc Hive Hadoop cluster, production Hive Hadoop cluster, and many more. Now that we have gone through a few facts on Facebook's Hadoop cluster, let us move on to the Hadoop architecture, which has the following components. The architecture of Hadoop consists of the following components: HDFS and YARN. Let us now begin with HDFS. HDFS consists of the following components: the name node, secondary name node, and data node. Let us discuss about each one of them in detail. Name node. Name node is responsible for running master daemons. Name node is designed to store the metadata, which means the information about the actual data, or in short, the schema of the data. Name node is the first one to encounter the client's request for data. It then transfers the request to the data nodes, which store the actual data. The name node is responsible for managing the health of all the data nodes. It receives a heartbeat from all the data nodes at a particular interval of time, and it also receives a status update of the task assigned. If any of the data node fails to respond with a heartbeat, then the name node considers the data node to be dead and it reassigns the task to the next data node. The next one is data node. Data nodes are called as the slaves of name node, and they're responsible to store the actual data and also to update the task status and health status to the name node in the form of a heartbeat. Now, the last one is the secondary name node. The secondary name node, as it speaks, is not actually a backup of name node, but it actually acts as a buffer which saves the latest updates to the FS image which are obtained in the intermediate process and finally updates them to the final FS image. Now, let us discuss about YARN. YARN, yet another resource negotiator. YARN consists of the following elements: node manager, app master, and container. Let us discuss each one of them in detail. Node manager. Node manager is a Java utility that runs as a separate process from WebLogic server. It allows you to perform common operations for a managed server regardless of its location with respect to the administration server. The second one is app master. App master is responsible for negotiating the resources between resource manager and node manager. And the last one is the container. The container is actually a collection of reserved amount of resources allocated from the resource manager to work with the task assigned by the node manager. Now, with this, we shall have a look on the overview of the Hadoop cluster architecture, and followed by that, we shall look into the rack awareness algorithm. So this is the architecture of Hadoop cluster, which consists of racks. Each and every rack consists of a set of computers, and one of the rack consists master. And these racks use core switches to communicate between each other. Now, let us move on to the rack awareness algorithm. The rack awareness algorithm is all about data storage. It says that the first replica of the actual data must be located in the local rack, and the rest of the replicas can be stored on a different remote rack. Let us look onto an example to understand this in a better way. Here I am having a data block on the data node 1, and the data node 1 is available on the rack 1, which happens to be our local rack. Now, according to the rack awareness algorithm, the replica of the data block in data node 1 can be stored in the remote racks, which might be rack 2 or rack 3. As you can see, the replicas have been stored in a remote rack, which is the rack number 2. Now, let us deal with a different block. As you can see, we have a new block in rack number 2, data node 7. This is the local rack for the data block stored in data node 7. Now let us see where the replicas of data node 7 are stored. The replicas of data node 7 are stored into the remote rack, which is rack number 3, and the data block is stored in data node 9 and data node 12. As you can see, now we have a new data block stored in the data node 11, and rack 3 is a local rack for the data block stored in data node 11. Now let us see where the replicas of data node 11 are stored. As you can see, The replica blocks of data node 11 are stored in the remote rack, which is rack number 1, and the data blocks are stored in data node 2 and data node 4. With this, we have finished our theory part. Now let us get into the practical part, where we'll learn to set up a Hadoop cluster with one master and two slaves. So let us begin with our practical session. Here we must create 3 host systems, out of which one is the master and the other 2 are the slaves. So I'll be choosing the Linux operating system for this, and I'll be using CentOS 7. I'll be starting with creating a new virtual machine. Here I'll be selecting my ISO image. This happens to be my ISO image, which has the Hadoop pre-installed. So let the process finish. And using the similar process, you must create 2 new host systems, and you must name them as Hadoop Slave 1 and Slave 2, as I have done here. As you can see, I have my Hadoop master here and Hadoop Slave 1 and Hadoop Slave 2. Let me start each one of them. Now I have started my Hadoop master, Hadoop Slave 1 and Hadoop Slave 2. Now all the components of Hadoop cluster, which are the Hadoop master, Hadoop Slave 1 and Hadoop Slave 2, all are started. Assuming that you know how to install Hadoop, I have chosen a CentOS operating system which has the Hadoop pre-installed. Now let us start our local host. Our local host is started. Now let us see the HDFS web user interface. This is how our HDFS web user interface looks like. And you can see our name node is in progress. And similarly, let us try to start the HDFS web user interface in our Hadoop Slave 1 and Slave 2. As you can see, the HDFS web user has been successfully started on Hadoop Master, Hadoop Slave 1 and Hadoop Slave 2. Now, let us begin with setting up our Hadoop cluster with Hadoop Master and Hadoop Slave 1 and Slave 2. Before getting started, our first job will be getting to know the IP address of our Hadoop Master. To know the IP address of the Hadoop Master, we can type in the command fconfig. This command will give us the IP address of our Hadoop Master. Here, my IP address is 192.168.233.130. Similarly, let us find out the IP address of our Hadoop Slave 1 and Slave 2. Now I'm in the Slave 1. Here I'll type in my command fconfig, which must show me my IP address of Slave 1. So here, the IP address of the Slave 1 is 192.168.233.138. Similarly, let us find out the IP address of Slave 2. As you can see, the IP address of Slave 2 is 192.168.233.129. Now, our next job is to edit the host and set the IP addresses of the master and slaves. Now let us open a new terminal. You can edit the host by the command vi etc/hosts. Here I have already edited the host. As you can see, I have given 192.168.207.134 as my Hadoop master and 192.168.233.128 as my Slave 1, and finally 192.168.233.129 as my Slave 2. This step must be followed on all the 3 machines, which is the Hadoop Master, Hadoop Slave 1 and Hadoop Slave 2. Once you define the IP addresses, you can simply press escape and :WQ to exit the terminal and save the changes you made in the terminal. As you can see, I have made the same changes in Hadoop Slave 1, and you can also see the same changes in Hadoop Slave 2. Remember, you have to follow all these changes in all the 3 machines, which includes Hadoop Master and Hadoop Slaves. Now we know that we have defined the IP addresses of all the 3 machines to all the 3 machines. Now let us see if they work or not. Let me open a new terminal and try to ping the Hadoop Slave 1. the name of my Hadoop slave 1 is slave 1. So let me write ping to slave 1. As you can see, the ping is successful and the data is been sent to the slave 1. Now let me open a new terminal and try to ping to my next slave using the command ping. As you can see, my second slave name is slave 2. So I'll be writing slave 2 and I'll start the ping. As you can see, the ping is successful. Now similarly, let us try this on our slaves too. Let me open a new terminal on slave 1 and let me type in the command to ping the master. As you can see, the name of my master is master. So let us try to ping to the master. The ping is successful and the data is been sent. Similarly, let us try on our slave 2 if slave 2 can successfully send ping to the master or not. Let us open a new terminal and write in ping to the master. As you can see, the data has been successfully sent to the master here. So with this, we have successfully established a Hadoop cluster consisting of Hadoop master and Hadoop slaves. As you can see, the pings are successful. The master is communicating with both slave 1 and slave 2. And similarly, the slave 1 is communicating with master and slave 2 is also communicating with master. Now with this, we have finished our demo session. Now let us learn about managing a Hadoop cluster. Hadoop is both a command line interface as well as an API. It does not require any tool in specific for managing and monitoring utilities. Yet, there are some options available such as Ambari and Hortonworks. The most popular one is the Ambari. Let us see how does a typical Ambari user interface looks like. So this is how a typical Ambari user interface looks like. We can see the HDFS disk usage percentage, data nodes alive, memory usage graph, network usage graph, and CPU loads, cluster load, name node heap, and many more. What is a Hadoop cluster? A cluster is basically a collection. A computer cluster is a collection of computers interconnected to each other over a network. Similarly, a Hadoop cluster is a collection of extraordinary computational systems designed and deployed to store, optimize, and analyze petabytes of big data with astonishing agility. Now that we are clear with the definition of Hadoop cluster, we shall move ahead and understand the factors that decide the Hadoop cluster capacity. The various factors that we need to look into in order to design and deploy an efficient Hadoop cluster are volume of data, data retention, data storage, and the type of workload. We shall discuss each one of them in detail. We shall discuss the first factor, which is the volume of data, and what is its role when it comes to deciding the capacity of a Hadoop cluster. So if you ever wonder how Hadoop came into existence, then it is because of huge volume of big data that the traditional processing systems couldn't handle. Since the introduction of Hadoop, the volume of data is increased exponentially. So it is important for a Hadoop admin to know the volume of data he needs to deal with and accordingly plan, organize, and set up the Hadoop cluster with appropriate number of nodes for efficient data management. Followed by the volume of data, the next factor is data retention. Data retention is all about storing important and valid data. There are many situations where data arrived will be incomplete or invalid that may affect the process of data analysis. So, there is no point in storing such data. Data retention is a process where the user gets to remove outdated, invalid, and unnecessary data from the Hadoop storage in order to save and improve the cluster computation speeds. Followed by data retention, the next important feature is the data storage. Data storage is one of the most crucial factors that come into picture when you are into planning a Hadoop cluster. Data is never stored directly as it is obtained. It undergoes through a process called data compression. Here, the obtained data is encrypted and compressed using various data encryption and data compression algorithms, so that the data security is achieved and the space consumed to save the data is as minimal as possible. Followed by the data storage, the last and the most important factor is the type of workloads. This factor is purely performance oriented. All this factor deals with the performance of the cluster. The workload on the processor can be classified into three types: intensive, normal, and low. Some jobs like data storage will cause low workload on the processor. Jobs like data querying will have an intense workload on both the processor and the storage unit of the cluster. So the type of workloads also matter a lot. So if you want to have a smooth and efficient cluster, then the processors you use and the RAM you use should be high-end. So these were the factors that decide the planning of a Hadoop cluster. Followed by this, we shall move into the next topic, which deals with the hardware requirements of Hadoop cluster. But before that, let us understand the Hadoop architecture. In the Hadoop architecture, we have the following components: the HDFS and YARN. Inside HDFS, we have name node and secondary name node, which are considered as masters. Similarly, in YARN, resource manager would be your master. And when it comes to slaves, data nodes and node managers are the slaves. So basically, name node controls all the data nodes which are existing in a Hadoop cluster. Name node is considered as the master daemon that manages the data nodes. The name node records all the metadata or the schema of all the files which it receives. Followed by that, name node receives a heartbeat and a block report from all the data nodes. On the other hand, data nodes are considered as the slave daemons that run on slave machines. The actual data is stored on data nodes, and the data nodes are responsible for serving read and write requests. So this was the architecture of Hadoop. Now let us discuss about the hardware requirements. The name node, secondary name node, and job tracker are the masters. The name node and secondary name nodes are the most crucial parts of any Hadoop cluster. They are expected to be highly available. The name node and secondary name node servers are dedicated to store all the namespace storage and edit log journaling. So the hardware requirements for these nodes are at least 4 to 6 SAS storage disks. So these disks will be divided as follows. 1 TB hard disk space will be dedicated for operating system. Followed by that, 2 TB hard disk space will be dedicated for FS image storage. Followed by that, 1 TB hard disk memory will be given for other softwares like Apache Zookeeper and other required softwares. Now, when we come into the processor, we require a hexacore or at least a octa-core processor with 2 to 2.5 GHz processing speed. And now, if we discuss about RAM, we have to include at least 128 GB capacity of RAM for an efficient and flawless performance. And finally, the major part, the internet. One should have at least 10 Gbps speed internet to have an efficient workflow. So these were the requirements for name node, secondary name node, and job tracker. Followed by the name node and job tracker, the next crucial components in a Hadoop cluster where the actual data is stored and Hadoop jobs get executed are the data nodes and task trackers respectively. Let us now discuss the hardware requirements for data node and task trackers. The number of nodes in a standard Hadoop cluster are 24 nodes, and each node should be having a capacity of 4 TB storage. Followed by that, the next important requirement is the processor. Similar to the name node, we also need a hexacore or at least an octa-core processor of speeds 2 to 2.5 GHz. Followed by that, the RAM. We should have at least 128 GB of RAM. And finally, the internet should be similar to the name node, that is 10 Gbps. So these were the hardware requirements for the Hadoop cluster. Now let us move ahead and understand the software requirements of the Hadoop cluster. When it comes to software, the operating system becomes the most important one. You can set up your Hadoop cluster using the following operating systems of your choice. Few of the most important and recommended operating systems to set up a Hadoop cluster are Solaris, Ubuntu, Fedora, Red Hat, and CentOS. Now that we have understood the hardware and software requirements of a Hadoop cluster capacity planning, we will now plan a sample Hadoop cluster for better understanding. The following problem is based on the same. Let us assume that we have to deal with minimum of 10 terabytes and assume that there is a gradual growth of data, say 25% every 3 months or every quarter of an year. In future, assuming that the data grows per every year and the data in year 1 is 10,000 terabytes. By the end of 5 years, let us assume that it may grow to 25,000 terabytes. If we assume 25% of year-by-year growth and 10,000 terabytes data per year, then in 5 years the resultant data may be nearly equals to 1 lakh terabytes. How exactly can we estimate the number of data nodes that we might require to tackle this data? The answer is simple, using the formula which is mentioned here. Hadoop storage, HS, is equals to CRS divided by 1 minus I, where C is the compression ratio, R is the replication factor, S is being the size of the data which is being moved into Hadoop, and I is the intermediate factor. Now, let us calculate the number of nodes required. Assuming that we will not be using any sort of data compression here, we shall keep C as a standard 1. And we all know that the standard replication factor in Hadoop is 3. So R is equals to 3. And next, the intermediate factor I is equals to 0.25. Then the calculation for Hadoop in this case will result as follows. Hs is equals to 1 into 3 into s whole divided by 1 minus 0.25, which will result in Hs is equals to 4s. The expected Hadoop storage instance in this case is 4 times the initial storage. The following formula can be used to estimate the number of data nodes, which is n is equals to Hadoop storage divided by d, which in turn results as CRS divided by 1 minus I whole divided by d, where d is none other than the disk space available for each node. Let us assume that 25 terabytes is the available disk space per single node, each node comprising of 27 disks of 1 terabytes each. Here, 2 terabytes is dedicated to operating system. Also, assuming the initial data to be 5000 terabytes. N is equals to 5000 divided by 25, which results in 200. Hence, we need 200 nodes in this scenario. So that's how we plan a sample Hadoop cluster. Now that we have understood how to plan a sample Hadoop cluster, we shall move into the final topic for today's discussion, which is the Hadoop admin responsibilities. The Hadoop admin should be responsible for implementation and administration of Hadoop administration. Followed by that, he or she should be responsible for testing MapReduce, Hive, Pig, and should be having access for all the Hadoop applications. The third responsibility is the Hadoop admin should be taking responsibility of cluster maintenance tasks like backup, recovery, upgrading, and patching. The fourth responsibility is performance tuning and capacity planning for clusters. The last but the most important responsibility of a Hadoop admin is to monitor Hadoop cluster and deploy security. Who is a Hadoop developer? Hadoop developer is a professional programmer with sophisticated knowledge of Hadoop components and tools. A Hadoop developer basically designs, develops, and deploys Hadoop applications with strong documentation skills. So the basic definition of a Hadoop developer is as follows. A Hadoop developer is a professional programmer who has some sophisticated knowledge about Hadoop components along with its tools. A Hadoop developer basically designs, develops, and deploys Hadoop applications with strong documentation skills. Now, let us move ahead and understand the roadmap to become a Hadoop developer. To become a Hadoop developer, this is the roadmap which you need to follow. Firstly, you need a strong grip on SQL basics and understand the terminology of distributed systems, which is mandatory. Followed by that, the next important skill is that you need to be comfortable with Linux basics. You need to know the important commands and terminologies in Linux. Then comes the next stage where you need to have strong programming skills in popular languages such as Java, Python, JavaScript, Node.js, and many more. Followed by that, you need to have your own Hadoop projects in order to understand the terminology of Hadoop. Then you need to be comfortable with Java because Hadoop was developed using Java. And the most important thing is you need to have a bachelor's or a master's degree in computer science and engineering technology. And finally, you need to have an experience of about 2 to 3 years. You might want to join some startup companies for experience, or you might also want to join some internships based on Hadoop. So this is the roadmap to become a successful Hadoop developer. Followed by this, we shall discuss the skills that are required by a Hadoop developer. Hadoop development involves multiple technologies and programming languages. So the core and important skills to become a successful Hadoop developer are enlisted as follows. Firstly, you need to have a basic knowledge of Hadoop and its ecosystem. Later, you should be able to work with Linux and execute some of the basic commands in Linux. Followed by that, you are expected to have some hands-on experience with Hadoop core components. Then, Hadoop technologies like MapReduce, Pig, Hive, and Hbase are mandatory. Followed by that, you should be able to handle multi-threading and concurrency in ecosystem. Once you're familiar with that, your next stage is to work with the ETL tools. The familiarity with ETL tools such as loading data and processing it using Flume and Sqoop is compulsory. Followed by that, you should be able to work with backend programming as well. Once you're done with that, you should be experienced with some scripting languages such as Big Latin, and after that, you should be having a good knowledge of query languages like HiveQL. So these were the few important skills which you require to become a successful Hadoop developer. Now let us move ahead and understand the salary trends of Hadoop developer. Hadoop developer is one of the most highly rewarded profiles in the world of IT industry. Salary estimations based on the most recent updates provided in the social media say the average salary of a Hadoop developer is more than any other professional. Let us discuss the salary trends of a Hadoop developer compared to other technologies. Firstly, VMware. You can see that the salary trends for a VMware professional lies between the $90,000 to $85,000. Followed by that, we have MySQL. So the MySQL professionals also lie under the same segment. Followed by that, we have .NET, VB, which is Visual Basics. Then we have IBM mainframe developers. Then followed by that, we have C++ developers with an annual income of $90,000. Followed by that, we have JavaScript in the same segment. Then SAP developers with a little hike around $95,000 per annum. Then we have Teradata developers. Then we have the second highly paid Unix developers, which lie under the segment of $105,000 per annum. And finally, you can see the Hadoop developers with the most highly paid profile, which lie under the segment of $110,000 paid per annum. Now with this, let us move ahead and discuss the salary trends of Hadoop developer in different countries based on their experience. Firstly, let us consider the United States of America based on experience. You can see that the average salary of a Hadoop developer in United States of America with experience around 1 to 2 years is around $120,000 per annum. Followed by America, we have the average salary of a Hadoop developer in United Kingdom, which comes around £85,000 per annum. And finally, we have the average salary of a Hadoop developer in India, which is around 5 lakh rupees per annum. We shall discuss the salary trends of Hadoop developers in a much detailed way. You can see that in America, for an entry-level Hadoop developers, the salary begins from $75,000 to $80,000. And you can see that for an experienced Hadoop developer, the salary trends from $125,000 to $150,000. Now followed by the United States of America, we have United Kingdom. Here you can see that for an entry-level Hadoop developer, the salary starts from £25,000 to £30,000, and whereas on the other hand, for an experienced Hadoop developer, the salary trends from £80,000 to £90,000 per annum. Now, in India, we have 4 lakh package to 5 lakh package for an entry-level Hadoop developer. On the other hand, for an experienced level Hadoop developer, the salary trends from 45 lakhs to 50 lakhs per annum. Now we shall move ahead and discuss the job trends for a Hadoop developer. You can see that compared to other developers, Hadoop developers has seen a gradual growth in the rate of requirement. The number of Hadoop jobs has increased at a sharp rate from 2014 to 2019. It has risen almost double in between April 2016 to April 2019. 50,000 vacancies related to big data are currently available in business sectors of India. India contributes to 12% of Hadoop developer jobs in the worldwide market. The number of offshore jobs in India is likely to increase at a rapid pace due to outsourcing. Almost all big MNC companies in India are offering handsome salaries for Hadoop developers in India. 80% of market employers are looking for big data experts from engineering and management domains. Now with this, let us move ahead and discuss about the top companies that are hiring Hadoop developers. The top companies which are hiring Hadoop developers are Oracle, Dell, Capgemini, IBM, Mphasis, CGI, Facebook, Twitter, LinkedIn, Yahoo, Medium, Adobe, Infosys, Cognizant, Accenture, Oracle, Dell, Amazon, and many more. Now, let us move ahead and understand the roles and responsibilities of a Hadoop developer. Different companies have different issues with their data. So, the roles and responsibilities of the developers need to be a varied skill set to be capable enough to handle multiple situations with instantaneous solutions. Some of the major and general roles of a Hadoop developer are as follows. Firstly, you should be capable enough to develop Hadoop and implement it with optimum performance. Followed by that, you should be able to load data from different data sources, which might be RDBMS, DBMS, data warehouse, and many more. Followed by that, you should be capable enough to design, build, install, configure, and support Hadoop system. Followed by that, you should be able to translate complex technical requirements in a detailed design. You should be able to analyze vast data storages and uncover insights. You should be also able to maintain security and data privacy. You should be capable to design scalable and high-performance web services using data tracking. High-speed data querying is a must. You should also be able to load, deploy, and manage data in Hbase. Defining job flows using schedulers like 𝐂𝐞𝐝 is mandatory. And finally, cluster coordination services through 𝐂𝐞𝐝 is also important. Now with this, let us also discuss about the future of Hadoop developers. Major large-scale enterprises need Hadoop for storing, processing, and analyzing their big data. The amount of data is increasing exponentially, and so is the need for this software. In the year 2018, the global big data and business analytics market was standing at $169 billion, and by 2022, it is predicted to grow to $274 billion. However, a PwC report predicts that by 2020, there will be around 2.7 million job postings in data science and analytics in the US alone. If you're thinking to learn Hadoop, then it's the perfect time. The prerequisites to install Hadoop in Windows operating system are Java. So, we all know that Hadoop supports only Java version 8. So firstly, we need to download Java 8 version. Followed by that, a latest Hadoop version, which we need for our operating system, then the configuration files. So these were the prerequisites. Now let's quickly go ahead and download Java 8 version into our local system and also Hadoop. So you can see that this particular web page belongs to Oracle, and here you'll be getting your Java Development Kit number 8. So these are the various versions available for Java 8 for Linux as well as Windows. So we need a JDK which is compatible with Windows. So here you can see that Windows x64 JDK version which will support Windows. So this particular link will redirect you and download JDK 8 for you into your local system. Once you click on it, it will ask you to accept the license terms from Oracle. Now you can just click on download. Followed by this, you will be redirected into a login page where you need to create your own account with Oracle so that you can download this JDK. Don't worry, this account is free of cost. So you can see the JDK is getting downloaded here. So as the JDK is getting downloaded, we shall now move ahead and download Hadoop for our local system. So this particular web page belongs to Apache organization where we can download Hadoop for free. So these are the various versions available for Hadoop, which are 2.10, 3.1.3, 3.2.1, and many more. So we shall select the latest version of Hadoop. But while you're selecting the latest version of Hadoop, please make sure that you're not actually downloading the exact latest version of Hadoop. Here you can see we have 3 different versions: 3.1.3, 3.2.1, 3.1.2. As you can see, 3.2.1 is the latest version. We have to select the version which is earlier to it, which is 3.1.3, because this particular version will be the stable version. Now we shall move ahead and select binary. Once you select binary, you will be redirected into a new web page where you will have a mirror link. Select that mirror link and your Hadoop will be downloaded for your local system. As you can see, Hadoop 3.1.3 tar.gz is getting downloaded. Now here you can see I have successfully downloaded Hadoop version 3.1.3 tar file as well as JDK 8, and those 2 files are successfully moved into my C drive. Now let's install Java first. Now make sure that you create a new folder for Java. So select change, and here select Windows C drive, then select make new folder. Now rename this new folder as Java, click OK. And now select next. You can see the installation procedure has now been started. You can see Java Development Kit 8 has been successfully installed. Now we shall enter into program files and move our JDK into Java file, because sometimes there will be an error while we set environment variables for Java. So you can see inside program files we have another folder called Java. So inside Java, there you have our JDK. So now what I'll be doing is just moving this JDK into Java file which we have created in C drive, this one. Now you can just delete this Java file from your program files so that you don't have to mess with duplication of Java file. Now you have your Java and JDK in one single file, which is Java, that is you have created in Windows C drive. Now we shall move ahead and set the environment variables for Java. So click Windows and then enter into settings, and inside the settings select system, and inside system just type in environment variables. And there you go. Select the edit the system environment variables option and you have this dialog box. Here select environment variables, and inside the environment variables you need to set the Java home as well as path for Java. Now select new and here just type in Java home, and here let us add the location of JDK bin. So here we will add in the variable value, that is the JDK bin location. So our JDK bin location is in the C drive, and inside the C drive we have the Java folder, and inside Java folder we have our JDK 1.8.0, and inside JDK file we have the bin location. So this will be the home location for Java. Select OK, and then now move into the next dialog box, which is the system variables, and inside that select path and select edit. Here create a new path variable which will be the JDK path, the same location, that is the bin of JDK. Select OK, and now select OK again, and now OK, and close it. Now Java has been successfully installed into our local system. Now let's check Java is functional or not. We can do that by selecting Windows R, and inside Windows R just type in cmd so that you can open your command prompt. Here just type in Java C. If you see the set of files popping up into your terminal, then it means that Java is working properly. So you can see Java is working just fine. Now let us check the version of our Java installed into our local system. So this can be checked by typing in Java space hyphen version. So you can see we have 1.8 version which is running in our local system. Now that we have successfully installed Java into our local system, let us now move ahead and install Hadoop into our local system. You can see that we have downloaded the tar version of Hadoop. So for that, we need to extract it first. Now you can see that the process of extraction has been completely finished, that is 100%, but you have 3 errors. You can ignore these errors. Now just close the extracting process. Then you have your Hadoop file. Now let us rename our Hadoop 3.1.3 as just Hadoop to reduce the confusion. Now that we have successfully extracted Hadoop, let's set environment variables for Hadoop. But before that, let's set the configuration of Hadoop. You can select Hadoop, and inside that you have a file called etc. And inside etc, you have another folder with the name Hadoop. And inside that, you have a set of folders. So out of these all folders, we have 4 important folders. They are core site.xml, then HDFS site.xml, followed by HDFS. We have another one which is MapRed site.xml, and lastly the yarn site.xml file. So we need to edit all these 4 different files, and once after we edit these 4 files, we need to edit one last file, which is the Hadoop env Windows command prompt file. So here you're just going to add in the Java home location. Now let's quickly edit all those 4 files. So we have successfully opened our 4 important files, which are core site.xml, MapReduce site.xml, yarn site.xml, HDFS site.xml, followed by the 4 important files. The last file, which is the Hadoop environment.cmd file. Here we are going to set this Java home location. Now let's first set the values for core site.xml. So the values that are changed in core site.xml are the properties. So inside the configuration, I have added one property, which is the file location, that is fs.default file system, and the local host location, that is 9000. Now let us save this core site.xml. Similarly, we need to also edit MapReduce site.xml files. Here, inside this, we need to add some properties. As you can see, we have also edited the configuration files of MapReduce site.xml. Let's save it. Now followed by the MapReduce site.xml, we have yarn site.xml. Let's edit this also. As you can see, the yarn site.xml is also being updated. Don't worry about this property file. I will link this in the description box below. You can have the access to it and you can use the same configuration file and install Hadoop. Followed by yarn site.xml, we have the last one, which is HDFS site.xml. But before editing this particular file, I want you to create a new folder in Hadoop location, which is data. Let's see how to create it. So this particular folder is inside C drive. This is Hadoop, and inside this Hadoop file, you need to create a new folder with the name data. Inside data, you need to create two more new files, which are data node and name node. So the first folder will be name node, and now another folder, which will be our data node. So now let's copy the location of data node and name node. So this location is the data node location, and followed by that the name node location. So this particular location will be the name node location. We have the two locations copied onto our clipboard. Now let's go back to the HDFS site.xml file and edit the configurations here. So you can see that we have edited the configuration file of HDFS site.xml, and inside the configuration we have provided the replication factor, which is the first property, and we have set the value as 1. Since we're using our local system, we might want to save memory, so the replication is only 1, but the default value for the Hadoop replication factor is 3. And followed by the first property, the second property, which is our name node. So we have provided our name node location, which is Hadoop file, and followed by that the data file, and inside that we have the name node. And similarly, the last property, which is the data node property. So here the value is Hadoop data node. Now let's save it. Now that we have successfully edited all our 4 important files, let's get back to Hadoop env.cmd file and edit the Java home location. So for safer side, let's get back to environment variables and get our JDK location. So this particular location is the location for Java home. We might want to remove the bin over here. So only C Java JDK is enough to set the Java home into our Hadoop env.cmd file. Now let's save this particular file and close it. So all the important files have been now successfully edited. Now let's go back to environment variables and set home and path for Hadoop. Now select new and write in Hadoop home. So this particular location, that is C Hadoop bin, is the location for Hadoop home. Now select OK. Now let's get back to path and set path for Hadoop files. In here, let's set up a new path variable, that is Hadoop bin. And now remember to create another path variable, that is your sbin. So to locate sbin, get back into Hadoop and select sbin, and this will be the location or path value for your sbin. Select that and edit a new variable in path and paste it. So that's how you set sbin, and select OK, OK, and finally another OK, and close the system properties. Now that we have successfully set home and path for Hadoop, let's go ahead and fix the configuration files. You can see that inside the bin folder of Hadoop, we are missing some important configuration files. To fix this, we need a new configuration file, which will be available in the description box below. You can click on that particular link and the required configuration file will be downloaded into your local system, and all you need to do is just replace that particular file with your bin folder in your Hadoop. You can see that there is a new file in my Hadoop, which is Hadoop configuration fixbin1.rar. Now all you need to do is just extract this particular folder. You can see that the folder has been successfully extracted, and all the executable files that you require in your Hadoop have been downloaded successfully. Now, what you need to do is just move this bin into your Hadoop bin. So cut this bin and get back to Hadoop and enter bin. So just delete this particular bin and replace it with a new one. So there you go, you have successfully done it. Now let's delete the unnecessary files. There you go, as good as new. So you have all the executable files and your Hadoop has been set. To check if Hadoop is functioning properly or not, let's open cmd and type in HDFS space name node space hyphen format. If you see a set of files popping up on your terminal, that means you have successfully installed Hadoop. You can see that the name node has been successfully getting started. Now let's open a new terminal and start all the Hadoop daemons. Here, you just need to enter your Hadoop location file, that is cd space Hadoop. Now you are inside Hadoop, and inside Hadoop enter sbin. Now you're inside sbin. Now you need to type in startall.shr, startall.cmd. And there you go. All your daemons are getting started. So that's how you install Hadoop into your local Windows operating system with the version Windows 10.
Now you'd be thinking, how does HDFS work? First of all, as you know, HDFS stands for Hadoop Distributed File System. So let us take a step back and understand what actually is a distributed file system in the first place. A distributed file system talks about managing data, that is files or folders, across multiple nodes or computers. It serves the same purpose as the file system provided by the OS in your PC. For example, for Windows, you have something called as NTFS, or for Mac, you have something called as HFS. The only difference between the file system that is there in your PC, that is your local file system, and a distributed file system is that instead of storing data in a single machine, in case of distributed file system, your data is stored in a cluster, which is again nothing but a bunch of computers connected to each other forming a network. Even though the files are stored across a cluster, the DFS will organize and display your data in such a manner that if you try to access the data from any one of the machine in the cluster, you will feel as if the data is stored in the machine that you were using. In other words, DFS provides you an abstraction of a single big machine that has a combined disk capacity equal to sum total of disk capacity of each node in the DFS cluster. Now let me give you an example just to clarify things further. Suppose you have a DFS comprising of 4 computers where each computer has a disk capacity of 1 TB. In this case, the DFS will provide you an abstraction of a very big machine that has combined storage of 4 TB. Now you can go ahead and store a single file of, let's say, 3 TB, which will eventually get stored and distributed across the 4 computers. So this is all about DFS, guys. Next, you may ask why we need DFS in the first place. I mean, we could have just increased the disk capacity of single machine to whatever that is required. Well, first thing is, there is a limit up to which you can increase the disk capacity of a single machine. Even if you somehow manage to store all of the data on a single machine, it would lead to another big problem. That is, it would take a lot of time to process the data using a single machine. Let us take an example to understand this. For example, let us say I'm having a 4 GB file that takes 4 hours to completely process it using a single PC. Now what I did, I used DFS and stored the same 4 GB file in a 4-node cluster, where each node was storing a chunk of file that will be equal to 1 GB. So therefore, in total, the 4 GB file was distributed across the cluster. Now what I can do, I can process each chunk of file parallelly using the 4 computers, thus reducing the entire processing time, which will be reduced to 1/4 of the former, that is equal to 1 hour. So that is the advantage that you get with DFS. So I guess by now you would have understood what is DFS or why do we need it. Let us come back to HDFS again. So again, HDFS is also a distributed file system, but for Hadoop, that allows you to store huge data sets, that is terabytes and petabytes of data, across the cluster or multiple machines, so that you can go ahead and process the data stored in each machine in parallel. Simple yet quite powerful idea, isn't it? So that is the main reason why Hadoop or HDFS became so famous. Now the next question that would be pondering in your mind is, how does HDFS manages the data? Or who distributes the data across the cluster? How can one access the data present inside HDFS? To answer these questions, you need to understand the architecture of HDFS. Now, HDFS or Hadoop cluster follows master-slave topology. It means that you have one master node and remaining all other nodes are slave nodes. In HDFS, the master node is called as name node, whereas the slave nodes are called as data nodes. Now, data nodes are actually responsible for storing the actual data, whereas name node, being the master node, is responsible for managing all the slave nodes or data nodes. Other responsibility of name node includes maintaining and managing metadata. The metadata is information about data that is there or present inside the data nodes. So name node will be keeping all those information regarding which data are stored in which of the data nodes. Along with that, data node are supposed to send some hard bit or a signal so as to ensure that all the data nodes are working to name node. So if, let's say, one of the data nodes stops sending that signal, the name node will assume that that particular data node has been failed, and that same will be notified to the admin so that a new data node can be commissioned. So other information in the metadata are like file permission, directory permission, the data locations, and all that. So all those stuffs are there in the name node metadata. So now that you have understood the architecture that is followed by HDFS, where we have one master node and we have slave nodes as data nodes. Now the question is how files are actually stored inside HDFS. Just like any file system, in case of HDFS also, the files are stored as blocks. The only difference between the file system block size that is there in your system to that of our HDFS is the default size of each block in HDFS is 128 MB, since we are dealing with a large or huge amount of data set. It is configurable and you can go ahead and change the default block size as per your use case. Now let us understand how does this work. For example, let's say I want to put a file of 380 MB into HDFS. So this 380 MB file will be broken down into 3 data blocks, where the first 2 data blocks will be of 128 MB, thus making 256 MB, and the last block will be occupying 380 minus 256 MB, that is equal to 124 MB. Then finally, these data blocks will be distributed across the cluster, that is in different data nodes. Now, when you will look at this implementation, you will find one more problem. What will happen if one of the data nodes containing the data blocks crashes? So how will name node ensure, or how will HDFS ensure fault tolerance with respect to the current implementation that we are having? Let's understand this problem with an example. So we'll take the same example that we were having in the previous case, where we are having one file of 380 MB that has been distributed across the HDFS with 3 blocks. Now let's say the third data node having the 124 MB block has been crashed. So in this case, we will not be able to retrieve the data, or we will be facing data loss issue. So HDFS has a solution for it called as replication factor. So what happens is whenever you are storing any data or copying any file into HDFS, it is broken down into blocks, and each blocks are replicated thrice by default and are distributed across the data nodes. In case if any of the data nodes fails, in that case, we can again retrieve the data by having a replica that will be stored in some other data nodes. So that is how your HDFS ensures fault tolerance capability. Also, there is one more advantage of having master slave topology is that we can go ahead and add more nodes on the fly. So for example, let's say I want more disk space in my cluster. In that case, what I can do, I can commission new data nodes on the fly without affecting the current infrastructure. So enough of the theory, guys. So let's go ahead and have a look at the real cluster. How does it look like? And what are the different ways via which we can go ahead and access HDFS? So these are edge node, guys. Let me log in. All right. So basically, we'll be having 2 types of file system over here. One will be the local file system with respect to your edge node, where all the files will be there. And then there will be distributed file system with respect to HDFS. So let me list all the files and directory in both the cases. For example, for local file system, I will be using local shell command, which is ls. And using that, you can see these are the files that is there inside my edge node. Now for listing out the directories and the files that is there inside my HDFS, I will be using HDFS shell command. So for that, you have to go ahead with HDFS DFS, then -ls, and then you provide the name of the directory on which you want to list the files or subdirectories. For example, in my case, I'll be looking at my profile directory, that is /user/edu_bigdata user. So as you can see, these are the files and directories inside my profile directory. So now you would be understanding how HDFS provides you that abstraction that you are using a single big machine. So let's go ahead and do some demos as well. For example, let's say I want to create a directory inside my DFS. So for that, I'm going to go ahead and say HDFS DFS -make_dir, and we'll go ahead with the name of the directory, which will be user/edu-bigdata user. And let's name the directory as HDFS dir. All right, so the directory has been created. Let's go ahead and list all the files that is there inside HDFS again. For that, again, I'm going to go ahead and say /user/edu-bigdata/user. Oops, I made a mistake, sorry. So here you can see I'm having a subdirectory called as HDFS dir, which has been created recently. All right, now let's go ahead and copy some of the data from edge node to HDFS. So if I do ls, these are the files that is there inside my edge node. Let me choose one file. So basically I'll be copying this particular tar file. So let me check the size of this tar file. All right, the file size is of 1.1 GB. Let's go ahead and copy it into the cluster. So I'll say sdfs dfs -put. Put is for moving data from your local system to sdfs. And then I'll mention the name of the file, which is cdh-char.tar.gz. And then I'll mention the directory where I want to copy it inside SDFS. So which will be /user/edu BigData user /SDFS_dir, the directory that we have created recently. Now let's go ahead and list the files that is there inside the newly created directory so as to ensure whether the copy has been done successfully or not. For that, I'm going to again do SDFS dfs -ls. Then we'll mention the directory path. So let me copy it and paste it over here. So as you can see, found one item. That is the file that we have copied recently. Now let us go ahead and check the number of blocks that has been made with respect to this particular file that we have copied inside SDFS. So I'm going to say Hadoop fsck, and then again I'm going to mention the directory path. So as you can see, we have total of 9 blocks that has been created with respect to 1.1 GB file, and each block has been replicated thrice by default. So in total of there will be 27 blocks there residing in SDFS in different data nodes. So this is how your SDFS works, guys. Now for a programmer, again, I don't have to worry about how data blocks are being created or how it is being distributed among different nodes. All I have to worry about is the logic that I'll be working on these data. So that's why your SDFS provides you all those abstraction and provides you tools and all those APIs so that it is very easier for you to go ahead and access it and manage the data that is there inside SDFS. With the given fact that even if I run a job or even if I process the data, that again the data will be processed locally in each node in a distributed and parallel fashion. Thus we'll be getting a reduced processing time. So whenever you're talking about huge amount of data sets or huge data sets, SDFS is the best option. The last fact that I'm going to mention is that all these SDFS hardwares are commodity hardware. So basically Hadoop is a very cost-effective solution to big data problem. In case if you have a specific use case that requires more cluster configuration, then you can go ahead and upgrade your cluster or hardware on the fly. You can add more nodes to it so that more parallelism can happen and you can again process a large data sets.
What is Hadoop MapReduce and why is it required? So Hadoop MapReduce is actually the processing unit of Hadoop, using which you can process the big data that is present on Hadoop HDFS or that is stored on Hadoop HDFS. But what is the requirement? Why do we need Hadoop MapReduce in the first place? It is because the big data that is stored on Hadoop HDFS is not stored in a traditional fashion. The data gets divided into chunks of data which is stored in respective data nodes. Okay, so there is no complete data that is present in one single location or one centralized location. Hence, a native client application which used to be there like a Java application or any other application cannot process that data right away. And hence we needed a special framework that has the capability of processing the data that stays as a blocks of data into respective data nodes, and the processing can go there and process that data and then only bring back the result. So that kind of a framework is Hadoop MapReduce. And we'll move on to the next slide and we'll see MapReduce in a nutshell. So this particular slide basically gives you the overview of MapReduce and what are the things that are related to MapReduce. To start with, what are the applications of MapReduce or where it is used? For example, it is used for indexing and searching. It is used to create classifiers. It can be used to create recommendation engines, like it has been created by big e-commerce companies like Amazon, Flipkart. It can be used for analytics by several companies. When we talk about the features of MapReduce, it is a programming model. It can be used for large-scale distributed model like Hadoop HDFS. It has the capability of parallel programming, which makes it very useful. When I talk about functions that are present in MapReduce, there are basically two functions that get executed. One is the map function and the second is the reduce function. If you talk about design patterns that has already been there in the industry for a long time, yes, you can also implement all those design patterns using MapReduce like summarization, classification, recommendation, or analytics, right? Like join and selection. MapReduce has been implemented by major giants like Google, and it has also been adopted by Apache Hadoop for HDFS, for processing data in HDFS, for processing data using Pig, for processing data using Hive, or for storing data or executing queries over the big data using HBase, which is a NoSQL database, right? So this is something which actually gives you the overview of MapReduce and what are the various features, what are the applications where it is implemented, what are the functions that are used. That kind of information is given in this slide. Guys, are you able to grab that information? And now we'll explore the two biggest advantages of MapReduce. The very first advantage is parallel processing. You must be aware of parallel processing from before as well, because it's not a very new term. Using MapReduce, you can always process your data in parallel. Okay, as you can see in the diagram, there are 5 slave machines, and there's some data that is residing on these machines. These boxes are nothing but representing a chunk of data, a block of data, or a HDFS block, which is getting processed in the respective slave machines, right? You can see a circle going on. So this simply represents the processing. Okay, so in here data gets processed parallelly using Hadoop MapReduce, and hence the processing becomes fast. So it is as simple as the work time problem that you would have solved in your school days. For example, you would have solved a problem like, if a particular task is done by one person, he is going to take 1 day. So the same task, if it is done by 3 persons, how many days it is going to take to finish the job, right? So what are we doing there? We are actually distributing the task among 3 people, and hence the time that is taken to execute that job becomes less, right? Similarly, same happens in Hadoop MapReduce. What happens is entire chunk of data gets divided by Hadoop HDFS into HDFS blocks, and the processing now processes this data in parallel, and hence the processing becomes fast. So I'll move on to the next slide, and we'll explore the second advantage of Hadoop MapReduce, that is data locality. This is one versatile thing that is given by Hadoop MapReduce, that is, you are able to process the data where it is. What does it mean? Let me tell you. The data that you move into Hadoop cluster gets divided into HDFS blocks, and these blocks are stored in the slave machines or the data nodes, right? As you can see, the data is stored in all these slave machines that are there in this picture, right? What MapReduce does is, it sends the processing, it sends the logic to the respective slave nodes or the respective data nodes where the data is actually residing as HDFS blocks. So what happens is, the processing is executed over a smaller chunk of data in multiple locations in parallel, right? This saves a lot of time, as well as it saves the network bandwidth that is required to move big data from one location to other. Just remember that this was big data which was broken down into chunks, right? If you start moving that big data through your network channels into a centralized machine and then process it, it will give you no advantage, right? Because you're going to consume the entire bandwidth just in moving the data to a centralized server, right? So using MapReduce, you are not just doing parallel processing, however, you're also moving the processing, the logic that you would like to execute over big data into the respective slave nodes where the chunks of data are present, and hence you're also saving a lot of network bandwidth, right? Which is very beneficial. Finally, when the slave machines are done with the processing of the data that is stored at the slave machines, they send back the results to the master machine. Because the results are not as big as the blocks that were stored on the slave machine, hence it will not be utilizing a lot of bandwidth, right? So what they do is they send the results back to the master machine. These results are aggregated together, and the final result is sent back to the client machine, which actually submitted the job. So we'll move on to the next slide, and we'll explore the traditional versus the MapReduce way. For this, we'll take a real-life analogy of election votes counting. Okay, everyone would be aware of elections, right? It happens everywhere. So you would be aware of booths as well. So booths are the location where people come and cast their votes, right? So there are n number of booths spread across the country, right? Let's take a scenario where we have 5 booths, okay, where people will go and cast their votes. Now, we also have a result center which has all the information of the booths that are there and where they are located. Okay. However, when people come and cast their votes in these respective booths, the votes are kept there itself. That is, booth A will have its own n number of votes, booth B will have n number of votes, booth C will have n number of votes. Similarly, booth D and E will also have n number of votes that were casted there itself. That information is not shared with the result center, right? So let's move on and let's see how does the vote counting will happen in the traditional fashion. Okay. So if you solve this problem using the traditional way, all these votes will be moved to a centralized result center right here, and then the counting would start. Now in this case, if we do this, what happens is we need to move all the votes to a result center, which is a costly affair, right? That is, you'll have to gather all the votes and move to a center location. So there is a cost involved along with that, along with the effort, right? Second point is result center also gets overburdened because it has to count all the votes that were casted in these respective booths, right? As well as, since they are counting votes that were casted in all the booths, it is going to take a long time. So this process doesn't work very well. Let's see how does MapReduce solve this problem. So the very first thing is MapReduce doesn't follow this approach. Now when you see the MapReduce way, what happens is, as you already learned in our previous slide, that is, MapReduce follows data locality, right? So that means it is not going to bring all the votes into a centralized result center. Instead, it will do the counting in the respective booths itself in parallel, right? So what is happening is, so once the votes that are casted on every booth are counted, they are sent back to the result center, and the result center now only has to aggregate the results that were sent from respective booths and announce the winner. So this way declaring the result becomes easy and very quick. Otherwise, I'll move on to the next slide. Okay, let's move on. Now let's understand MapReduce in detail. Okay. Now what did we do in the previous example? So we had an input, okay, and that input was distributed among various booths. Now every input was processed by a respective map function. Okay. In the starting, I told you that MapReduce has got two functions, one is map and the other is reduce. So the counting part that I talked about, which was done on the respective booths, was done by the map function. So every input at every booth was counted using the map function right here. After that, the results were sent to the reduce function. So the aggregation part is done by the reduce function and the final result is given as the output. So this is what has happened in our previous example. Okay, so the entire thing can be divided into map task and reduce task. Map task gets an input, the output of the map task is given to the reduce task, and this reduce task gives the output finally to the client. In this slide, we'll understand the anatomy of MapReduce. So what happens is a MapReduce task works on a key value pair, as you can see on the left. So when I talk about a map takes the input as key value, okay, and gives an output as a list of key value. Okay. Now this list of key value goes through a shuffle phase, and an input of key and a list of values given to the reducer. Finally, the reducer gives you a list of key value pairs. Okay. In this slide, what you need to understand is MapReduce works with key values itself, and the remaining thing we'll be understanding this in the coming slides. We'll move on to the next slide. Now let us take an example to understand the MapReduce way. Okay. So we had an input, right? The input that you have gets divided, or it gets splitted into various inputs. Okay. So that process is called input splitting. So the entire input gets divided into splits of data on the basis of the new line character. The very first line is the first input, that is deer, beer and river. The second line is the second input, car, and river. Okay. It would be deer, car and beer. Now let's move on to the next phase, that is the mapping phase. Now in the mapping phase, if you can see, what we do is we create a list of key value pairs. Okay. So the input is key and value. So key is nothing but the offset of the line number. The line number is the key and the entire line is the value. Okay. So line 1, the offset would be the key and the value would be deer, beer and river. In real life, the line number or the offset is actually a hexadecimal number. However, to make it easy, we will only consider it as 1 or 2, right? So line number 1 would be the key and the entire line would be value. Okay. When it is passed to the mapping function, what mapping function will do is it will create the list of key value pairs. For example, deer. So what it will do is it will read every word from the line and it will mark 1 after the comma. Okay. It will mark 1 as a value. So deer, comma 1, beer, comma 1 and river, comma 1. Why are we putting 1 after every word? It is because deer is 1 count, so deer comma 1. Beer in itself is 1 count, so beer comma 1. River in itself is again a 1 count, so river comma 1. So we have key value pairs, that is deer comma 1, beer comma 1 and river comma 1. Similarly, when we come to the second line, we'll read each word from the line, that is car, and we'll mark 1 against it because it is 1 count in itself. So car comma 1, again car comma 1 and again river comma 1. What will happen with the third line? What will be the result of the mapping function when this is the input? It is exactly the same, that is deer 1, deer is in itself 1, car in itself is 1 and beer in itself is 1. Let's move on and let's go on to the shuffling phase. So let's see what happens in shuffling phase. In shuffling phase, for every key, there is a list prepared, okay? So K2 comma list V2. For every key, there is a list of values that will be prepared in shuffling phase. So what shuffling phase will do is, so it will find the appearance of key beer and it will add the values into the list. So let's see what is happening. You can see that there are 2 incoming arrows. The first arrow is coming from list 1, so beer, and then in the list it has added 1. The other arrow was coming from this list, so beer comma 1 again. So what it did, instead of adding another key, it just added the value 1 in the list of values part. Okay, so the result would be beer comma list 1 comma 1 because there were 2 occurrences of beer in 2 different lists. Similarly, when I talk about car, so again for car another list will be prepared for values. So as you can see that there are 3 incoming arrows. 2 arrows are coming from the same list, so car 1 comma 1, and the third arrow is coming from the last list, again comma 1. Okay, so since there were 3 occurrences of car, hence the list of values will have 3 ones, 1 comma 1 comma 1. Okay, similarly goes with deer. Now deer was there in the first list and the third list, hence there were 2 occurrences, so deer comma 1 and 1. 1 and 1 is nothing but the values that are against the respective keys in the map phase, right? Can you tell me what will be the fourth answer? The answer would be river 1 comma 1. It is because river was found in 2 different lists. The first list river 1, so first occurrence, and then river 2, so river, and then the list of values, that is 1 comma 1. Now comes the reducing phase. In reducing phase, what we are doing is we start aggregation of the values that were present in the list against every key. So for beer, there were 2 values present in the list 1 comma 1, so the summation of these values will be done, so beer comma 2. Similarly for car, the values will be summed, so 1 plus 1 plus 1 becomes 3. A result from reducing function would be car 3. For deer, it becomes 1 plus 1, deer 2. What will be the last answer? The answer would be river comma 2. It's because the values are 1 and 1 plus 1 becomes 2. So this will be the result for river, and at last the final result will be sent back to the client with beer comma 2, car comma 3, deer comma 2 and river comma 2. This is how the entire word count process works when you are using MapReduce way. Okay, now let's execute this program practically. Okay, I showed you the entire process. Now let's execute this program, execute a word count program over the same input file that we saw and see what is the result. Okay, so I'll enter the password. This is the Edureka virtual machine that you can download from your LMS. I'm sure that the setup is already ready on your end. In case you're not ready with the setup, guys, please do that. Okay, so this is the input file that I have already created to save time. So this was the input in the example, right? Deer, beer, river, car, river, deer, car, beer. Okay, so what we are trying to do is execute a word count program over this. For your information, let me tell you that, so there are a set of MapReduce example that already comes with the Hadoop package that you download. Okay, so let me just show you. Even word count example is also a part of it. So I'll just take you there. My Hadoop is installed in user lib Hadoop. Let us see the contents of this folder. The MapReduce examples jar is present in the share folder. I'll just change the directory, share Hadoop and we need to go to the MapReduce part. We'll find the jar in this. This is the jar that I'm talking about, that is Hadoop MapReduce examples jar. Let me show you the examples that are present in this jar first. So Hadoop jar, Hadoop MapReduce examples 2.2.0.jar. So I'll execute this command. It will give me the list of all the classes, all the examples that are there within this jar. As you can see, one is aggregate word count, aggregate word list, BBP, along with a description. So you guys can go through it and try all the examples. What we are going to try is the word count example, a MapReduce program that counts the words in the input files. Okay, so this is what we are going to execute now. You can try other examples as well. As you have already seen the list of examples that is present in the Hadoop examples jar, now it's time we execute the word count example. But before that, we need to move the input file to HDFS first, and then only we can execute the MapReduce example. It is because MapReduce takes the input from the HDFS and dumps the output to the HDFS. Okay, so very first thing is I'll move the file. So Hadoop DFS, that is Hadoop Distributed File System, -put, that is I'm trying to put a file into HDFS. I'll give the path of my file that is present on my local file system, that is home, Edureka, desktop, and then the name of the file input, and then I'll give the HDFS directory, that is I would like to store on the root directory of HDFS. Okay, I'll press enter. I'm sure by now you would be very clear with the HDFS commands. In case you are not, I request you to please execute the HDFS commands that are present in the HDFS tutorial blog, or you also have a document in the LMS. Okay, so looks like a file has been copied to HDFS folder. Let me just check if it has been done. So Hadoop DFS, I'll directly cat, that is I'll read the file directly, and I'll put the name of the file, that is input. So I'm telling that go look for the file input that is present in the root directory of HDFS and read it. Okay, so this was the file that we copied, right? Good. So let's execute the word count example. I'll write Hadoop jar, and I'll mention the name of the jar, that is Hadoop MapReduce examples jar. I'll mention the class that I want to execute, that is word count. I'll give the input part of HDFS, that is \input, and then I'll mention the output directory, that is first example out, and I'll press enter. So looks like it has started the execution. It is again connecting to resource manager. It is because the client submits the job to the resource manager, right? Good. As you can see, the map and reduce task has started now. So first the map task would be executed. You can also track the status of your job at this particular location. Okay, so for every job there's an ID, application ID, that is generated. So you can always go to port 8088, which is nothing but resource manager's port. Now as you can see, the map has finished 100%, and finally the reduce phase would be executed. So reduce phase is also complete now. Now finally the job has executed successfully. Okay, as you can see, completed successfully. Let's go and check the output. Okay, I'll clear the screen. So Hadoop DFS -ls, and the name of the directory was first example out, and enter. As you can see, there is a success file that has been created and a part file. The output is always present in the part files. Okay, so we'll just read the part file now. Instead of ls, now I'll use the command cat, and I'll copy this part and I'll paste at the end of first example output. Okay, and let's press enter. This is the command that I'm using to read the final part file, the output. So this is the output: beer 2, car 3, deer 2, and river 2. Let's try and compare this with the input file itself. So first we'll read the input file, Hadoop DFS -cat \input, right? So this is the input file, and now we'll read the output file again, the part file. Now guys, can you compare? Is the result correct? Let's check. Beer, it says it has come twice. So beer 1 and then beer 2, right? Car has come thrice, so car 1, 2 and 3. Deer has come twice, so deer 1 and then second. Finally river came twice, so river 1 and river 2. So we can see that the output that has been given by the word count example is absolutely correct. Now, do you want me to execute the same word count example on a bigger file? Will that be interesting? Let me just show you. So for that, what I'll do is, let's open the browser first. Let's select a website like Apache Hadoop itself. Okay. So let's open Apache Hadoop. Apache Hadoop. So we'll open this website. So as you can see, there are multiple tags, multiple words there. Let me open the source file of this page. So I'll go to view page source. So how about running the MapReduce program on this page source and find out the frequency of every word that is coming in this page? Will that be something you would like to see? Good. So what I've done is I've written a small Python script. Okay, I'll just show you. Using that Python script, I'm trying to scrape the page that we have just opened, that is Apache Hadoop org. Okay, so I'll just change my directory to desktop first. I'll clear the screen. So the name of the script is scrape.py. Since it is a Python script, its extension is scrape.py. I'll open the file scrape.py. So in this, just I'm telling that this is where my Python is located. I'm importing a library that is called URL lib2. The page that I would like to scrape is http hadoop.apache.org that I have already shown you now. Using this command, that is URL lib2.url open Hadoop page, I'm able to fetch the entire source code of this page in one variable that is called page, and then finally I'm writing this page variable, the content of this page variable, in a file that is called Hadoop Apache. Okay, that will be created on the desktop. Okay, very simple script. I'll just save the file and I'll execute the script by /scrape.py. So you'll see that there will be a file that will get created once this script is finished. So right here, as you can see, Hadoop Apache is the file that has been created. I can open it for you. So it has the entire source code that was there in the Apache's website, right? Interesting. Now what I'll do is I'll execute the same word count example, but before that I need to move the file into Hadoop HDFS, right? I hope you remember. So I'll do Hadoop DFS -put. I'll give the path of this file, that is Hadoop Apache, the local path, and then I'll mention \, that is I would like to move this file to the root directory of Hadoop. Okay, I'll make the terminal full screen now. Now the file has been copied. Now I'll execute the word count example on this. So Hadoop jar, I need to give the entire path where my jar is located, that is user lib Hadoop, within that share folder Hadoop MapReduce, and then there will be the Hadoop MapReduce example jar. Next I need to mention the class I would like to execute, that is word count. Now I'll mention the name of the input file that is present on HDFS, that is Hadoop Apache, and I'll give the name of the output directory where I would like to store the final result of this MapReduce program, and I'll name it as second example out. Okay, and let's press enter. As you can see, it's connecting to resource manager again. It is because it is somebody who executes all your jobs that are submitted from the client. So the MapReduce task has started now, as you can see. Which will be the first phase that will get executed, guys? Is it map or reduce? It will be map itself. I hope everyone is very clear that map will get executed first. So as you can see, map has executed now. Even the reduce phase is also over, as you can see. And we have the results written on HDFS. I'll clear the screen. So let's check the results quickly. So Hadoop DFS -ls, the output directory was second example out, and we'll find the part files within it which will have the final output. So as you can see, this is the part file. Let's try and cat it. Okay, so Hadoop DFS -cat. I need to mention the entire path. I'll copy this and paste and enter. It will be a huge file. It is because the number of words that were present in the file was more than the previous input that we gave, right? As you can see, for every character, every word that was there in the file, you have the word count, right? So let me just clear this. So let's try and find out the count for Hadoop. Okay, so I'll simply execute a Linux command, that is grep Hadoop. On the output that will be received from after reading the file, I'll simply look for the word Hadoop. So Hadoop came into so many words, as you can see right here. So this is the command that I executed, and here is the result. Okay. So since this was the source code, it is a little messy. However, when you're working with real data set, you'll be cleaning that data set first, and then only you'll be executing your final processing. Okay. Even for cleaning, you'll be writing a MapReduce program. Okay. So how did you like the example? Matthew already says that, wow, that's a great example to observe. It gives the taste of real-time scenario. Okay, so Matthew, it was not a very real-time thing. However, still we were able to scrape a page and then do a word count on this. Okay, there are a lot of other things that can be done using MapReduce because the limits of MapReduce is endless. Okay, let's go back to our slides now. Now let's understand how MapReduce is using yarn to execute the jobs over the cluster. But before we go ahead, what does yarn stand for? Yet another resource negotiator. It is the one which allocates the resources for various jobs that needs to be executed over the Hadoop cluster. It was introduced in Hadoop 2.0 itself. Till Hadoop 1.0, MapReduce was the only framework or only processing unit that can execute over the Hadoop cluster. However, in Hadoop 2.0, yarn was introduced, using which we were able to go beyond MapReduce as well. The slide. Okay, so we have HDFS in the bottom. In between we have got yarn, and using yarn, a lot of frameworks are able to connect and utilize HDFS. Okay, so now even MapReduce has to connect using yarn request for resources, and then only it can execute the job over HDFS, that is Hadoop cluster. Okay, similarly Spark can connect, other search engines can connect to HDFS, Storm can connect to it, Hbase, which is a NoSQL database, which can connect to it. So the applications of HDFS became huge just because yarn was able to open the gates for other frameworks, other big data analytics tools as well. Let's move on. Let's talk about the daemons present in Hadoop 2.x cluster, which runs the components, that is storage and processing. And let's understand how does resource manager and node manager works in Hadoop 2.x cluster and manages the processing and the jobs that needs to be executed over the Hadoop cluster. Okay. So what is resource manager? Resource manager is the master daemon that runs on the master machine, which is a high-end machine. Node manager, on the other hand, is the daemon that runs on the slave machines or the data nodes, okay, along with the data node process, right? Let's understand this in a little more detail and explore other components as well, okay? So what is a client? A client is nothing but which submits a MapReduce job, like we did from the CLI, okay, that is command line interface. So it is also a client using which we were able to submit the MapReduce job. Okay, so it is a client. Similarly, a client could be a Java application or anything. Now, what is a resource manager? Resource manager, as I said, is the master daemon to which all the jobs are submitted from the client. It is the one which allocates all the cluster level resources for executing a particular job. Resource manager runs on a machine which is actually a high-end machine with good configuration because it is the master machine which has to manage everything over the cluster. Okay. What is node manager? Node manager is a slave daemon that runs on the slave machines or the data nodes. So every slave machine will have a node manager running. It monitors the resources of a particular data node. Resource manager manages the cluster resources and node manager manages the data node resources. Okay. So what is job history server? It is someone who keeps a track of all the jobs that has been executed over the cluster or has been submitted on the cluster. It keeps the track of their status as well. Okay. It also keeps the log files of every execution happened over the Hadoop cluster. Okay. So what is application master? Application master is again a process that is executed on a node machine, on a slave machine, and created by a resource manager to execute and manage a job. It is the one which negotiates the resources from the resource manager and finally coordinates with the node manager to execute the task. Okay. Similarly, what is a container? A container is created by the node manager itself, which has been allocated by resource manager, and within the container, all the jobs are finally executed. Okay. Let me give you a pictorial representation of this process. So yarn application workflow in MapReduce. So as I said, resource manager. So there is a resource manager to which all the jobs are submitted. There is a cluster in which there are slave machines. On every slave machine, there is a node manager running. Okay. Resource manager has got two components. One is scheduler, another one is application manager. Okay. So Matthew says, what is the difference between application master and application manager? Application manager is a component of resource manager which ensures that every task is executed and an application master is created for it. Application master, on the other hand, is somebody who executes the task and requests for all the resources that are required to execute it. Okay. Now, let's say a job is submitted to the resource manager. As soon as the job is submitted, the scheduler schedules the job. Once the scheduler schedules the job to be executed, application manager will create a container in one of the data nodes. Now, within this container, application master will be started. This application master will then register with the resource manager and request for a container to execute the task. Okay. Now, as soon as the container is allocated, application master will now connect with the node manager and request to launch the container. So as you can see, application master got allocated these two data nodes. Now this application master requested the node manager to launch these containers. Okay. As soon as the containers were launched, application master executed the task within the container and the result was sent back to the client. Let's understand this in a little sequential manner. Okay. So on the right, as you can see, these are the lines. The first one is the client. The second one is the resource manager. Third one is the node manager. And the fourth one is the application master. So let's see how are the steps executed between them. Okay. So very first step is client submits the job to the resource manager, as you can see right here. Now the second step is resource manager allocates a container to start the application master on the slave machines, right? The third step is application master registers with the resource manager, as you can see right here. As soon as it registers, it requests for the containers to execute the task. That is the fourth step. After that, application master notifies the node manager on which the container needs to be launched. Once the node manager has launched the containers, application master will execute the code within these containers. Finally, the client contacts the resource manager or the application master to monitor application status. Okay. And at the end, finally the application master unregisters itself from the resource manager and the result is given back to the client. Right? So this is one simple sequential flow of how a MapReduce program is executed using yarn framework.
Let me take this opportunity to explain you what is yarn and how it works. We'll first start with Hadoop version 1, where we had MapReduce version 1. So in MRV1, the two core services were HDFS, that is Hadoop Distributed File System, and MapReduce, which forms the basis of almost all Hadoop functionality. All other components are built around these services and must use MapReduce to run Hadoop jobs. While MapReduce method enables user to focus on the problem at hand rather than the underlying processing mechanism, they do limit some of the problem domains that can run in Hadoop framework. So now let us know how MapReduce version 1 works in order to understand its limitations. The MapReduce processing model consists of two separate steps. The first step is parallel map phase, in which input data is split into discrete chunks that can be processed independently. The second phase is the reduce phase, in which the output of map phase is aggregated to produce the desired result. This is simple and fairly restricted nature of programming model, which lends itself to a very efficient and extremely large scale implementation across thousands of low cost commodity servers. When MapReduce is paired with a distributed file system such as HDFS, which can provide high aggregate I/O bandwidth, the economic of the system becomes extremely compelling. This is a key factor in the popularity of Hadoop. One of the key to Hadoop performance is the lack of data motion, such as compute tasks are moved to the server on which the data resides and not the other way around. Specifically, the map task can be scheduled on the same physical nodes on which data resides in HDFS, which exposes the underlying storage layout across the cluster. This design significantly reduces the network input-output patterns and keeps most of the I/O on local disk or on a neighboring server within the same server rack. To understand the new yarn process flow, it is helpful to review the original Apache Hadoop MapReduce design. As a part of Apache Software Foundation, MapReduce has evolved and improved as an open source project. MapReduce project itself can be broken down into the end user MapReduce APIs for programming the desired MapReduce applications, the MapReduce runtime, which is the implementation of various phases such as map phase, sort, shuffle or merge aggregations, and the reduce phase, and the MapReduce framework, which is the backend infrastructure required to run users' MapReduce application, manage cluster resources, and schedule thousands of concurrent jobs, among other things. This separation of concerns has high significant benefits, particularly for end users, where they can completely focus on their applications via the API and let the combination of MapReduce runtime and the framework deal with the complex details such as resource management, fault tolerance, and scheduling. As you can see in the right hand side image, the master process is the job tracker, which serves as the clearinghouse for all MapReduce jobs in the cluster. Each node has a task tracker process that manages tasks on the individual node. The task tracker are controlled by the job trackers. The job tracker is responsible for resource management, tracking resource consumption, availability, and job lifecycle management, like scheduling individual tasks of the job, tracking progress, providing fault tolerance for tasks, etc. The task tracker has simple responsibilities like launch or tear down tasks on order from job tracker and provide task status information to the job tracker periodically. Hadoop MapReduce framework has exhibited some growing pains, in particular with regard to the job tracker, several aspects including scalability, cluster utilization, ability to control upgrades to the stack, and support for workloads other than MapReduce itself. MapReduce is great for many applications, but not everything. Other programming model better serves requirements such as graph processing and iterative modeling using message passing interface. As is often the case, much of the enterprise data is already available in Hadoop HDFS, and having multiple paths for processing is critical and clearly necessity. Furthermore, given the MapReduce is essentially for batch processing, support for real-time and near real-time processing has become an important issue for the user base. A more robust computing environment within Hadoop will enable organizations to see an increased return on their Hadoop investment by lowering their operational cost. Now, the first challenge was scalability. The processing power available in data center continues to increase rapidly. Consider the additional hardware capability offered by a commodity server over a 3-year period. In 2009, we had 8 cores, 16 GB of RAM, and 4 into 1 TB of disk. Coming down to 2012, we had 16 plus cores, 72 GB of RAM, and 12 into 3 TB of hard disk. These new servers are often available at the same price. In general, servers are twice as capable today as they were 2 or 3 years ago. MapReduce is known to scale to production deployment of approximately 5,000 server nodes in 2009 vintage. Thus, for same price, the number of CPU cores, amount of RAM, and local storage available to the user will put continued pressure on the scalability of new Apache Hadoop installations. So the next point is utilization. So in the current system, the job tracker views the cluster as composed of nodes with distinct map slots and reduce slots, which are not fungible. Utilization issues occurs because of map slots might be full while reduce slots are empty, or a vice versa scenario. Improving the situation is necessary to ensure the entire system could be used to its maximum capacity for high utilization and applying resources when needed. Next is user agility. In a real-time deployment, Hadoop is very commonly offered as shared multi-tenant system. As a result, changes to Hadoop software stack affects a large cross-section of enterprise. Against the backdrop, users are very keen to control upgrades to the software stack, as such upgrades have a direct impact on their applications. Now let us discuss a problem that Yahoo faced. Yahoo was the first company to embrace Hadoop in a big way, and it was a trendsetter within the Hadoop ecosystem. In late 2012, it struggled to handle iterative and stream processing system of data on Hadoop infrastructure due to MapReduce limitations. Scalability bottleneck was caused by having a single job tracker, According to Yahoo, the practical limit of such design are reached up to a cluster of 5,000 nodes and 40,000 tasks running concurrently. After implementing Yarn in first quarter of 2013, Yahoo installed more than 30,000 production nodes on Spark for iterative streaming, Storm for stream processing, Hadoop for batch processing, etc. Such a solution was possible only after Yarn was introduced and multiple processing frameworks were implemented. So to address these needs, the Yarn project was started by Apache Hadoop community to give Hadoop the ability to run non-MapReduce jobs within the Hadoop framework. Yarn provides a generic resource management framework for implementing Hadoop applications. In Hadoop version 2.x, MapReduce has undergone a complete renovation. Yarn is also known as MRV2, that is MapReduce version 2. Yarn provides both full compatibility with existing MapReduce application and a new support for virtually any distributed application. The introduction of Yarn does not change the ability of Hadoop to run MapReduce jobs. It does, however, position MapReduce as a merely one of the application frameworks within Hadoop, which works the same way as it did in MRV1. The new capability offered by Yarn is to use the new non-MapReduce frameworks that adds many new features to the Hadoop ecosystem. So as you can see here, in Hadoop 1.x, MapReduce serves two purposes, that is processing paradigm as well as resource management. Now in Hadoop 2.x, Yarn takes all the responsibilities of resource management, or MapReduce or other frameworks can be used as processing paradigms. The fundamental idea of Yarn is to split the two major responsibilities of job tracker, that is resource management and job scheduling or monitoring, into separate daemons, a global resource manager and a per application master. The resource manager and per node slave, the node manager, forms the new and generic operating system for managing applications in a distributed manner. Yarn relies on these three main components for all its functionalities. The first component is the resource manager, which is the arbitrator of the cluster resources. It has two parts, a pluggable scheduler and an application manager that manages user jobs on the cluster. The second component is the per node node manager, which manages user jobs and workflow on the given node. The central resource manager and the collection of node manager creates a unified computational infrastructure of the cluster. The third component is the application master, a user job lifecycle manager. The application master is where the user application resides. Together, these three components provide a very scalable, flexible, and efficient environment to run virtually any type of large-scale data processing jobs. So, the resource manager is the ultimate authority that arbitrates division of resources among all the applications in the system. Per application master is a framework-specific entity and is tasked with negotiating for resources from the resource manager and is working with the node manager to execute and monitor the component tasks. The resource manager has a pluggable scheduler component which is responsible for allocating resources to various running applications like capacity, queue, and other factors. The scheduler is a pure scheduler in the sense that it performs no monitoring or tracking of status for the application, offering no guarantees on restarting tasks that are not carried due to either hardware failure or could be application failure. The scheduler performs its scheduling function based on the resource requirement of an application by using the abstract notion of resource container, which incorporates resource dimensions like memory, CPU, disk, and network. The node manager is the per machine slave which is responsible for launching the application containers, monitoring their resources like CPU, memory, disk, network, and reporting the same to the resource manager. The per application master is responsible for negotiating appropriate resource containers from the schedulers, tracking their status, and monitoring the progress. From the system perspective, the application master runs a normal container. One of the crucial implementation details of MapReduce within the new Yarn system is the reuse of existing MapReduce framework without any major surgery. This step was very important to ensure compatibility of existing MapReduce applications and users. Now the major benefits of Yarn is increased scalability, better memory utilization with containers, and the third one is other frameworks can be integrated like Spark, Storm, Hive, etc. Now, by adding new functionalities, Yarn brings new components into Apache Hadoop workflow. These components provides finer grained control for the end user and simultaneously offer more advanced capabilities to Hadoop ecosystem. Let's look at them one by one. So first is resource manager. As mentioned earlier, the Yarn resource manager is primarily a pure scheduler. It is strictly limited to arbitrating requests for available resources in the system made by competing applications. It optimizes the cluster utilization, like keep all resource in use all the time, against various constraints such as capacity guarantees, fairness, and SLAs. To allow for different policy constraints, the resource manager has a pluggable scheduler that enables different algorithms such as those focusing on capacity and fair scheduling to be used as necessary. So as we discussed, resource manager has two components, that is scheduler and application manager. So the scheduler is responsible for allocating resources to applications and does not offer guarantees about restarting failed tasks. Scheduler also have pluggable policies, that is capacity scheduler or a fair scheduler, etc. Moving down to application manager is responsible for accepting job submission, negotiating with the first container for executing the application specific application master, and it also provides the service for restarting the application master on failure. Next is node manager. The node manager is Yarn's per node worker agent taking care of individual compute nodes in Hadoop cluster. Its duties include keeping up to date with resource manager, overseeing application containers lifecycle management, monitoring resource uses like memory, CPU, network, etc. of individual containers, tracking node health, log management, and auxiliary services that may be exploited by different Yarn applications. On startup, the node manager registers with the resource manager. It then sends heartbeat with its status and waits for the instruction. Its primary goal is to manage application containers assigned to it by the resource manager. Yarn containers are described by a container launch context, that is CLC. This record includes a map of environment variables, dependencies stored in remote accessible storage, security tokens, payload for node manager services, and the command necessary to create the process. After validating the authenticity of the container lease, the node manager configures the environment for the container, including initializing its monitoring subsystem with a resource constraint specified application. The node manager also kills container as directed by the resource manager. Now, next is application master. So application master is an important concept in Yarn. The application master is in effect an instance of the framework specific library and is responsible for negotiating resources from the resource manager. It is also working with the node manager to execute and monitor the containers and their resource consumption. It has the responsibility of negotiating for appropriate resource containers from the resource manager, tracking their status and monitoring progress. The application master is the process that coordinates an application's execution in the cluster. Each application has its own application master, which is tasked with negotiating resources from resource manager and with the node manager to execute and monitor the task. In Yarn design, MapReduce is just one application framework. This design permits building and deploying distributed applications using other frameworks. Once the application master is started, it will periodically send heartbeats to resource manager to affirm its health and to update the record of its resource demands. After building a model of its requirement, the application master encodes its preferences and constraints in a heartbeat message to the resource manager. In response to subsequent heartbeats, the application master will receive a lease on container bounds to allocation of resources at the particular node in the cluster. Depending on the containers it received from the resource manager, the application master may update its execution plan to accommodate the excess or lack of resource. Container allocation or deallocation can take place in dynamic fashions as an application progresses. The application master design enables Yarn to offer some important features like scalability. The application master provides much of the job-oriented functionality to the job tracker so that the entire system can scale more dramatically. Simulations have shown that jobs may scale to 10,000 node clusters composed of modern hardware without any significant issue. As a pure scheduler, the resource manager does not have to provide fault tolerance of resources across the cluster. By shifting fault tolerance to application master instance, control becomes local rather than global. Second is moving all the application framework specific code into the application master generalizes the system so that it can now support multiple frameworks such as MPI, that is message passing interfaces, and graph processing. In reality, every application has its own instance of an application master. However, it is completely feasible to implement an application master to manage a set of applications. Furthermore, This concept has been stressed to manage long-running services which manage their own applications. Example, launching HBase in Yarn via a special HBase app master. So you can go ahead and see the responsibilities of application master, that is managing the application lifecycle, making dynamic adjustment to resource consumptions, managing execution flow, managing faults, providing status and metrics to the resource manager, interacting with node manager as well as resource manager, and so on. So next component is containers. Yarn has a pluggable scheduling component. Depending on the use case and user needs, administrator may select either a simple, that is first in first out capacity, or a fair share scheduler. The scheduler class is set in yarn default.xml file. At the fundamental level, a container is a collection of physical resources such as RAM, CPU, cores, and disk on a single node. There can be multiple containers on a single node. Every node in the system is considered to be composed of multiple containers of minimum size of memory and CPU. The application master can request any container so as to occupy a multiple of minimum size. A container is supervised by the node manager and scheduled by the resource manager. Each application starts out as an application master, which is itself a container, often referred as container 0. Once started, the application master must negotiate with the resource manager for more containers. Container requests can take place in a dynamic fashion at runtime. For instance, a MapReduce job may request a certain amount of mapper containers. As they finish their task, it may release them and request more reducer containers to be started. Now, as we have already discussed, yarn containers are described by a container launch context, that is CLC. So, this record includes a map of environment variables, dependencies stored in remotely accessible storage, security tokens, payload for node manager services, and the command necessary to create the process. So, a CLC includes everything that you need to launch a container. Moving ahead, let us understand the yarn workflow. So in earlier Hadoop versions, each node in the cluster was statically assigned the capability of running a predefined number of map slots and a predefined number of reduce slots. The slots could not be shared between maps and reduces. The static allocation of the slot wasn't optimal because slot requirements vary during the MapReduce application lifecycle. Typically, there is a demand of map slots when the job starts, as opposed to the need of reduced slots towards the end of the job. The resource allocation model in Yarn addresses the inefficiencies of static allocation by providing a greater flexibility. As discussed previously, resources are requested in form of containers, where each container has a number of non-static attributes. Yarn currently has attribute support for memory and CPU. The generalized attribute model can also support things like bandwidth or GPUs. So, first, let's look at the client resource request. So, as you can see, a Yarn application starts with a client resource request. A client communicates with the application manager component of the resource manager to initiate this process. The client must first notify the resource manager that it wants to submit an application. The resource manager responds with an application ID and information about the capabilities of the cluster that will aid the client in requesting resources. Next, the client responds with an application submission context. The application submission context contains the application ID, user, queue, and other information needed to start the application master. In addition, a CLC, that is container launch context, is sent to the resource manager. As we already have discussed about CLC, that it contains job files, security tokens, resource requirements, and other information needed to launch an application master on the node. Once the application has been submitted, the client can also request the resource manager kill the application or provide status report about the application. When the resource manager receives the application submission context from a client, it schedules an available container for the application master. If there are no applicable containers, the request must wait. If a suitable container can be found, then the resource manager contacts the appropriate node manager and start the application master. As part of this step, the application master RPC port and tracking URL for monitoring the application status will be established, using which your client can see the application status. In response to the registration request, the application master will send information about the minimum and maximum capabilities of the cluster. At this point, the application master must decide how to use the capabilities that are currently available. Based on the available capabilities reported from the resource manager, the application master will request the number of containers. The request can be very specific, including containers with multiple of resource minimum values. The resource manager will respond as best as possible to the request with container resources that are assigned to the application master. As the job progresses, heartbeat and process information is sent from the application master to the resource manager. Within these heartbeats, it is possible for the application master to request and release containers. When the job finishes, the application master sends the finish message to the resource manager and exits. Next is application master and container communication. At this point, the resource manager has handed off control of assigned node managers to the application master. The application master will independently contact its assigned node managers and provide them the container launch context that includes environment variables, dependencies located in remote storage, security tokens, and commands needed to start the actual process. Next, the node manager launches the container. When the container starts, all data files, executables, and necessary dependencies are copied to local storage on the node. Dependencies can potentially be shared between containers running the application. Once all containers have started, their status can be checked by the application master. The resource manager is absent from the application progress and is free to schedule and monitor other resources. The resource manager can direct the node manager to kill containers. Expected kill events can happen when the application master informs the resource manager of its completion, or the resource manager needs nodes for other applications. When a container is killed, the node manager cleans up the local working directory. When a job is finished, the application master informs the resource manager that the job is completed successfully. The resource manager then informs node manager to aggregate logs and clean up container specific files. The node manager are also instructed to kill any remaining containers, including the application master, if they have not already exited. Now let us quickly move ahead and look at the summary of the Yarn application workflow. So first, client submits an application to the resource manager. Then resource manager allocates the container and starts the application master. Then application master registers the container with resource manager. Second, the application master asks for the containers from resource manager. Moving ahead, application master notifies node manager to launch containers. Application code is executed in containers. Then client contacts resource manager and application master to monitor the application health. At last, application master unregisters with the resource manager and leaves all the resources acquired by it. So let us now quickly understand how Yarn works. Let's go to VM. So this is our VM. I'll be executing a simple word count example. So let us go to our Hadoop home. In share, Hadoop MapReduce. So we have a sample Hadoop MapReduce examples. So in this jar, we have a word count file which we can execute and check the status of Yarn. But before that, I'll show you the HDFS. So this is the HDFS. You can see we have one data node. Let us browse the file system. So this is the word count underscore input.txt file, which I'll be giving as input for the word count. If you are not having any file on your HDFS, you can go ahead and execute put command. So let us quickly go ahead and execute this command. The command is Hadoop jar, then the name of the jar file, that is Hadoop MapReduce examples. The name of the class is word count, and then we'll give the input file, that is, let me tally it, word count underscore input.txt, and the output files will be stored in output directory, which is in the root of HDFS. So let us quickly go ahead and execute this command. Meanwhile, we'll go to our Yarn web UI, that is 8088. So this is the Yarn web UI. As you can see, this is the application that we are executing. This is the application ID, the user, so the name of the application, that is word count, type of application. Again, the status is accepted, final status is undefined. There is one container running, allocated CPU vCores is 1. And here you can track the progress of the application. This is the tracking UI. Let us go to the tracking UI. So state is succeeded. Let us go back to our terminal. As you can see, the program has been successfully executed. You can also see the parameters over there, like number of bytes to be read, number of bytes to be written, number of read operations, the number of write operations. Again, you can figure out the MapReduce framework, how many number of map input records, number of map output records, and then we have all the MapReduce details over here. So let's not worry about them. So it gives you all the details related to that job which you have executed. You can see the log files that has been created while executing this job. You can also track it on your web history server, that is localhost 19888. So again, you can see this word count job, and you can again track the details, that average map time, shuffle time, average reduce time. So these are the details, guys. Let us go to that HDFS browser and look at the output file that has been created. So this is the output file. Let's go ahead and download it. So as you can see, the number of count for car is 4, deer is 3, and the river is 2. So this is the output that we received. I've given a simple input file. Let me show you the file as well. This is the input which we have given, and this is the output which we have received.
So what were the problems associated with the relational database system? As I have already mentioned that for a Hadoop developer, actual game starts after the data is being loaded in HDFS, and the developers play around this data in order to gain various insights that are hidden in the data stored in HDFS. So, for this analysis, the data residing in the RDBMS needs to be transferred to HDFS. And you all know that the task of writing MapReduce code for importing and exporting the data from relational database to HDFS is tedious. So this is where Apache Sqoop comes to rescue and remove the pain of data ingestion. So why do we need Sqoop? It's a known fact that before big data came into existence, the entire data was stored in relational database servers in the relational database structure. But with the advancement of Sqoop, it makes the life of developers easier by providing CLI for importing and exporting the data. And Sqoop internally converts a command into MapReduce tasks, which are then executed over HDFS. It uses Yarn framework to import and export the data, which provides fault tolerance on top of parallelism. It also uses Yarn framework to import and export the data, which provides fault tolerance on top of parallelism. Not only that, it is also very useful for data analysis, high in performance, and provides command line interface. Now let's understand what is Sqoop. So before I tell you what is Sqoop, let me tell you how the name Sqoop came into existence. By now, I hope that you have got an idea that it is used for data transfer between relational database and HDFS. So before I tell you what is Sqoop, let me first tell you how the name came into existence. The first two letters in Sqoop stands for the first two letters in SQL, and the last three letters in Sqoop refers to the last three letters in Hadoop, that is OOP. So it clearly depicts that it is SQL to Hadoop and Hadoop to SQL. That is how the name of Sqoop came into existence. So what is Sqoop? It is a tool used for data transfer between RDBMS like MySQL, Oracle, SQL, etc. and Hadoop like Hive, HDFS, Hbase, etc. It is used to import the data from RDBMS to Hadoop and export the data from Hadoop to RDBMS. Simple. Again, Sqoop is one of the top projects by Apache Software Foundation and works brilliantly with relational databases such as Teradata, Netezza, Oracle, MySQL, etc. It also uses MapReduce mechanism for its operations like import and export work and work on a parallel mechanism as well as fault tolerance. As I have already mentioned that it provides command line interface for importing and exporting the data, the developers just have to provide the basic information like database authentication, source, destination, operations, etc. And the rest of the work will be done by Sqoop tool itself. Sounds much reliable, correct? Now let's move further and talk about some of the amazing features of Sqoop for big data developers. First, full load. Apache Sqoop can load whole table by a single command. You can also load all the tables from a database using a single command. Next, incremental load. Sqoop provides the facility of incremental load where you can load the parts of a table wherever it is updated. Next, parallel import and export. Again, as already mentioned, Sqoop uses Yarn framework to import and export the data, which provides fault tolerance on top of parallelism. Next, compression. You can compress your data by using gzip algorithm with compress argument or by specifying compression codec argument. Next, Kerberos security integration. So what is Kerberos? It's a computer network authentication protocol which works on the basis of tickets to allow the nodes that are communicating over a non-secure network to prove their identity to one another in a secure manner. Next, load data directly into Hive and Hbase. Here, it is very simple. You can load the data directly to Apache Hive for analysis, and you can also dump your data in Hbase, which is a NoSQL database. Now let's see what's next. The architecture is one of the empowering Apache Sqoop with its benefits. Now, as we know the features of Apache Sqoop, let's move ahead and try to understand Apache Sqoop's architecture and its working. So when we submit our job or a command through Sqoop, it is mapped into map task, which brings the chunks of data from HDFS. And these chunks are exported to a structured data destination. And combining all these exported chunks of data, we receive the whole data at the destination, which in most of the cases is RDBMS server. Next, reduce phase is required in case of aggregations. But Apache Sqoop just imports and exports the data. It does not perform any aggregations. Map job launch multiple mappers depending on the number defined by the user. For Sqoop import, each mapper task will be assigned with the part of data that is to be imported. And Sqoop distributes the input data among all the mappers equally in order to achieve high performance. Then, each mapper creates a connection with the database using JDBC and fetches the part of the data assigned by the Sqoop, and then writes that data to HDFS, Hive, or Hbase based on the arguments provided in the command line interface. So this is how Sqoop import and export works. Like they gather the metadata, again it submits only map job, the reduce phase will never occur here, and then it stores the data in HDFS storage. Coming to Sqoop export, it's the same thing. The data will be reversed back to RDBMS. So here, the Sqoop import tool will import each table of the RDBMS in Hadoop, and each row of the table will be considered as a record in the HDFS. And all the records are stored as text data in the text files or binary data in sequence files. On the other hand, the Sqoop export tool will export the Hadoop files back to the RDBMS tables. Again, the records in the HDFS files will be the rows of a table, and those are read and passed into a set of records and delimited with the user-specified delimiter. So this is all about the Sqoop architecture and its import and export. Now, let's execute some Sqoop commands and understand how it works. So at the first, we have Sqoop import. That is, it imports the data from RDBMS in Hadoop. The command goes very simple. Here, you have to just provide the connection for MySQL, your IP address, your database name, your table name, the username for MySQL user. If you have set privileges for password, you can specify the password or it is not required, and the target directory. Now, let's see how to execute. So I'll open my terminal and check whether all my Hadoop daemons are up and running or not. So I can see that all my Hadoop daemons are up and running. So now let's execute Sqoop help and see whether the Sqoop has been properly installed or not. So these are the available commands in Sqoop. Here I will show you the execution and explain you few of these commands. Now this is also properly been set. Now I will open another terminal and connect to MySQL database. The command goes like this. My user is Edureka, so I'm giving it as Edureka. You can give it as root if your user is root. Simple. So now I'm into MySQL database. If you want to create a database, you can create a database by giving this command, create database, database name, etc. As I have already created a database, so I'll just specify show databases command to list the database present in the MySQL database. So now these are the list of database present here. So now I want to use employees database. So I'll give use employees. Database got changed. Now I want to list the tables present in the employees database. So I'll give show tables. So these are the 11 tables present in the database employees. Now let's say I want to use employees table. So what will I do? I'll just give select star from employees. That is table name. So it's just a huge amount of data that is present in this database. So there are these many rows present in this table. Now open the other terminal where you have executed this command, and here I will show you how to import the data present in that table to HDFS. So how we are going to do that? By using Sqoop import command. The command goes like this. The IP here is localhost, and you know that employees is my database name, and the username will be Edureka, And the table that I have chosen is employees. So I have not set any privileges for password, so I'm not specifying the password over here. So it got executed. And you can see the number of job counters, the MapReduce framework, the input records, output records, etc. So what happens after executing this command? The map task will be executed at the backend. Now let's check the web UI of HDFS. That is, the web UI port for HDFS is localhost 50070. And let's see where the data got imported. One important thing to note, I have not specified target directory. So by default, the data will be imported to this folder, user, Edureka, and employees. So here you can see the 4 different part files where our data got imported. So you might be thinking, why 4? Correct? Here I have not specified the number of mappers. So by default, it takes the number of mappers to 3 and then gives the output in 4 different part files. So let's open the part file and see how the output will be. So here you can see the data is imported from RDBMS to HDFS. There's lots of data being present over here. I'm just scrolling down and it's not coming to an end. Similarly, the output will be same in the other part files as well. So this is all about the simple Sqoop import command without specifying the target directory and the number of mappers. Now let's see how to import the data from RDBMS to HDFS by specifying the target directory. This part remains out to be the same. Now I will do one thing. I'll specify the number of mappers as 1 so that your output will be in just one single part file, and then I will specify the target directory as well. And I will name the target directory as employee 10. Enter. Again, it takes a lot of time to execute because there is a lot of data present in the database. So it got executed and retrieved these many records. Again, you can see the MapReduce framework, the number of bytes written, number of read operations, write operations, etc. Now again, let's go to the HDFS browser and see the output. So I had specified the target directory name as employee 10. So you can see it here. And the output is just in one single part file because I have specified the number of mappers as 1. In this case, you can control the number of mappers independently from the number of files present in the directory. So the entire records will be present in one single part file. So this is the output. Now, let me tell you how to import the command using where clause. Here you can import a subset of the table using the where clause in Sqoop import tool. It executes a corresponding SQL query in the respective database server and stores the result in a target directory in HDFS. So this is how the command goes. The same command as before. I'll just change the name of the target directory. I'll specify employee 11 and I will increase the number of mappers to 3. And here I will specify the where clause. So let's give a condition like where the employee number will be greater than 49,000. It should display the output. Enter. So what you expect your output will be. So here it displays the output records of the employees whose employee number is greater than 49,000. So here it retrieved these many records which are above the employee number 49,000. Now let's check the output. So I have specified the target directory name as employee 11. So here you can see the output that it has retrieved the records of employee number which is more than 49,000. So I hope you understand how to do this. Next, let's see how to import all the tables from the RDBMS database server to the HDFS. Here, each table data is stored in a separate directory and the directory name is same as the table name. It is mandatory that every table in that database must have a primary key field. The command will be simple like simple import, but just that you have to remove the table name and you have to replace the import with import all tables. That's all. So it will retrieve all the tables present in the employees Okay, so it imported all the tables from RDBMS to HDFS. Now let's check the output. Again, I have not specified the target directory file. So by default, it will be in user Edureka, and you can see here it imported all the tables present in the database to HDFS. So these are the various tables present in RDBMS, and now it is present in HDFS. So this is how import all tables command works. So this was all about executing import command in various ways. Now let's move further and see how the Sqoop export works. It exports the data from HDFS to RDBMS, correct? Again, the command goes very simple. You have to specify the connection, your table name, username, and instead of the target directory, you have to specify the export directory path. So let's see how it works. One important thing to notify, the target table must exist in the target database. That is, the data is stored as records in HDFS, and these records are read and passed and delimited with the user-specified delimiter. The default operation is to insert all the records from the input files to the database using the insert statement. In update mode, Sqoop generates the update statement that replaces the existing record in the database. So first we are creating an empty table where we will export our data. I'm going to create a table called employee 0. The primary key value should never be null, so I'm specifying it as not null. So here I created an empty table called employee 0, and now I'll show you how the Sqoop export works. Here, instead of import, I'll make it as export. This is the database name, and I have created a table called employee 0, and I'm going to specify the path for export directory. Simple, that's all. So you can see here it exported all these records into the RDBMS. So now let's cross-check. I'm going to give select count star from the table name that I have specified to export the tables. So you can see the entire records got exported to this table. So this is how the Sqoop export works. Now let's see how to list the database present in the relational database. Here, you need not even specify the database name because you're going to list the database that is present in the relational database system. So you're going to specify list databases and execute the command. So the databases present in the relational database system is test, JDBC test, employees and information schema. Again, let's cross-check. I'm going to give show databases. It retrieved the same database. So the result tallies. So we can also list the tables present in the database. Let's see how to list all the tables present in the database. Again, it's very simple. You have to just specify the database name, like here, and give list tables instead of import. So you can see that it listed all the tables present in the database, employees. So again, let's cross-check. Show tables. Same thing. And now let's see what is 𝐂𝐝𝐿. In object-oriented application, every database table has one data access object class that contains getter and setter methods to initialize the objects. And 𝐂𝐝𝐿 generates DAO class automatically. And it also generates the DAO class in Java based on the table schema structure. So this is a simple command. Let's see how to execute it. Here I will give Sqoop 𝐂𝐝𝐿 and give the connection and the database name as employees. And I'm going to specify the table name as well. So it is going to create an employee jar file in which the backend code will be generated. So I'll copy this path and jump into this directory. So you can see here that it created employees class, jar file and the Java object file as well. So now let's open the file system and check for the file. So what was the name of the file? It ends with 539D9. So here is the folder. So in this you can see the object file that is being generated. So this is the backend code that is being generated. So this is all about how the Sqoop 𝐂𝐝𝐿 works. Why do we need Flume for data ingestion? Let's take a scenario here. Say we have hundreds of services running in different servers and that produce lots of large logs which should be analyzed together. And we already have Hadoop to process these logs. So how do we send all the logs to a place that has Hadoop? It's an obvious fact that we need a reliable, scalable, extensible, and a manageable way to do it. So to resolve this problem, Apache Flume came into picture, which is the most reliable, distributed, and available service for systematically collecting, aggregating, and moving large amounts of streaming data into the HDFS. And that's why and where we need Flume. So what is Apache Flume? By now, you all might have thought that Flume is a tool for data ingestion in HDFS. It collects, aggregates, and transports large amount of streaming data such as log files, events from various sources like network traffic, social media, email messages, etc. The main idea behind the Flume's design is to capture streaming data from various web servers to HDFS. It has very simple and flexible architecture based on streaming data flows. It is fault tolerant and also provides a reliability mechanism for failure recovery. Again, Flume can easily integrate with Hadoop and dump all the unstructured as well as the semi-structured data on HDFS, and that complements the power of Hadoop. This is why Apache Flume is said to be the most important part of Hadoop ecosystem. Now let's move further and see the benefits of Flume. There are several advantages of Apache Flume which makes it a better choice over others. I have listed some of the benefits. Flume is scalable, reliable, fault-tolerant, and customizable for different sources and sinks. It can also store the data in centralized storage like Hbase, HDFS, etc. If the read rate exceeds the write rate, Flume provides a steady flow of data between read and write operations. Flume also provides a reliable message delivery. The transactions in the Flume are channel-based where 2 transactions are maintained for each message. That is, 1 sender and 1 receiver for each message. Using Flume, we can ingest the data from multiple servers into Hadoop. And it also helps us to ingest online streaming data from various sources and supports a large set of sources and destination types. So let's see what's next. The architecture is the one which is empowering Apache Flume with its benefits. Now, as we know the advantages of Apache Flume, let's move ahead and understand Apache Flume's architecture. One important thing to note here, there's a Flume agent which ingests the streaming data from various data sources to HDFS. From this figure, you can easily understand that web server, Facebook, cloud, social media, all these indicate the data source from where we are getting the data. And Twitter is among one of the famous sources for data streaming. And now coming to Flume agent, it comprises of 3 components: source, sink, and channel. First, source. It accepts the data from the incoming streamline and stores the data in the channel. Now coming to channel, in general, the reading speed is faster than the writing speed. Thus, we need some buffer to match the read and write speed difference. Basically what happens, the buffer acts as an intermediary storage that stores the data which is being transferred temporarily and therefore prevents data loss. Similarly, channel acts as a local storage or a temporary storage between the source of data and the persistent data in HDFS. Now coming to our last component, sink, it collects the data from the channel and commits or writes the data in the HDFS permanently. So this is all about the working of Flume architecture. As we know how Apache Flume works, let's take a look at the practical where we will sync the Twitter data and store it in the HDFS. In this figure, you can see there is lots of data generated from Twitter. Now you want to go ahead and stream this data. So how will you do it? For this, we have Apache Flume, which will help us to do the real-time data streaming of Twitter data and store it in the HDFS. So let's see how to do it. So first, we will create an application and get the tweets from it. Here we use the experimental Twitter source provided by Apache Flume. So here we will use memory channel to buffer these tweets and HDFS sync to push these tweets into the HDFS. The first step is to create a Twitter application. For this, you have to go to this URL, that is apps.twitter.com, and you have to sign in to your account. If you do not have developer account, you have to apply for the one by completing the form. As I already have a developer account, I'll just click on developer.twitter.com and click on my profile and choose apps. So here you have an application called Create an App. Here you have to fill these required fields. First, app name. Now while filling the website address, you have to give the complete URL pattern like this. And then you have to specify how this app will be used. I'll say something like this. So after everything is done, you have to just click on create. So your application got created. Now click on keys and tokens. And here you will find something called as consumer API keys, an access token and access token secret. You have to regenerate this and you have to create an access token keys. Now we got the API key, the API secret key, the access token, and the access token secret as well. So copy the key and access token. So you might be thinking why you need to copy these things. We need to pass these tokens in our Flume configuration file to connect to this Twitter application. So I'm going to copy this. Make sure you copy it properly. Now let's create a Flume configuration file in the Flume's root directory. I have already created a flume.conf file. I'll show you how to specify the parameters. As we have discussed in the Flume's architecture, I have configured source, sink, and channel. Here our source is Twitter, channel is memory channel, and the sink is HDFS. In source configuration, we are passing the Twitter source type as this. Then we are passing all the 4 tokens which we have received from Twitter. That is the keys and the secret keys that I have copied. Make sure you paste them properly. At last, in the source configuration, we are passing the keywords on which we are going to fetch the tweets. So I have specified some keywords like Spark, Hadoop, Big Data, Analytics, Cloud Computing, etc. Now in the sink configuration, I have configured the HDFS properties. That is, HDFS channel as memory channel. The type will be HDFS. The path of HDFS where the Flume tweets will be stored. The file type, the write format will be always text. Remember that. The batch size, the role size, role count, etc. And at last, we are going to set the memory channel properties like the type, capacity, and the transaction capacity. Now save this file and close it. For my convenience, I'll copy this file from Flume directory and paste it in the home directory. Okay. Now we are all set for execution. Let's go ahead and see how to execute this command. Now I have placed a flume.conf file from the Flume's root directory to home directory. So I'll go back to the home directory and then run the command. The command goes like this. That is flume ingestion conf file path, that is home Edureka and the conf file name. The name will be Twitter agent and dflume.root.logger will be debug.console. Enter. Now it started executing. So you can see here it started processing the records and created this Flume tweets folder. In that you have this file. So after executing this command for a while, you can exit the terminal using Ctrl+C. Now let's open the web browser and go to HDFS Web UI. So here in the mention path, you can check the file that is present. So here you have Flume tweets. Click on that. So this is the output file where the data will be streamed. So this is the output where you can see the tweets from the followers. Someone is saying, as a survivor of a politically motivated attack, it's tragic to think this is an acceptable state of political discourse. It depends, like whatever you follow and you will get all those things. And here someone is saying Youth Association for Transforming National Kulu based on NGO working in the field education, environment protection, health and general awareness among the people. So this output is nothing but the live data streaming of Twitter data.
What is Apache Pig? So Apache Pig is an abstraction over MapReduce. It is a tool or platform which is used to analyze larger sets of data, representing them as data flows. Pig is generally used with Hadoop. We can perform all the data manipulation operations in Hadoop using Apache Pig. To write data analysis programs, Pig provides a high-level language known as Pig Latin. This language provides various operators using which programmers can develop their own functions for reading, writing, and processing data. To analyze data using Apache Pig, programmers need to write scripts using Pig Latin language. All these scripts are internally converted into map and reduced as respectively. Apache Pig has a component called Apache Pig Engine that accepts the Pig Latin scripts as input and converts those particular scripts into MapReduce jobs. So this was a basic introduction to Apache Pig. Now moving ahead, we shall understand the different modes in which Apache Pig functions. There are two particular modes in which Apache Pig functions. Those are the local mode and MapReduce mode. First, we will understand what exactly is local mode. In local mode, Apache Pig is designed to execute in a single JVM and is used for development, experimenting, and prototyping. Here, files are installed and run using localhost. The local mode works on local file system, and the input and the output data is stored in the local file system. To access the command or the grunt shell in local mode, you need to execute a command called pig-x local. We shall practically execute this in the demo section. Now moving ahead, we shall discuss about the second type of mode in which Apache Pig can be run. That is the MapReduce mode. The MapReduce mode is also known as Hadoop mode. Apache Pig chooses Hadoop mode as its default mode. In this, Pig renders Pig Latin into MapReduce jobs and executes them on a Hadoop cluster. It can be executed against semi-distributed or fully distributed Hadoop installation. Here, the input and the output are present on HDFS. The command for executing pig in MapReduce mode is pig or pig-x MapReduce. Again, we shall discuss about this particular command in our demo section, where I'll show you both the modes and execute the pig scripts there. Now, followed by the pig modes, we shall understand the ways to execute pig program. So basically, the pig scripts are executed in three particular modes. Those are interactive mode, batch mode, and lastly, the embedded mode. Don't worry, I'll explain to you each of these modes. Firstly, we shall discuss about the interactive mode. In this particular mode, the pig is executed in a grunt shell. To invoke grunt shell, run the pig command. Once the grunt mode executes, we can provide pig Latin statements and command interactively at the command line itself. So the next mode is the batch mode. In this particular mode, we can run a script file having a .pig extension. These files contain the pig Latin commands. So basically what we do is we write the pig command or the pig script and store it in a location. And using the terminal, we will access that particular location and that particular file and run the code present in that file. So this is what happens in batch mode. So followed by that, the last mode is the embedded mode. In this particular mode, we can define our own functions. These functions can be called as user-defined functions. Here, we use programming languages like Java and Python to define our own user-defined functions. So these were the three different modes in which we can execute pig scripts. Now moving ahead, we shall enter into our next topic, that is the features of pig. So there are 5 different and important features of pig. So first up, we shall understand the ease of programming. Writing complex Java programs for MapReduce is quite tough for non-programmers. Pig makes this process very easy. In the pig, the queries are converted into MapReduce processes internally. So obviously, it has grown the ease of programming. Followed by that, the next important feature is the optimization opportunities. So what exactly is optimization? It is how the tasks are encoded permits the system to optimize the execution automatically, allowing the user to focus on semantics rather than efficiency. So followed by the optimization, we have the extensibility. A user-defined function is written in which the user can write their logic to execute over the datasets. So this increases the extensibility of the programmer. Followed by that, the next important feature is it is highly flexible. Apache Pig can easily handle structured as well as unstructured data. So Apache Pig tool is considered to be highly flexible, irrelevant of the data type. Followed by that, the last and important feature is inbuilt operators. Apache Pig contains various types of operators such as sort, filter, joins, and many more, which are inbuilt. So here, the programmer doesn't have to program these functions externally. Instead, he can just directly get an access to those inbuilt functions and execute them. So these were the 5 important features of Apache Pig. So the next topic in our today's discussion is Apache Pig installation into our local system. Now we shall discuss about one of the easiest ways to install Apache Pig into our local system. So today I'll explain you how to install Apache Pig into Windows operating system. So to do this, the easiest way is to download one of the virtual machines. So I would prefer you to download Oracle VirtualBox for this particular task. Followed by that, we shall also download a quick start VM of Cloudera. Don't worry about the softwares, I'll drop down the link for those softwares in the description box below. You can use that and download them. So once after the Oracle VirtualBox is installed into a local system and it is running, this is how it looks like. Now what we want to do is to add a new virtual machine into our VirtualBox. So for that you just need to select import option and it will give you a new dialog box, and from here you must redirect to the location where your VirtualBox is located. So in my system, it's located in F drive, and inside F drive CCA, Cloudera VirtualBox Cloudera Quick Start VM. So there you go. Now you just have to select open. And before we actually select the button import, you might want to select the RAM and increase its size to at least 8 GB. So I'll just write in 9000 MB, which is just a little above 8 GB. Now we are good to go. Just select the option import and your VirtualBox will be imported. You can see that the quick start VM is getting imported. Now you can see that the virtual machine got successfully imported. Now to start it, all you need to do is just click on it and then select the start button. So you can see that the Cloudera Quick Start VM version 5.13.0 has been successfully imported and booted up. Here we are. We have the Quick Start Cloudera VM welcome note. And now if you want to start up with Pig Editor, you might want to log into Hive first or your HDFS. Remember, in Cloudera, the default username is Cloudera and the password also is Cloudera. Now let me tell you, in Cloudera, the default username and password for everything is Cloudera. For example, let's log into our Hive using the username Cloudera and password Cloudera. Now you might want to just select remember to remember your password. And there you go, you have successfully logged into Hive. And now, if you want your query editor for Pig, you can just select the bottom arrow mark, and there you can select editor, and inside editor you have the editor designed for Pig. Now you are in the window where you can write Pig scripts and execute them. Now we will move ahead into our next topic, and after finishing the theory part, we shall come back into our Cloudera and execute some of the basic operations on Pig terminal. So our next concept is understanding the Pig architecture. So first of all, let us go through the diagram of Pig architecture. The following diagram represents the architecture of Apache Pig. As shown in the figure, there are various components in Apache Pig framework. Let us look at the major components. Firstly, the parser. Initially, the Pig scripts are handled by the parser. It checks the syntax of the script, does type checking and other miscellaneous checks. The output of the parser will be a DAG, which is directed acyclic graph, which represents the Pig Latin statements and logical operators. In directed acyclic graphs, the logical operators of the scripts are represented as the nodes and data flows are represented as edges. And next, the optimizer. The logical plan for directed acyclic graphs is passed to the logical optimizer. This carries out the logical optimizations such as projections and pushdowns. Next comes the compiler. The compiler is used to compile the optimized logical plan into the series of MapReduce jobs. Followed by that, we have the execution engine. Finally, the MapReduce jobs are submitted to the Hadoop in a sorted order. Finally, these MapReduce jobs are executed on Hadoop, producing the desired results. So this was a basic explanation based on Apache Pig architecture. Now moving ahead, we shall understand the major advantages of Apache Pig. So some of the major advantages of Apache Pig are less code. The pig consumes less than a line of code to perform any operation. So this reduces the number of lines included in the code. Followed by that, code reusability. The pig code is so flexible enough to reuse it again. You can basically write the pig script into a file and access the file whenever you need it. So followed by that, the next important advantage of Apache Pig is the nested data types. The pig provides a useful concept of nesting data types like tuple, bag, and map. So these were the few important advantages of Apache Pig. Now we shall move ahead into the next topic, which is about the differences between Apache Pig and Apache MapReduce. So there are basically 4 differences between Apache Pig and Apache MapReduce. So first up, we will begin with MapReduce. In MapReduce, we have low-level data processing. When it comes to Apache Pig, it is considered as a high-level data processing tool. Followed by that, the next important difference between MapReduce and Apache Pig is that we find complex Java programs when we are using MapReduce. But when we come into Apache Pig, we have simple programming scripts, which are shorter in code length and easily understandable. Followed by that, the third difference is the data operations are completely tough and complicated in MapReduce. But in Apache Pig, you don't have to worry about those operations because they're already built in. Next, and the last difference between MapReduce and Apache Pig is Apache MapReduce does not allow nested data types, whereas Apache Pig allows nested data types. So these were the basic differences between Apache MapReduce and Apache Pig. So the next topic is the Pig demo. Here, we will understand all the basic commands in Apache Pig and the basic functionalities which are available in Pig. Now, without further ado, let's quickly begin with our demo for today's session. Now, we have come back to our Cloud Era that we have installed into our local system. Now, let's start Pig. As we have discussed before, Apache Pig can be executed in 2 modes. They are the local mode and the MapReduce mode. Firstly, we shall execute an example based on local mode. To start Pig in local mode, you need to type in the command pig space -x space local. Firing this command will enable Pig in local mode. As you can see, the command is getting decrypted. Now you can see that it has successfully started the grunt shell in local mode. Now what are we going to execute? We are going to execute a very simple word count program. For this particular word count example, I have considered a basic text, that is the definition of Apache Pig, which happens to be Apache Pig is a high-level platform for creating programs that run on Apache Hadoop. The language for this particular platform is called Pig Latin. Pig can execute its Hadoop jobs in MapReduce, Apache Test, and Apache Spark. So we will consider this particular paragraph, and we will also count the number of words which are included in this particular paragraph. Now let's quickly go back to our terminal and execute our program. So now we have come back to our terminal. Let's clear it using the command Ctrl+L. Now let's quickly start up typing our commands. So as discussed before, we are going to execute this particular program in local mode. So here we are not loading the data into HDFS. Instead, we are considering the local location, which is the local location that is home Cloudera desktop word count. Now we're going to run this command and see the output. So the data has successfully loaded. Now we'll execute the next command. So now we're going to tokenize each and every single word in this particular paragraph, and we'll be considering each and every word as a single word, and we are going to separate each and every word by using a space. Now let's fire up this command and see the output. Yeah, the command just got executed, or the script just got executed. Now in the next script, we are going to group the words according to their occurrence. Yeah, even that is done. Now the next script would help us to count the number of words which have been repeated. So even that is done. Now the last script would be dumping the output which is stored in p word c, which is big word count. Now let's enter the command and see the output. You can see some MapReduce jobs that are getting executed, and there you go. We have our output. So the words are in, on, for, its, days, Hadoop, Apache, and all those words. And along with them, we also have the number of repetitions of each and every word. For example, we have Hadoop, which is repeated 1 time, and the word Apache is repeated for 4 times, and so on. So with this, now let us move ahead and execute some examples based on Apache's Hadoop mode or MapReduce mode. Now let's close this terminal and open a new one, and let's begin executing Hadoop in MapReduce mode. As discussed before, Apache Pig can be executed in both local mode and MapReduce mode. We have already executed some examples based on local mode. Now we shall execute some examples based on MapReduce mode. To do so, we will first load some local data into HDFS. So using this command, I'll be loading my local data, that is pictutorial.csv, into my HDFS, and I'll name it as Edureka in. As you can see, the command is getting deprecated and the data has been successfully loaded. Now let us use cat command and see what exactly is present in that particular data. As you can see, the command got deprecated and the data is a simple CSV file related to students that has ID, name, department, and year. Now let's start Pig in MapReduce mode. To do so, we just need to type in PIG and strike enter. There you go, we have successfully started Pig in MapReduce mode. Now let's execute some commands. So using this command, we will be loading edureka.in, that is the data, the CSV file which we have discussed before, using pig storage as comma separated file, and the schema for the data will be ID as character array, name as character array, department as character array, and year as integer array. Now let's strike an enter and see the output. There you go, the data has been successfully loaded now. Now let's use dump command to see the data what we have loaded. So there you go, the data has been successfully dumped. So this was the data which we have loaded. Now let's move further and execute few more commands. Now we shall use for each command, and for each data present in our data file, we will generate ID, name, and department. There you go. The command got successfully executed. Now let's dump the data using dump command. So pig for each is our variable that stores the data. Now let's type in semicolon and enter. So there you go, the for each command has been successfully executed and we have generated ID, name, and department. Now we shall execute few more examples. Now we shall use descending operator to arrange the data in the form of descending order of ID. So it's been executed. Now let's dump the data and see the output. There you go. We have successfully executed the dump command and the IDs are being arranged in the descending order now, as you can see it. Now this is how the order by descending function works. Now let's move ahead and execute one last command. As you can see here, we are using a filter operation. We are going to filter the students based on their department, where department is equals to CSE. So executing this command will give us the students which are inside the department CSE. Now the command got executed. Now let's dump the data using dump command. So there you go. You can see some commands getting deprecated. Here you can see the MapReduce jobs getting executed. So there you go. You can finally see the output. which has the students that belong to the CSE department. Why exactly we needed Apache Hive? It all began in the early 90s when Facebook started. Slowly, the number of users at Facebook increased, that is, nearly 1 billion users, and along with the users increased the data, which is nearly equals to thousands of terabytes of data and nearly 1 lakh queries, then also 500 million photographs uploaded daily. And this was a huge amount of data that Facebook had to process. And the first thing that everybody had in their mind was to use RDBMS. And we all know that RDBMS couldn't handle such a huge amount of data. And neither it was capable enough to process it. And the very next big guy who was capable enough to handle all this big data was Hadoop. Even when Hadoop came into picture, it was not too easy to manage all the queries. It used to take a lot of time to execute all the queries performed. So one common thing that all the Hadoop developers had was the SQL. So they thought to come up with a new solution that has Hadoop's capacity and interface like SQL. That is when Hive came into picture. So now we understand the exact definition of Apache Hive. Apache Hive is a data warehouse software project built on top of Apache Hadoop for providing data query and data analysis. Hive gives a SQL-like interface to query data stored in various databases and file systems that integrate with Hadoop. Also, Apache Hive has data warehousing software utility. It can be used for data analytics. It is built for SQL users, manages querying of structured data, and it simplifies and abstracts the load that is on Hadoop. And lastly, no need to learn Java and Hadoop API to handle data using Hive. So followed by this, we shall understand Apache Hive applications. Apache Hive is used in many major applications. Few of the major applications are as follows. Hive is a data warehousing infrastructure for Hadoop. The primary responsibility of Hive is to provide data summarization, query, and data analysis. It supports analysis of large datasets in Hadoop's HDFS as well as on Amazon S3 file system. Followed by that, we have document indexing with Hive. The goal of Hive indexing is to improve the speed of query lookup on certain columns of a table. Without an index, queries could load an entire table or partition a whole process as rows. This would be troublesome. So, with Hive, we have solved this problem. Followed by that, predictive modeling. The data manager allows you to prepare your data so it can be processed in automated analytics. It offers a variety of preparation functionalities, including the creation of analytical records and timestamp populations. Followed by that, the next important application of Hive is business intelligence. Hive is a data warehousing component of Hadoop, and it functions well with structured data, enabling ad hoc queries against large transactional datasets. Hence, it happens to be a best-in-class tool available for business intelligence and helps many companies to predict their business requirements with high accuracy. Last but not the least, log processing. Apache Hive is a data warehouse infrastructure built on top of Hadoop. It allows processing of data with SQL-like queries and is very pluggable so that we can configure it to provide our logs quite easily. So these were the few important Hive applications. Now, let us move ahead and understand Apache Hive features. The first and the foremost important feature of Apache Hive is SQL type queries. The SQL type queries present on Hive will help many of the Hadoop developers to write queries with ease. Followed by that, the next important feature of Apache Hive is OLAP based design. OLAP is nothing but online analytical processing. This allows users to analyze database information from multiple database systems at one time. So using Apache Hive, we can achieve OLAP with higher accuracy. Followed by the second feature, we have the third feature which says Apache Hive is really fast. Since we have SQL-like interface in Apache Hive, using this feature on HDFS will help us writing queries faster and executing them. Followed by that, we believe Apache Hive is highly scalable. Hive tables are defined directly in Hadoop file system. Hence, Hive is fast and scalable and easy to learn. Followed by that, it is known to be highly extensible. Apache Hive uses Hadoop file system, and Hadoop file systems or HDFS provides horizontal extensibility. And finally, the ad hoc querying. Using Hive, we can execute ad hoc querying to analyze and predict data. So these were the few important features of Apache Hive. Let us move on to our next topic, where we deal with Apache Hive architecture. The following architecture explains the flow of submission of query into Hive. The first stage is the Hive client. Hive allows writing applications in various languages including Java, Python, and C++. It supports different types of clients such as Thrift Server, JDBC Driver, and ODBC Driver. So what exactly is Thrift Server? It is a cross-language service provider platform that serves the requests from all these programming languages that supports Thrift. Followed by that, JDBC Driver. It is used to establish connection between Hive and Java applications. The JDBC driver is present in the class org.apache.hadoop.hive.jdbc.hive driver. Finally, we come to ODBC driver. So what exactly is ODBC driver? ODBC driver allows the applications that support ODBC protocol to connect to Hive. Followed by that, we have the Hive services. The following are the services provided by Hive. They are Hive CLI, Hive Web User Interface, Hive Metastore, Hive Server, Hive Driver, Hive Compiler, and lastly, the Hive Execution Engine. The Hive CLI or Command Line Interface is a shell where we can execute the Hive queries and commands. Followed by that, the Hive Web UI is just an alternative for Hive CLI. It provides a web-based graphical user interface for executing Hive queries and commands. Followed by that, the Hive Metastore. It is a central repository that stores all the structured information of various tables and partitions in the warehouse. It also includes metadata of column and its type information, the serializers and deserializers, which is used to read and write data, and the corresponding HDFS files where the data is stored. Followed by that, the Hive server. It is referred to as Apache Thrift Server. It accepts the requests from different clients and provides to the Hive driver. Moving on, we shall deal with Hive driver. The Hive driver receives queries from different sources such as Web UI, CLI, Thrift, and JDBC or ODBC drivers. It transfers the queries to the compiler. Followed by that, we have the Hive compiler. The purpose of Hive compiler is to parse the query and perform semantic analysis on the different query blocks and expressions. It converts HiveQL statements into MapReduce jobs. Finally, we have Hive Execution Engine. Hive Execution Engine is the optimizer that generates the logical plan in the form of DAG or directed acyclic graph of MapReduce tasks and HDFS tasks. In the end, the execution engine executes the incoming task in the order of their dependencies. Followed by that, we have the MapReduce and HDFS. MapReduce is the processing layer which executes the mapping and reducing jobs on the data provided. Lastly, the HDFS or Hadoop Distributed File System is the location where the data which we provide is stored. So this is the architecture of Apache Hive. Then moving next, we have Apache Hive components. So what are the different components which are present in Hive? They are, first one, the shell. Shell is the place where we write our queries and execute them. Followed by that, we have Metastore. As discussed in the architecture, the Metastore is the place where all the details related to our tables is stored, like schema, etc. Followed by that, we have the execution engine. So execution engine is the component of Apache Hive which converts the query or the code which we have written into the language which the Hive can understand. Followed by that, driver is the component which executes the code or query in the form of acyclic graphs. And lastly, the compiler. Compiler compiles whatever the code we write and executes and provides us the output. So these are the major Hive components. Moving ahead, we shall understand Apache Hive installation on Windows operating system. So Edureka is all about providing the technical knowledge in the simplest way as possible and later play around with the technologies to understand the complicated parts of it. So now let's try to install Hive into our local system in the most simplest way as possible. To do so, we might need the Oracle VirtualBox which looks like this. So once after you download Oracle VirtualBox and install it into your local system, The next step would be to download the Cloudera Quick Start VM for your local system. The link to this will be provided in the description box below. Now let's quickly start our Cloudera Quick Start VM with our Oracle VirtualBox. Select Import option and now provide the location where your Cloudera Quick Start VM is existing. In my local system, it is in the local disk drive F. There you go. Select Open and now just make sure your RAM size is more than 8 GB. Just randomly I'm providing 9000 MB, which is just above 8 GB, so that you have a smooth functionality of Cloudera. Now select Import and there you go. You can see that Cloudera Quick Start VM is getting imported. Now you can see that Cloudera Quick Start VM has been successfully imported and it's ready for deployment. You can just double click on it and it'll get started. You can see that Cloudera VM has been successfully imported and it started. And also you can see that we have gone live on Cloudera. You can see all the Hive, Hadoop, HBase, Impala, Spark, which are pre-installed in Cloudera. Now our concern would be to start up Hive. So to start Hive, you need to start up Hive first. So let me remind you one thing. In Cloudera, every single password and username is Cloudera by default. So for example, we have got Hive username and password here. So the username, that is the default username for Cloudera's Hive, would be Cloudera. And along with that, even the password will be Cloudera. That is by default. So we have got Cloudera and Cloudera as username and password respectively. Let's just sign in. You may select remember option in case if you forget your passwords. So now we are getting connected to Hive and we are live on Hive now. There you go. We've got started our Hive. So now we'll enter into HDFS. There we go. We have our Hive here. Now that we have successfully installed Hive into our local system, let us move further and understand a few more concepts in Hadoop. Firstly, we shall deal with the data types. The data types are completely similar to any other programming language which we have. They are tiny int, small int, integer, big int. Similarly, followed by that we have float. And inside Hive, float is used for single precision. And if you want double precision, you can go ahead with double. And followed by that we have a string and boolean, which are completely similar to any other programming languages which we use in this daily life. Followed by that we have Hive data models. So these are the basic data models which we use in Hive, that we basically create databases and store our data in the form of tables. And sometimes we also need partitions. We will discuss each one of these data models in our demo ahead. So we'll first create databases, and inside databases we will be creating tables inside which we will be storing data in the form of rows and columns, and along with that partitions. Partitions, they are like advanced way of storing data. Like if you have, just imagine you're in a school, say standard 1, and inside standard 1 you have sections A, B, C, D. So partition is like you're getting partitions for section A, section B, section C, and section D. You're storing different students in different sections, so that when you're querying for a particular data, for example, say you're searching for a kid called Sam and you have the section of his class is B. So you just don't have to just search for Sam in all the 4 sections. You can just directly go into section B and call in Sam and you'll get access to him. That's how partitions work. Followed by partitions, we have buckets. So similar to partitions, even buckets work in the same way. Let's understand each one of these in much better way through a practical demo. After data models, we shall understand about Hive operators. So what are operators? Operators are any other operators that we use in normal programming languages, such as arithmetic operators, logical operators. We shall also go through some examples based on arithmetic and logical operators in Hive in the Hive demo. We will use some arithmetic operations as well as logical operations on the data which we have stored in the form of tables in Hive. We shall go through a brief look on that as well. So before we get started, let's have a brief look on the CSV files that I have created for today's demo. These are the small CSV files that I've personally created using MS Excel, and I've saved them as .csv files. I've made the CSV files to be smaller because just to make sure the execution time consumed is as less as possible. Since we're using Cloudera, the execution time might be a little more. So it's better we use smaller CSV files. So this is my first CSV file, which is employee.csv, which has employee IDs, employee name, salary, and age. Similarly, we have another employee2.csv file, which has the same details along with one more column, that is the country column. I've included country because we will be using this country column in joins that we will be performing in future. Followed by that, we have the department. So here we have department ID and department name. So we have development department, testing, product, relationship, admin, and IT support. Similarly, we also have student CSV. This is another CSV file that I have created. This has ID, name, course, and age of the student. Followed by that, we have another CSV. This is student report.csv, which has the reports of a particular student, gender, ethnicity, parental education, lunch, course, math score, reading score, writing score, and other. So these are the CSV files that we will be using in our demo today. So now let's quickly begin with our demo. So to start Hive, we shall open a terminal. So starting or firing up Hive in Cloudera is really simple. You just have to type in Hive and enter. There you go. Logging initialized using configuration files and etc. The Hive CLI is deprecated and migration to Beeline is recommended. And there you go. Your Hive terminal or CLI has been started. So first, let's try to create a database. To save time, I've already created the document which has all the codes that we will be executing today. So this is the particular file which I will be using today. So don't worry, this file will be linked in the description box below. You can use the same file and try executing the same codes in your personal systems just for practice if you feel so. So just to save time, I've already created the document which has the codes that we are going to execute today. So this code or this file will be attached in the description box below. You can get access to it and you can also execute the same codes in your own personal system to have a practical experience about this particular Hive tutorial. So the first thing that we will be doing today is to create a database. So I'm going to create the database using SQL type commands, which are create database, name of the database, which is Edureka. There you go. The database has been successfully created. So now you can also use the following command to check if your database has been created or not. So show databases will help you to find it. So there you go. You can see the first database, which is a default database, which will be pre-existing. And followed by that, you have our own database, which we have created now, that is Edureka. So followed by this, next we will move ahead and try to create a new table. So when you come into tables, you need to understand there are two types of tables in Hive. They are managed tables or internal tables, followed by that external tables. So what is the difference between these two tables? So internal table or managed table is the default table that will be created whenever you try to create a table in Hive. So for example, if you're trying to create a new table, say Edureka, then Hive considers that particular table as an internal table by default. So when you create an internal table, your data is not secured. Understand this. So when you create an internal table, your data is not secured. In case, just imagine you are working with a team and all your team members have access to your Hive or Hue. So the table has been existing in your Hive and some random newbie or some random inexperienced guy tries to change few things in your table and accidentally he ends up deleting the table. So when you delete the table, then if the table was created using an internal table code, then your data will be erased. So that's the disadvantage of using internal tables. But in case if you create an external table, even if somebody tries to delete your table, the table or the data, whatever is there, will be deleted from their own local system, but not from Hive. So that's the best part of using external tables. Don't worry, we will discuss about internal tables and external tables as well. So first we'll try to create an internal table. So this particular code is based on internal tables. So we are using SQL type command here, which is create table and the table name is employee. And the columns inside our table are ID of the employee, name of the employee, salary and age. So row format has been delimited, followed by that, since this is a CSV file, so the fields will be terminated by comma. And don't forget, you have to use semicolon. Unless you use semicolon, your code is not complete. So let's fire and enter and see if the table gets created or not. Yeah, the table is created successfully. Now we shall see the table, or let's describe the table. So describing the table means you can see what are the columns which are present in your table. So to describe a table, you can use the keyword describe and name of the table, which is employee. And don't forget semicolon. There you go. So your table has the columns ID, name, salary, age. So those are the 4 columns which you have included in your particular table employee. Now let's move ahead and see if this particular table is an internal table or managed table, or the other type of table, which is the external table. So to do that, we can just write in describe formatted table name and semicolon. There might be a small issue here. Yeah, there is a typing mistake. That is describe. I missed S. So there you go. We got it. So this particular table is managed table, as you can see here. Now let's move ahead and try out external tables. Let's clear our screen first. You can use Control plus L to clear your screen. There you go. We have a clear screen now. Now let's try to create an external table. Creating an external table is completely similar to that of internal table, but the only difference is that you need to add in a keyword which is external. So this particular keyword is used to create an external table. Now let's fire and enter and see if the table gets created or not. You can see the table got created. Now let's try to describe the table employee 2. Don't forget the semicolon. I'm saying this again and again because most of the times we miss semicolon and we will get an error. So you can see the table got described and we have the following columns inside our table. Now let's move ahead and see if this particular table is an external table or a managed table. To do so, you can type in describe formatted, the same code what we have used earlier, that is describe formatted, name of the table, that is employee 2. Semicolon, don't forget. There is some issue again. I think I've missed something, or maybe a typing error. Yeah, this is a typing error. Yeah, there you go. The table type is external table. So that's how we create an internal table or managed table and external table. So now that we have understood how to create a database and table and the 2 types of tables, that are internal table or managed table, followed by that the second type of table, that is the external table. Now let's try to create an external table in a particular location. So for that, you can use the following code, but the only difference is you are specifying the location, that is user Cloudera Edureka employee. EDUEMP is a file that we will be creating in our Hive. So let's fire and enter and see it if it's created or not. Yeah, it's successfully created. Let's go back to Hue and see if the following table is created or not. So one thing you have to remember is when you fire in a command or if you try to create a table, the first folder that will be created is a warehouse. So inside Hive, you have your warehouse, and inside warehouse, you have all the databases that we have created. Our first database was the Edureka database, and after that we have created table which is employee, and the second table is employee 2. So this is in the particular location which is user Cloudera, and the file is employee 2. Let's see that. This was the file. Yeah, sometimes Hue will not show it because of network issues. You don't have to worry about it. You will get back that data. Now, followed by this, let us enter into Hue again. So when you come back into Hue, if you have to upload a file into Hue, you can just select this particular option, which is plus. So selecting this will give you a dialog box, which will be something like this. And here you can just select any of the files which you want to upload into Hue. Now let me select a student report.csv and select open. So there you go, upload is in progress. So the data file has been successfully uploaded. Now if you want to access your data file, you can just click on that. So there you go, you have all your data successfully loaded onto Hue. You can also perform queries on this particular data. You can just select query, and inside that you just need to select editor, and you have various editors over here, which is Pig, Impala, Java, Spark, MapReduce, Shell, Sqoop, and we also have Hive in here. So if you just select Hive, and there you go, you have the editor here. You can just type in your commands or queries, whatever you have. See, you have many dictionaries as well. You can just select any one of those, select, and that's how you write queries on the Hive terminal. Now let's not waste much time here, and we have a lot to learn. So let's continue with the next topics in our today's session. Now we shall try to edit the tables. Now we have created the new table, that is employee 3, and we have named the columns as ID, name, string, salary, age, and float. Now we shall try to make some alterations to our table. So the first alteration that we will try to make to our table is to rename our table as EMP table. You know that our employee table was named as employee 3. Now we are trying to rename it to EMP table. So we are using the keyword alter here. So just fire and enter and see if this is possible or not. Yeah, it is possible. The name has been changed to EMP table. Now let's try if it's completely changed or clearly changed or not. You can just type in describe EMP table semicolon. If we get the same column names in our description, then it should be changed. So there you go. We can see the same columns here. So we have successfully changed the name to EMP table. Now we shall also try to add in some more columns to our table, which is EMP table. So here we'll try to add in a new column, that is the surname of string data type. So I'm doing that by using the keyword alter, followed by that table. The table name is EMP table, and I'm using the keyword add columns, and the column name is surname, and the data type of that column is string. So now let's fire and enter. And there you go. We have successfully added a new row to our table. Now let's try to describe our table again and see if the column has been successfully added or not. There you go. You can see the last row, which is the surname that we have added most recently. So this is how you can alter the table, and you can also change the names of the existing columns. Let's try to do that one as well. Now what I'm doing is I'm changing the column name to first name. So one of the column name in my table EMP table is the name, which gives me the names of the employees. So since I added surname, I'll change this column name from name to first name. So this is the command that I'm using for that operation right now. Let's fire and enter and see the result. Yeah, the change has been made. Let's describe our table. Don't forget the semicolon. There you go. You can see that earlier we had name. Now it's been changed to first name, and we also have a surname. Let's clear our screen. So that's all for alterations. Now we shall move ahead into our next major topic, or the data model, which is partitioning. So we have dealt with the first two data models, that are databases and tables. So we have learned how to create a database, and we have learned how to create a table. We have learned how to create internal or managed table, and also we have created external table, and also we have learned how to create an external table in a particular location in your Hive and load data to your table, and also how to alterate your tables, the column names, the name of your table, and how to add or delete new columns to your table. So far so good, and now we shall continue with the next type of data model, that is the partitioning. As we have discussed earlier about partitioning, it's completely similar to a school or a college. Just imagine that you are in a college and you are in computer science section. So a college has many branches. So maybe computer science, mechanical, and electronics and communications. So imagine your name is Harry. So if someone comes to your college and if he's looking for Harry, so there are many Harrys in your school. So if the person is asking specifically about you, that is Harry from computer science, then can you imagine how simple is this query? So you don't have to search for electronics and mechanical. You just have to come into the class computer science and search for Harry, and there you go, you're present. So that's how partitions work. To execute commands or to execute queries on partition, we will create a whole new database here. Let's start everything from fresh. So we'll create a separate database for executing our new data model, that is partitioning. So I'm creating a new database, that is Edureka student. So there you go, the database has been successfully created. Followed by that, let's use this database now. To use the database, you just need to add in the keyword use and name of the database. So let's fire and enter, and now we are currently using Edureka student database. Now let's create a table in Edureka student database. So here I'm creating a normal table, that is the managed table. So inside my student table, I'll be having some basic columns such as ID number of the student, name of the student, what is his age, and course. So you're not finding course here because I'm going to partition the table based on course. So here you can find the course. I'm using the keyword partitioned, and on what terms? So on the terms of course, I'm going to partition students. So we have discussed about our students CSV file, right? So here we have our CSV file, and the courses that this particular institute is offering are Hadoop, Java, Python, and yeah, so these are the courses that this particular institute is offering. So I'm going to categorize, or I'm going to partition these students based on their courses. So this is how I'll be partitioning them using this following code. So basically the table has all the columns, and I'm going to partition the table using course. So let's fire and enter and see the execution of this particular code. The partition has been done. Now all we have to do is try to load in our data. Before that, let's try to describe it. Let's try to see what are the columns present in our particular table student. So as you can see, the course column is present. Don't worry. The code looks that we have messed out course, but we did not mess the course column. It is present in the table. The only thing is that we have just partitioned it based on the course that we are going to offer. Now let's try to categorize the students based on their course. So you can do that by using the following code. We are going to load the data using the command load data local in path. So this particular folder, that is the student.csv, is in my local location. So that is home, Cloudera, desktop, student.csv. And I'm loading the data present in this particular location into the student, which is present in Hive right now. So I'm going to partition the student based on their course Hadoop. Now let's fire in this command and see the output. Yeah, now you can see some MapReduce jobs taking place. Yeah, the data has been successfully loaded. Let's now refresh our Hive. You can refresh your Hive or Hue based on two methods. The first one is just clicking refresh button on the URL, or you can also select a manual refresh. So this is the manual refresh, and there you go, it's done. You can see the new database, that is the Edureka student database that we have right now created. And inside that you can see the student table that we have created, and there you go, we have the file of students based on course Hadoop. Now we will try to add in few more students based on the course Java. For that, all you need to do is just replace the course name with Java. There you go. Here we had Hadoop course, and now here we have Java course. Just fire and enter and you can see the output. Followed by that, we also had another course, that is Python. So let's also execute a code for that. There you go, Python. So now we have uploaded student details into our Hive, and we have also partitioned using one of our data models, that is partition, into three categories that are based on Hadoop, Java, and Python. Now let's go back to our Hue and see if the three categories are done or not. Yeah, we need to refresh that. There you go, you have successfully refreshed. Still, there is no sign of Java and Python. Maybe a manual refresh could help. Yeah, the manual refresh has resulted in the two new files, which are Java and Python. So you have all the three partitions here, Hadoop, Java, and Python. Just enter them and you can see the student details. And now that we have understood partitioning, sorry, I forgot to mention, we have two types of partitioning, which are dynamic partitioning and static partitioning. So the static partitioning is in static or manual partitioning. It is required to pass the values of partition columns manually while loading the data into the table. Hence, the data file does not contain partitioned columns. You can see that we have sent the partition columns manually for Python, Java, and Hadoop. But when it comes to dynamic partitioning, you just need to do it once, and all the three files will be automatically configured and the files will be created. So now what is dynamic partitioning? So dynamic partitioning, the values of partition columns exist within the table. So it is not required to pass the values of partition columns manually. Now, what is this? Don't worry, we shall execute the code based on dynamic partitioning, and we shall understand this in a much better way. Now let's clear our screen. Now let's start fresh again. Let's try to create a new database for dynamic partitioning, and let's start again fresh. So here we'll be creating a new database, that is Edureka student 2. So earlier we created Edureka student, and now we'll be testing our dynamic partitioning on our new database, that is Edureka student 2. So there you go, the database is been successfully created. Now we shall use this particular database. Currently we were in Edureka student 1 database. Now we'll enter into student 2 database. So we'll use it now. Now we are in Edureka student 2. Now before we start up with dynamic partitioning, we have to set Hive execution to dynamic partition is equals to true, because by default the partitions that will be taking place in Hive will be static. So we need to convert that into dynamic partition by specifying this particular code. Now we are good to go with dynamic partitioning. Along with that, we need to execute another command which says partition mode would be non-strict. So by default, when you are partitioning using the static partition, the partition mode will be strict. So now you're specifying it to be non-strict. Now let's execute this. So there you go. We have executed the 2 required codes for that. Now let's create a new table. So the name of the table will be Edureka student, that is EDUSTUD, and this will have the same columns, which are the ID of the student, name of the student, course, age, etc. Now we will try to load in the data from our local path, that is home, cloud, or our desktop, student.csv into the table EDUSTUD. So the data has been successfully loaded and the size is 267 KB. Number of files is 1. Now comes the tough part. So here we are going to partition. So we will be partitioning the table based on the same thing, which is the course, and we will be separating the data using the comma. Now let's fire an enter. Now the table has been separated based on course, and now we will be loading the data to this particular table, which is the student part. So this particular table that we have created based on dynamic partitioning, and we are going to partition the data based on course. Now it's been created. So the student part table has been successfully created. Now the only part remaining is to load the data to this particular table. Now we will be writing a code. So using that code, the MapReduce will automatically segregate the data members or the students based on their courses. So the guys which are in Hadoop will be separated. Guys in Java will be separated and loaded into different file, and similarly with Python. Now let's see how to do it using the code. So there you go. We are going to insert into student part, partition based on course, select ID, name, course, age from the table Edureka. So the data will be imported from the table what we have created here, that is Edureka student. So this particular location has the student.csv file. Now let's fire an enter and see if it's created or not. Fine. You can see some of the MapReduce jobs are getting executed. You can see we have 3 jobs. So first one is getting executed. We have 3 because one is for Hadoop, one is for Java, and one for Python. So this will take a little time. So this is the reason why I have chosen smaller CSV files, so to save time. When you take up the course from Edureka, then you can work on real-time data so that you get hands-on experience from real-time, and you can get yourself placed in some good companies with the experience what you gain from this particular course. So the stages have been successfully finished and the data has been loaded. Now let's see what are the data present in the particular table, student part. There you go. You have the output executed here. So these are the data members present in the partition student part. So these are the data members which are separated based on their courses. That is the partition based on their courses, that is Hadoop, Java, and Python. So now that we have understood dynamic partitioning and static partitioning, we shall move ahead into the last type of data model, which is bucketing. Once after we finish the bucketing, we shall enter into some query functionalities of Hive or query operations which can be performed in Hive. And followed by that, we will also learn some functions which are present in Hive and some of the other things like group by, order by, sort by. And finally, we shall wind up the session with joins which are available in Hive. For now, let's get continued with bucketing, the last type of data model present in Hive. So for that, let's again start fresh. We shall create a new database for that. Before that, let's go back to Hue and check if our partition has been made or not. Let's refresh. Also, let us make a manual refresh. So our database was Edureka student 2 database. And inside that, we have the table that is student part. And there you go. You can see the files which are based on the partition. So 22 is for a different course, 23 is for a different course, and 24 is for a different course. And this is the default partition which has all the data members. As we discussed earlier, now let's start with the last data model in Hive, that is bucket. Now we have created a new database that is Edureka bucket. Now we shall also create a new table for that. Before that, we need to start with this particular database so we can use the command use Edureka bucket. Now we are in Edureka bucket. Now let's create a new table. So the table name will be Edureka bucket, and it will be containing the ID name, salary, age of the employees. The table is created. Now let's try to load the data. So the data file that we will be using is the same one, that is the employee.csv. So the data has been successfully loaded into the location. Now comes to the major part, that is the bucketing part. So to start bucketing in Hive, we need to use the command set hive.info.bucketing is equals to true. So that's done. Now we will cluster or classify the data present in this particular file using this particular code. So we will be clustering based on the ID, and we will be categorizing them into 3 different buckets. So let's fire in this command and see if it happens. Yeah, that's successfully done. Now we will override the data using the following command. Now we'll be inserting data into this buckets that we have made, that is 3 buckets, and we will override the table using this particular code. There you go. You can see some MapReduce jobs to be taken care of now. So 1 mapper and reducers are 3 for now. So stage 1 is getting done. So we should be having 3 tasks basically. So let's see what's the output. Stage 1 is finished. The process is finished and data has been successfully inserted. Now let's go back to Hive and check if it's done or not. So before that, let's do a refresh. Now a manual refresh would be much better. There you go. We have our database here, which is Edureka bucket. And inside Edureka bucket, we have EMP bucket, and that's our data, employee.csv. There you go. Now let's move ahead and understand the basic operations we can perform in Hive. So for that, let's start fresh again. Let's create a new database. I'm creating a new database for each and every option or each and every operation that I'm performing in this particular tutorial, just to make things or keep things in a sorted manner. So as you can see here in our particular file system, I have separated each and everything, like I have sorted everything. So for bucketing, I've got a separate database, and for partitioning, I've got a separate database, and for understanding how to create database and tables, I've got a separate database for that, just to keep things arranged and sorted. This looks in a much better way. So now let's discuss about the operations that we could perform in Hive. So I'm creating a new database again for this. So the database would be Hive query language. Now let's use this particular database. This creates a habit of learning things in a better way, or it's like a revision for the things what you have performed or learned so far. As you can see, the table has been successfully created. Now let's try to add in some data into this particular location. That is employee data. It's been successfully loaded. Now let's try to see what are the details present in this particular file. We can use in the command select star from the table Edureka employee. So there you go. These are the details or information present in the table Edureka employee. Now we shall see what are the functions that we can perform on this particular file. So since we discussed that the mathematical operations and logical operations can be performed on Hive, so let's try to perform an addition operation. So I'm selecting the column salary, and as we have seen here, the salaries are 25, 30, 40, 20,000 rupees for every employee. Now let me add in 5,000 more to each and every employee. So I'm adding the value 5,000 by using the addition operation. So let's enter. You can see we have added 5,000. So the first element was 25. Now it's 30. So similarly, all the other employees got 5,000 rupees hike all of a sudden. Now let's try to remove 1,000. So to do so, all you need to do is replace the addition operation with a subtraction operation, that is minus. Fire and enter, and there you go. Each and every employee lost 1,000. So the initial amount was 25,000. So removing 1,000 from that will result in 24. So this is considering the first initial values. So this is how it's working. Followed by that, let's also perform some logical operations. Let's clear the screen, and yeah, here I'm fetching for the employees who are having a salary equal to or greater than 25,000. So these are the employees which are having the salaries above or equal to 25,000. Similarly, let's execute another one which detects the employees with salaries less than 25,000. So we have got two employees which are having lower salaries, which are Amit and Chaitanya. Fine. So this is how you perform some operations in Hive. So now let's move ahead and understand the functions which you can perform on Hive. So in the same way, let's create a new database again, and let's use this particular database, that is Hive functions. Now let's create a table in this particular database. So the table is employee function and it's created. Now let's try to load in the data. Yeah, the data has been successfully loaded. And now let's see if the data is correctly loaded or not. Yeah, the data is loaded correctly. Now let's try to apply some functions in this particular data. So the first thing, or the first function I'm going to apply, would be a square root function, where I'll be finding out square root of the salaries of the employees. So there you go. The square root of 25,000 was 158 dot decimal numbers. So this is how you perform some basic functions on your data. Now let's try to find out the maximum salary. So yeah, the job is getting executed. You can see some MapReduce jobs here. I think the biggest salary would be from Sanjana. So the maximum salary is 40,000. So this is how it works. Since we are working on Cloudera and the system configuration is limited, the execution speed is a bit low. But if you're working in real time, then this process would take like a few seconds and it's done. There you go. You have the value 40,000 as shown here. So 40,000, the employee name is Sanjana, is the maximum salary. So that's what we got here. Now let's try to find out the minimum salary. So the minimum salary is 15,000, and who would that be? Yeah, it's Chaitanya with minimum salary 15,000. So that's how you do some operations in Hive. Let's execute some more operations, such as converting the names of the employees to uppercase. So you can see the employee names are converted to uppercase here, and similarly, let's try to convert to lowercase. So here you can see we have converted them to lowercase. So this is how you learn technology. You need to play with the technology. Then you'll come to know the advantages and disadvantages. So you can learn the possible ways where you can make things work out. This is how you do it. Now let's move ahead and understand group by function in Hive. So for that, we'll be creating a separate database, that is group. Now we will use this particular database, that is group. So we'll type in command use group semicolon. Now we'll create a table. So the table has been successfully created. Now we will load data into this particular table. Now we will use the new CSV file which will be employee2.csv. Now we are using this particular table because we have an additional column in this particular table, which is the country column. Now, as discussed before, we will be grouping the employees based on country. Let's see our data first. So we have countries such as USA, India, UAE. So these are the three countries that we are having in our CSV file. So we will be categorizing the employees based on their countries. So this is the particular command that we will be using. So maybe I made an error while creating the table. I think I gave a wrong table name here. So let's drop our table. So by mistake, I gave different table, that is employee order. So to drop a table, you just need to use the keyword drop and it's done. Yeah, the keyword table was missing. So you need to type in drop table and the table name, and the table gets dropped. So we were supposed to create a different table, that is employee group. So now let's create a new table, that is employee group. Employee group has been created. Now let's try to add in data into the employee group. So we have used employee2 here because the employee2 has another column which is based on country. So the countries that we are having here are India, USA, and UAE. So we will be using the group by function here, and we will categorize the employees based on their countries. So there you go. You can see some MapReduce jobs getting executed. Yeah, there you go. We have categorized the employees based on their countries, that is India, UAE, and USA, and the sum of the salary. So the guys working in India and their summation of the salary is 90,000, and similarly UAE is nearly 1,05,000 and USA is 80,000. Now let's also execute a different command based on group by. So here we'll be using group by function, and we will categorize based on the country as well as the summation of the salary, which is greater than or equals to 15,000. So it's similar to the previous command. So you can see the data got executed and we got the same output. Now let's move ahead and understand order by and sort by methods. So for that, we'll create a new database orders. Now we'll use orders. Now let's create a new table again. So the new table is employee order and the table got created. Now let's load the data into this particular table. By now, I think you have some good practice of how to create a database, how to create a table, and how to load data into that particular table. So the data got loaded, and now we are going to order the data present in this particular table based on the descending order of their salary. So you're seeing some MapReduce jobs going ahead. So here we'll see the employees ordered based on their salaries in descending order. So the highest salary will be at the first place and the lowest salary will be at the last place. Yeah. So we have Sanjana at the first position with 40,000 as the highest salary, and she's working for UAE. And we have Chaitanya with lowest salary, 15,000, working for India. Now, let us also execute another command based on sort by. So first we try to execute a command based on order by. Now let's see the same output using sort by. So basically both work in the same way. So there you go. We have sorted the records based on descending order of salary. Now that we have learned what are the various operations that can be performed in Hive, that are the arithmetic operations, logical operations, and also some of the functions such as maximum, minimum, group by, order by, sort by. So these are the various operations and functions that you can perform in Hive. Now let's move ahead into the last type of operations that can be performed in Hive. Those are the joins. So for that, let's again create a new database. So here I'll be creating a new database, that is Edureka join. And followed by that, let's use this particular database now. For that, we need to use the keyword use, and there you go. We are in Edureka join. Now let's create a new table for that. So the table will be EMP join. Here you can see that I forgot to mention semicolon. So now the table got created. Now we shall load the data into this particular table. So now I've created the first table, that is employee table, and I'm loading the employee data into this particular table. Now to perform join operations, we always need two tables. So in this particular database Edureka join, I've already created the first table, that is employee join. Now let's create second table, that is the department table, which will be present in the same database. So this particular table is a department table, which will be having the entities that are department ID and department name. Now let's load the data of department into this particular table. So the data has been loaded. So you can see the employee2.csv had the columns ID, name, salary, age, and country. And similarly, the department.csv has the entities which are department ID and department name. So the department IDs are present here and the names are development, testing, product, relationship, and admin and IT support. Now we have created both the tables and we have loaded the data also. Now we have 4 different joins available in Hive. They are inner joint, left outer joint, right outer joint, and full outer joint. Now let's perform the first type of join, which is the inner joint. So in inner joint, we are going to select the employee name and employee department. And based on the employee ID and department ID, we are going to perform the join operation. That is the first join, inner joint. So you can see some jobs getting executed. So the MapReduce task successfully completed. So the first set of join has been successfully finished and the output has been generated. Now let's try out the second type of join, that is the left outer join. So the only difference is that we are using the keyword left outer join. Now you can see one of the job got started. So you can see the output has been generated as well of the left outer join. Now let's move ahead and understand right outer joint. So for right outer joint, you need to use the keyword right outer join. Fire in the command and you can see the jobs getting executed. So you can see the output of right outer joint has been successfully executed or displayed. Now let's type in the last join operation, that is full outer join. So here I'm using the keyword full outer join. Fire in the command and you can see it's getting executed. So the output for full outer joint has been displayed here. So this is how the join operations are executed in Hive. So we have learned how to create database, how to create table, how to load data, and the various data models present in Hive that are the tables, databases, partitions, bucketing. And after that, we have also understood various operations that are the arithmetic operations, logical operations, and functions that can be performed in Hive, such as square root and summation, minimum, maximum. And after that, other operations such as group by, sort by, order by, and also the joins that are possible in Hive, which are inner join, left outer, right outer, and full outer. So each and every operation that could be possibly executed in Hive have been displayed in this particular tutorial, and everything is sorted here in the base of databases, and you can get all the details about this. And you'll also get the code that I have used in the description box below, and you can try it out. And also, if you're looking for an online certification and training based on Big Data Hadoop, then you can check out the link in the description box below. And during the training, you'll get to have real-time hands-on experience with real-time data. You'll learn a lot of things in the training. And so far, so good. Now, we shall also discuss some of the limitations of Hive. So Apache Hive limitations. So Hive is not capable of handling real-time data. Hive is capable of batch processing. If you have to work with real-time data, then you have to go with real-time tools such as Spark and Kafka. So it's like Hive will actually take in the data. For example, imagine you're working on Twitter and you have 1 lakh comments on a particular post. So if you had to process those 1 lakh comments, you'll have to first load all those comments into Hive. Then you need to process it. So while you're loading the data from Twitter to Hive, you may also get a few more comments that you will be missed out. So it's not preferable for real time. Hive is preferable for only batch mode processing. So followed by that, it is not designed for online transaction processing. So online transaction processing is something which only works in real time. So Hive cannot support real time processing. So last but not the least, Hive queries contain high latency. Yeah, Hive queries take a longer time to process. As you've seen, I've taken a smaller CSV file and the time consumed to process such a small CSV file was taking so long. So yeah, Hive queries contain high latency. So these are the few important noticeable limitations of Hive.
Now let's just start with the databases. A database is a systematic collection of data, and a database management system supports storage and manipulation of data, which makes data management easy. For example, an online telephone directory uses a database to store data of people like phone numbers and other contact details that can be used by service provider to manage billing, client-related issues, and handle fault data, etc. So, in simple words, we can say a database management system provides the mechanism to store and retrieve the data. There are different kinds of database management systems present today, which are Relational Database Management System, known as RDBMS, Online Analytical Processing, known as OLAP, and NoSQL, which is popularly known as not only SQL. NoSQL refers to all databases and data stores that are not based on the Relational Database Management System or RDBMS principles. NoSQL is a new set of a database that has emerged in the recent past as an alternative solution to relational databases. In 1998, Carl Strauzy introduced the term NoSQL to name his file-based database. So now, we'll see what NoSQL actually is. NoSQL does not represent a single product or technology, but it represents a group of products and various related data concepts for storage and management. NoSQL is an approach to database management that can accommodate a wide variety of data models, including key value, document, column, and graph formats. A NoSQL database generally means that it is non-relational, it is distributed, flexible, and scalable. So we can bind it up as an approach to database design that provides flexible schemas for the storage and retrieval of data beyond the traditional table structures found in relational databases. It relates to large data sets accessed and manipulated on a web scale. Now, when we have understood what is NoSQL, the question arises is why to use NoSQL? The concept of NoSQL databases became popular with internet giants like Google, Facebook, Amazon, etc., who deal with huge volumes of data. The system response time becomes slow when you use RDBMS for massive volumes of data. So to resolve this problem, we could scale up our systems by upgrading our existing hardware. But this process is expensive. So the alternative for this issue is to distribute database load on multiple hosts whenever the load increases. This method is known as scaling out. NoSQL databases are non-relational, so they scale out better than relational databases as they are designed with the web applications in mind. Now, the NoSQL database is exactly the type of database that can handle all sorts of semi-structured data, unstructured data, rapidly changing data, or big data. So we can say to resolve the problems related to large volume and semi-structured data, NoSQL databases have emerged. Now, let's talk about the features of NoSQL databases. NoSQL databases never follow the relational model and don't provide tables with flat fixed column records, so they doesn't require object-oriented mapping and data normalization. Most of the NoSQL databases are open source. Multiple NoSQL databases can be executed in a distributed fashion, and they offer auto-scaling and failover capabilities. they follow shared nothing architecture, which enables less coordination and higher distribution. NoSQL databases are non-relational and offer heterogeneous structures of data in the same domain, which supports new generation web applications. NoSQL databases are either schema-free or have relaxed schemas and do not require any sort of definition of the schema of the data. And NoSQL databases offer easy-to-use interfaces for storage and querying data provided, and APIs allow low-level data manipulation and selection methods. Now we can compare SQL and NoSQL. On comparing SQL and NoSQL, we can find the differences like SQL databases have fixed or static or predefined schema, while NoSQL databases have dynamic schema. SQL databases are not suited for hierarchical data storage, while NoSQL databases are best suited for hierarchical data storage. SQL databases are vertically scalable, while NoSQL databases are horizontally scalable as they are distributed. SQL databases follow ACID property, that is atomicity, consistency, isolation, and durability, while NoSQL databases follow CAP theorem, that is consistency, availability, and partition tolerance. Now, you must be wondering, what is CAP theorem, which plays an important role in NoSQL databases? CAP theorem is also called Brewer's theorem, and it states that it is impossible for a distributed data store to offer more than 2 out of 3 guarantees, which are consistency, availability, and partition tolerance. So basically, some NoSQL databases offer consistency and partition tolerance, while some offer availability and partition tolerance. But partition tolerance is common as NoSQL databases are distributed in nature. So based on the requirement, we can choose which NoSQL database has to be used. Different types of NoSQL databases are available based on the data models. So before talking about those, let's just understand what is data model. The data model is defined as an abstract model that organizes data description, data semantics, and consistency constraints of data. The data model emphasizes on what data is needed and how it should be organized instead of what operations will be performed on data. Now, we can see the types of NoSQL databases available based on their data models. So NoSQL databases come in a variety of types, which are key-value pair-based, graph-based, column-based, and document-based. Now we will see each of these NoSQL databases one by one. So let's start with key-value pair-based NoSQL databases. In this, data is stored in key-value pairs. Each data element in the database is stored as a key-value pair consisting of an attribute name or key and a value. These databases are used to handle lots of data and heavy load. Some of key-value pair-based NoSQL databases include Redis, React, Voldemort, etc. Now we will see a demo for key-value pair-based NoSQL databases. Data has to be stored as key-value pairs, so here our key is name and value for this key is Richard. So it makes a pair of key and value. That is actually the data. Similarly, for DOB key, 2nd August 1988 is the value, and for address key, 32W-NYC is the value. Now moving on, let's understand column-oriented NoSQL databases. Column-oriented databases work on columns where each column is treated separately, and the values of single column databases are stored contiguously. These databases are used to manage data warehouses, business intelligence, CRM, library card catalogs, etc. Some of column-oriented NoSQL databases include Hbase, Cassandra, etc. And these databases are based on Big Table Paper by Google. Now, let's understand this with a demo. We have row keys associated with the columns. So here, we have a row key 1 associated to column 1, which has value 1, and the column 2, which has value 2, and column 3, which has value 3. We can say key 1 is associated to 3 columns, where each column has some value. Similarly, Row key 2 is associated to column 1 and column 2, which have value 1 and value 2 respectively. Here, row keys are for grouping the columns, but actual data is stored in the columns. Now moving on, let's understand the graph-based databases. A graph-type database stores entities as well as the relations amongst those entities. The entity is stored as a node with the relationship as edges. An edge gives a relationship between nodes, and every node and edge have a unique identifier. A graph database is a schema-less yet multi-relational in nature. These databases are used to manage social networks, logistics, and spatial data. Some of graph-based NoSQL databases include Neo4j, OrientDB, etc. Now, let's understand graph-based databases with a demo. We have a person as node who has a relationship with another person as friend, and he has other relationships with city, that he lives in a city whose properties could be address. As a node can have multiple relationships and properties, here the person has one more relationship with the city, that he likes the city, and properties include the ratings and reviews. Similarly, the person likes a mall based on the properties like ratings and reviews, and the node mall has a relationship with the city, that it is located in a city and properties include address. So we can infer that in graph-based databases, the data is stored as nodes, relationships, and properties, where properties can be of nodes as well as of relationships. Now moving further, let's understand document-oriented NoSQL databases. A document database stores data in JSON, BSON, and XML documents. In a document database, documents can be nested and particular elements can be indexed for faster querying. Document databases make it easier for developers to store and query data in a database by using the same document model format they use in their application code. These databases are used for the applications having dynamic schema and characteristics. Some of document-oriented NoSQL databases include MongoDB, Couchbase, etc. And MongoDB is the most popular database in NoSQL databases. Now, let's understand this with the demo. So we have a particular database which can have multiple collections. Here we have collection 1 and collection 2. Let's see how collection is made. Each collection can have multiple documents with different schemas as it has dynamic schema. So here we have document 1 with one key value pair, then document 2 with 2 key value pairs, document 3 again with 2 key value pairs, and finally document 4 with 3 key value pairs. These key value pairs can be of any type like string, numbers, even another document as well. Basically, document-oriented databases are hierarchical version of key value-based databases. So with this, we have covered all the 4 kinds of NoSQL databases based on their data models.
Why we needed Hbase? We all know that the traditional data storage system what we had was RDBMS, that is Relational Database Management System, for storing data and maintaining the related problems. But slowly we faced the rise of big data. So since the rise of big data, we have come across new solutions, and Hadoop was one amongst them. And we started using Hadoop, but when we stored huge amount of big data inside Hadoop and tried to fetch few records from Hadoop, it was a major issue, because you had to scan the entire Hadoop distributed file system to fetch for a smallest record. So this was the limitation of Hadoop. It did not provide random access to databases. So this problem was solved using Hbase. So Hbase is similar to database management systems, but it provides us the capability to access data in a random way. So this was the limitation of Hadoop, and this is how Hbase solved it. Now moving ahead, we shall understand the basic definition of Hbase. Hbase is a distributed column-oriented database built on top of Hadoop file system. It is an open source project and horizontally scalable. Hbase is a data model that is similar to Google's Big Data table, designed to provide quick random access to huge amounts of structured data. It leverages the fault tolerance provided by Hadoop file system, and it is a part of Hadoop ecosystem that provides random real-time read and write access to the data in Hadoop file system. So now this was the basic definition of Hbase. Now we will move ahead and understand the basic differences between Hbase and HDFS. Hbase is built on top of Hadoop HDFS, whereas HDFS is one of the major components of Hadoop, and it is built in a way to store the files in a distributed manner. Followed by the first difference, Hbase provides fast lookups for larger tables. And when we come into HDFS, we all discussed this limitation. HDFS does not provide random access to the data, and it does not support fast individual record lookups. Followed by the second difference, Hbase provides low latency to single rows from billions of records. This is because Hbase is capable to provide us random access to the data. That is, we can randomly read the data from any location as well as write it. Followed by Hbase, HDFS provides high latency processing, and it cannot process random access of data, and it is not capable to provide us random access to the data as Hbase does. Followed by the third difference, the fourth difference is Hbase internally uses hash tables and provides random access, and it stores data in indexed HDFS files for faster lookups, whereas HDFS provides only sequential access of data. So these are the major differences between HDFS and Hbase. Followed by the differences, we shall move into the storage mechanism in Hbase. Hbase is a column-oriented database, and the tables in it are sorted by row. The table schema defines only column families, which are the key value pairs. The table have multiple column families, and each column family can have any number of columns. Subsequent columns values are stored continuously on the disk. Each cell value of the table has a timestamp, and in short, in an Hbase, table is a collection of rows, row is a collection of column families, column family is a collection of columns, and column is a collection of key value pairs. The following table gives you the brief description of the storage mechanism followed in Hbase. Followed by the storage mechanism, now we shall enter into the next stage where we will understand the features of Hbase. The first feature is Hbase is linearly scalable, because Hbase is built on top of HDFS, and HDFS provides the horizontal scalability, and this similar feature is also adopted by Hbase. Followed by the first feature, the second important feature is that Hbase has automatic failure support. This automatic failure support provides us the fault tolerance feature of HDFS. Followed by the second feature, the third feature is HDFS provides consistent read and writes. This important feature provides us the random access of reading and writing data. Followed by the third feature, we have the fourth feature that says HDFS integrates with Hadoop, and both as a source and destination. Followed by the fourth feature, the fifth feature is that it is easy for Java API for client. And the last and important feature is that Hbase provides data replication across all the clusters. So these are the important features of Hbase. Followed by the important features, we shall move ahead into the next topic, which is the Hbase architecture. Inside Hbase, tables are split into regions and are served by region servers. Regions are vertically divided by column families into stores, and stores are saved as files in HDFS. The following image describes about the architecture of Hbase. Hbase has three major components: the client library, a master server, and region servers. We shall understand master server first. Master server assigns regions to the region servers and takes the help of Apache Zookeeper for this task. Master server also handles load balancing of the regions across region servers. Master server is also responsible for maintaining state of the cluster by negotiating the load balancing. Followed by the master server, we shall discuss about the regions. Regions are nothing but the tables that are split up and spread across the region servers. The region servers have regions that communicate with the client and handle data-related operations. They also handle read and write requests for all the regions under it. The region servers get to decide the size of the region by following the region size thresholds. Now we shall move into the next slide where we will look into regions, and the following image describes how the region is split up. When we take a deeper look into the region server, it contains regions and stores the data as shown below. The store contains memory store and H files. Mem store is just like cache memory. Anything that is entered into the Hbase is automatically stored initially. Later, the data is transferred and saved into H files as blocks, and the mem store is erased out. Followed by the region server, we shall enter into the next important component, which is Zookeeper. Zookeeper is an open source project that provides service like maintaining configuration information, naming, providing distributed synchronization, and many more. Zookeeper has emperor nodes representing different region servers. Master servers use these nodes to discover available servers. In addition to availability, the nodes are also used to track server failures or network partitions. Clients communicate with region servers via 𝐂𝐸. In pseudo and standalone modes, HBase itself will take care of 𝐂𝐸. Now this was the architecture of HBase. Now we shall move ahead into the next important stage of this particular tutorial, which is the HBase demo. So in this particular demo, first we will deal with installation of HBase into our local system, that is Windows operating system. After the installation, we shall start HBase in our local host, and followed by that we shall open a terminal and execute the commands which are possible in HBase. Now without wasting much time, let's start with the installation process. To install HBase into your local system, the easiest way is to have an Oracle virtual machine. So you have to download Oracle virtual machine and install into your local system. Once after you have downloaded and installed Oracle virtual machine into your local system, the next step would be downloading Quick Start Cloudera VM for your local system. Once after you download your Cloudera Quick Start VM for your local system, you need to just import that using your Oracle VirtualBox. You have to select import and you will be provided with a new dialog box where you have to provide the location of your Cloudera Quick Start VM. So this is the location of my Cloudera Quick Start VM in my local system, and then you have to select open, and there you go. You can see that you have got a new dialog box here, and remember to increase the RAM size to at least 8 GB for smooth functionality of Cloudera. I have provided a random size of 9000 MB, which is just about 8 GB. Now let's click import, and there you go. It is starting to import your Cloudera Quick Start VM into Oracle VirtualBox. This might take a little time. There you go. The process has been successfully finished, and you can see the Cloudera Quick Start VM icon on your VirtualBox. All you need to do here is to just click it and select Start to start it. You can see a new window just got popped up. Now you can see the Cloudera has been successfully started. Now let's open the browser and start our local host. So you can see that Cloudera is live now, and the local host is also live. So this is our HBase. Click on it and just open all tabs. And there you go. You have the HBase region server here and HBase master service, and everything is online. And remember one thing, in Cloudera, the username and password is Cloudera by default. For example, if you want to start up Hive or if you want to start up the Hue, you will be redirected into a new web page where Cloudera will ask you the username and password, which looks something like this. You just need to type in Cloudera as the username and password as Cloudera, and there you go. You can just simply click on sign in and you will be logged in. So this is how it works. Now that we have started our HBase, let's quickly get started with our demo and execute some of the commands which are possible in HBase to have a briefer idea how HBase works. So now that everything is good to go, let's start our terminal. And you can quickly see that the terminal got started, and let's increase the size of the font so that it's visible. Yeah, I think it's pretty good now. So to start HBase in Cloudera's terminal, you need to type in HBase shell, and there you go. Yeah, we are successfully logged into HBase, and the HBase got started here. I have created a document of the codes that I will be executing today to just save time. So firstly, we will try to execute some of the basic commands in HBase, such as status, which will give us some important information about master, backup masters, region servers, and many more. You can see that we have one active master and one server. And since it is a VM, we don't have any backup masters over here. So followed by status, let's try to execute version command, where we'll come to know the version of HBase that we are using in our current system. So we are using 1.2.0 and the Cloudera version is 5.13.0. Followed by the version command, let's take in another command, which is the table help, which will show us some various operations that we could perform using that are table enable, table disable, and flush the table, drop table, which are completely similar to an RDBMS. Let's click in Ctrl+C to clear our screen. Now, one last command would be who I am I, which will give you the important information related to your local system, that is Cloudera, groups, Cloudera default. There are many other commands in HBase. Now, we have executed few of them. You can check out our article in Edureka site to get more information related to the commands based on Hbase. Now that we have executed some of the basic commands, let's move ahead and create a table. So here I'm going to create a table by the name employee, and our table has been successfully created. And the columns in my particular table are name of the employee, ID of the employee, designation, salary, and his or her department. So followed by the creation of table, we shall move ahead and verify if our table is created or not. So for that, you need to type in list. So when you type in list, you'll get to know what are the existing tables in your Hbase. So we had a table that is default, and followed by that we have employee table now. Let's check our local host and see if the table has been created or not. Yeah, here you can see the new table has been created successfully. So this is our table. Now moving ahead, let's try to perform few more operations on tables, such as enabling and disabling them. So to disable a table, you can just write in disable and the name of the table, and you can disable it. So there you go, it's been successfully disabled. Now you might have a doubt if it's properly disabled or not. So to resolve that issue, you can just type in scan employee, and if you get the details of the employee table, then the table is not disabled. If you don't get the details of the table, instead if you get something like this, which says the employee table is disabled, so you must be sure that the table got disabled now. So this is how it works. Now let's quickly clear our screen and move ahead with the next type of operations. Now let's try to create another table with different name. This time we will create employee 2. Now we have got two tables in our Hbase. So if you had to delete multiple tables, or if you had to disable multiple tables with starting letter E, or some like many other databases have with same names. For example, if you are in a school, then you have classes, and inside classes you might have sections. So for example, if you take class 10, you have section A, section B, and section C, D. So you might name them as class 10 section A, class 10 section B, class 10 section D. And if you had to delete all details of all the students of class 10, then you might use this command. So here I'm using disable all E. So this command will give me two tables, which are my first table, which are employee and employee 2. So you can just provide Y for yes and N for no to disable these tables. Now I don't want to disable my table, so I'll just give N. So I've closed it. Now moving ahead, now we will create a new table with the name student and apply some operations on it. So create is the keyword and student is the name of my table, and inside that I have columns name, age, and course. Let's create it. The table has been successfully created with the name student. Now followed by that, we shall try to put in some data into this Hbase. So the table name is student, and the value will be Sharath, and inside the column family name, I've got another column which says the full name. So the full name of Sharath is Sharath Kumar. So I'm going to load this data into my student table, fire and enter, and the data is in now. Let's add in another data into my table. This time I'll add in age. So here I'm trying to use the keyword put, and I'm loading the data into the table student, and the row is Sharath's row, and inside Sharath's row I've got a column family called age, and inside that I've got the column name as present age. So the present age of Sharath is around 24, so I've added that data as well. Followed by that, let's add in the course to Sharath, the course which he is studying. So inside Sharath's row and student table, I've got course family, and inside course family I've got pursuing column, and he's pursuing Hadoop in this particular institution. So now let's fire and enter to load this data. So the data has been successfully loaded. Similarly, let's add the same details for another student, which is Shashank. So we have added Shashank into the table. Now let's add in his age. So Shashank is around 23 years of age, and now we have added that data as well. Now let's add in the course with Shashank is studying. So he's studying Java, which is also loaded now. Now that we have loaded all the data into the tables, now let's get the details. So we are here using the keyword get. So we are getting the information from the table student, and the particular student of the information which we require is Shashank. Now let's fire and enter, and you get all the information related to Shashank. So the complete name of Shashank is Shashank R, and the course he is studying, that is course pursuing, is Java, and his age, the present age, is 23. So this is how you get the data. Now we will also get the data of Sharat using the similar way. So there you go. So the present age of Sharat is 24, and the course he is studying is Hadoop, and the complete name of Sharat is Sharat Kumar. Now, if you want to get a particular information, like if you don't want his age, if you don't want his full name, and you just want his course, what is Sharat studying in particular institution, then you can provide the command as get information from the table student of the student Sharat and his course, that is course. Now let's fire and enter and see. You can see that we have got the course family, and inside course family we have the column pursuing, so which says Sharat is pursuing with the course Hadoop. Similarly, let's try to get the complete name of Sharat. So if you just want the complete name of Sharat, then you can provide the keyword get from the table student from the row Sharat and his name. So there you go. From the column family name, you have the column full name, and his complete name is Sharat Kumar. So this is how you get data from a table. Now we shall see the complete details of the table student. So for that you can use the command scan table, which will give you the complete details of all the students present in your particular institute. So right now we have two students, so which are Sharat and Shashank. So this particular command gives you the age of Shashank, the course he is studying, and his complete name. Followed by that you have Shashank, his complete age, the course he is studying, and his complete name, which is Shashank R. So followed by this, we shall try to count the number of rows available in this particular table, that is student. So we have 2 rows right now, and yeah, here you go. You have 2 rows which are present in the table student. So this is how you can perform count operation in Hbase. Followed by that, you can also alter some informations based on your table. So I'm going to alter the table student, and the column which I'll be altering is age. So you can see that the process is getting done. So you can alter the age. Now we shall try to alter the name of a particular student. So for now, I want to alter Shashank name as Shashank Rao. So the R alphabet present in his name is about his full name, which is Rao. Now we will rename Shashank R as Shashank Rao. So the process has been successfully completed. Now let's scan student again and see if his name is changed or not. So there you go. Earlier we had Shashank R, now it's changed to Shashank Rao. So this is how you can alter some of the rows or data present in your table. Now let's try to delete one particular column from your table, that is the full name. Now we will delete the full name, so Shashank's full name will be deleted and only Shashank will be remaining. So now the process is complete. So this is how you can execute some of the basic commands in Hbase, and don't worry about this code. We will drop down this file in the description box below where you can get access to it, and you can execute the same commands in your own personal system to just have a practice about Hbase tutorial. What is Apache Oozie? Answer: well, Apache Oozie can be defined as a job scheduler system designed and deployed to manage and run Hadoop jobs in a distributed storage environment. It allows users to combine multiple complex jobs to be run in a sequential order to achieve a higher order job to be finished. The reason behind using Oozie along with Hadoop framework is its capability to strongly bind and integrate itself with Hadoop jobs like Hive, Scala, Apache Pig, and many more. Oozie is an open source Java web application available under Apache License 2.0. It is responsible for triggering workflow actions, which in turn uses Hadoop execution engine to actually execute the task. Hence, Oozie is able to leverage the existing Hadoop machinery designed for many tasks such as load balancing, system failover, and many more. Now that we have a brief understanding of Apache Oozie, let us move ahead and understand the major job types that Apache Oozie can practically perform. Apache Oozie jobs. The reason for choosing Apache Oozie for Hadoop jobs is its way of executing its jobs. Apache Oozie is capable to detect the completion of tasks through callback and polling. When Oozie starts a task, it provides a unique callback HTTP URL to task and notifies the URL when the task is completed. If the task fails to invoke the callback URL, then Oozie can poll the task for completion. There are three main types of jobs in Oozie. They are Oozie workflow jobs, Oozie coordinator jobs, Oozie bundles. Firstly, Oozie workflow jobs. These are directed acyclic graphs or DAGs, which specifies a sequence of actions to be executed. Next, Oozie coordinator jobs consist of the workflow jobs triggered by the time and data availability. And lastly, the bundles. These can be referred to as a package of multiple coordinators and workflow jobs. Now let us understand all these jobs in a little detailed way, one by one. Firstly, we shall understand Apache Oozie's workflow. A sample workflow with controls such as start, decision, fork, join and end, and actions like Apache Hive, Shell, Apache Pig will look like the following diagram. Oozie workflow is nothing but a sequence of actions that can be carried out and represented in the form of DAGs, or directed acyclic graphs. The actions will be carried out in a sequence, which means the output of the previous action will be the input for the present action, and the output for the present action will be the input for the next upcoming action. Let us understand this in a bit more detail. In a flow of different sequential tasks, some tasks can be performed in parallel. To execute some tasks in parallel, we can use the fork option in Oozie. The join option is used to merge two parallel tasks into one. Let us discuss with this diagram as shown down below. You can see the starting phase is the start and the last phase is the end. In between, we have MapReduce job, Pig job, and fork and join. So here, out of multiple jobs such as Hive, Shell, Pig, MR, we are using MapReduce job and Pig job. After starting the job, the workflow will enter the MapReduce job first. After executing the MapReduce job, a result will be generated or an output will be generated, which will act as an input for the next upcoming Pig job. And inside the Pig job, the task gets executed and the output will be forwarded to fork. Here, two other jobs are existing, which are MapReduce job and a Hive job. As said earlier, fork is used to execute two different tasks in parallel to save time. So here, the output from the Pig job is forwarded to two different jobs, that is the MapReduce job and the Hive job using fork. And after that, the output will be generated from both the jobs, that is the MapReduce job and the Hive job, and these two outputs will be joined together using the join method. And after that, the entire output or the final output will be thrown out. And that is the end of the execution of Oozie workflow. So this is how the Oozie workflow works in real time. So here the different components used in this particular job are start, MapReduce job, Pig job, fork, join, Hive job, and finally the end. Next are the nodes in the Oozie workflow. There are mainly three control flow nodes in Oozie workflow. They are start, end, and kill nodes. As you can see in the above diagram, we have start node in the first and end node in the last position. In between, we have a MapReduce program which is based on word count. If this particular MapReduce job encounters an error, then the job will be terminated using the kill option or the kill node. In case if the MapReduce job is successful, then the control will flow into the next node, which is the end node. Next, we deal with the coordinators. You can schedule complex workflows as well as workflows that are scheduled regularly using a coordinator. Oozie coordinators trigger the workflow jobs based on time, data, or even predictions. The workflows inside the job coordinator start when the given condition is satisfied. Definitions required for the coordinator jobs are start, end, time zone, frequency, and some more properties that are available in control flow information. Firstly, the start. Start says about the date and time which is related to the particular job assigned. Next is the end. The end defines the date and time for the particular job assigned. Followed by that, we have the time zone. Time zone represents the time zone of a coordinator application based on the particular location where the program is being executed. Followed by that, we have the frequency. Frequency says about the information of the number of minutes consumed while executing the job. Now, apart from that, we have a few more which are like timeout. The maximum time in minutes for which an action will wait or satisfy the additional conditions before getting discarded. The 0 indicates that all the input events are satisfied. At the time of action materialization, the action should be timed out immediately. 1 indicates no timeout. The action will wait forever. The default value will always be 1. Next is the concurrency. The maximum number of actions for a job that can run parallelly. The default value is always 1. Followed by that, we have the execution. The execution specifies the execution order if multiple instances of the coordinator job have to be satisfied with their execution criteria. That can be FIFO by default, which is first in, first out, or LIFO, which can be last in, first out. Finally, the last only. The command for the coordinator jobs to be executed is shown in the slide below. So followed by the command, if a configuration property used in the definition is not provided with the job configuration while submitting the coordinator job, the job submission will fail. So now, with this, we finish off the coordinator jobs. Followed by coordinator jobs, we have the Oozie bundle. Oozie bundle system allows you to define and execute a set of coordinator applications, often called as a data pipeline. In Oozie bundle, there is no explicit dependency among the coordinator applications. However, you could use the data dependency of coordinator applications to create an implicit data application pipeline. You can start, stop, suspend, resume, rerun the bundle. It gives a better and easy operation control. The most important term we need to understand about Oozie bundle is its kickoff time. The kickoff time is the time when the bundle should start and submit coordinator applications. Advancing in this Apache Oozie tutorial, we shall understand how to install Apache Oozie. Now, to install Apache Oozie, there are multiple ways. In CentOS, we need to install Cloudera, then download Oozie, download external J support for Oozie, download Maven setup, and then set up MySQL database. And after that, we need to configure the setting. And this seems very complex, right? No worries. In this tutorial, we shall learn the simplest way of installing Oozie, and then later we can try to learn the complex ways. So firstly, all we need is an Oracle VirtualBox. So just Google Oracle VirtualBox for Windows, and you will be redirected into a new web page where you can choose Oracle VM VirtualBox downloads Oracle technology, which is the first link in the description. You can go ahead and click the latest version for Windows. So by clicking on the Windows installer button, you'll get your Oracle VirtualBox basic packages installed into your local system. You can see the VirtualBox is getting downloaded. Followed by that, open a new tab and Google Cloudera. So you can see that we have Googled Cloudera download for VirtualBox. So that will redirect you into a new web page, and the first link, which is download quick start for CDH 5.13 Cloudera. Clicking on this link, you will be redirected into a new web page. And in this, you need to select a platform. So here we shall select VirtualBox. And now just click on Get It Now. And here you need to provide your details. Why are you using this product, which is for learning or anything else, and followed by that you need to provide your name, last name, business email ID, the company which you're working, or you can ignore if you're a student. After that, your job title, and you can ignore this if you're a student. Then your official phone number, then accept all the above, the private data policies, and if you would like to prefer someone to use Cloudera. Then press continue and your VirtualBox will be downloaded. I have already downloaded a quick start CDH 5.13 in my local system, so I would prefer to ignore this. Now that we have successfully downloaded our Cloudera CDH and VirtualBox required, we shall run them and install into our local system. You can see that the Oracle VM VirtualBox setup is started now. You can select next, followed by that just select next again, and here You're provided with different options, whether to create a shortcut menu on your desktop or not. I would prefer not. Then just select next, then yes. And the last button will be install. So I have already installed Oracle VirtualBox 6.4 version into my local system. To save time, we shall cancel this, but you have to select install button to install your VirtualBox system. So once after the VirtualBox is installed into your system, it will be looking something like this. So here you need to select the option import, and you will be provided with a new dialog box, and in here you need to select the browse button over here. So once you select the browse button, you will be redirected into your local file system. So you have to know the location where your Quick Start Cloudera has been downloaded. So I have saved my Quick Start Cloudera ISO file in this particular file. So I need to select my Quick Start VM, then just select open. And for the safer side, in the configuration, we shall select the RAM size above 8 GB. So I'll just specify randomly as 9000 MB, which is just above 8 GB. And now just import. You can see the importing appliance has started. So your Cloudera will be imported as soon as possible. So you can see that the Cloudera Quick Start VM has been successfully imported onto the VirtualBox. Now let's quickly start it by double clicking it. Or also you can just select start. Now you can see that Quick Start VM has been successfully started and it's loading. You can see the Cloudera is getting booted up. So there you go. The Quick Start Cloudera VM has been successfully booted up. Now the best part about Cloudera is it's got everything you need. The Oozie, Hive, Hue, Spark, Hbase, Impala, everything for a beginner to start with. Now what we need is Oozie. So we need to start up our Hue and Oozie first. Let's open Oozie in a new tab. And parallelly, let us also start Hue. So this is how the web page of Hue looks like, or the editor of Hue looks like. And also, this is the web page or web console of Oozie. So here you can have workflow jobs, coordinator jobs, which I mentioned in the previous explanation, and also the bundle jobs, SLA, system info, instrumentation, metrics, and all the extra additional settings you require. Now we shall discuss about the editors present in Hue. So to find out the editors in Hue, you need to select the button Query, and inside that you'll be getting a drop-down menu, and inside the menu select editor, and you can see there are various editors present in Hue that are Impala, Hive job, Big job, Java code, Spark job, MapReduce, Shell, Sqoop, and many more. So now that we have understood how to install Oozie into local system and the editors present in Hue and the Oozie web console, we shall advance ahead and understand the advantages of Oozie. The first among the advantages of Oozie is scalable and reliable to monitor jobs in Hadoop cluster. Oozie supports various jobs in Hadoop ecosystem like MapReduce, Pig, Hive, streaming, and also Java-based applications. Oozie has an extensible architecture that supports great programming paradigms. The next advantage is complex workflow action and dependencies. Oozie workflow comprises of actions and dependencies among them. Followed by complex workflow action dependencies, we have reduced the time to market system. The directed acyclic graph specification enables users to specify the workflow. So this saves a lot of time to market. Followed by TTM, we have frequency execution. Users can specify execution frequency and can wait for data arrival to trigger an action on the workflow. Followed by frequency execution, we have native Hadoop stack integration. Oozie supports all types of jobs such as Spark, Hive, Pig, and many more. Oozie is validated against Hadoop stack, and Oozie is integrated with Yahoo distribution of Hadoop with security and is a primary mechanism to manage a variety of complex data analysis.
Let's compare Apache Spark with Hadoop on different parameters to understand their strengths. We will be comparing these two frameworks based on these parameters. Let's start with performance first. Spark is fast because it has in-memory processing. It can also use disk for data that doesn't fit into memory. Spark's in-memory processing delivers near real-time analytics. And this makes Spark suitable for credit card processing system, machine learning, security analytics, and processing data for IoT sensors. Now let's talk about Hadoop's performance. Now Hadoop was originally designed to continuously gather data from multiple sources without worrying about the type of data and storing it across distributed environment. And MapReduce uses batch processing. MapReduce was never built for real-time processing. Main idea behind Yarn is parallel processing over distributed dataset. The problem with comparing the two is that they have different way of processing, and the idea behind the development is also divergent. Next, ease of use. Spark comes with a user-friendly APIs for Scala, Java, Python, and Spark SQL. Spark SQL is very similar to SQL, so it becomes easier for SQL developers to learn it. Spark also provides an interactive shell for developers to query and perform other actions and have immediate feedback. Now let's talk about Hadoop. You can ingest data in Hadoop easily, either by using Shell or integrating it with multiple tools like Sqoop and Flume. And Yarn is just a processing framework that can be integrated with multiple tools like Hive and Pig for analytics. Hive is a data warehousing component which performs reading, writing, and managing large dataset in a distributed environment using SQL-like interface. To conclude here, both of them have their own ways to make themselves user-friendly. Now let's come to the costs. Hadoop and Spark are both Apache open source projects, so there's no cost for the software. Cost is only associated with the infrastructure. Both the products are designed in such a way that it can run on commodity hardware with low TCO or total cost of ownership. Well, now you might be wondering the ways in which they are different. They're all the same. Storage and processing in Hadoop is disk-based, and Hadoop uses standard amounts of memory. So with Hadoop, we need a lot of disk space, as well as faster transfer speed. Hadoop also requires multiple systems to distribute the disk input-output. But in case of Apache Spark, due to its in-memory processing, it requires a lot of memory, but it can deal with a standard speed and amount of disk. As disk space is a relatively inexpensive commodity, and since Spark does not use disk input-output for processing, instead it requires large amounts of RAM for executing everything in memory. So Spark systems incurs more cost. But yes, one important thing to keep in mind is that Spark's technology reduces the number of required systems. It needs significantly fewer systems that cost more. So there will be a point at which Spark reduces the cost per unit of the computation even with the additional RAM requirement. There are two types of data processing, batch processing and stream processing. Batch processing has been crucial to the big data world. In simplest term, batch processing is working with high data volumes collected over a period. In batch processing, data is first collected, then processed, and then the results are produced at a later stage. And batch processing is an efficient way of processing large static datasets. Generally, we perform batch processing for archived datasets. For example, calculating average income of a country or evaluating the change in e-commerce in the last decade. Now, stream processing. Stream processing is the current trend in the big data world. Need of the hour is speed and real-time information, which is what stream processing does. Batch processing does not allow businesses to quickly react to changing business needs in real time. Stream processing has seen a rapid growth in that demand. Now coming back to Apache Spark versus Hadoop, Yarn is basically a batch processing framework. When we submit a job to Yarn, it reads data from the cluster, performs operation, and writes the results back to the cluster. And then it again reads the updated data, performs the next operation, and writes the results back to the cluster, and so on. On the other hand, Spark is designed to cover a wide range of workloads such as batch application, iterative algorithms, interactive queries, and streaming as well. Now let's come to fault tolerance. Hadoop and Spark both provides fault tolerance, but have different approaches. For HDFS and Yarn, both master daemons, that is the name node in HDFS, and resource manager in Yarn checks the heartbeat of the slave daemons. The slave daemons are data nodes and node managers. So if any slave daemon fails, the master daemons reschedules all pending and in-progress operations to another slave. Now this method is effective, but it can significantly increase the completion time for operations with single failure also. And as Hadoop uses commodity hardware, another way in which HDFS ensures fault tolerance is by replicating data. Now let's talk about Spark. As we discussed earlier, RDDs, or Resilient Distributed Datasets, are building blocks of Apache Spark. And RDDs are the one which provide fault tolerant to Spark. They can refer to any dataset present in external storage system, like HDFS, Hbase, shared file system, etc. They can also be operated parallelly. RDDs can persist a dataset in memory across operations, which makes future actions 10 times much faster. If a RDD is lost, it will automatically get recomputed by using the original transformations. And this is how Spark provides fault tolerance. And at the end, let us talk about security. Well, Hadoop has multiple ways of providing security. Hadoop supports Kerberos for authentication, but it is difficult to handle. Nevertheless, it also supports third-party vendors like LDAP for authentication. They also offer encryption. HDFS supports traditional file permissions as well as access control lists. Hadoop provides service-level authorization, which guarantees that clients have the right permissions for job submission. Spark currently supports authentication via a shared secret. Spark can integrate with HDFS and it can use HDFS ACLs or access control list and file-level permissions. Spark can also run on Yarn leveraging the capability of Kerberos. Now this was the comparison of these two frameworks based on these following parameters. Now let us understand use cases where these technologies fit best. Use cases where Hadoop fits best. For example, when you're analyzing archived data. Yarn allows parallel processing over huge amounts of data. Parts of data is processed parallelly and separately on different data nodes and gathers result from each node manager. In cases when instant results are not required. Now, Hadoop MapReduce is a good and economical solution for batch processing. However, it is incapable of processing data in real time. Use cases where Spark fits best. In real-time big data analysis. Real-time data analysis means processing data that is getting generated by the real-time event streams coming in at the rate of millions of events per second. The strength of Spark lies in its abilities to support streaming of data along with distributed processing. And Spark claims to process data 100 times faster than MapReduce, while 10 times faster with the disks. It is used in graph processing. Spark contains a graph computation library called GraphX, which simplifies our life. In-memory computation along with inbuilt graph support improves the performance of algorithm by a magnitude of 1 or 2 degrees over traditional MapReduce programs. It is also used in iterative machine learning algorithms. Almost all machine learning algorithms work iteratively. As we have seen earlier, iterative algorithms involve input-output bottlenecks in the MapReduce implementations. MapReduce uses coarse-grained tasks that are too heavy for iterative algorithms. Spark caches the intermediate dataset after each iteration and runs multiple iterations on the cached dataset, which eventually reduces the input-output overhead and executes the algorithm faster in a fault-tolerant manner. So at the end, which one is the best? The answer to this is Hadoop and Apache Spark are not competing with one another. In fact, they complement each other quite well. Hadoop brings huge data sets under control by commodity systems, and Spark provides real-time in-memory processing for those data sets. When we combine Apache Spark's ability, that is the high processing speed and advanced analytics, and multiple integration support with Hadoop's low-cost operation on commodity hardware, it gives the best results. Hadoop complements Apache Spark capabilities. Spark cannot completely replace Hadoop, but the good news is that the demand of Spark is currently at an all-time high. So this project is based on the e-commerce domain. So let me give you an introduction to this project in context of one of the biggest names of e-commerce platforms, none other than Amazon. So if you have ever shopped from Amazon before, which I presume you must have seen something like this when you click on a product. So you'll view the details of the product, something like this. And as you know, most of the e-commerce organizations do not have any inventory, so they tie up with different merchants. Similar is the case with Amazon. Amazon provides the merchants or the sellers a platform to get connected to the buyers. So when you click on the details of a product, you can see that Amazon gives you something like this. And you also find something like this. There are 28 offers from this price. And if you click on it, you can see the name of the different sellers who are selling the same product at different prices. And the prices they're offering are listed like this. But you can see over here that by default, Amazon has selected the Apparel Retail Private Limited for this particular product. So how does Amazon do that? So it is actually based on a merchant rating system. And as a platform, as an e-commerce platform, you have to ensure that you always display the product from the best merchant in order to ensure quality, because you don't want angry customers, right? So it is very important that your customers are satisfied with their product. So you have to choose from different merchants for the same product in order to decide which merchant's product needs to get displayed by default. And hence Amazon has a merchant rating system in order to decide that. And this is what exactly we're going to build. All right. So we're going to make a merchant rating system similar to this. So here is the problem statement. So there are multiple merchants selling the same type of products. As you can see that merchant 1 and merchant 6 are selling the same shirt, merchant 3 and 4 are selling the same shoes, and similarly 5 and 1 are selling the same pants, and there are multiple other merchants who are selling the same kind of products. And you have to build a merchant rating system, or the company wants to build a merchant rating system in order to determine which merchant sells the best product, so that their product would be displayed by default. And as a big data expert, let's just assume that you were hired by the company as a big data expert, you are assigned this task. So this is now your problem to solve. So the first thing your organization will give you before you start to do your work is the data set. So this is the data set that you're going to get. So this is the transaction data set, and has certain fields like transaction ID, customer ID, merchant ID, timestamp when the purchase was made, the invoice number, the amount, and the segment of product that was bought. You have another data set, which is the merchant data. So these are the details about the different sellers or the merchants. So you have got your merchant ID, the tax registration number, the merchant name, their mobile number, start date, email, address, state, country, PIN code, description, longitude, latitude, the location basically. So these are all the details about the merchant that you have in your data set. So let me just show you the data set. So this is the data set that is in your HDFS right now. So here is the transaction data. So here is the transaction data, which is a 2 GB of file. and the merchant data set, which is 20 MB, because as you know, there are many transactions, but a limited number of sellers or merchants. So that is why the size of the data set, the merchant data set, is quite smaller as compared to the transaction one. And to tell you, we haven't actually used the entire data present in the data set. We have just selected a subset or a sub data set, you can say, because the original data set was quite huge. And this was a demo project. So just for your understanding, we have chosen a sub data set. We just took 2 GBs of data out of it. All right. And this is how it exactly looks like. So this is the CSV file of the data set that we have. This is the transactions data. All right. So this is the approach to solve. So the first thing we'll do is that we'll segregate the merchants based on the price of their products and their sales. So we will be segregating them into 4 categories. So the categories are the merchants who are selling products that are below $5,000 or less than $5,000. There is one more category for merchants who sells products between $5,000 to $10,000. Another category of merchants who sells products between $10,000 to $20,000, and another category greater than $20,000 or more than $20,000. We'll be using a simple logic to approach solving this problem. So let's say that if there is a merchant who's selling their products at quite a low price, and you see if he's not making a good number of sales, it means that he is not selling quality products, because if a merchant who's selling the product at quite a less price and people aren't still buying from him, it clearly indicates that his products are not up to the mark. So it's a low rating for a merchant. Similarly, on the other hand, if you see a merchant who is selling their product at quite a high price and yet he has a very good number of sales, so it clearly indicates that his products must be very good, because despite of the higher price, people are still buying from him. So in that case, obviously the rating of the merchant would be also very good, right? So this is a simple logic that we're going to use in order to rate our merchants or sellers. And you have 3 options to choose from. So you have got Apache Hive, which is a great analytical tool. We have got Hadoop MapReduce and Apache Pig. And today we will be choosing Hadoop MapReduce. So MapReduce is the core component of Hadoop that processes huge amount of data in parallel by dividing the work into a set of independent tasks. MapReduce is the data processing layer of Hadoop. It is a software framework for easily writing applications that processes the vast amount of structured and unstructured data that is stored in your HDFS. HDFS is Hadoop Distributed File System. In Hadoop, MapReduce works by breaking the data processing into 2 phases, map phase and the reduce phase, and that is how exactly it gets its name, MapReduce. So the map is the first phase of processing where we specify all the complex logic business rules. Reduce is the second phase of processing where we specify lightweight processing like aggregation or summing up the outputs. But the question is, why choose MapReduce? Well, I'll give you 2 reasons for it. First is the custom input format. Now, input format is something that defines how your input files are going to be split and read. So in MapReduce, you can create your own custom input format instead of using the default input format. This actually makes handling of your data quite easier, because here we can create our custom input format for transactions and pass it as an argument. Then we have the distributed cache. So distributed cache is nothing but it is a facility that is provided by MapReduce framework to cache files. Files like your text files, archives, jars, etc. that is needed by your application. Let's understand this with an analogy. Just think about it that there are 3 students sitting on a table solving chemistry problems, and they have one periodic table. So you keep the periodic table in the middle of the table so the students, all the 3 students, can refer from the periodic table to see the atomic numbers of different elements and solve their problems, right? So one periodic table everyone can refer to it and solve their own problems. So this is what distributed cache is. So with distributed cache, you can put the data that will be used by your different data nodes to refer in order to run MapReduce jobs. So we'll be learning more about how to create your custom input format and how to use the distributed cache in the demo part. All right. So before that, let us just understand how MapReduce exactly works. So this is a sample MapReduce job execution with an example. So this is your input file. This is a text input file. So it contains some words. So first, what will happen is that the input will get divided into 3 splits. All right, so I'm taking one sentence at a time. So I have got 3 splits over here. And this will distribute the work among all the different map nodes. Then we will tokenize the words in each of the mapper and give value 1 to each of the tokens or words. So deer 1, bear 1, river 1. Similarly here, car 1, river 1. And now a list of key value pair will be created where the key is nothing but the individual word and the value is 1. So this is the key and this is the value. And this will happen on all the 3 nodes. So the mapping process remains same on all the nodes. So after the mapper phase, a partition process takes place where the sorting and shuffling happens. Here all the tuples with the same key are sent to the corresponding reducer. So all the bear are together, cars are together, deer and river are together. So after the sorting and shuffling phase, each reducer will have a unique key and a list of corresponding values to that key. For example, bear 1, 1, car 1, 1, and so on. Now comes the reducing phase. Now each reducer counts the values which are present in the list of values. So reducer gets a list of values which is 1, 1 for the key bear, and then it counts the number of ones in the list and gives the final output as bear 2. Similarly for car, it's 3, deer 2, river, it'll count 2 ones, so 2. And finally, all the output, the key value pairs are then collected and written in the output file. So this is your output file. So it has just combined the result from different reducers, and here is your final output. So I've understood MapReduce with the classic example of the word count program. Now this is the generic execution flow of the MapReduce job. So you have your input file over here. So the data for MapReduce task is stored in input files, and input files typically lives in the HDFS. The format of these files is arbitrary, while line-based log files and binary format can also be used. And you have an input format. Now input format defines how these input files are split and read. It selects the files or other objects that are used for input, and input format creates the input split. So it logically represents the data which will be processed by an individual mapper. One map task is created for each split, and thus the number of map tasks will be equal to the number of input splits. The splits are then divided into records, and each record will be processed by the mapper. Now let's talk about the mapper. So mapper processes each input record from the record reader and generates a key value pair. And this key value pair is generated by the mapper is completely different from the input pair. The output of the mapper is also known as the intermediate output, which is written to the local disk. The output of the mapper is not stored on HDFS as this is temporary data, and writing on HDFS will create unnecessary copies. So then the mapper's output is passed on to the combiner for further process. The combiner is also known as the mini reducer. So Hadoop MapReduce Combiner performs local aggregation on mapper's output, which helps to minimize the data transfer between mapper and the reducer. Once the combiner functionality is executed, the output is then passed to the partitioner for further work. Now, partitioner comes on the picture if you're working on more than one reducer. And here we have 2 reducers in the example. So if you have one reducer, you don't actually need a partitioner. So the partitioner takes the output from the combiners and performs partitioning. Partitioning of output takes place on the basis of the key and then sorted. So by hash function, a key is used to derive the partition. According to the key value in MapReduce, each combiner output is partitioned and a record having the same key value goes to the same partition, and that each partition is sent to a reducer. So by using partitioner, it allows to have an even distribution of the map output over the reducer. So after that comes the shuffling and sorting part. So now the output is shuffled to the reduce node. The shuffling is the physical movement of the data which is done over the network. Once all the mappers are finished and their output is shuffled on the reducer nodes, then this intermediate output is merged and sorted, which is then provided as an input to the reduce phase. Now comes the reducer, so it takes the set of intermediate key value pairs produced by all the mappers as the input and then runs a reducer function on each of them to generate the output. The output of the reducer is the final output, which is stored in HDFS. So if you have multiple reducers, the result from different reducers will combine, and that is going to be your final output, which will be written into the HDFS. So this was the MapReduce job execution flow. So we'll also be using the distributed cache. So you'll have different data nodes. Each data node will have their local copy of their data. And if each of the data nodes needs to reference something, we will keep that in the distributed cache. And in this case, we'll be keeping the merchants file. All right, so distributed cache is nothing but think of it as a shared drive, right? So if you have multiple users who wants to have access to one data set, so you can just put it up in the shared drive and all of your users can share the data, use the same data, right? So this is what distributed cache is. So applications specify the files via URLs to cache via the job conf. So I'll be telling you about the job conf later in the demo section. And the distributed cache assumes that the files specified via URLs are already present on the file system at the path specified by the URL and are accessible by every machine in the cluster. So the framework will copy necessary files to the slave node before any jobs are executed on that node. And distributed cache tracks modification timestamps of the cache files. So clearly the cache files should not be modified by the applications or externally while the job is executing. So how will it work? So in our case, we'll be storing the data into HDFS and we'll be executing MapReduce program over that file. So we'll store the merchant data in the distributed cache. Then we'll segregate the transaction data into categories such as less than $5,000, $5,000 to $10,000, $10,000 to $20,000, and greater than $20,000 with the merchant ID. Then we'll use the merchant file from the distributed cache and map the merchant ID with the merchant name. And at last, we'll receive the output as the merchant name with date indicating the number of sales in different categories. Now let us talk about the code sections. So the execution will start from the main method where we'll use the tool runner. So the tool runner can be used to run classes implementing tool interface. So it passes the generic Hadoop command line arguments and modifies the configuration of the tool. Then it will point to the run method, which will point to the run MR jobs. So here we are specifying the driver code. So I'll be telling you about the driver code later on. So next, the execution will move to the mapper class, which is the transaction mapper. The framework first calls the setup method, followed by the map method for each key value pair in the input split. So in setup method, we are loading the cache file and calling a method where we'll be resolving the merchant name from the merchant ID. Next, in the map method, we are creating the object of transaction, which we will be using to catch all the fields of transaction first, and then using the object of aggregate data, we will create the segment of transactions as we discussed before, the 4 segments, less than 5,000, 10,000, 20,000, those segments. At last, using the merchant ID name map, we will resolve or find out the merchant name. The output of the map method would be the key, which will be the combination of merchant name and date of sale.
while the value would be in the form of number of sales of different categories. Next, the execution will go to the partitioner code, where we'll have the getPartition method, which will send the records with the same key to the same reducer. And at last, the reducer code will execute, which will aggregate the data with the same key and provide the output. So I'll be showing you and explaining you all the codes involved over here in the demo part. All right, now let us move ahead. So first, let me take you through this transaction class, where we are defining all the variables corresponding to the transaction file. As you can see, we have got the transaction ID, customer ID, merchant ID, timestamp, invoice number, invoice amount, and segment here. So these are the fields in the transactions, and we have created the variable for the same. So next, we are creating the getter and setter methods for each of the variables so as to read the value of the field, and we write the value of the field. So as you can see here, we are defining the method get. So get segment, we have got get segment here, where we are returning the value of the field, and the set method here, the set segment, where we are writing the value of this field. So similarly, we're doing it for all the variables, as you can see here. So we have the get and set for customer ID. So we have the get customer ID method, which returns the value of the field, and we have got the set customer ID, which writes the value of the field. So this is similar for all the fields in our transaction data. So similarly, you can have the aggregate data class, which we have used to create the categories of the product. So here we have fields like order below 5,000, order below 10,000, order below 20,000, order above 20,000, which are nothing but the different categories which we have defined earlier. And similar to the transaction class, here we are defining the getter and setter methods. So we have got get total order method, which returns the value of total order, and we have set total order method, which is writing the value of this field total order. So we have the same for all the different variables that we have defined in the aggregate data class, the getter and setter methods. Then we've got the aggregate writable class. So first here we are creating an object of JSON class. So JSON is basically used to convert Java objects to JSON format. Next, we're initializing the aggregate data object. Now we have two constructors. First one is the basic constructor, which is not taking any argument. The second constructor is taking aggregate data format as an argument and trying to initialize the aggregate data object. Next, we have the getter method for the aggregate data, which will return the aggregate data object. After that, we have the write method, which will write the value of corresponding fields using the getter method of the field. Like for order, get order below 5,000, get order below 10,000, order below 20,000, get order above 20,000. Then you have read fields method, which will be calling the setter method of each field to assign the values to the corresponding field. And at last, we are overriding to string method, which will convert the aggregate data object to JSON and then return the JSON. So I hope you guys are clear with the custom input format. So now let us take a look at the main Java file, which is the merchant analytics job.java. So the main class is the merchant analytics job class, inside which all the jobs will reside. So the execution will start from the main method. So first let us go to the main method. So here we are using tool runner. So tool runner can be used to run classes implementing the tool interface. It passes the generic Hadoop command line arguments and modifies the configuration of the tool. So toolrunner.run method runs the given tool after parsing the given generic arguments. It uses the given configuration or builds one if null. It sets the tool's configuration with the possibly modified version of the conf. Here we are passing the configuration object, merchant analytics job object, which is the main class, and arguments which we will be providing while executing the job. So in our case, there are three arguments. First is the path of the transaction file, second is the path of the merchant file, and third is the output directory. Now we will execute the run method, where we are returning the values of the run mr jobs method.
We're also parsing the arguments, that is all the three paths, that is the transaction, merchant, and output directory to the run mrjobs method. Now let us see the run mrjobs method. So here we have the driver code. So first we initialize the configuration object and then we will initialize the control job object. So control job class encapsulates a MapReduce job and its dependency. It monitors the state of the depending jobs and updates the state of this job. And now we are creating the object of job class and we will define the properties of the job. So first we have the set output key class property where we are defining the output format class of the key, which is text class. Similarly, we're defining the set output value class for output format class of the value, that is the aggregate writable class. Next, we have set jar by class, which tells the class where all the mapper and reducer code resides, which the merchant analytics job in our case. Now we are specifying the reducer class, which is merchant order reducer. And next we are providing the input directories. So the set input, the recursive method will read all the files from the directories recursively if we are providing the directory path. So first we're adding the input path of the transaction file, which is present in the argument 0. Then here we are also specifying the input format of the file and the mapper class, that is the transaction mapper. Next we're talking about all the merchant file from the directory provided in argument 1. And adding this file to the distributed cache using the job.addCacheArchive method. And moving ahead, we are setting the output directory path, which is provided in argument 2, and we are also adding the timestamp as the subdirectory. And at last, we are setting the partitioner class, that is the merchant partitioner, and then we are returning 0 or 1 depending on whether the job has been executed successfully or not. And next we will take a look at the transaction mapper class, which implements the mapper interface. So it maps input key value pairs to a set of intermediate key value pairs. So maps are the individual tasks which transform input records into an intermediate record. The transformed intermediate records need not to be of the same type as the input records. The Hadoop MapReduce framework spawns one map task for each input split generated by the input format for the job. And mapper implementations can access the job conf for the job via the job configurable and initialize themselves. The framework first calls the setup method followed by map method for each key value pair in the input split. So in the setup method, we are loading the merchant file from the cache using the getCacheArchives method. Then from each file, we are calling the load merchant ID name in cache. So we're calling this method and we are passing the path of the cache files and the configuration objects. Now in this load merchant ID name in cache method, we are initializing the object of file system using the conf. And next we're opening the file and then we're reading the data line by line from the file. Now here first we're removing the quotes from the line and then we're splitting the line using the comma. And at last we're putting the merchant ID and merchant name in the merchant ID name map variable. So here you can see in the merchant file that we have merchant ID at index 0 and merchant name at index 2. So this merchant ID name map will help us in resolving the merchant name from merchant ID. And next, we're defining exception to notify us if the cache file is not read. And at last, we're closing the object of the buffered reader. Now let's talk about the map function. So now the map function will be called. So the input format of key is long writable and the value is text. We're also creating a context of the mapper framework where we will be writing our intermediate output. Now the output format of the key is text and the value is aggregate writable. Again, here we are removing the quotes from the line and then we're splitting the line using comma. So in the split array, we have all the fields of the transaction data stored in the consecutive indexes. Now we are creating an object of transaction class and setting the values of the field using setter methods. And next we are creating the objects of aggregate data and aggregate writable class. Then using transactions get invoice amount field, We are deciding that in which aggregate data field the transaction would lie. We will set the value of corresponding field of the aggregate data object to 1. And next we have the output key, which will contain the merchant name and the date of sale. We will set the value of corresponding field of that aggregate data object to 1. And next we have the output key, which will contain the merchant name and the date of the sale. So merchant ID name map method will return the merchant name from the merchant ID as we just discussed. So we are passing the values as merchant ID and the date. At last, we'll pass the intermediate result in the form of key and value to the context. Next, the result will be sent to the partitioner class, that is the merchant partitioner. So it's over here. So in this class, we are overriding the default getPartition method. And in this method, we are converting the key using hash function and using abs method to return the absolute value of a number. And at last, we're using the modulo function to get the remainder. And now we're dividing it with the number of partitions, so which is nothing but the number of reducers. And in our case, we have specified 5 reducers, so the modulo 5 would return the value between 0 and 4. And one more thing is, the same key would always have the same hash generated, and hence the modulo result would be also the same. And thus the records with the same key will be sent to the same reducer. And based on this, records are sent to the reducer. So next we have the reducer code, and it's over here. So it's the merchant order reducer. The reducer class, as defined in the driver code, resides in the merchant order reducer class. So here we have the key input as text and value input as aggregate writable, which was written by our mapper class. And the output key format is again text, and the output value format is aggregate writable. So here our execution will move to reduce method, where we are passing the input key, value, and context as argument. And here we are again creating the objects of aggregate data and aggregate writable class. And next we are taking the input values. Now here we are calling the setter function of each category, getting the earlier value of that category, and then adding the new value of the new aggregate data object for that category. So it will add the value to the corresponding fields if there is a record with the same key. And at last, we are writing the key and value in context.write method. So I have explained to you the code, so now let us just go ahead and execute it. So first, let us move to the project directory. So we have the pom.xml file, which has all the dependencies that we require in order to run our MapReduce job. So this is the command. So it has my jar file and the path of my jar file. Then I have got my main class over here, which is merchant analytics job. So this is where my main function is. And then I'm passing the 3 paths. So first is my transactions.csv. This is my data set. This is the path of my data set. Then my merchant data, this is the path of my merchant data. And finally, my output directory, which is the result. This is the path over here. So let us just go ahead and execute this command. So the code is run. So here are the different parameters on which this MapReduce job was run. So you can see the details over here. So you can see the number of reduced tasks were 5, since we had 5 reducers. So you can see all the details here. Let me just show you the result now. So it is in the results directory. So there are 2 directories over here, because this was the earlier one that when I had previously executed it. So this is the one that we have got right now. So let me just show it to you. So we have got 5 part files because there are 5 reducers. So I'm just clicking on one part, and you can just click on download. All right, let me just open it. So this is what you get. So you get the merchant name and the timestamp over here, and also the category or the segregation that we did based on the cost of the orders, right? So it was order above $20,000 at this timestamp, and the total order was 1. So this is the format of the result. So we have got a lot of rows. So this is the result. So we have just used a few fields or parameters from the merchant file. We have just used the merchant name and the ID over here. Since this is a sample project, sample demo project, but the scope of this particular project is huge. You can use a lot of other parameters that was mentioned there, like the location. You can analyze it based on locations, based on the time period where the order was placed. So you can take in account different fields and improve this or make this analysis even better by yourself. So when you're doing this project as a part of your course curriculum, so you will be exploring the other fields as well. I have just shown you with just using 2 fields, the merchant name and the ID.
What is Kafka? In general, Kafka is a producer to the consumer-based messaging system that has a producer that produces the message and the consumer that consumes the message. In between the both, we have brokers that distribute the messages to the consumers and data storage unit, which is none other than Apache Zookeeper. To understand more about Apache Zookeeper and Kafka, you can go through the article link in the description box below. Apache Kafka. So basically, Apache Kafka is an open source messaging tool developed by LinkedIn to provide low latency and high throughput platform for the real-time data feed. It is developed using Scala and Java programming languages. So followed by the definition of Kafka, we shall enter and understand what exactly is a stream. In general, a stream can be defined as an unbounded and continuous flow of data packets in real time. Data packets are generated in the form of key value pairs, and these are automatically transferred from the publisher. There is no need to place a request for the same. The below image depicts the key value pairs that are involved in data stream. Each and every single key value pair is one single unit of data, or it is also called as one single unit of a record. So followed by the stream, we shall understand what exactly is a Kafka stream. Kafka Stream is an API that integrates Kafka cluster to the data processing applications, which are either written in Java or Scala. This API leverages the data processing capabilities of Kafka and increases data parallelism. Apache Kafka Stream can be defined as an open source client library that is used for building applications and microservices. Here, the input and the output data is stored in the form of Kafka clusters. It integrates the intelligibility of designing and deploying standard applications using the programming languages such as Scala and Java with the benefits of Kafka server-side cluster technology. So this was the basic definition of Kafka Stream. Now, let us understand Kafka Stream API in a much better way through its architecture. Apache Kafka Streams internally use the producer and consumer libraries. It is basically coupled with Kafka, and the API allows you to leverage the capabilities of Kafka by achieving data parallelism, fault tolerance, and many other powerful features. The following image depicts the basic architecture of Kafka Stream. Here, you can see the Kafka cluster, which has the input streams and the output streams together. Followed by that, we have Kafka Streaming Application, or the API, which takes care of the queries which are received from numerous applications which are connected to Kafka Streaming Application. Followed by this, we have numerous components present in Kafka Stream architecture, which are as follows. They are input stream, output stream, instance. We have 2 instances here, which are stream instance 1 and stream instance 2. So inside every instance, we have consumers as well as local state and stream topology. So in Kafka Stream API, input stream and output stream can be one single Kafka cluster. Followed by that, we have a consumer which provides the input and receives the output. And inside the stream instance, we have stream topology and local state. We shall understand about stream topology in a much detailed way in the next slide. Stream topology is all about the directed acyclic graph, or the steps in which the particular process is executed. Followed by that, we have a local state. Local state is none other than a memory location which stores the intermediate data or the result provided by the stream topology. These results are produced after applying various transformations such as map, flat map, etc. So after the data is processed, the tasks are united together and sent back to output stream. So this is how the architecture of Kafka Stream API works. Now let us understand more about stream topology. So this particular diagram explains the stream topology. Here you can see the stream processor. All the dots which are provided here are none other than stream processors. And the line which is connecting them is the stream. The stream is none other than the key value pairs of the data or records. So basically, the input is read from Kafka cluster first. Followed by that, we apply various operators such as filter, map, join, aggregate, and many more. And finally, we will receive the results which will be sent back to the output Kafka cluster. So this is how the stream topology works. Now, let us discuss the important features of Kafka streams that give it an edge over the other similar technologies. So the various important features of Apache Kafka Streams API are elastic, fault-tolerant, highly viable, integrated security, Java and Scala language support, and exactly once. Don't worry, we shall discuss each one of them in detail. Firstly, we shall discuss about elastic nature. Apache Kafka is an open source project that was designed to be highly available and horizontally scalable. Hence, with the support of Kafka, Kafka Streams API has achieved its highly elastic nature and can be easily expandable. So this was the first feature. Followed by that, we have the second feature, which is about fault tolerance. The data logs are initially partitioned, and these partitions are shared among all the servers in the cluster that are handling the data and their respective requests. Thus, Kafka achieves fault tolerance by duplicating each partition over a number of servers. Followed by fault tolerance, we have the next important feature, that is highly viable. Since Kafka clusters are highly available, they can be preferred to any sort of use cases regardless of their size. They are capable of supporting small-scale use cases, medium-scale use cases, also the large-scale use cases. Followed by highly viable feature, we have integrated security. Kafka has three major security components that offer the best-in-class security for the data in its clusters. They are mentioned as follows. They are encryption of data using SSL or TLS, followed by that authentication of SSL or SASL, and finally the authorization of ACLs. So followed by the security, we have its support for top-end programming language. The best part of Kafka Streams API is that it integrates itself with the most dominant programming languages such as Java and Scala, and makes designing and deploying Kafka server-side applications with ease. Followed by that, we have exactly once processing semantics. Usually, stream processing is a continuous execution of unbounded series of data or events. But in the case of Kafka, it is not. Exactly once means that the user-defined statement or logic is executed only once, and the updates to the state, which are managed by SPE or stream processing element, are committed only once in a durable backend store. So this is how Apache Kafka Streaming API is considered to be having exactly once processing semantics. So followed by the important features, we shall go through a sample program based on Kafka Streams API. So this particular example can be executed using Java programming language, yet there are few prerequisites on this one. One needs to have Kafka and Zookeeper installed in the local system, and it should be running in the background. If you have not installed Zookeeper and Kafka in your local system, then I have linked the article in the description box below, which will explain you about the detailed installation procedure of Zookeeper and Kafka in your local system. Once the Zookeeper and Kafka are installed into your local system, you need to fire them up. Once the Kafka and Zookeeper are successfully installed into your local system and they are running in the background, you can go to Kafka and define a producer, topic, and the consumer. Once the producer, topic, and consumer are defined, you can come back to Kafka article and execute the following code in any of the Java editors. The code will count the number of words that you have provided in your text document, and you will receive the output, as shown in the article. Here, the text given to the code was "Welcome to Edureka Kafka training," and this article is based on Kafka streams. These were the two sentences given to the program, and the output is as shown below. Here, the word welcome is repeated for once, to is repeated for once, Edureka once, Kafka is repeated for 2 times, and training is once. This article is about streams. So all these words are repeated for once. So this is how exactly you should be receiving the output once after you execute the following code in your Java editor. So followed by the example based on Kafka streams, we can move ahead and understand the important differences between Kafka and Kafka streams. So now the first difference is that in Kafka Stream API, single Kafka cluster can support as both consumer as well as producer. While on the other hand, in Kafka, we need separate consumer and producer, and Kafka considers consumer and producer as separate entities. The second difference is that in Kafka API, exactly once processing semantics are supported, whereas in Kafka, it is not by default. But you can achieve exactly once processing in Kafka manually. The third difference is that Kafka Streams API is capable enough to perform complex operations, whereas Kafka is designed to perform only simple operations. The fourth difference is that Kafka API supports single Kafka cluster. On the other hand, in Kafka, you need 2 different clusters for producer and consumer. Followed by that, in Kafka API, the code length is significantly shorter. When you come into Kafka, the code length involved is highly lengthy. The next difference between the both is Kafka Streams API can support both stateless and stateful networks. What are stateless and stateful networks? In stateless networks, the client provides requests to the server and he gets instantaneous reply from server. And here, the cookies or the requests which are sent by the client are not stored. Whereas if you come into stateful network, the client requests the server along with some additional data which is required by the server. In this case, the cookies or the requests which are provided by the client are recorded. So Kafka Stream API is capable to support both stateless and stateful networks. But on the other hand, Kafka is capable only to support stateless network protocols. Followed by that, the Kafka Streams API can support multitasking, whereas Kafka is not capable to support multitasking at a single task level. Followed by that, Kafka Stream API does not support batch processing, whereas Kafka is capable to support batch processing. Kafka Stream API is all about real time, so it doesn't have to support batch processing. So these were the few important differences between Kafka Streams API and Kafka. Now, we shall move ahead and wind up the session with our last topic, which are the important use cases based on Apache Kafka Streams API. Apache Kafka Streams API is used in multiple use cases. Some of the major applications where Streams API is being used are mentioned as follows. Firstly, the New York Times. The New York Times is one of the powerful media in the United States of America. They use Apache Kafka and Apache Kafka Streams API to store and distribute the real-time news through various applications and systems to their readers. Followed by the New York Times, we have Trivago. Trivago is the global hotel search platform. They use Kafka, Kafka Connect, and Kafka Streams to enable their developers to access details of various hotels and provide their users with the best-in-class service at lowest prices. And finally, Pinterest. Pinterest uses Kafka at a longer scale to power the real-time predictive budgeting system of their advertising system. With Apache Streams API backing them up, they have more accurate data than ever.
Reason number 1. The top priority of organizations is now big data analytics. Well, big data has been playing a role of a big game changer in most of the industries over the last few years. In fact, big data has been adopted by a vast number of organizations belonging to various domains. And by examining large data sets using big data tools like Hadoop and Spark, they are able to identify hidden patterns to find unknown correlations, market trends, customer preferences, and other useful business information. And let me tell you that in an article in Forbes, it was published that big data adoption has reached up to 53% in 2017 from 17% in 2015, with telecom and financial services leading early adopters. And the primary goal of big data analytics is to help companies make better and effective business strategies by analyzing large data volumes. The data sources include web server logs, internet clickstream data, social media content and activity reports, text from customer emails, phone call details, and machine data captured by sensors and connected to the Internet of Things, IoT as we call it. Big data analytics can lead to more effective marketing, new revenue opportunities, better customer services, improved operational efficiency, competitive advantages over rival organizations, and other business benefits. And that is why it is so much widely used. And IDC says that the commercial purchases of big data and business analytics, related hardware, software, and services are expected to maintain a compound annual growth rate or CAGR of 11.9% through 2020 when revenues will be more than $210 billion. And that is huge. And the image here clearly shows the tremendous increase in unstructured data like images, mails, audio, etc., which can only be analyzed by adopting big data technologies like Hadoop, Spark, Hive, and others. This has led to serious amount of skill gap with respect to available big data professionals in the current IT market. And hence it is not at all surprising to see a lot buzz in the market to learn Hadoop. Reason number 2. Big data is revolutionizing various domains. Now, big data is not leaving any stone unturned nowadays. What I mean by this is that big data is present in each and every domain, allowing organizations to leverage its capability for improving their business values. The most common domain which are rigorously using big data and Hadoop are healthcare, retail, government, banking, media and entertainment, transportation, natural resources, and so on, as shown in the image over here. Well, to be honest, it is not only limited up to these domains mentioned here. Big data is spreading even more across different domains. As the technology is evolving, the data is increasing, and hence big data is getting adopted across a wide range of domains. Hence, you can build your career in any of this domain by learning Hadoop. Reason number 3. Increasing demand for Hadoop professionals. The demand of Hadoop can be directly attributed with the fact that this is one of the most prominent technology that can handle big data and is quite cost-effective and scalable. With the swift increase in big data sources and amount of data, Hadoop has become more of a foundation for other big data technologies evolving around it such as Spark, Hive, etc. And this is generating a large number of Hadoop jobs at a very steep rate. You can check out different job portals like Indeed.com, Naukri, TimesJob, etc. and you'll see the demand of Hadoop professionals when you browse through the job postings. Reason number 4. Scarcity of big data Hadoop professionals. Now the demand must be more, but the supply is quite less. And as we discussed, Hadoop job opportunities are growing at a high pace, but most of these job roles are still vacant due to a huge skill gap that is still persisting in the market. And such scarcity of proper skill set for big data and Hadoop technology has created a vast gap between supply and demand chain. And hence now it is the right time for you to step ahead and start your journey towards building a bright career in big data and Hadoop. In fact, the famous saying, now or never, this is an apt description that explains the current opportunities in the big data and Hadoop market. Reason number 5. Big data and Hadoop salary. This in fact is quite rewarding. One of the captivating reasons to learn Hadoop is the fat paycheck that you're going to get. The scarcity of Hadoop professionals is one of the major reasons behind their high salary. And according to payscale.com, the salary of a Hadoop professional varies from $93,000 to $127,000 per annum based on different job roles. You can see the different job roles and their annual salaries over here. But of course, it can vary according to the organization that you're joined in and also with the experience you have. Reason number 6. The Big Data and Hadoop trend. And as per Google Trends, Hadoop has a stable graph in the past 5 years. And one more interesting thing to notice here is that the trend of Big Data and Hadoop are tightly coupled with each other. You can see over here that they go hand in hand and have a direct correlation. Big data is something which talks about the problem that is associated with storage, curation, processing, and analyzing of the huge amount of data. And hence it is quite evident that all of the companies need to tackle the big data problem one way or another for making better business decisions. And hence one can clearly deduce that big data and Hadoop has a promising future and is not something that is going to vanish into thin air, at least for the next 20 years. Reason number 7. It caters different professional backgrounds. Hadoop ecosystem has various tools which can be leveraged by professionals from different backgrounds. If you are from programming background, you can write MapReduce codes in different languages like Java, Python, etc. If you're exposed to scripting language, Apache Pig is the best fit for you. And if you're comfortable with SQL, then you can also go ahead with Apache Hive or Apache Drill. The market of big data analytics is growing across the world, and its strong growth pattern translates into great opportunity for IT professionals. It is suited for developers, project managers, software architects, ETL and data warehousing professionals, analytics and business intelligence professionals, and also for testing and mainframe professionals. It is also recommendable for freshers who are going to start a fresh career in the IT world. So if you start with big data, I'm very sure that you're going to have a bright future ahead. Reason number 8. The different big data and Hadoop job profiles. So there are various job profiles in big data and Hadoop. Learning big data and Hadoop doesn't mean that you'll be sticking on to just analytics. You can pursue any one of these job roles based on your professional backgrounds. You could be a Hadoop developer, a Hadoop admin, a data analyst, a big data architect or a data scientist, software engineer, senior software engineer, data engineer, whatever seems more convenient for you. Reason number 9. Hadoop is a disruptive technology. When Hadoop came into the market, it completely disrupted the existing market and created a market of its own. Hadoop has proven itself as a better option than that of traditional data warehousing systems in terms of cost, scalability, storage, and performance over a variety of data sources. It can handle structured data, unstructured data, and semi-structured data. In fact, Hadoop has revolutionized the way data is processed nowadays and has brought a drastic change in the field of data analytics. Besides this, Hadoop ecosystem is going through continuous experimentations and enhancements. In a nutshell, I would tell you that big data and Hadoop is taking out the world by storm, and if you don't want to get affected, you have to ride with the tide. Reason number 10, and the most important one. Hadoop is the gateway to all the big data technologies. Hadoop has become a de facto for big data analytics and has been adopted by a large number of companies. Typically, besides Hadoop, a big data solution strategy involves multiple technologies in a tailored manner. So it is essential for one to not only learn Hadoop, but become expert on other big data technologies falling under the Hadoop ecosystem. This will help you to further boost your big data career and grab elite roles like that of a big data architect, data scientist, etc. So if you want to become a big data architect or a data scientist, Hadoop is the best option to get started with. Hadoop is the stepping stone for you to move into the big data domain. So here were the top 10 reasons to learn Hadoop.
So the first book in the beginner section is Hadoop Definitive Guide. So this particular book was written by Tom White and the publisher is O'Reilly Media. So let's have a quick overview of this particular book. If you are a complete beginner, then there is no better book than Hadoop Definitive Guide. This book guides beginners to build a reliable and easily maintainable Hadoop configuration. It helps to work on datasets regardless of sizes and types. It has numerous assignments
that help you understand Hadoop real-time functionality in a much better way. Going through this book will help you to understand even the latest changes very easily. Followed by the first book, the second book in the beginner's section is Hadoop in 24 hours. So this particular book was written by Jeffrey Evan, and this book was published by O'Reilly Media. Let's have a quick overview of this book. In case if you already have a brief idea on Hadoop and want to have a quick recap of the technology, then this book is for you. This particular book gives you a perfect overview of building a functional Hadoop platform, interface, all Hadoop ecosystem components, and many more. Also, if you're looking for some real-time examples, then it has the best-in-class Hadoop solutions ready for download. Followed by the second book, the third book in this section is Hadoop in Action. This particular book was written by Chuck Lamb, and the publisher is Manning Publications. Let's have a quick review of this particular book. Hadoop in Action is like the one-step solution to learn Hadoop from scratch. This book basically starts from the default Hadoop installation procedures. Followed by the installation, it explains all about the most crucial components of Hadoop, the MapReduce, and many more. Also, the book deals with some real-time applications of Hadoop and MapReduce, including the major big data frameworks which are used in data analytics. So the last book in the beginner section is Hadoop Real-World Solutions. This particular book is written by 3 authors. They are Brian, John, and Jonathan Owens. And the publisher of this particular book is Pact Publishing. And now, let's have an overview of this particular book. This particular book is for the intermediate learners who are looking to try out multiple approaches to resolve the problems. This book has an in-depth explanation of the concepts, problem statements, technical challenges, steps to be followed, and crystal clear explanation of the code used. You will also understand the procedures to build solutions using tools like Apache Hive, Apache Pig, Mahout, Graph, HDFS, and many more crucial components. Now, we shall learn about some books for the experienced programmers. So the first one amongst the books for the experienced Hadoop developers are Pro Hadoop. This particular book was written by Jason Venner, and it was published by Appriss Publications, and the overview goes like this. This particular book gives the readers an upgraded stage to play with Hadoop. The Hadoop clusters. This book covers every single detail related to Hadoop clusters, starting from setting up a Hadoop cluster to analyzing and deriving valuable information for improvising the business and scientific research. You can understand to solve the real-time big data problems using the MapReduce way by dividing problem into multiple chunks and distributing these chunks across the cluster and solve it parallelly in a short period of time. Followed by Pro Hadoop, we have the second book in the experience section, that is Optimizing Hadoop for MapReduce. This particular book was written by Khalid Thaner, and the publisher is Pact Publishing. Let's have an overview of this particular book. This book is all about solving the major loopholes in real-time applications of Hadoop and MapReduce. This book majorly concentrates on the optimization process of MapReduce jobs. This book basically starts from introduction of MapReduce, and then it takes off to the real-time applications of MapReduce and gives us an in-depth understanding of MapReduce so that we could tune the code for maximum performance. Followed by Optimizing Hadoop for MapReduce, we have Hadoop Operations. This particular book was written by Eric Summers, and it was published by O'Reilly Media. Let's have a quick overview of this particular book. The necessity for managing operation-specific data has grown exponentially, and Hadoop has become the standard solution for all the big data problems. Processing these large-scale industry-level problems require a whole new different level of approach and Hadoop cluster configuration. This book exactly explains the same and gives you a brief on managing large-scale datasets and Hadoop clusters. So followed by Hadoop Operations, we have Scaling Big Data with Hadoop Solar. This particular book was written by Mr. Rishikesh, and it was published by Pact Publishing. Let's have a quick overview of this particular book. This particular book is all about Big Data Enterprise Search Engine, and with the help of Apache Hadoop and Apache Solar. Together, Apache Hadoop and Apache Solar have come up with an approach to help organizations to deal with their big data and resolve their problem of information extraction through an amazing solution, and it has extraordinary facet search capabilities. This book gives a complete briefing about the same. Followed by Scaling Big Data with Hadoop Solar, we have Professional Hadoop Solutions. This particular book was written by 3 authors. They are Boris, Kevin, and Alexei. and it was published by Rocks Publications. Let's have a quick overview about this book too. This book is for advanced and professional level Hadoop developers. This book deals with one concept: to increase the power and maximize the capability of Hadoop. The crucial responsibility of Hadoop developers and Hadoop architects is to understand the compatibility between Hadoop frameworks and Hadoop APIs and how to integrate them to provide optimized performance and to deliver real-time solutions. Now, with this, let us move ahead into the last book of today's session, that is the Data Analytics with Hadoop. So this particular book is written by two authors. They are Benjamin and Jenny Kim. So this particular book was published by O'Reilly Media, and let's have a quick overview of this book. In recent days, machine learning and artificial intelligence are taking over, and Hadoop is nowhere giving up the race. It is constantly trying to integrate itself with data science, and Hadoop framework has now become the standard for data analytics. This book is a perfect guide to understand data warehousing techniques and higher order workflows that Hadoop can perform in the process of data analytics. So these were the top 10 best books for learning Hadoop.
Now, who is a big data engineer? A big data engineer is somebody who is responsible for collecting the data from various sources, transforming it into a usable format, and storing it. They basically take raw data and convert it into something that is optimum for stakeholders that access the data. It makes it easier to process and derive business insights from. Stakeholders can be data analysts, data scientists, and software developers. In simple words, data engineers transform data into a format which can be easily analyzed. In order to collect and store data, these professionals design, build, test, and maintain complete infrastructures. This system provides a foundation for each and every data-driven activity and action that is performed in the organization. And while doing so, big data engineers always keep the business requirements in mind. Now, let's look at the big data engineers' roles. Now, there are typically three kinds of roles that a big data engineer has to assume. First of all, we have the generalist. Now, generalists are typically found on small teams or in small companies. In this setting, data engineers wear many hats as of one of the few data-focused people in a company. Generalists are often responsible for each step of the data process, from managing data to analyze it. Next, we have pipeline-centric data engineers. Often found in mid-sized companies, these engineers work alongside data scientists to help make use of data that they collect. Pipeline-centric data engineers need in-depth knowledge of distributed systems and computer science. And finally, we have the database-centric profile. In larger organizations where managing the flow of data is a full-time job, data engineers focus on analytics databases. Database-centric data engineers work with data warehouses across multiple databases and are responsible for developing table schemas. Now, the next logical question will obviously be, what does a big data engineer do? Now, a big data engineer plays a big role in any data-driven business, which also means they are responsible for many things. But most importantly, they are responsible for designing, creating, testing, and maintaining the complete infrastructure, and for storing and processing data that is gathered from various sources. In order to perform this activity, data engineers need to have a good grasp of fundamental knowledge such as OS, programming knowledge, and database management system. Apart from this, the professional has to be an expert in SQL development, further providing support to data and analytics in database design, data flow, and analysis activities. The position of the database engineer also plays a key role in development and deployment of innovative big data platforms and for advanced analytics and data processing. The next thing I want to talk about is building highly scalable, robust, and fault-tolerant systems. Now imagine a building. We all know that the deeper it is under the ground, the higher the building can be constructed without collapsing. Now, a big data engineer does something pretty similar with data. Now, these data engineers work closely with big data architects in designing a complete architecture. Both of them make sure that the system must be scalable in terms of either adding new data sources or in handling exponentially growing huge amounts of data. Big data engineers should also have the capability to architect highly scalable distributed systems using different open source tools. Designing consideration should incorporate that the system must be robust and fault tolerant, where each component should provide a level of fault tolerance. They are also involved in the design of big data solutions because of the experience they have with Hadoop-based technologies such as MapReduce, Hive, MongoDB, or Cassandra. A big data engineer builds large-scale data processing systems and is an expert on data warehousing solutions and should be able to work with the latest NoSQL database technologies. Next, let's talk about the biggest process in all these responsibilities, which is the ETL, or the extract, transform, and load process. Mundane as it sounds, this is actually the process which might take the most amount of time. In order to store data in such a format that data analysts and data scientists can analyze and derive meaningful insights from it, the raw data collected from various sources need to be transformed. Data engineers need to have the knowledge of programming language and tools to perform ETL. The ETL process becomes much more complex when big data comes into picture. With the advent of huge amounts of data, which is getting generated at a very high rate, it becomes even more tough to perform ETL. A big data engineer should be somebody who does this with utmost proficiency. Next is the business acumen aspect. Now, data engineers should have a good business acumen so that the system that he or she develops or the data that is transformed and stored should be according to business needs. This reduces the cost of deriving insights from data, and a good data engineer performs half the transformation that is required for data analytics. Larger organizations often have multiple data analysts or scientists to help understand data, while smaller companies might rely on a data engineer to do so. Next is data acquisition. Now, data engineers should always look at the bigger picture. He or she must have the idea about gaining data from various sources and how the data helps in gaining insights. This will help him or her to understand how data is acquired from different sources and can be used in different ways to derive insights from. They can also try finding more data sources that can help getting more accurate predictions and better insights. Next, let's talk about the programming languages and tools that a data engineer should be proficient in. Some of the responsibilities of a data engineer include improving data foundational procedures, integrating new data management technologies and software into existing systems, and building data collection pipelines. A big data engineer should embrace the challenge of dealing with petabytes or even exabytes of data on a daily basis. A professional so understands how to apply technologies to solve big data problems and to develop innovative big data solutions. In order to be able to do this, the big data engineer should have extensive knowledge in different programming or scripting languages like Java, Linux, Ruby, Python, or R. Also, expert knowledge should be present regarding different NoSQL or relational database management systems such as MongoDB or Redis. Building data processing systems with Hadoop and Hive using Java or Python should be common knowledge also to a big data engineer. Apart from this, he or she should have a good command over at least one programming language and multiple tools. Knowledge of ETL tools and data warehousing tools is also required. Apart from the knowledge of individual tools, big data engineers should also know how to integrate various tools and create a complete solution based on given requirement. Now, having said all that, one very important thing which a data engineer should be looking at is performance tuning. One of their responsibilities includes performance tuning and making the whole system more efficient with time. First, the performance of an individual component needs to be improved, and then the entire system needs to be optimized. With that, let's move on to the summary of what we've discussed so far in terms of responsibility. Now, with all that said, the basic responsibilities of a big data engineer boils down to these three things. First up, data ingestion. Now, this is associated with the task of getting data out of the source systems and ingesting it into a data lake. A data engineer should need to know how to efficiently extract data from a source, including multiple approaches for both batch and real time. Apart from these, they would also need to know about how to deal with issues around incremental data loading, fitting within small source windows, and parallelization of loading data as well. A part of it is also data synchronization, which could be considered a subtask of data ingestion, is data synchronization. But because it is such a big issue in the big data world, since Hadoop and other big data platforms do not support incremental loading of data, here the data engineer should need to know how to deal with changes in source data, merge and sync changed data from sources into a big data environment. Next, let's talk about data transformation. This is the T part in the ETL, which is extract, transform and load, and is mostly focused on integrating and transforming data for a specific use. The major skill set here is knowledge of SQL, and as it turns out, not much has changed in terms of the type of data transformations that people are doing now, as compared to a purely relational environment. Finally, performance optimization and data models. Now this is one of the tougher areas. Anyone can build a slow-performing system. The challenge is to build data pipelines that are both scalable and efficient. So the ability and understanding of how to optimize the performance of an individual data pipeline and the overall system are at a higher level of data engineering skill. For example, big data platforms continue to be challenging with regard to query performance and have added complexity to a data engineer's job. In order to optimize performance of queries and the creation of reports and interactive dashboards, the data engineer needs to know how to denormalize, partition, and index data models, or understand tools and concepts regarding in-memory models and OLAP cubes. Now that we've spoken about the responsibilities of a data engineer, let's talk about the skills that is required to assume these responsibilities. These are the basic skills that one should have to fulfill the responsibilities of a big data engineer. First of all, let's talk about big data frameworks or Hadoop-based technologies. Now, with the rise of big data in the early 21st century, a new framework was born, and that is Hadoop. All thanks to Doug Cutting for introducing a framework which not only stores big data in a distributed manner, but also processes the data parallelly. There are several tools in the Hadoop ecosystem which caters to different purposes and professionals belonging to different backgrounds, but some of the tools which are must to master are HDFS or Hadoop Distributed File System, which as the name suggests is the storage part of Hadoop, which stores data in a distributed cluster. Being the foundation of Hadoop, knowledge of HDFS is a must to start working with this framework. Next we have Yarn, which was introduced originally in Hadoop 2.x in order to make Hadoop more flexible, efficient, and scalable. Yarn performs resource management by allocating resources to different applications and scheduling jobs. Next, we have MapReduce, which is a parallel processing paradigm allowing data to be processed parallelly on top of distributed Hadoop storage. Next, we have Pig and Hive, which look at the data warehousing perspective of big data to perform analytics and scripting. Next, we have Flume and Sqoop, which are popular tools for importing and exporting data to HDFS. Next, we have Zookeeper, which acts as a coordinator amongst the distributed services running in the Hadoop environment. It also helps in configuration management and synchronizing services. And finally, we have Oozie, which is a scheduler binding multiple logical jobs together and helping in accomplishing a complete task. The next skill I'm going to talk about is real-time processing framework. Now, real-time processing with quick actions is the need of hour. Either it is to detect fraudulent transactions in a credit card system or a recommendation system. Each and every one of them needs real-time processing, and it is a very important skill for a data engineer to have. Now, Apache Spark is one such distributed real-time processing framework which is used in the industry rigorously, and it can be easily integrated with Hadoop leveraging HDFS. Next, database management systems and architecture. A database management system is something that stores, organizes, and manages a large amount of information within a single software application. Data engineers need to understand DBMS to manage data efficiently and allow users to perform multiple tasks with ease. This will help the data engineer in improved data sharing, data security, access, integration, and minimize data inconsistencies. These are fundamentals that said professional should know to build a scalable, robust, and fault-tolerant system. Next, we have SQL-based technologies. Now, there are various relational databases that are used in the industry such as Oracle DB, MySQL, Microsoft SQL Server, SQLite, etc. Now, data engineers must have at least the knowledge of one such database. Knowledge of SQL is also a must. Structured query languages is used to structure, manipulate, and manage data stored in relational bases. As data engineers work closely with relational databases, they need to have a strong command on SQL. Next, we have NoSQL technologies. As the requirements of organizations had grown beyond structured data, NoSQL databases were introduced. It could store large volumes of structured, semi-structured, and unstructured data with quick iteration and agile structure as per application requirements. Some of the most prominently used databases are Hbase, Cassandra, and MongoDB. Next, we have programming languages. Now, various programming languages can serve the same purpose. The knowledge of just one programming language is enough, as the flavor changes but the logic remains the same. If you're a beginner, you can go ahead with Python as it is easy to learn due to its easy syntax and good community support, whereas R has a steep learning curve which is developed by statisticians. Now, R is mostly used by analysts and data scientists. Next, we have ETL or data warehousing solutions. Data warehousing, which is very important when it comes to managing a huge amount of data coming in from heterogeneous sources where you need to apply ETL. Now, data warehouse is used for data analytics and reporting and is a very crucial part of business intelligence. It is important for a big data engineer to master one data warehousing or ETL tool, and after mastering one, it becomes easy to learn new tools as the fundamentals remain the same. Informatica, ClickView, and Talend are very well-known tools used in the industry. I would recommend you start with Talend because after this, learning any data warehousing tool will become a piece of cake for you. And finally, we have operating systems. Apart from all these skills, intimate knowledge of Unix, Linux, and Solaris is very helpful, as many math tools are going to be based on these systems due to their unique demands for root access to hardware and OS functionality above and beyond that of Microsoft's Windows or Mac OS. That was all about the skills. We have spoken more about this segment in a previous installment to this video. You can go and look at it to understand the skills you'll be requiring as a big data engineer in detail.
Who is a Hadoop developer? A Hadoop developer is a professional programmer with good knowledge of Hadoop ecosystem. The job of the Hadoop developer is to design, develop, and deploy Hadoop applications with strong documentation skills. Now, this was the basic definition of a Hadoop developer. Now, let's move ahead and understand what exactly a Hadoop developer does. As discussed before, a Hadoop developer designs, builds, installs, configures, and supports Hadoop ecosystem. He translates complex functional and technical requirements into detailed documentations, along with performing analysis of vast data stores to uncover insights by maintaining security and data privacy. Now, followed by this, we shall enter the next section where we shall discuss about the salary trends of a Hadoop developer. Hadoop developer is one of the most highly paid profiles in the current IT industry. The salary trends for a Hadoop developer have increased decently since the last few years. Let's check out the raise in the salary trends for Hadoop developers compared to the other profiles. The profiles that we are going to consider here along with Hadoop are professionals, IT service providers, application and analytics engineers, storage management engineers, computation specialists, SQL developers, NoSQL developers, data management engineers, network engineers, and lastly, the Hadoop developers. So the graphs since 2012 to 2020 and ahead can be shown as follows. We have Hadoop developers on the top, which have the highest salary in the 2020, which is around $100,000 to $105,000 for an entry-level engineer. And it might also grow up to $110,000 or more than that in the upcoming years. So followed by this, we shall discuss the salary trends of a Hadoop developer in different countries. Firstly, we shall consider India. You can see that the salary for an entry-level Hadoop developer in India lies in between 4 lakh to 5 lakh rupees per annum. And for an experienced Hadoop developer, the salary lies between 45 lakhs to 50 lakhs per annum. Followed by India, we shall consider United Kingdom. The salary for an entry-level Hadoop developer in the United Kingdom lies between £25,000 to £30,000 per annum. And on the other hand, for an experienced level Hadoop developer, the salary lies between £80,000 to £90,000 per annum. Followed by the United Kingdom, we have United States of America. In the United States of America, the salary for an entry-level Hadoop developer lies between $75,000 to $80,000 per annum. And on the other hand, for an experienced level Hadoop developer, the salary lies between $125,000 to $150,000 per annum. So these were the salary trends for the Hadoop developer in different countries. Now let us understand the job trends for a Hadoop developer. According to the survey, based on last few years, the number of Hadoop jobs have increased at a peak rate. About 50,000 vacancies of Hadoop developers are available in India. India is the contributor of 12% of Hadoop developer jobs in the worldwide market. The number of offshore jobs in India can increase at a rapid pace due to outsourcing. Many big MNCs in India are offering some handsome salaries for Hadoop developers in India. 80% of the market employers are looking for big data experts. The big data analytics market in India is currently valued at $2 billion and is expected to grow at CAGR of 26%, reaching approximately $16 billion by 2025, making India's share approximately 32% of the overall global market. This contributes to 1/5 of India's KPO market worth $5.6 billion. Also, The Hindu predicts that by the end of the year 2019, India alone will face a shortage close to 3 lakh data scientists. This presents a tremendous career and growth opportunity. According to the survey, we have found a huge gap in the big data, and this can be bridged through comprehensive learning of Apache Hadoop that enables professionals and freshers alike to add the valuable big data skills to their profile. Now, followed by this, we shall discuss about the skills required by a Hadoop developer. So the mandatory skills required by each and every Hadoop developer are as follows. Firstly, the basic knowledge of Hadoop and its ecosystem is compulsory. Followed by that, he or she should be able to work with Linux and execute some basic commands in Linux. The next key skill is Hadoop technologies like MapReduce, Pig, Hive, Hbase are important. Followed by that, the ability to handle multi-threading and concurrency in the Hadoop ecosystem is compulsory. The next important skill is he or she should be familiar with the ETL tools and data loading tools like Flume and Sqoop. Followed by that, the professional should be experienced with scripting languages like Pig Latin. And finally, he or she should be having some good knowledge of query languages like HiveQL. So these were the few key skills required by every Hadoop developer. Now we shall move into the key topic of today's video, the roles and responsibilities of a Hadoop developer. The first amongst the important roles and responsibilities of a Hadoop developer is strong grip of Hadoop and its ecosystem. Understanding the basic suite that provides a solution to big data is mandatory. The basic components of Hadoop, which are HDFS and MapReduce, should be learned. Later, the data accessing tools like Hive, Pig, Sqoop, and finally mastering the data management and monitoring tools like Flume, Zookeeper, and Oozie are mandatory. So followed by the first one, the next one is having the comfortability with Linux and executing some basic commands in Linux. If you're stepping into the world of Hadoop, then chances are there that you might start learning Hadoop using any one of the popular distributions like Cloudera CDH and the Hortonworks HDP. These platforms help you speed up learning by providing a tailor-made platform where most of the services in Hadoop ecosystem are already running. You can start writing MapReduce jobs right away. These distributions mainly use one of the Linux flavors. For example, Cloudera CDH uses CentOS. Having some comfortable understanding of Linux and its flavors will help you to smoothen your learning curve. I strongly recommend gaining some competency in Linux while or before learning Hadoop. Followed by that, the next of the roles and responsibilities is hands-on experience with Hadoop core components. Hadoop is the technology that the future relies on. Hence, making real-time and data-driven decisions happen to be a crucial move. This can be achieved only when you get real-time hands-on experience with Hadoop systems. Followed by this, the next one is developing Hadoop and implementing it with optimum performance. The main motto of Hadoop is to provide high-performance oriented data systems. This can be done by coding data processing algorithms like MapReduce in an efficient way and balancing the load amongst all the available nodes in a cluster. The next one is design, build, install, and configure Hadoop ecosystem. These 5 stages in Hadoop system are crucial. A Hadoop developer should be capable to install, build, and configure the Hadoop system. This happens to be the most basic requirement by every Hadoop developer. Followed by that, we should be having an ability to translate complex technical requirements into a detailed design. Hadoop is the most widespread technology used at a global level, and different companies using it have their own requirements. A Hadoop developer should be capable enough to decode the requirements and explain the technicalities of the project to the clients. Next, analyze the vast data storages and uncover insights. Hadoop is undoubtedly the technology that enhanced data processing capabilities. It changed the face of customer-based companies. Based on the artificially intelligent systems, it is now possible to identify customer requirements and make decisions with a little human interaction. It becomes a crucial role for every Hadoop developer to own a skill to analyze and generate the respective reports based on the collected data. Followed by that, the next important role and responsibility of a Hadoop developer is to maintain security and data privacy. Every company has its own gravity for its data. It might be sensitive information like customer data, transactions made, company's confidential information. It becomes the priority of every Hadoop developer to maintain strong data security and privacy to protect the companies from potential cyber threats. The next one is high-speed data querying. The major role of any Hadoop developer is to make sure that there is enough memory available on both query end and the server end. The buffers, indexes, and the joins play a key role while dealing with huge amount of data. In case if enough memory is not available to the system, then there are possibilities that the system might tend to slow down. The next one amongst the important roles and responsibilities of a Hadoop developer is to design scalable and high-performance web services for data tracking. Hadoop stands superior when it comes to performance and reliability. Hadoop developers should be able to design the Hadoop system to be highly scalable and withstand any unexpected calamities that are prone to data loss. For example, the Hadoop system should always maintain a standby node which can take up the position of the current node when the current node encounters an unexpected failure. Followed by that, we have the cluster coordination services through Zookeeper. Apache Zookeeper provides the best-in-class service to connect, coordinate, and maintain a Hadoop cluster. It gets in synchronization with all the nodes in a cluster using the most robust techniques and providing the simplest user interface. Being comfortable with Zookeeper services would be beneficial for a Hadoop developer to design any Hadoop cluster with strong connectivity. Next comes is Hbase. Loading, deploying, and managing data in Hbase. Hbase is designed and developed to host huge tables of data for interactive and batch mode analytics using NoSQL on top of Hadoop. Its parallel data accessing ability in distributed systems make it the most capable, fastest, and scalable data store for Hadoop framework. Having sound knowledge in working with Hbase would be an added weight to a Hadoop developer's resume. So these were the common and important job roles and responsibilities of a Hadoop developer. Now let's move ahead and understand job trends for a Hadoop developer in different sectors. The job trends for Hadoop developers are available in multiple business sectors in the current IT industry, like travel and transportation industry. Then comes the retail industry. Followed by that, we have the finance companies. Then medical and life sciences, ad agencies, business sectors, telecommunications, biosciences, mass media, natural resources, manufacturing industries, government, and many more. Now with this, we shall enter into the last section of today's discussion, which deals with the top companies hiring Hadoop developers. There are multiple companies in the current IT industry which are hiring Hadoop developers. Few of them are Oracle, Dell, Capgemini, Cognizant, IBM, Accenture, Mphasis, CGI, Facebook, Yahoo, and many more.
In this era, each and every organization is acquiring data from all possible sources, analyzing it, and making thought-out data-driven decisions. Now, data engineers are the ones who design, build, test, and maintain the complete architecture of this large-scale processing system. With the increasing data sources and accelerating data growth, various challenges have emerged in storing, processing, and handling data. And that is called big data. Fun fact, according to an Accenture study, 79% of enterprise executives agree that companies that do not embrace big data will lose their competitive position and would eventually face extinction, as quoted by the Forbes magazine. Next, let's look at the market trends and projections. Now, the best way to analyze a big data engineer's job trend is by analyzing the jobs available on various job portals. According to Glassdoor, the number of jobs for a big data engineer is way over 9,000, and in UK it is way more than 2,000. But Indeed begs to differ. According to Indeed, the number of jobs for a big data engineer in India are way above 13,000, and in the US is way above 127,000. In spite of considering big data as a challenge, organizations are turning it into an opportunity to find insights from the data and gain competitive advantage over the rivals. To achieve that, they hire big data engineers who are paid handsomely no matter how fresh they are in the field. Here you can see the job distribution per salary range in India for a data engineer. As we can see, people who get paid more than 5 lakhs in annum are about 33%, 730 per annum are 26%, 8,70,000 about 20%, which are very high salary brackets. Apart from that, the average salary for a data engineer is almost 8 lakhs in annum, and for a senior data engineer is almost 16 lakhs in annum. If we look at the same numbers in the US, there are 32% of professionals who make more than $90,000 a year and 27% professionals who make $105,000 a year. The average salary in the US for a data engineer is way more than $90,000, and for a senior data engineer, it is $124,000 per annum. Now, as we have discussed the salary of a big data engineer, let's look at a few factors in the form of skills and technology that they know on which their salary depends. Here we've carefully curated a table which lists out the skills and the average salary which can be encashed through them. You can see services such as AWS, data analysis, data mining, warehousing, machine learning, and even programming languages like Java and R. Apart from that, you can see BI tools and statistical tools like Tableau, database architecture, ETL, and structured query languages. Now, another influence on the salary is experience, because experience is also a very important factor in deciding the big data engineer's salary. The distribution of salary is like so. An entry-level data engineer makes about $85,000 a year. People who have 5 to 8 years of work experience bag nearly $103,000 a year. And people who are experienced, I'm talking like 10 years of industry experience, get over $118,000 a year. Now, this salary must be coming from somewhere. Presenting to you the companies that hire in this job role. As you can see, there are some very big names like Amazon, Google, Bosch, Microsoft, and IBM who hire big data engineers. Now, companies that hire big data professionals are companies that are invested in the future. And the worldwide big data market revenues for software and services are projected to increase from $42 billion in 2018 to $103 billion in 2027, attaining a compound annual growth rate of about 10.5%. That sort of a growth needs some kind of work. After going through multiple job descriptions, we found that the big data engineer's salary has many variables. Here are the skills that you require to be a big data engineer. A big data engineer must know his operating system, and Linux is one of the most widely used OSs in the industry. Apart from that, they must be proficient in at least one programming language, say R or Python for instance. Database management system is also a very crucial skill required for big data. Apart from that, they must know how to work with structured query languages and NoSQL technologies. Data models and data schema are amongst the key skills that a data engineer should possess. Hence, data warehousing is something that they should be acquainted in doing. Apart from that, what is a big data engineer who does not know big data frameworks? HDFS, Yarn, MapReduce, Pig and Hive should be on the fingertips of the big data engineer. And finally, real-time processing with quick actions is the need of the hour. Either it is a credit card fraudulent detection system or a recommender system. Each and every one of them needs real-time processing. It is very important for a data engineer to have this knowledge.
Now, when we talk about big data, right, the very basic questions a lot of time pops up. What are 5 V's available in big data? Can anybody answer that? Okay, so Ravi want to answer this. Okay, let me unmute Ravi. Ravi, over to you.
First is volume. Volume of size of data, how much it is growing day by day. And next is variety. Varieties, we have 3 types of data, actually structured, unstructured, and semi-structured data. Structured data is nothing but relational database, all those things. Unstructured data is audio, images, files, all this data. Semi-structured is XML files. Velocity is how much fast is growing.
Okay, very much good answer. When big data started, IBM gave a definition with just 3 V's. The 3 V's were volume, variety, velocity. So what was in volume? Volume was when we talk about like in terms of amount of data what we are dealing with, right? For example, today's Facebook is dealing with very huge amount of data, right? When we talk about variety, now is it only Facebook which is generating data? No, right? Even Twitter is generating data. Okay, we are talking about just social media sites. No, can we talk about medical domains? Yes, in medical domains also the data is getting generated, right? A lot of big data is getting generated. So that's a different variety of data. We have structured data, unstructured data, like we can have videos, audio, right? This is basically going to be called as a variety part. Third component is velocity. Like I said to you, Facebook is just a 10 to 12-year-old company. And imagine the growth they have made it in just 10 to 12 years. Imagine each user is also doing this activity, posting video, audio, all kind of chats, right? So with that, how much data they are dealing with. So that is, you will be calling that velocity. With the pace they have grown up from scratch to this level, with the speed they have grown up to this level is called velocity. Now, these were the 3 components which were actually going in the market for long. Actually, if you ask me, these 3 were the major components even go today. But slowly they started realizing there should be a 4th category of data, which is veracity, which also makes sense in big data, because what basically happens is that the data what we receive to us, right? The problem with that data is we cannot expect that the data is going to be always a clean data. There can be a missing data, there can be a corrupted data in middle. How to deal with this scenario? How to deal basically with those scenarios, because that is a component of now that big data, right? So basically that corrupted or the bad data what we are getting, how to or missing data what we are getting. So those category also they decided to call it as veracity. Now people started calling that, okay, these 4 are the major components, but we are not yet done. Now they started adding few more components. They started saying that no, we are not going to stop with 4. When you are saying that veracity can be added, why not value? Because the data what I am getting, I want to know what is the value of data, how much important that data is. Now somebody said that I want to visualize the data. So visualization should also be one of the V factors. Somebody started saying that I want to see the vocabulary of the data or the validity of the data. Now they started keep on adding their V's. But majorly if you talk about, there are 4 V's which carry some good value. Okay. And usually in any interview, they will not expect you to know all the V's basically. If you know it, all good. But they will be just expecting you to kind of understand that, okay, do you know at least 4 V's which are important? If you can answer that, they will be all good with it. Okay. So sometimes to make it tricky, they ask you 5 V's to just see that how good you are in terms of thinking. Like I generally do that. So when I generally ask questions, I generally see that, okay, that guy must be doing 4 V's. Let me ask 5 V's. Let me see that is he able to think little beyond what he knows already. Moving further. We just talked about something called structured and unstructured data, right? Can anybody explain me the difference between them? What basically are these structured data and unstructured data? Let me add one more component to it. Semi-structured data. That 3rd category of data, let me add it. Now, can anybody explain this? Plus, give me the difference between them as well. Can anybody give me an answer? So, unstructured, not easy to save the data into RDBMS. That's the question's answer from Navesh. Okay. Structured data is basically in row and column format, easy to read and pass from Word. Okay. Narasimha is saying structured data, RDBMS data, unstructured is like log, audio, video, semi-structured is like XML, JSON. Yes. So a lot of people are giving the right answer here. If we talk about basically structured data, if you go with basically 1980s and all, when this Oracle and IBM and all those companies came up into the market. So if we talk about 1970s, 1980, even at that time they used to have data, but that data was not huge. It was small data. But you will be surprised to hear at that moment it was still a challenge to deal with that data. Though it was having some sort of pattern, it used to have some sort of pattern, and it's a small data. Now people used to think that how to use it, how to manage it, how to store it, where to store it. All those questions were coming in people's mind, and that is where companies like Oracle, IBM and all came up into market with their RDBMS solution. Now they started delivering this solution that you can now store the data, you can now process that data, what sounding like having some pattern, and you will be all good. And today I need not tell you that today where these companies are, like Oracle, Microsoft and all. In fact, everybody of you must be willing to work for them if given a chance, right? So they are basically now the market giant, and they have given the solution for that. It was going all good, but now slowly what happens? The other kind of data started coming. So the data what they were dealing with was structured kind of data. But with today's world, right? Like Facebook came up in few years back, right? Now as soon as Facebook came up into market, I'm just giving an example. Now what you do in Facebook? On Facebook you either upload video, upload audio, pictures, right? So you started dealing with this kind of data. Now, do you think this kind of data can be dealt with my RDBMS system? Answer is no, right? Because now we cannot deal with this kind of data. Now, we cannot call this data as structured data because this kind of data do not even have any sort of pattern. And that is where we started calling it as unstructured data. Means any sort of data which do not have pattern kind of thing, like your audios, videos, we started calling it as unstructured data. Now, the third category of data is semi-structured data, right? So there are some sort of files. For example, let's talk about XML data. So as soon as you see XML, what is it sounding like? Does it have pattern or not? Does it have pattern or not? XML files. Can I get answer? XML files, JSON files, do they have pattern? Yes, it has pattern. So as soon as they say that it has pattern, our first answer which must be coming in your mind should be that, okay, it is a structured data. But now as soon as you tell me that it's a structured data, my question for you is, in that case, can you do all the activities what you can do in RDBMS to XML data? I know you can do today, even you can deal with unstructured data as well because they have introduced glob and 𝐂𝐞 data types as well. But is that efficient? Can you fire triggers on that? Can you do all the things which you can do with your traditional data? No, right? Now it started sounding to me that it's a unstructured data. Now I am confused. Whether it's a structured data or an unstructured data, that's where they created a third category called as semi-structured. So that they can keep it in the middle. The data which is sounding something of the structured type or as an unstructured type, they created a new category called as semi-structured data. Everybody clear on this part? What basically is structured data, semi-structured data, unstructured data? Okay, moving further. Now, I have another question for you. How Hadoop differs from your traditional processing system using RDBMS? Can I get an answer? What would you answer this part? So these are like warm-up kind of questions. Usually in interview, they will not start with the most complicated questions with you, right? So these are kind of warm up. They want to see your level of expertise, how much you know. So basically that is what is happening here. So can you answer this part? How Hadoop differs from traditional processing system using RDBMS? And friends, I have a request. Rather than raising your hand, please type it on chat window because this chat window I want to make it more interactive. Okay. Okay. I don't know why your name is showing up 𝐂𝐝𝐿, but let's take it. Processing is done where the data is done. No input output. Okay. Hadoop can store and process any type of data, where RDBMS can store only relational data. Okay, I can take this answer correct. Distributed storage and processing. Okay, good answer, but parallel processing large data, distributed, so few people have just started answering what is Hadoop, right? Don't answer me that. I want difference. Like, read the question properly. The question state, give me the difference. Do not tell me what this do and that do. Tell me the clear-cut difference. What are the differences what we notice with RDBMS system? Or I can ask you another way as well. Can Hadoop replace RDBMS system in future? Or maybe is it really replacing right now? Okay, this question can be asked in this way as well. Now can you answer me this part? So I hope anybody who know Hadoop basics should be able to answer this easily. Can I get some answers now? Who want to come on air also can tell me, I can unmute you. If anybody want to come on air and answer, both are complementary to each other. Okay, good. Anyone who want to come on air, want to answer it? This will give you good confidence also when you will be speaking in interview. It cannot replace RDBMS, but I want reason they do that. That's everybody know. It cannot replace RDBMS, but what's the reason? Very good, very good. Asset property is not supported. Or in other words, can I say CRUD operation is not supported? Create, delete, update. Can I do that at pro level? No, right? So that's the major reason you cannot go with Hadoop systems. Like, you cannot replace them. Also, when the data is small, okay, if the data is small and it's a structured data, which is going to be more efficient, RDBMS or Hadoop systems? Yeah, that's basically in the latest version they are supporting it, but there are a lot of restrictions in it. That's all about Hadoop 3.x, which is yet to come in the market properly. So hold on till the time it come up, because it has a lot of restrictions. It have right now a lot of restrictions. If you have already seen it, you might be aware of this part. Hadoop is used when we are more of write once, read multiple times. Very good. It follows WORM principle, WORM, which means write once, read multiple times. Okay. So, and one more important difference. RDBMS is free of cost. Is RDBMS free of cost? No, right? So basically it's a licensed software. You need to pay for it, right? But when it comes to Hadoop, it's completely open source. There are companies who are now basically making money with this as well. This, because it's an open source community, right? Hadoop is an open source community. Now if you get stuck, where you will get the support? There is nowhere you can get the support. If you get stuck in RDBMS system, there are companies to support you. But what about Hadoop system? If you get, let's say, some bug, who will fix it for you? Right? It's an open source. So basically anybody can come and fix it, but let's say if nobody is fixing your bug, then what, right? So in that case, what people are doing is they are taking support. Okay. So a lot of companies are providing support also on this. So a lot of companies are providing support in terms of now they are making money from it. They say that, okay, if you want to use Hadoop, use it. We will give you the appropriate support, what is required, and you have to pay the money for it. So a lot of companies actually came up like this kind of idea that they are expert in Hadoop, and if you require any support, we will help you with it. So that is one thing which is happening. Now RDBMS can only deal with structured data, right? Basically when we talk about RDBMS, you cannot deal with unstructured kind of data. Though you can right now deal with it as well, because like somebody just argued with me, he said that, you know, in the latest version of Hive, they are trying to support even CRUD operation, right? But it has a lot of restriction. It's not efficient at of the moment. Till the time it do not come out of the beta phase, we cannot say anything about that. Similarly, RDBMS also started creating CLOB and blob data type, CLOB and BLOB, right? Where what they say that you can now store unstructured data and can work on it, but are they efficient? Answer is no, right? So similarly, like most of the data what you deal with RDBMS is going to be structured data. But when it comes to your Hadoop system, it can be unstructured, semi-structured, as well as structured data, right? Because if we take an example of Hive and all, they deal with structured data. right? So that is one thing which is there. RDBMS, you work just on a single machine, right? So let's say you work on a single laptop where you have RDBMS installed and working. But when it comes to Hadoop, you are working in a distributed fashion, right? There will be multiple machines which can be involved in this case, right? And as I said, in RDBMS, mostly when the data is small, your speed will be very fast. Your computation is going to be very quick. At the same time, with Hadoop, your computation speed is not going to be that great. Okay, with the small data, it's not going to be that great. With Apache Spark pitching into the market, that's a different story. Now they are actually picking up basically because if your memory is good, then you can actually make up a good speed. But with traditional Hadoop, when we talk about MapReduce, the speed are slower. I believe if you have already done the classes of MapReduce, you might have already noticed this thing, right? When you were doing that word count example, right? I hope everybody must have done word count example in MapReduce, right? If you have taken the session, right? So in that case, you might have seen the speed of word count example that it is not that fast. So that is one thing with Hadoop system, if especially the data is smaller, your speed is not comparatively with RDBMS, it's going to be slower. Now, which brings me to another question. Can anybody tell me the components of Hadoop and their services? In fact, I'm showing you all the components. Can you explain these components? What are the components available of Hadoop and what are the services what they provide? Can I get an answer? Very good. So basically when we talk about HDFS, right, it is for your storage side. Okay, very good. Can I get more answers? I believe everybody must be knowing this part. Narsim is saying storage, HDFS is for storage, YARN is for processing cluster. Very good. So you can say YARN is a cluster resource manager, right? There are a few more things. Can I get more answers? Name node manages the cluster, data node stores the data. Okay, I can take this answer, but partially they would. Name node manages the cluster. Can you be a little more explicit in this part? YARN for resource allocation. Very good. Are in saying YARN to run MapReduce. Okay. You can say to schedule MapReduce. That would be better, anyone, right? Rather than saying to run MapReduce, can I say schedule MapReduce? Right? That would be a more appropriate answer here. But a good attempt. Name node has metadata. Very good. Right? Name node has metadata. You can take it of something of this sort. So, in your real-term scenario, right? Let me go back. You can simply relate it with this your real-time life also, right? Let's say in real-time scenario, what happens? Let's say you have a boss. Okay. How many people have kind of a smiling boss? Good boss? Smiling boss, but a cunning boss? Very cunning. He plays with your emotions. When I say emotions, I basically mean that basically he kind of is a very clever boss. Anybody who have it? Okay, Shri have it. Ariban have it. Naresan boss is very innocent. Okay, so let's say this boss. Okay, let me draw a smiling boss. Okay, the smiling boss. Now, usually every boss is smiling, right? They just keep on smiling. But the point to note here is the smile is cunning smile or what kind of smile? Now, what next? Now, these are people who are working, right? Like Shri said, that he reports to such kind of boss, right? So basically, Vivek said he's report to such kind of boss, who's a very clever boss, right? Now, let's say Narasim is saying that okay, fine, his boss is also kind of a very innocent boss, but you know, behind that innocence, there might be a lot of cleverness, I think, right? Behind the scenes. So let's say these three people are reporting to this clever boss. What happens? Boss get projects, right? Boss get project. Let's give the project. Now what happens? Boss will be getting a project. These three people are reporting to this boss, right? So what they will do? So boss usually will distribute the project, right? So let's say the project was P. He distributed into three parts: P1, P2, and the third component he made it P3. What he's going to do? So he is going to keep this P1, he's gonna come to Shri and say that work on P1 project. He will come to Vivek and say that work on P2 project. He will come to Narsim and say that work on P3 project, right? He will say that. Now, all the three people are working properly, given the project on timeline, boss is going to be happy. Now, imagine a scenario that Vivek ditch his boss. Not basically ditch, but maybe he said that, okay, fine, my boss was innocent, so let me take an advantage of him, telling him that, you know, I have a family emergency, I can't work, I have to take leave, something of family emergency kind of thing. Now boss is in trouble, right? Because boss needs to work on these two projects now, right? P1 and P3, who will deliver P2 project? So that is the problem. So boss, what they do? They come up basically with an earlier kind of backups. And boss is clever, remember, right? So boss is going to call Shri in his cabin and say to Shri, you know, you are doing very, very good job, right? So you are doing very good job. I'm thinking to promote you. If you keep on working like that, you will get promoted very quickly in the market for sure. And so you should take up some senior responsibilities from now, right? So as soon as she will not hear anything. She will just hear that, you know, boss is telling me promotion word. Okay, he will just hear promotion word and he will be very happy in his mindset. Suddenly his boss will throw a time bomb because boss is clever. So boss usually what he will say, we just discussed, right, that you are going to take up some senior responsibilities. So can you do one thing now? Can you basically take the backup of Vivek first? Now, what happened in this case? Immediately, as he said that, can you take the backup of basically Vivek project? Now she came back to Santos and started arguing, you know, I'm already busy. But he said that you have to just take backup. I'm not asking you to work, right? Just take backup of his work. If you did me, then only you have to work. Anyway, you are a senior candidate. Anyway, boss is boss. She will not be able to say no, right? You have to work for it. Similarly, he will go to Vivek. He will do the same stuff, right? Because managers usually tell this, right? Everything is confidential. So same thing he will do with Shri also. This is confidential. Do not speak about it outside. Same way he will call Vivek, tell the same story, and he will ask now to take the backup of nursing project, right? So he is backing up this project. Similarly, nursing, if you note that, nursing have to back up Shri project. He did the same thing with nursing also, and basically now nursing have to back up this basically the Shri project. Now, if you note in this situation, if Vivek took has emergency leave, now boss will not face any trouble, right? Now boss will not face any trouble because the work, who has to do the extra work? In fact, who will be sacked in this scenario? Definitely boss is not going to be sacked, but who is going to be sacked in this scenario? Definitely she is going to be sacked, right? So definitely she is going to face the heat of doing the extra work. Now, similarly, why I'm telling you all this? Because all the components you can relate here. So basically, when we talk about Hadoop, Hadoop is not much different with this. What Hadoop do is, and boss is also keeping one more information, right? So boss is also keeping information of, let's say, what all projects he have, who is working on what project. Let's say Shri is working on project P1 and he have also a backup of P2. So all these details what boss is keeping. When we talk about Hadoop, Hadoop is kind of doing that exactly the similar kind of stuff. When we talk about boss, the first thing is now in Hadoop what every human is going to be replaced by machines. Now the first component what we were talking about, right? So if we talk about the first component, it was name node. The boss is representing name node. Second component was data node. These employees who are working basically for that boss, you can represent them as data node. The node where you are doing all the processing, because employee do the work, right? Employee do the work, boss only instruct or manage, right? Same story here. So these are your data node. Third property, what is this? Metadata, right? Even name node is going to keep all the data about data. That is called your metadata. Now, what is this? This basically secondary name node and all those stuff. So basically, we require some, like, this is the backup for the data part, right? For this data file P1, P2, P3. But what about this boss backup? So basically, we want to create some backup for that. So that's the reason we keep like casting name node and all those stuff here. Okay. So basically, that is the backup part. That's one of the components. Now, that is means like, let's say in your company, they have also backup of boss. Like if in case if this boss leaves, then I should have all the details. So that's what the backup means here. Now there is one more component called as node manager, resource manager. What are these things? Now, what basically a boss is doing, right? What is boss doing? Boss is having the skill set to schedule the job, right? He only decided where to send what, all those details, right? So that you can call it as a part of your resource manager. Kind of scheduling the work. Who is helping you to schedule the work? You can call it as a resource manager, right? Boss have that skill set. Similarly, in your Hadoop work, your resource manager is going to schedule everything up. Now, the last part, right? Node manager. Now, do you think you will be able to work on this project without any skill set? No, right? You require some skill set to work on that project, right? So that skill set you can relate it like a node manager, which is managing your own node. Means you can relate it like your skill set, which is helping you to solve a project, right? So same way, the node manager, you can say that it is managing the whole node. It is kind of helping the node to execute the task. That you can call it as node manager. So this is how you can relate everything. I hope with this example, now it will make your life easy to remember all these components, because this is a very important question in basically in interview questions. They generally ask this question, what are the configuration files, what basically are the main components. So you should be aware of this, and that's the reason I have explained you with this analogy, so that you get some idea and you can relate to it, that if you have to explain in interview, you need not remember all this stuff. Okay, let's move further. Now, so can I ask this question now? What are the main Hadoop configuration files, right? So basically now we are talking about configuration files. This is related to mostly Hadoop administration interviews. Now, when you talk about Hadoop administrator, right? So there will be few files which you need to configure. So I hope there are people in this batch, in this session also, where people must have done some Hadoop administrator course, right? So I'm assuming that you two people know that. People who do not know that, let's not worry about this. That's the reason I'm answering this directly. So there are few important files here. One is Hadoop environment.sh. This is where you kind of mention all your environmental variables. For example, where is your Java home? Where is your Hadoop home? All those things you define in Hadoop env.sh. Code site.xml. So this file basically you define where your, let's say, your name node is going to run, right? So you need to tell the address of your name node, where you want to run that. Maybe you want to run at some machine at 9000 port. So you will be telling all that in your code site XML. When we talk about HDFS site XML, here we talk about what should be the replication factor, where should physically my data node should be present, where physically my name node should be present. All those things you define in HDFS site.xml. Yarn site and MapReduce site basically defines the map jobs, right? What kind of cluster you are going to use? Are you going to use, let's say, resource, or you are going to use Yarn, or you are going to run a local distributed mode? All those things you will be defining here. Also, you will be defining where your resource manager should be running. It should be running on this machine on 9001 port, or whatever port you want to define, right? So those information you will be defining in Yarn site or MapReduce site.xml. Now, last two files are masters and slaves file. In masters file, we usually mention where my secondary name node would be running. When I say secondary name node, it's like a backup. Not exactly I should call it as a backup, but I should call it as a snapshot of the name node. It's something like this, like somebody just copying the metadata. That's it. It's not going to become active as soon as the main node is down. It is copying the data, so that if name node is down, at least I should have a backup. That's it. Slaves, very clear with the name. Where are all my data nodes? What all machines are going to be my data node? That thing we define in my slaves machine. So people who slaves file, sorry. So basically people who have done this Hadoop administrator, you must have basically played with this file. These are the major Hadoop configuration files. There are others as well, right? Like Hive site XML. There are others like Hbase site XML. Now these are very much kind of tool specific. So that's the reason they will not be called as the main Hadoop configuration file. When somebody says main Hadoop configuration file, your answer would be these 7 files. You need to remember these 7 files. Basically, these 7 files are the one which you will mention. If you are going for Hadoop administrator interview, expect good number of questions in this. Okay, they will ask you to explain each and every file. How basically you will be, what you do in which file, which I just explained you. Make a note of that. And that is definitely one of the favorite questions of the interviewer when you go for Hadoop administrator kind of role. Moving further. Now let's talk about some HDFS questions. In terms of HDFS, now my question is, HDFS stores data using commodity hardware, which has higher chance of failure, which is obvious, right? Because my laptop can be one of the data node, right? Now definitely my data node can fail at any moment. Now, so how HDFS ensures the fault tolerance capability of the system? Can anybody answer this? Very good work. Can I get more answers? I just answered it beforehand itself. Remember that boss and employee relationship. What that boss was doing? Boss was keeping backup, right? Boss was creating backup. Similarly, Hadoop also create backup, right? That backup in Hadoop word is called replication, right? So basically, if you have, let's say, one block P1, you are creating one backup or two backups of basically that block P1, and that is called replication. This is how Hadoop is ensuring that in case of any failure also, there should be no mistake. Okay, we should not be losing data, because in case if one machine fails also, it's okay, it will all work fine for me. So that is what going to happen. So very good, a lot of people have given me the right answer in this case. So block replication is the answer in this case. As you can see in this example also, like block 1 is replicated 3 times, if you notice here, right? So block 1 is replicated 3 times. Similarly, if you notice, block 2 is also replicated 3 times. So these are 4 different machines, and I have replicated block 1, block 2, block 3, block 4, block 5. Okay, so this is what is happening. Edit log and FS image is used to recreate an image. FS image and edit log are 2 different things. These basically are 2 different things. You cannot relate with replication. If you want to know about that, let me just answer you here. So what happens? What is basically this FS image and edit log is? Now, what happens? Basically, you have a name node, right? You have a name node. Where you keep the data in name node? Anybody have answer? Where you keep the data in name node? No, not FS image file. Initially, where you keep the data? In name node, and not HDFS fetch. I'm asking in name node. This can also be an interview question. Very good, Anand. We keep it in memory. Why? Let me answer this part. Let's say there is one client came up. Okay? This is one client. This is client C2. This is client C3. Let's say there are multiple clients. Okay. Now, what is happening in this case is, let's say if this was my name node, and let's say my data in name node is, my metadata is, let's say, sitting in disk. What would be the problem here? Let's say client 1 came and want to access some data. What is going to happen? This data will be moved, because any processing which need to happen, right? That happens in memory only, right? Now this data will come to the memory. Once this memory work will be over, then what will happen? Then basically again it will come back to this, right? It will remove it from memory. Now, don't you think there is an input-output operation happening? An input-output operation is always expensive, right? Now imagine if there are multiple clients asking at the same time to the name node. Don't you think there will be too many input-output operations? Every time we need to basically bring the block to the memory and then basically do the stuff and give the output. Now this is something which we want to avoid. In order to avoid, what they came up with the idea is that whatever metadata you are going to create should directly be created and kept in memory. Okay, that is what the idea they came up. They are not going to keep any data in the disk right now. Should be directly kept in the memory, which brings another question for you. In fact, a serious question for you. Now, since you are telling that the data what you can keep in memory, but my RAM is volatile. When I say volatile, I can lose the data at any moment, right? That's very obvious. I can lose the data at any moment because my RAM is always going to be volatile, right? Now I restart my system, my RAM data is gone, right? So I will lose all the metadata. In that case, how I will ensure that I should not lose my metadata? Now what they started doing is, okay, fine, I will create everything in name node memory only, but what I am going to do is, whenever any, what I'm going to do, at some interval of time, I will keep on taking a backup of that metadata in disk. Okay, in this I will keep on taking the backup of that data, and whatever backup you are taking in the disk from memory is called your FS image. Now, don't you think this FS image is going to be big? Right? This FS image is going to be big. Now, what usually happens is, let's say today my FS image is version FS1. Now, usually the backup what they take is every 24 hours. Just give me 1 minute. If any pop-up kind of thing comes up, it actually stops my system. Now, anyway, now what basically is going to happen? So what happens is every 24 hours we usually do this backup. Okay. So basically today we did some backup. Tomorrow again this metadata is going to do backup. Now, which brings another problem. The problem now again would be, let's say, what about in 18th hour or maybe in 23rd hour my machine fails or my RAM fails. In that case, I am going to lose that 23-hour data, right? Which is again not good. What should I do for that? Now, for that, what they came up is that let's create whatever activity is happening here. I will keep on writing in a small file that will be created for, let's say, 24 hours. Okay, and that file is called as edit log. Then what gonna happen for 24 hours? Whatever activity you are doing will be getting stored as a edit log. Okay. Now what's gonna happen? After every 24 hours, this FS1 plus edit log is gonna be added up, and FS2 will be created. Now in this scenario, even if I lose the data in 23rd hour, my edit log will be having the data, and that's how I am ensuring that I am not losing any data. Now are you clear about this edit log and FS image question? I usually see that people are very confused with this logic, that what is FS image? They just kind of bug up and come back and tell that, I know FS image and edit log, but what exactly are they? I have seen people actually kind of confused with this. So I hope you should be very clear now on this. In which file can this backup time interval be configured? So basically, wherever the physical location of name node you have configured, and where you configured, I just told you what, in HDFS site.xml, right? So wherever you have configured that, so there will be a name directory in it. In that name directory, there is another subdirectory called as current directory. In that current directory, there is another directory called as SNN directory, which is secondary name node directory. There we keep this FS image and edit log files. Clear about this part? So this is where we basically keep that. So can you please summarize the answer once? Sure. You have the same answer of FS image and edit log, but correct. Not exactly two files. One file will be kind of very big file. So that's the reason we are creating a smaller version of that file called as edit log. So that every 24 hours activity we can track. Edit logs are stored in the disk as well. Yes, in the name node. So it's kind of act like a backup. That's it. It's a very good interview question. That's the reason as soon as this question came up, I thought to answer it up, though it's not a part of this slide, but this is a very famous interview question. That can you explain this FS image and edit log? And I can tell you that most of the people fail to explain this. Here memory is RAM, correct. So it's just metadata which is stored, correct. It is just creating a backup of that metadata for the 24 hours activity. That means edit log is getting erased and get new data. Yes. Every 24 hours, it just keep on working and kind of erase the data. That's what keep on happening. Okay, or it creates a new version. It depends how your admin have configured that. What if the block data goes more than the memory? Now, in that case, there is something called as fill. Basically, usually it do not go like that, but there is some concept called as fill. So in that case, there will be some input-output operation happening. You have to deal with that. So then you are making your name node slow. So you have to make sure if you should have a good configuration, but if you do not have it, then in that case, you have to do input-output operation. No other option. Then you have to keep in the disk, and then the data will be having input-output. The window is of 24 backup. Can be changed? Yes, it can be changed. To summarize this, what we just talked about. So in name node, basically you will be storing all the data. But the problem is my RAM is going to be volatile. Now, because of that, I definitely want to have a backup. Now we keep a backup in the disk, and that whatever backup we are keeping, we call it as FS image. Now FS image backup is always taken in 24-hour slot. Now another problem started with this. What happened if I lose the data in 23rd hour? In that case, I should again create a smaller version of the file called as edit log. Okay, that will also be a file. Now these things will be added and will be basically given. What can be the RAM size? The bigger, the better. So definitely there is no right answer for it. Now definitely if you say that 32 GB is good, I will say how about 128 GB? If you say 128 GB is good, I will say how about 256 GB, because that will be better. What if I have more metadata? So we can keep on arguing and keep on increasing, right? So the more the RAM, better it is for you. Correct, Vivek. With every change in HDFS, there's a bit block. Yes, correct. That's what basically happened, Anuj. Now let's move further. So I hope now everybody should be clear with this question. Though it's a separate question, but actually it's good that you brought it up, because that's one of the very famous interview questions. So I thought to cover it up. Now, another question: what is the problem in having lot of small files in HDFS? Please provide one method to overcome this problem. Can I get this answer? Can I get this answer? So what are the problems if you will have small files in HDFS? And also, can you give me basically a method to overcome this problem? Change block size. If you change the block size, no, I want a better answer. I want a better answer. Name node memory will be overload. Good. Now you are coming to right track. See, RAM will run out. Yeah, because if you will have small data, right? If you will have small files, definitely your metadata is going to be kind of too much, right? Your metadata entry will be too many, and that's how you will be kind of filling up your RAM, right, of your basically name node. We just learned that every metadata is stored in the RAM of the name node. Now, what are the solution for it? So this is the problem. What is the solution for it? Having larger data block size so that name node will have reasonable metadata to handle. I can take this answer, but I'm expecting a better answer sheet. More map jobs will be used. Yes, that's also one of the problems. Merge them and save them. Very good job. Okay. What's your name basically? 𝐤𝐝𝐿. I hope that should not be a real name. I don't know why it's showing me 𝐤𝐝𝐿. Oh, is this your real name? Because it's telling me twice 𝐤𝐝𝐿. Okay. So it should be once, right? It should be once, I should call it. Okay. Then fine. Now. So I don't know, this is occurring 2 times, so that's why I'm feeling it weird. So increasing block size in HDFS, merging the file with same, and it's easier to read and write the data. Somebody just answered. Can you combine everything? That is the right answer. We can create .har file. In your Windows, what you do? You create a zip file, right? Or a RAR file. Similarly, in Hadoop also you can do that. You can create a .har file, which is called as Hadoop archive. So you can bring all the small files into one folder together, kind of zipping it together. Now basically with that, what's gonna happen? It's gonna just keep only one metadata entry for it. The metadata entry is going to be reduced. How to do that? This is the command. Hadoop archive. Now hyphen archive name, whatever archive name you want to give it, your input location and output location. Okay, so basically this is how you can deal with the smaller files as well. Better to create a zip file. This is what you do in the real time also, right? When you have multiple files of the same type, you zip them, right? Just to keep them together. So the same thing you will be doing in Hadoop as well. Moving further. Now another question. This is also a very interesting question and an easy question also. Suppose there is a file of size 514 MB stored in HDFS 2.x using default block size configuration and default replication factor. We did an assignment with image files. I'm on LinkedIn as 𝐤𝐝𝐿. Okay. Now I got it. So using default block size configuration and default replication factor, then how many blocks will be created in total and what would be the size of this block? Okay, before you answer this, can I get an answer? What is the default replication factor and what is the default block size if I'm talking about Hadoop 2.x? Very good. So replication, as everybody said, 3 MB. What is the size? Very good. 128 MB. Now it's very easy to answer. Can everybody answer how to split this 514 MB of file? How to split this 514 MB of file? It's in front of you. You can do the calculation and give me the answer as well. Can I get this answer? Very good. 15 block. Lot of people have given me basically less. They said 5 block. But don't you think there will be a replication also of all the blocks? So a lot of people who are giving me this answer of 4 block is completely wrong, Anand, right? Because there will be a block of 2 MB as well, right? If you notice what's going to happen, this is 128 into 4 is basically 512, right? There will be 2 MB blocks. So there are going to be 5 blocks. Because the replication is 5, now replication factor is 3, so it's going to be 5 into 3, 15 block. Okay, this is how basically we will be calculating. This is a very famous interview question. Moving further, how to copy a file into HDFS with a different block size to that of existing block size configuration. Can I get an answer? What basically I'm asking is, let's say you have a block size of 128 MB by default. But when you are copying that data, right, when you are doing, let's say, SDFS-put, SDFS-put, maybe you want to now use the block size of 32-bit, not the default of 128-bit. Then what you will do to achieve this? Yes, there is a parameter. What is that parameter? What is that parameter? Block size? No. Can you see this? DFS dot block size. Okay. So what you need to do? You need to just define the basically the bytes what you want to mention. So 32 bytes is equivalent to this number. Okay. 32 bytes is equivalent to this number. So you need to basically define the bytes what you want to put it up. Now while doing any command, let's say hyphen put or maybe hyphen copy from local, there you can mention this DFS dot block size and whatever number of bytes you want to mention. So you can mention that. Okay. If you want to check the block size, you have another command called as stat. Hadoop fs hyphen stat, and you can see all the statistics related to it. So it will tell you how many bytes it is basically distributed and everything up. You can basically directly use this stat thing and you will get that output as well. Okay, this is sometimes useful in projects, and that's the reason it's a very good interview question as well. Because a lot of time in the projects you don't want to use the default size, you want to change some other number. So in that case you will be using this, because one way is either you change everything from your configuration files, which is not a good idea to do. So better thing is programmatically you deal with it, and here you can change it by the usage of DFS dot block size. Okay. So it's not block underscore size, correct? I hope you got your answer. What's the mistake you were doing? It should be block size. But you are close. Now, what is a block scanner in HDFS? Can I get this answer? This is usually a question in your Hadoop administration. This is basically what your Hadoop administrators do. So people who have done this Hadoop administration classes, can you answer this? I'm expecting this answer basically from you. Even others can answer. What is a block scanner in HDFS? What is a block scanner in HDFS? Can I get answer? Nobody is answering this. Who all have done administration course or no administrator, Hadoop administration? Can I get answers? Who all have done? I'm not asking you to answer me this part. Just to answer me, who all have done this Hadoop administrator course? Initially, few people mentioned it that I have done this administrator course. You must have read about block scanner. Okay, let me answer this part. Usually in a block scanner, okay, Bird is answering now to check if the block has any empty space left in the block. Okay, one of the answer I can take, but not exact answer. It's not very good. Scan the block and report the remaining spaces. Okay. Again, I can take partially this answer. Not just reclaiming space, but in fact, it ensures the integrity of your data blocks. Okay. It basically keep on reporting every data node will keep on reporting to the name node, and it will keep on checking the integrity of the data block. Let's say if any data block got kind of corrupted, right? Or maybe the replica value become low, right? All those things it keeps on monitoring and try to rectify it. Okay, so it will basically keep informing the name node. That's the reason this is been usually done by administrators, because they keep on monitoring the health of the data nodes, data block, name node. They're also responsible for this work, right? So this is what they keep on doing in order to make sure that they use block scanner basically to do that. Okay, there is one more way to check the replication factor. Anybody know what is that? There is one more way to check the replication factor. So this is about block scanner, but there is one more way to check the replication factor. Environmental file, no. Heartbeat, no. Heartbeat will just tell that data node is good or not. Data node, right? I'm talking about, let's say, some file got under replicated. In that case, who will kind of inform name node? Let's say block scanner is not there. There is something called as Hadoop load balancer. I'm not sure if you have read about that. Hadoop load balancer. That basically ensures that if your data blocks are not up, right? If they're under replicated or not, that basically informs that, okay, this is under replicated, let me take care of it. Okay, so this is basically the way also to check the under replicated or over replicated blocks. Can multiple clients write into an HDFS file concurrently? Can I get this answer? If somebody asks you this question, can multiple clients write into an HDFS file concurrently? Interesting. I'm getting 1 yes, 1 no. Now 2 yes, 1 no. Okay, 2 no, 2 yes. Lot of yes. Okay. Do you think it should be feasible to write multiple write? I'm not saying reading. I'm saying writing. Notice this part. Now can you answer? Don't you think it will make my file inconsistent? Yes, single file I'm talking about. Don't you think it will make my file inconsistent if I do that? Right? It will make my file inconsistent. So it is not allowed. Basically, it allowed only one writing and multiple reading stuff. So that's the reason. Single file, it will not allow you to basically keep on writing by, at the same time by multiple clients. It will not allow you to basically do that for multiple clients at the same time. Once one client is writing, it will be kind of file will be kind of locked for other clients. Once the client have written, after that only the other clients can write. But everybody can read concurrently. That is one thing which is very important in Hadoop. So writing at the same time is not possible concurrently, but reading is possible. That's how HDFS is basically created. Why they have not allowed multiple writes together at the same time? Because if they do, it can make the file inconsistent. That will be a big trouble, and that's the reason they do not allow you to do concurrent write. Because this is distributed system. If multiple clients will write on the same file, now maybe somebody can overwrite my change, right? So that's the reason they will not allow you to do this. Okay, this is my architecture. Another question. What do you mean by high availability of name node and how it is achieved? Can I get this answer? How this is achieved and what do you understand by high availability of the name node? In fact, I already answered this in boss example. You can answer me this part, not replication. The rack awareness, name node fails or crashes, they will be standard. So, okay, few people are giving right answer now. Active and passive name node. What basically happens in this cases? So let's say if there are two, in fact, let me show you the slide itself. We have drawn it properly. See this part. There will be two name nodes. One will be active name node and one will be passive name node. So what happens is, let's say this is my active name node which is running, okay, and what these data nodes are there at, who are reporting to the active name node. Now we also create a passive name node. Now this passive name node also, these data nodes will be reporting. This passive name node will not be doing anything, but it will just keep on collecting the data from your data nodes. Okay, that is what the role of passive name node would be. Now, as soon as this, because this now is reading, right? So it knows the status of data node. It knows that where the blocks are being written, everything, it has the information. Now suddenly if this machine is down, in that case my passive name node will ensure, it will immediately start acting like a backup, and that is how it is ensuring high availability. You are not going to lose your cluster time. So basically the downtime will not be there. Immediately your passive name node will start acting like an active name node. Okay, so this is how basically the Hadoop is ensuring high availability. This is a very famous interview question. Passive and secondary name node, good question. Difference between passive name node and secondary name node. Secondary name node we used to use in Hadoop 1.x. Now secondary name node, what used to happen was, secondary name node, you can say, is just like a snapshot of this machine. Means you're just copying the data to other machine. But if my active name node is down, if my main name node is down, in that case my secondary name node will not start acting like a backup. It will only keep the data, but it will not start acting immediately like a name node. It will just keep the data. You have to physically, manually kind of bring the name node up, copy the data from the secondary name node to primary name node, and then start working on it. But in passive name node, yes, but so it's kind of a human intervention, right? Manual intervention is required here, and there will be a downtime. There will be a downtime here. But when it comes to the active and passive name node, passive name node is going to ensure that it is not only collecting the data, metadata, but as soon as active name node is down, passive name node start acting like a active name node. Clear on this difference about now? No, Anand, you have asked this question, right? Clear about this question? Answer? Anand, the difference should be very clear to you. Wait. So let's move further. Okay. So we have few more questions now. So this is for MapReduce side. So let's do one thing, friends. Let's take a 5-minute break. Okay. Let's take a 5-minute break, and we will start with MapReduce questions. Okay. I'm not sure. Maybe Edureka guys, somebody will answer you. Just need a sip of water or so. So just give me 5 minutes. We will take a. Okay, you want 10 minutes? Ravi, this is just basically a 2 to 3 hour session, so we don't want to make it too much. Let's make it a 7 to 8 minutes. Will that work? Let's come up with a in middle kind of solution. So let's come back by maybe by 10:03. Okay, we will start there. Have a water break also. We will come back to MapReduce. Then we have Hive, we have Sqoop and that. So let's come. Everybody, please be back by 10:03. Exactly, I'm going to start by 10:03. Okay, so guys, everybody is back now. Everybody back? Naveen, you should be able to hear me now. Okay, looks like he's restarting. Okay, fine. So now we are going to start. So basically now we are going to start with MapReduce topic. Okay. Now no, yeah, I've not shared. I'm just going to share that. Just give me a second. It takes almost a few seconds to basically come to this. Now I hope it should be showing to you. Okay. Meanwhile, I have talked with the Edureka team, and they have informed me that you all will be receiving this video recording in a day or two. Okay. Since that was a question from a lot of people, will we be getting all this video recording or not? So you will be getting this video recording on your email ID in a day or two. So all these things will be there with you. So I think that will be a quick review for you if you want to take a look at any moment. Now, question for you. Can you explain me the process of spilling in MapReduce? This is an interesting question. In fact, think from a perspective of where mapper keeps the output, and from that you can basically make out what is this spelling. I give you a biggest hint possible here. So can you give me this answer? Can you explain the process of spilling in MapReduce? Spills to temp folder LFS, when it spills and from where it spills. Can I get this answer? Mapper phase. Very good. What usually happens is the output of your mapper task, it goes to your RAM. Now what basically gonna happen? They have kept a specific size of that thing. So let's say they keep, let's say just 100 MB. Now 100 MB of data will be kept, let's say in RAM, but they will be keeping a threshold. So it will slowly keep on filling up, slowly keep on filling up. Then what will happen? As soon as it will reach a threshold, let's say 80% of that RAM of 100 MB is filled, it will start filling that output to the local disk. Notice here, I am not saying HDFS, I am saying local disk. Okay, to local disk only we will be keeping this data. Local disk means your C drive, D drive, wherever you want to keep up. So this is how they have designed it. So as soon as the mapper output in the memory reach to a threshold limit, it starts filling that mapper data to your local disk, and this phase is called as filling phase in MapReduce. Okay, so this question is also asked, and this shows basically the internal working of your MapReduce. Okay, so basically this is how internally your MapReduce work. So this is how this is filling the data. Once it's filling, it will again come down, and you can keep more and more data in it. Which brings me to another question. Can you explain me the difference between block, input splits, and record? This is a very famous interview question. Can anybody answer me quickly? What is the difference between blocks, input split, and records? What is the difference between these three? Friends, this is a very important question. If you have done this MapReduce part, then you must be knowing this part. Difference between blocks, input split, and records. Very good, Jyoti. So Jyoti is answering record is a single line of data, right? Very good. Kanan is saying block is hard cut of data, just 128 MB. Very good, Kanan, right? Block is equal to 128 MB. If record is 130 MB, input split will happen. Very good. Block is based on block size. Input split makes sure that the line is not broken. So it makes sense record is single line. Block is set by HDFS. Input split is logically split. Very good. Very good. So what usually happens, right? So let's say when we talk about block, so let's say you have default space is 128 MB. So that will be called as a physical block. Okay. When we talk about input split, right? So let's say if your data is of 130 MB. Now in that case, don't you think it makes sense to have a logical split of 130 MB here? So that will be your input split. And record is when you do MapReduce programming, right? When you do MapReduce programming, how your mapper take the data? It takes line by line, right? It takes line by line. That line is called record. So one line of data which it picks up in the mapper phase is called your record. Okay, very, very famous question on this part. So you can say block is a physical division, while logical division are called your input splits and records. Okay, because the logical division is what your MapReduce program do. Which brings me to another question, again related to MapReduce. What is the role of record reader in Hadoop MapReduce? What is the role of record reader in Hadoop MapReduce? Make sure to read the complete record. No. How that is how mapper reads a record. Good. But Digambar, can you be a little more explicit? You are coming close to the answer. Can I get more answer? Also, Digambar, can you just be a little more explicit? That is how mapper reads and record. You are coming close. What about others? What is record? Record is single line. We have just understood it. So what should be record reader? Parsing that single line. Very good word, right? So don't you think that single line what you are reading, and how mapper convert your data? It converts into key value pair, right? So it initially takes an input as a key value pair. So when that conversion is happening, that is done basically by record reader. Look at this. See, let's say this is the data. It will be getting converted to key value pair, where key is called your offset and value is first line, right? Or second line or third line, right? So this is done by record reader. Okay, so this is what record reader do. Now, what is the significance of counters in MapReduce? Significance of counters in MapReduce. Okay, give statistics of data. Counters will be done in name node. Okay, counters to validate the data read to calculate bad records. Good. Not just bad record people, it can do even other things, right? It just bad record is just one example, right? It's just one example you can say. So what it do is it helps you to identify the statistics, right? Now basically it gives you the statistics about some operation what you want to do. You can print it in the console also. I believe that if you have done this Hadoop course, you must have seen one code for your counters, right? Where you must be doing some sort of operations and you might be printing it on your console window. Now, how you will be doing all that? So what you will do, let's say we are applying counters on this example. And in this example, as I think somebody just mentioned for the kind of reading the bad data, this example actually bring up the same thing, but it can do even other things. I will tell you what are the things now. But let's take this example. Let's say we want to find out what all bad data I have in this. So let's say it is reading table, all good, no problem. Counter will remain as 0. Then what it did, it basically just gave the value as 0. It reached to the second line. Now this value move up. Now basically this was the bad data. I read it. I passed the statistics. Now counter value became 1. It reached to Jeff. If the value stays as 1 because this is a good data. Now Sean, again the value remains the same. Now as soon as it reaches the last line of bad data, it will again increase this counter and will return that I have 2 bad lines of code. But does that mean we can only do this operation on this? No. Maybe I can have an example where let's say I have data of which is let's say of timestamp. Timestamps are there. Okay. I want to print in this time. So timestamp I can convert to date type, right? In my program, I can convert it to date type. Now, when I convert to date type, maybe I have months being defined, right? Because in date I have months. Now, maybe I want to find out or want to calculate the statistics that in among this timestamp, how many times January is occurring, how many times February is occurring, how many times March, April and all are occurring. Let's say I want to identify all the statistics. I can do that with the help of counters very easily. Okay, so this is the purpose of your counters. Now, moving further, why the output of MapPass was filled into the local disk and not in HDFS? Good question now. Can you answer me this? Remember we talked about, yes, we have just discussed that question, right? So we have just seen spilling. Now, how can we access counters? There are basically libraries available for that. There are classes available. Get counters is the member function to get that. This is how basically we'll be accessing it. So counter is the class in which we have member functions, predefined functions. Using that we can access that. Because it's an intermediate output. Okay. Intermediate output, that's fine. But why we are not keeping in HDFS? That's my question. When I can keep intermediate output in HDFS? Very good, Ramya. Very good, Narsimha. So basically, if you notice what happens, if you keep in HDFS, right? Remember, there is a replication factor, right? That replication factor will do what? It will increase the number of output blocks. Do you think it makes sense to increase the replication for your mapper output? Definitely a big no, right? So that's the reason we will be keeping in your local file system. We will not keep in HDFS. Otherwise, HDFS will replicate even mapper output, which we don't want to happen to do. So that's the reason we will stop that. So we will be keeping in the local disk, not in HDFS, in order to avoid basically the replication. Which brings me to another question. Can you define this speculative execution? Can you define this speculative execution? Can I get this answer? Can we define speculative execution? It prioritizes only some tasks, coming close but not exactly right, Namsuna. If a job in a node is taking much time, very good people. So this is what happens in speculative execution. Let's say if any of your task is running very slow, in that case your speculator, there will be a scheduler which will basically start a duplicate task of it. It will start running a duplicated task for it to ensure that basically that duplicate task runs faster, and once it will finish, it will kill all the duplicate tasks. So it is just kind of making sure that, because it can happen, right? Maybe your task is waiting due to some resource, it got blocked due to any reason. So in that case, it will start immediately a duplicate task and making sure that your job finish quickly. Okay, so this is the part of your speculative execution. Which brings me another question. Question is, how will you prevent, Jan, very good. How will you prevent a file from splitting in case you want the whole file to be processed by same mapper? How you will prevent a file from splitting in case you want the whole file to be processed by same mapper? I want my file to be now basically to be used by the same mapper, not combined, not combine or decombine. Can I get some more answers? It's easy. Can you see this part? So what we can do here is, first of all, we can increase the minimum number of split size, which should now make it larger than your last file, right? This operation is itself good enough to make this case true, right? Because if we increase the size itself, we will be all good. But there is one more thing which you can do after that is, this is method 2 basically. In method 1, you can just basically increase the size itself, it will be all good. Or what you can do, you can go to your input format class, and in that you can just update this property. You can make this is splittable to be returning first. Usually people prefer method 1 because that's the easiest method, right? You need not update the Java code basically to achieve all this. So what you will do for this? Can you please tell a scenario where file splitting is not needed? It all depends, right? So let's say if I know that I have only one data node. Let's say I have only one data node. Now in that one data node, do you think it makes sense to divide a file multiply together? I have only one data node, right? Do you think it makes sense? Because again, it's in the same machine, right? So that's the reason there you want to basically keep one block itself so that I can execute it. So these can be few situations where you can decide not to split the file, and in that case, how you will be doing it? These are the two methods to achieve. Okay, moving further. Is it legal to set the number of reducer tasks to 0? That's question number 1. Where the output will be stored in this case? Is it legal to set the number of reducer tasks to 0? Is it legal? Definitely legal, right? Everybody have used Sqoop. In Sqoop, was there any reducer? Was there any reducer in Sqoop? No. Sqoop only used mapper, no reducer, right? That's itself a tool, right? When a tool is not even creating any reducer, definitely I will not be using that, right? So what is going to happen here is, let's say, so what was the purpose of reducer? Purpose of reducer is when you want to do some sort of aggregation, right? Maybe you want to sum it in the end and all those category kind of thing. But it's not mandatory that all the problem statement in the word require aggregation, right? So those problems where you do not require aggregation, like I said, Sqoop, because in Sqoop what happens? You copy the data from RDBMS to your HDFS or vice versa. Now, are you doing any sort of aggregation? No, right? You're just copying the file from RDBMS to your HDFS system. No aggregation required. So in those cases, you will be having reducer as 0. Output where to store? Definitely whatever mapper output is coming, wherever you are telling, it will be stored in that HDFS location, right? So that's how you will be using it. So definitely the answer is yes, and basically wherever the mapper output you are keeping, there it will be getting stored. What is the role of application master in MapReduce job? Can I get this answer? This is a very famous interview question. What is the role of application master in MapReduce job? To assign the task, okay, that's it. Only to assign the task. Sets the input split, okay. It manages the application fired and keep track of sub-process. That's it. Vipul, nothing else. To get the resources needed for the task. Very good, Ramya. Now you are coming here. You are coming close. To create task until it runs? Yes. What basically application master do? First thing is, application master is kind of deciding that how many resources it needs. Okay. And it can basically now inform resource manager that I require this many resource and give me this many resource to execute that. Then after that, resource manager give back the container, right? If you might have gone through your YARN architecture, right? There you might have understood all these portions. Right. So basically what happens, it first basically find out how many resources are required. Secondly, what it want to do is, it basically want to find out, once it happens, when it gets all the container, it kind of basically get them working together. It collect the output back and return it to basically the master node. So it is doing multiple things in MapReduce. It's basically not doing just one task. It is also checking, which is a very important role of it. It is checking that how many resources I require and kind of helping the resource manager to take that decision. Okay. So this is what the same thing being explained here. The role of your application master. Which brings me to another question. What do you mean by over mode? So when your MapReduce job runs, I'm not sure whether you have noticed that or not. There is something called as over mode. It sometimes comes in your console, if you have noticed that. So can you tell me what is that over mode? Is there any advantage of switching on the over mode? What basically over mode is going to do? Runs on application master node. Very good. Can I get some more answers? More insight on this? Good people. Can I get some more answers? Yes. So let's say if you have a small job, right? If you have a small job, in that case, you're basically, again, application master need to be anywhere. Now application master will request and then it will allocate container, right? So container sending and all, basically creating container, all those things are time consuming. If the jobs are small, what your application master can do, application master can start a JVM in itself. Okay, so basically application master can decide to complete your job. Because the job is small, it may decide to complete the job on its own. In that case, we call it as over mode. So over mode basically require less. It's when you will be using, let's say, less number of mappers, let's say only 10 mappers. You have only one producer to work on. So in those cases, you use over mode. Now, how to enable all that? So basically, there's a property which you can set to true, and it will basically enable your over mode. In which, what's going to happen? Your application master will start acting like a JVM and will finish the job. So thus, it will save you by creating containers, making your performance better. So usually, what people do is, whenever they will be having some sort of, whenever they will be having small jobs, right? And they want to improve the performance, they usually kind of enable the over mode. So now the application master itself start executing the task, and that way they improve the performance. But when you have a bigger job, it will not work. In that case, you need to keep the over mode as possible. Otherwise, you will degrade your performance. It will not even work. Okay? So this is basically your over mode. Another question. How you will enhance the performance of MapReduce jobs when dealing with too many small files. If you have, let's say, many small files, in that case, very good report. Yeah, that's also one thing. If you have, let's say, many small files, how you can improve the performance of your MapReduce job? Combiner? No. Coming close, but not the right answer. Too many small files are there. Then now what you will do? Basically, there is something called as, because none of you give the very right answer, there is something called as combined file input format. That's the reason I told you what you are coming close but not exactly coming right. So what this do is it kind of package all the small files together. See this diagram. See this file. Like these are some small files. It basically now combined all the files together. Now because these small files got combined together, now my execution time will be faster. This is basically one practical thing which is being represented. This performance, can you see? Like the small files was taking this much of time, and basically with this, when you combine this, it actually started taking less time. So thus improving the performance of your system. So this is how basically you can improve the performance if you have multiple small files. Now let's move to Hive. Hive is very important topic. Now, question for you: where the data of Hive table gets stored? Yeah, that I know, Narasimha, that is going to be in HDFS, but where is the location of that? Where is the location for that? But what is the default folder? That's the version. Very good. Now you are coming close. So by default, you keep it in /user/hive/warehouse. So this is the location where by default all your Hive table gets stored. If you want to change this, you can go to your hivesite.xml and can update this setting as well. Another question: why HDFS is not used by Hive Metastore for storage? What I mean is, you might have read in your course that you keep your Hive, basically your Metastore, in your RDBMS, right? Not in HDFS. What is the reason behind that? Why we not keep all these things in my HDFS? Why your Metastore is created in your RDBMS? Why you are configuring your Metastore in RDBMS for Hive? Why not in HDFS? Can I get this answer? Why you are keeping your Metastore in your RDBMS system and not in your HDFS? I can tell you this is the most important question of Hive. In any interview of Hive you will go, expect this question. This usually everyone asks for random access, but that you can do in HDFS also. Ramya, it needs DB catalog. What is that catalog? Because it needs to use JDBC connection? No, that's not the answer. Okay, let me ask you this question, okay, which is actually the main reason for it. So let's say if what you do is, when you create a table in Hive, what happens? It creates an entry for that table in Metastore table, right? What it's doing? It's inserting the row level, right? At a row level it is inserting. You created another table in Hive. Again, you are basically inserting some values here, right? Now, let's say you deleted some table in Hive. What happened? It did a row level delete. Can you do this row level delete, row level insertion and all in your HDFS? Okay, you are referring to the same thing, Rajesh, then you are good. Can you do this, basically this in your HDFS? No, right? This itself is a good answer to explain this, right? So, and second thing is definitely in RDBMS, the syncing time is going to be faster and all. Those are the other factors. But first thing is basically your CRUD operation cannot be done in HDFS. That's the reason we will not be able to keep in HDFS itself. Forget about other factors, right? They do not make any sense in fact, because my first property itself is failing of basically CRUD operation. Now, let's see some scenario questions. Usually in Hive Pig, you will find some scenario questions coming up. Now, scenario question is, Suppose I have installed Apache Hive on top of my Hadoop cluster. Can you please show the last answer? Sure, why not? See this answer in the clear? Let's move forward. Now, can we see this question now? Suppose I have installed Apache Hive on top of my Hadoop cluster using default Metastore configuration. Then what will happen if we have multiple clients trying to access Hive at the same time? Can I get this answer? Suppose I have installed Apache Hive on top of my Hadoop cluster by using default Metastore configuration. Then what will happen if we have multiple clients trying to access Hive at the same time? Very good. Usually in Hive, you can only basically access one by one client. So multiple client access itself is not allowed, right? Very good, Narasimha. They have given basically the right answer for it. So usually these are the scenarios what it follows. So main thing is your multiple client access in Hive is not allowed. This is by architecture, right? Because you should maintain the read consistency. Very good, Rajeshwar, right? So that's the reason this itself is not going to work out. So basically that is what you need to keep in mind. What is the difference between external table and managed table? In fact, managed table you also call it as internal table. So can I get an answer? What is the difference between external table and managed table? Can I get this answer? External table can be a file, okay, but I want a difference, proper difference. External table where the HDFS file won't be deleted if we delete the table. When you say HDFS file, okay, I can accept your answer, Najma. External table is stored in separate location of our thread, but even internal table I can store it at some other location by defining the location keyword, and the external table keeps data when it gets deleted. Very good. That is the major factor. When you talk about managed table, what happens is if you have deleted any of the table, what is going to happen? It will delete the entry in your Metastore. At the same time, it is also going to delete the data file. But in external table, if you delete a table, it is going to only delete the entry in your Metastore, not from your main data. Okay, so that is the major difference basically in the managed table and external table. Another question, when should we use sort by instead of order by? If you notice, these two APIs belongs to Hive and these two basically going to do exactly same thing. So when should I use sort by and not order by operation? When should I use sort by and not order by operation? So basically to answer this, not able to catch things. I did not get this, Ravi. When we should have only one mapper. Okay, Ravi, I think you are in 5th module, right? So that's the reason. Yeah, I can understand. You have told me in the starting itself, right, that you are still going through this course. So if you are not getting it, it's completely fine. Just listen to this, okay? Just listen to this conversation. Once you will go over these course topics in basically from wherever you are doing, you will be all compatible with it. Okay? Basically now I can understand if you will not get anything because these modules is not being taught to you yet. So these are basically the new modules which will be taught later. Now, can I get this answer? In case of numericals, no, that you can use also order by. One of it use reducer, other use mappers. Okay. When you use group by operation, no, that's not the way. Actually, what happens is if you have huge data set, in that case, you should use basically the sort by option. It usually do this sorting on multiple reducer while order by do it on one reducer. That is basically the Major difference. So when you have huge data set, use sort by instead of order by. Okay, lot of people remain confused with this. That's why this is a very tricky question. What people are usually, if you ask anyone, right, if you do not know the answer, he will tell you both do the same thing. But actually, that's not the fact. There is a difference. Now, another question: what's the difference between partition and bucket in Hive? I think the most easiest question to answer. Can everybody answer this? Whoever have done on Hive topic. What's the difference between partition and bucket? This is the most easiest answer. Can I get this answer? Difference between partition and bucket. Simple, right? Partition is basically at the first level, right? When you split the data into different directories. Bucket is like a sub-partitions of that, right? So even for that partition itself, when you create another sub-partitions, you can call them as bucket. Like in this case, can you see the first partition is PLC department, civil department, electrical department. But after that, we have also created some sub-partitions of it. And that is your bucket. That's basically the difference. Another question. Let's say this is the scenario. You are creating a transaction table. Now, this is the table what you have. Like transaction table is the table. You have this many columns, delimited field by comma. Now, let's say you have inserted 50,000 tuples in this table. Now, I want to know the total revenue generated for each month, but Hive is taking too much time in processing this query. Can you tell me what the solution you are going to provide? This scenario is actually a very good interview scenario. Very good, Nasima. Can I get more answers? Very good, people. Can I get more answers? You will be partitioning this table. How you will be partitioning? You will be partitioning your table with month, right? So basically, if you partition a table, you will improve your performance. So these are the simple steps. You can create a table, partition by month, set these properties to true so that you can enable your partition, insert the data, and then you can retrieve the data where your month is equal to January. So while after partitioning the table, you can improve the performance. Second thing. Can I get an answer of this? What is dynamic partitioning and when is it used? Can I get this answer? What is dynamic partitioning and when is it used? That can be static partitioning also in the, right? So I want to know what is dynamic partitioning. Very good. Partition happens when loading the data into table. Right now I don't know that if I do a dynamic partitioning where it is, how many partitions also it is going to create. So the value of your partition columns will be known only during your runtime when you will be creating the partition. That is called your dynamic partitioning. Okay. How Hive distribute the rows into bucket? Can I get this answer? How Hive distributes the rows into bucket? Very good. Hash algorithm. Okay. It uses the hash algorithm. To understand this part, if you look what we are doing here is, now, no, you will be using clustered by, but basically in the how internally this is doing. That's basically how it is doing. Let's say you want to put into two buckets. In that case, it is going to do modulo of 2. Okay. So let's say modulo of 2, this output came out to be 1. So it will decide to put in bucket 1. Modulo 2, it is going to become 0. It is going to keep in this second bucket. So this is how it will be decided. Okay. It will be using basically a hash computation of this. So basically it will be using hash function of this. So let's say hash value of this value came out to be 1. Hash function of this value came out to be 2. Hash function value of this came out to be 3. Then basically it is doing this modulo operation and giving the output, and that's how it distributes the bucketing data. Now, which brings another question. Suppose I have a CSV file which is named as sample.csv present in temp directory with the following entries. In that case, how you will consume this CSV file? into Hive warehouse using built-in SerDes. SerDes means serialization. SerDes, deserialization, that's basically serialization, deserialization. When you convert your data into kind of bytes. Can I get this answer? Row format delimited by comma? Not exactly. I'm looking for something else. Actually, this requires some API. So let me show you this part. See this answer. In this case, you will say raw format SerDes org.apache.hive.serde2.opencsv SerDes. This is what you need to add. Okay. Now you got it. What's the mistake you are doing? So basically, this is what you need to add. Otherwise, everything is same. You can save in the TMP folder and all that. Just that the only difference will come in row format SerDes. Another question. I have lot of small CSV files present in input directory in HDFS, and I want to create a single table, Hive table corresponding to these files. The data in these files are in this format. Now, as we know, Hadoop performance degrades when we use lot of small files. So how you will solve this problem? Can anybody give me a simple answer of this? This should be easy. You have multiple small files. Now in that case, what should be the solution? Because definitely my performance is going to degrade. What should I do? Concatenate small file, but can there be another answer? Don't you think you can use sequence file here? Sequence file, right? One solution can be to that is from my HDFS level itself, Girish, right? I'm talking from basically Hive perspective, right? Don't you think I can convert in a sequence file? Sequence file will convert everything like 0101 kind of thing. So that's what make it better, right? Will improve my performance. So first create a table, load the data. After that, what you do, store it as sequence file. And then basically load this data from this file, what you've inserted, to this file. This will ensure now that your speed will be quick. Why do we need to do in SerDes? Okay. So basically when you do SerDes, right, the advantage what you get is, so let's say first thing is compression, because you are serializing the data. When you serialize the data, it makes that transfer also very easy, because we have converted like 010101 kind of entry, right? So first thing is when you convert to SerDes, you compress the data. Second thing, since you convert to this 01 format, now the transfer over the network becomes a lot easier for me. Clearly, Kamba? That's the reason we basically use this SerDes schema. So, but remember, there is no free lunch, right? There is nothing called as free lunch. Don't you think this will also have a disadvantage? When you do a deserialization, again you need to convert it back. Don't you think it will impact the performance of it, right? So remember, there is no free lunch. Though it is nothing to this that, but at the same time, it will demand your performance. It will eat up some of your performance. Now some quick questions. Can you give me this answer? Difference between logical and physical plan? Should be simple. Difference between logical and physical plans. I know guys that you got little tired because this is a big session, but don't worry, we are almost getting done. So I want everybody attention to be back now. Can you tell me the difference between logical and physical plan? This must be the first thing what you must have learned in your Hadoop course when you went to pick topic. Whenever you are executing statement by statement, okay, it is just executing the statement, nothing. In that case, first it creates a logical plan. Means, let's say if there is no error, right? In that case, it is just creating a logical plan. But when you do dump, right? When you do dump, then only the execution starts, right? Because of lazy evaluation. Then your logical plan kind of get converted to like a physical plan. Means it start getting executed. Now let's say if you have given the wrong file path, right? In logical plan, it will not give you any error because there is no syntax error. Only at the time of physical plan, it will give you an error. So physical plan is when you are basically executing your MapReduce job, when this pig is getting converted to MapReduce job, and while logical plan is at the initial level. Okay, so that is what happens. Can you tell me what is bag? What is bag? Collection of tuples. Very good. right? So basically, when you say a whole data file itself, right, collection of tuples, if you notice. So let's say this is the data, right? If this is the data, now if you see this is one tuple, this is second tuple, this is third tuple. So collection of all these things will be called as bag. Okay, collection of all these things will be called as bag. Now, how Hive is only working with like Hive is able to deal with only structured data, but Pig is able to deal with unstructured data. How Pig is able to deal with unstructured data? Can I get this answer? How Pig is able to deal with unstructured data? It is actually happening because of schema-less part, right? Schema-less part. Basically, if you do not have schema, if you do not have schema defined, then also Pig can work. What Pig do is, let's say you do not know, like in Hive you have column names, right? Let's say column name is age, integer, all that, right? So you need to define the column names. In Pig there is nothing like that. So let's say if you do not know the column name, there's no schema being defined, you can define it like this. First column you can define by $1. Second column you can define with $2. So that's how you can also define. So basically in Pig you can define even your schema-less thing. Okay, so you don't have anything, it will treat it like null. It will start treating, if you do not define data type, it will start taking it as byte. So basically Pig kind of converts your values to other way. So basically that's the reason you can basically go with Pig with unstructured data. This is one of the major reasons that Pig can deal even unstructured data, while Hive cannot do, because Pig kind of converts the data or treats that data in different ways, right? Like if you don't have column name, you can define this as $2, $1, all those things as well. What are the different execution modes available in Pig? So there are two modes, right? One is local mode, one is MapReduce mode. Yeah, sure, Emily, can do that. This is the same thing, Emily. Like if you have no data, it treat it like byte array. If you don't have column, it start treating like $1, $2, right? One before. Okay. This one, back. Got it now? Wait, let's move further. Now, so there are two modes available. One is MapReduce mode, one is local mode. So when you go with Pig in MapReduce mode, so when you just type Pig, right, it takes you to the grunt shell. By default, it takes you to the MapReduce mode, which basically also states that basically if you are going with MapReduce mode, you are accessing your HDFS. While if you are using local mode, what you need to do? You need to go like this: Pig -x local. It will now take you as in the local mode. When you say local mode, what basically happens here? It basically now starts accessing the file from your local file system. Now it is no more accessing HDFS, but it is directly accessing the data from your local file system. These are the two execution modes. Flattening, this is very simple, right? So basically flatten is the keyword available. If you have this kind of data, you can flatten it up, like everything will come together in the line. So flatten is just an API, right? You can see this, flatten. So basically it is just basically converting this form of data to this form of data. Okay, so this is basically meant by flatten. These are simple questions. Now, can anybody explain me this Hbase components? Can anybody explain me these Hbase components? Anyone who want to talk about it? Hbase components? It's in front of you. Can anybody explain me these components of Hbase? You can start by one. This is the last topic. So friends, I want everybody to be attentive here. So Hbase keeps the data in a distributed mode, right? So distributed mode, where it keeps the data, it defines a region where it keeps the data. So like this will be your first region. This will be like the region where you're keeping, let's say, this column value, row value, right? This is a one region. Not together, just like how you define rack, right? You can define region servers, right? where you're defining basically different regions together. So this is one region server, this is one region server, right? Now what happens? The master will keep basically will be called as H master, like active master, just like your name node works, right? Similarly, HBase uses this H master. What is this zookeeper doing here? Zookeeper is kind of helping you to execute everything. So like in zoo, what happens? In zoo, basically they keep animals, right? They keep animals. They manage multiple different category of animals. Similarly, zookeeper like Big Data also got so many tools available for you now, and basically it helps you to manage everything up. So zookeeper maintains a lot of things for HBase. It kind of helps you to basically see that consistency is maintained. It like in HBase, right? When you work basically in your big data, when you're working in Hadoop, now you have name node, data node, all those things available. But when you're working with HBase, you don't have all those things, right? So in HBase, you don't have concepts of name node, you're keeping data and all. So for that, to do this part, like zookeeper play a major role here. So zookeeper is kind of going to act like a coordinator inside your HBase environment. Okay, it will help you to coordinate all the things, because here we don't have name node, data nodes, so and there is no yarn basically here. So you can treat it like basically just like how yarn was handling things there. It is going to help you as a coordinator. It also maintains the directory structures. Can anybody tell me what is Bloom filter? Bloom filter. Anyone know what is Bloom filter in HBase? Can I get this answer? What is Bloom filter? Basically, it helps to improve the overall throughput of your cluster. It helps you to basically improve the performance. Okay. Now, if you want to search any specific row, column, cells, it also helps you to do that. So it makes your system very fast. So that's what you need to just enable this. And if it is enabled, it kind of improves the throughput of your cluster. This is the role of your Bloom filter in HBase. Coming to next question. What is the role of JDBC driver in a Sqoop setup? Simple. Can I get this answer? This is basically Sqoop are important topic in interview. HBase, I would still say that they're not very important these days. People do not ask questions on HBase, but definitely this Sqoop topic is very important. Very good. RDBMS database, I want to connect. Now basically RDBMS can be of any type. It can be MySQL, it can be MySQL, it can also be your Oracle DB, it can be DB2, right? So the JDBC driver will be common and can be used for any of your things. So this will basically help you to create a connection with any sort of RDBMS system. This is a very famous question. What's the difference between --target dir and the difference with warehouse -dir? --target dir with warehouse dir. This is a very famous interview question for Sqoop. Because both will basically help you to put the data in some HDFS specific location. Then what's the difference between them? Very good. Not so importing all table and all is fine. That you are giving me a use case. That's enough. I want basically a proper solution. Means what's the difference between them? Is defined. No, Rajeshwari. What happens in target dir is, in target dir, if you're defining target dir, you need to give the directory path name. Okay, so you need to give the directory name where you will be keeping data. So it is possible, let's say in your MySQL or in RDBMS, let's say you have table called as accounts, but now you want to import this table to your HDFS using Sqoop. Now, if you give target dir, you need to tell the name of the HDFS directory where you will be keeping this. So now you can change this name of HDFS from accounts to, let's say, accounts 1. You can do all that. If you are using target dir, you can change the name of this accounts to accounts 1 in HDFS. But if you are using warehouse dir, in that case, whatever the name will be there in your RDBMS, same name will be created in your HDFS. Same name will be created in your HDFS. No change with that. Okay, so that is one of the major difference between them. So warehouse DIR will maintain the same name, while with target DIR you can keep the same name or different name as well. So you are forced to basically give the name of the HDFS folder where you want to import it. While in warehouse DIR, that's a different story. Now, can you tell me what this query is doing here? Read this query and tell me what this query is doing here. Incremental data, no. Importing employee table, but can you see this hyphen where clause? It is filtering, right? It is only filtering all the employees table where your start date is greater than this value. Okay, this is what this is doing. See, this is what this is doing. Now let's say this is a question. In a Sqoop import command, you have mentioned to run 8 parallel MapReduce tasks, but Sqoop is only running 4. What can be the reason? What can be the reason? Very good, Narasimha. Yes, because maybe your number of cores are not allowing you to run 8 parallel MapReduce, right? Maybe you have less number of cores itself. In that case, Sqoop will not be able to take you up to 8 parallel MapReduce pairs, right? It will only use less number of cores. So basically, if your cores are less, in that case, this is bound to happen. Give a Sqoop command to show all the databases in the MySQL server. Can you give a Sqoop command to show all the databases in MySQL server? It should be simple. Use Sqoop list databases, not show databases, list databases. Okay. Hyphen connect, give the connections. That's it. It will list all the databases. Basically, that's it. So this will list all the databases. Okay. So those sessions will be very useful for all of you. Thank you everyone for making it interactive and a nice session.
I hope you have enjoyed listening to this video. Please be kind enough to like it, and you can comment any of your doubts and queries, and we will reply them at the earliest. Do look out for more videos in our playlist and subscribe to Edureka channel to learn more. Happy learning!